In this video, you'll be building 8 unique games using Python and Pygame. Now, not only is this going to be super fun and give you some awesome games that you can share with your friends and family, but it's going to teach you a significant amount about Python and about building larger projects in general. We've got games like entire platformer games. We're building out different physics components. We've got things like a car racing game, making the classic game of Pong, 2048. We've got checkers with AI. We've got all kinds of stuff, even like Space Invaders. And the way that I've set this up is we're going to go from the easiest project to the hardest. So we're slowly going to build our way up. And if there's one project that interests you more than others, check the video player for all of the timestamps for these different projects. With that in mind, stick with me for some important information. All of the resources that you'll need for these projects is available from the description. So if you need an image or a sound effect, or you want to reference the finished code, all of that will be available from the description. It'll be titled under the project name itself. So if you're working on the platformer, for example, and you need those images, go find the platformer, and beneath that, I'm going to have all of the different resources for that project. Now, I absolutely love Pygame, and that's the module we'll be using to build out all of these games. And you'll see on my channel that I have tons of tutorials just covering Pygame. So what I did here is I combined some of my best videos, ordered them so they're easy to follow along with, and combined them into this video so you guys have one resource that contains really everything you need to know to get really good at Python and build some awesome projects. Now, if you appreciate this teaching style, if you want to learn more, if you want to become a software developer, I do have a program with Course Careers. Now, this is not just any other course. This actually is designed to specifically get you a job, and we walk you through everything from building your resume, applying to different companies. We have a Discord group you can join where we have coaches. Obviously, I'm in there, some other expert software engineers, and we guide you every step of the way to really accelerate that process and get you to your goal of landing a job and becoming a software developer as quickly as possible. We've already had success in the program landing students jobs. And if you want to be one of those, check it out from the link below. We also have a free intro course, 14-day money-back guarantee. Really, we want to make this the lowest risk investment it possibly can be, and you can go check the reviews, 5 stars across pretty much every platform. Anyways, I know this is going to give you guys a lot of value. That's why I'm promoting it so heavily. I really think this is the best program out there, and it's very affordable compared to some of the other boot camps that you'll see online. Anyways, with that said, let's get into this. Enjoy. Let me know in the comments what your favorite project is, and now let's build some games. In this video, I'll give you an introduction to Python game development by walking you through creating a simple, fun, yet extensible game. We'll make this game using the Pygame module, which is a simple 2D graphics library in Python that allows you to create a variety of games. In case you're curious, I have tons of different Pygame tutorials on this channel, and a recent one I posted actually shows you how to build an entire platformer game. Here, we'll make something much more simple just to get through the basics and get you up and started as fast as possible. Let me show you a demo of what we're going to build. So on the screen here, you can see our game. Again, this is fairly straightforward. We have a background, we have a rectangle that you could change to some kind of sprite or character if you wanted to, and then we have projectiles that are falling on the screen. As we progress further, these projectiles will get faster and more of them will fall, and eventually, if we are to collide with one of these rectangles, then it will tell us that we lost. Obviously, you could go and add lives, you can make different levels, you can make this game really completely your own, but I wanted to show you the basics covering things like movement, collisions, projectiles, backgrounds, and all of that kind of fundamental stuff that once you know, you can make a ton of different games with. So with that said, let's get into the video. So the first thing we need to do when we're going to be working with this Pygame module is we need to install Pygame. Now to do that, you're going to open up a command prompt or a terminal and type the following command, which is pip install Pygame. Now, for some reason this command does not work for you, you can try to run the command pip3 install Pygame, and if neither of those work for you, I will leave 2 videos in the description, and I'll kind of throw the thumbnails up on the screen that explain to you how to install Pygame. Alright, so now that Pygame is installed, we can start using this library. Now, I've used this a ton of times, but I'm going to walk you through step by step how we set everything up. So the first thing to do is go into a new Python file. You can see I'm in one here in VS Code. You can work in any editor that you like, and import the Pygame module. Now, while we're up here, we're going to import a few other modules we're going to use for this game. So we're going to import time, and we are going to import random like that. Perfect. All right, next thing we're going to do here is set up our Pygame window. Now, the first thing you need whenever you're working in Pygame is some kind of window. This is really the place where you can draw different objects and actually have your game running. Now, for your window, you need a width and a height. So I like to define my width and height at the top of my program in all capitals, just so that it's clear that these are constant values and they're not going to change. So for the width, I'm going to make this 1000, and for the height, I'm going to make this 800, and that is in pixels. Now, if you are working on a small display, chances are this will be too large for you, so you can make these values smaller so that the window will actually fit on your screen. Okay, now that we have the width and the height, we're going to say win, standing for our window, is equal to pygame.display.set_mode, and inside of here, we're going to pass a tuple with the width and the height. Make sure you have two sets of parentheses here, and inside of this inner set, you have your width and then your height, and make sure you spell the width correctly. Okay, the next thing we can do is set a caption for our window. This is going to be the name at the top of the window. To do that, we can say pygame.display.set_caption, and then we're going to pass a string here, and I'll just call this something like space dodge, but you can call this whatever you want. All right, before we go any further, let's run our code here. So I'm going to go and type Python and then main.py. Whatever editor you're working in, I assume you know how to run your Python script. In VS Code, you can also press this button. Okay, so when I do that, you'll notice that a window kind of popped up and then it disappeared immediately. That's because we don't have any loop kind of running that keeps our program alive. But you can see again, when I run this, window pops up and then it closes. In a minute, we'll make sure that window stays alive, and I'll show you how to do that. Perfect, so now that we have our window here, our width and our height, we need to set up what's known as the main game loop. Now, whenever you're working in Pygame, you need a loop, typically a while loop, that is going to run while the game runs, right? So that actually keeps it alive. The while loop will do things like check for collision, check for movements or key presses, and then adjust what's being displayed on the screen. So what we're going to do is create a function called main. This is really where the main game logic is going to exist. For now, we're going to create a variable called run, and we're going to say this is equal to true. And we're going to say while run, and then inside of here is going to be our main game loop. So the first thing that I always do inside of my game loop is I check to see if the user pressed the X button on the window. If they did that, then I want to close the window. It's not automatically programmed in. You need to handle that key press yourself. So to do that, I'm going to say for event in pygame.event.get. And this is essentially a list that contains all of the different events that have occurred in the last, kind of iteration of this loop. Then what we do is check for the X button event. So we're going to say if event.type is equal to pygame dot, and then in all capitals quit, what we are going to do is say run is equal to false, which will then end this while loop. And we are going to break out of the for loop because there's no reason to continue checking the events if you've hit the quit button. Then at the very end of our function here, we're going to say pygame.quit, and pygame.quit will just close the Pygame window for us. All right, so very quick recap of what we've done here. We've said run is equal to true. While the variable run is equal to true, we're going to check all of the different events that are occurring. This again will give us events like key presses, mouse being moved, all that kind of stuff, as well as if we hit the button in the top right-hand corner, that X button, which is the event.type, equal to pygame.quit. If that's the case, we're going to say run equals to false. We're going to break out of this for loop, and then that will force us to have this statement here, which will quit the Pygame window. Now what we need to do is call this main function so we can test this out. We're going to say if __ name is equal to __ main, like that. Then we are going to call the main function. Now, what this statement is doing right here is making sure that we are directly running this Python file. So we're running the file itself. We're not importing it, because if we were to import it, or if we were to not have this line, for example, and we were to import this file from another Python file, it would start running our game when we only want to do that if we directly run this Python file. So hopefully that makes a bit of sense, but this is just checking if you've run this file directly, whereas if you were to import it, this is going to be false. Okay, so now let's run our code. Python main.py, notice the window appears, and it has space dodge as the caption. Then if I press this X button, we can close out of it. That only works because of the code that we've written here. Fantastic. So the next thing I want to do is have a background image, and then I want to have a character that can move around on the screen. So let's start with the background image. Well, for our background image, we need some image that we're going to display on the screen. Now notice here that I actually have one, bg.jpg. Now, this is a largish image, which is just a space background. All of this code will be available from my GitHub, including the image. So if you want to download this exact image, you can do that by going to the link in the description. If you don't want this image and you just want your own background image, then just save an image. You can call it whatever you want, but put it in the same directory as your Python script, and then I'll show you how we can use that image as a background. So at the top of our program here, we're going to say bg, standing for background, is equal to pygame.image.load, and then we are going to load the name of our file, which in my case is bg.jpg, like that. That's all you need to do to actually load this image into Pygame. Now, if you named yours something else, obviously you're going to change the name to match that. And if you had it, for example, inside of a directory, then you would do something like /images/ and then bg.jpg. There's a few other ways to go about doing that, but in this case, we're just going to load directly from the same directory that this Python script is in. Okay, now that we have our background image, we actually need to put that on the screen. Now, I like to do all of my drawing in a separate function just to keep it very clear and kind of organized. So I'm going to create a function here called draw. Inside of this function, for now, I'm going to draw this background image onto the screen. To do that, we're going to use our window, which is this capital Win variable, and we're going to say win.blit. Now, blit is a special method that you use when you want to draw an image or a surface, that's what's referred to in Python, onto the screen. So we are going to blit the background image, and then we need to pass the coordinates of the top left-hand corner of this image. So in Pygame, when we're talking about our coordinate system, 0, 0 is the top left-hand corner of the screen. So if I run my code here, this should still be okay. Oops, that's not working. Let's do this. You can see that where my mouse is, this is 0, 0. If I go all the way over to the right here, now we are at whatever the width of the screen is, which is 1,000, and then the y coordinate of 0. If I were to go down here, now we are at the width of the screen, which is 1,000, and then the height of 800, or the height of whatever our screen is, because that's kind of how the y is incremented. So rather than y going up, the y actually goes down. 0 is the top, and as you go down to the bottom, you increase your y value. X is the same as normal, starts at 0, and as you go to the right, it increases. Meaning down here, we have an x of 0, and we have a y of the height of the screen. Okay, so that's the coordinate system. Now, I want my background image to fill the entire screen. So I'm going to put 0, 0 as the coordinate of where the top left-hand corner of this background image should be placed. Then the width and the height will fill the screen. Lastly, we need to say pygame.display.update. This is going to refresh the display, which means any draws that we've done, this is a drawing event, will actually be applied and put onto the screen. Every time you update, it takes all of the draws and applies it. If you don't have an update, then nothing's going to happen on the screen. Fantastic. So now, before we exit our while loop here, we're going to call this draw function. So now every single frame, we're going to call the draw function, and it's going to continue to draw this on the screen. Let's go ahead and run our code. Okay, so when we run it, you can see that we get our space image appearing. Now, in my case, my space image is quite large, so it actually fills the entire screen. For some of you, your image might be a little bit smaller, and you might want to scale it up or make it larger so that it fills the screen. Now, to scale your image, you can do the following. You can write pygame.transform, if we can spell that correctly, .scale, and then you can pass the image, which in this case is the image that we want to load, and then the size that you want to scale this image to. So in my case, I want to scale my image to be width height, so it's going to be this. Now, when you do this type of scaling, it is not going to preserve the aspect ratio, but there is different transform functions that will allow you to look up from the documentation that let you actually scale it based on a factor. So you can scale by 2x, 3x, 4x, etc., rather than scaling using kind of this, width height system. Hopefully that makes a bit of sense, but this will not preserve your aspect ratio. If you use a different scale function, it will. There's one that I believe is scale 2x, which just takes the image and scales it up 2 times the size. Okay, so now this should scale our image to be the width and the height. Let's quickly test this out. And let me just select this interpreter so this will keep working now. So now you can see our image looks a little bit better. We've kind of made it the exact size of our screen rather than having it be too large and overflow the screen. Okay, so now we have our background image and we have our main event loop. We have kind of the screen appearing. The next thing we want to do is create a character that can move around. So let's do that. So for our character, we're going to go inside of our main loop here and we're going to say player is equal to a Pygame dot rectangle with a capital R, and this is just going to be rect, and then we're going to pass the X position, Y position, width, and height of our player. So before I go here, I'm going to create two variables, one which is the player width, which will make equal to 40, and another which is the player height, which will be equal to 60. I like to declare all of my constant variables in capitals at the top of my program so I can easily change them and update all of my code by just changing one variable here. So now I'm going to go to my player, which is pygame.rectangle, and we're going to pick a starting X and a starting Y position for our character. Now remember that this is going to be the top left-hand corner of where we are drawing the player. So we can pick any X coordinate we want. I'm going to pick 200, and then for the Y coordinate, we want this player to be at the bottom of the screen. So to do this dynamically, we're going to take the height of the screen, and we're going to subtract the height of the player. So we take height minus player height. That gives us the top left-hand corner where we draw this player. So that means that since our height is 800 and our player height is 60, we're going to draw this at 740, meaning the bottom of the player will be directly at the bottom of the screen. You'll see what I mean when we draw this, but that's why I'm using this math here. Next, we're going to pass the player width and the player height. So it goes X, Y, width, height whenever you're using a rectangle in Pygame. Okay, so now that we have our player, we want to draw this player onto the screen. So I'm going to pass this player rectangle to my draw function, and then I'm going to go to draw, and I'm going to accept my player rectangle. Now I'm going to draw it. To draw my rectangle, I'm going to say pygame.draw.rect, and then the first thing I'm going to pass is where I want to draw a rectangle. Well, I want to draw a rectangle on my window, so I pass window. The next thing I pass is the color that I want my rectangle to be. In this case, I'm going to use red. Now, in the newest version of Pygame, which most of you will be using, you can just use string colors, so red, white, black, orange, any color you would know, or you can use RGB. So if I use RGB, then that would be something like 255, 0, 0, where I have 255 red, 0 blue, and 0 green. RGB, I think I read it in the wrong order. Red, green, blue. Yeah, sorry. So 0 green and 0 blue. But you get the idea. You can use an RGB color code, or for simplicity, you can just write the color in, which in this case is red. Okay, next we are going to put the rectangle that we want to draw, and that rectangle is our player. So our player is a Pygame rectangle, which is an accepted argument to this method here. So we say we're drawing it on the window, it's a red rectangle, and this is actually the coordinates of the rectangle, right? So it's at 200, it's at this height, and it has this width and this height. Perfect. Now that we have that, we should see a red rectangle appearing when we run our code. There you go. We have our rectangle showing up on the screen. Fantastic. Now that we have our rectangle, we want to move it around. Now, to move the rectangle is as easy as adjusting the X coordinate of this rectangle. So let's have a look at how we do that. The first thing we need to do is listen for different key presses. So if the user presses the left arrow key, I want to move to the left, which would be reducing its X value. If they press the right arrow key, I want to move to the right. So I'm going to say keys is equal to pygame.key.get_pressed. Now this will give you a list of all of the keys that the user has pressed and tell you, well, if they pressed them or not. So what I can do here is say the following. I can say if keys, and sorry, I said list, I mean dictionary, and then I can say pygame.k_left, which is the code for the left arrow key. If that's the case, then I can take my player.x and I can subtract from that the player velocity, which is a variable that we're going to define now at the top of our program. So we're going to say player vel, is equal to 5. Let me just move this down. Okay, so we're saying if keys pygame.k_left. You may be wondering how I found this. I just know it because I've used it many, many times before, but this is the kind of, what do you call it, code for the left arrow key. If you wanted, for example, the A key, then it would be K_A or K_B or C, etc. If you wanted like the shift key, it's K_shift. There's a whole kind of documentation where you can look up all of the key codes from the Pygame website. You can also just look up Pygame key codes and you'll probably find a big list that tells you, but the common ones are going to be like space, shift, C, A, W, etc., or left, right, so on. Okay, so if they are pressing the left arrow key, then we're going to subtract the y. The reason we subtract, sorry, not the y, the x, is because we want to move them left. So by subtracting their x coordinate, we move them closer to the 0, 0 position, so to the left. That's why we're doing this subtraction. Now we have the player velocity set at 5, which means every time that you press this key, we're going to go 5 pixels backwards. You can adjust that velocity if you want the character to move faster or slower. Now, of course, we're going to do the same thing for the other arrow key. So pygame.k_right. And then we say, if I can get rid of that crazy autocomplete, player.x plus equals the player velocity. One thing to note here, when I use .x, that's simply adjusting the first value here. So we start at 200, then we go back by the velocity or forward by the velocity, right? That's how you access that. You can also access the width property and the y property, as well as the height property, and that corresponds with the values up here. Okay, fantastic. So now we should be able to move our player because we have this movement code. So let's run and see if we can do that. And using my arrow keys, you can see that I can move my player. However, it's moving extremely fast. Now, the reason for this is that we haven't set up a clock or kind of a timer that regulates how fast our Pygame loop is running. Now, for some of you, if you're on a slower computer, you're going to run that and be like, oh, the speed is fine. It works okay. The issue is that the speed that this while loop runs at is what determines how quickly our character is moving. If I'm holding down the key and this while loop is running really, really fast, I'm going to move fast. If it's running very slow, say you're on a slow computer, then this is going to move slow. We don't want that. We want this loop to always run at the exact same speed so that no matter what computer you're on, it's going to run at the same pace and your character is always going to move at the same speed. To do that, we need to set up a clock object. So we're going to say clock is equal to pygame.time.C clock. Then we're going to go here, and we're going to say clock.tick, and then we're going to put 60, which is the maximum number of frames per second or number of times that you want this while loop to be running. So you create a clock object here, and then inside of your while loop, you have clock.tick. This is essentially going to delay the while loop such that it will only run a maximum of 60 times per second. If you wanted it to run faster, obviously you would adjust this value to be whatever the fixed FPS value is that you would like. Okay, now that we have clock.tick, you'll notice that when I run my code, my character now moves a lot slower. So again, you could speed this up by increasing the velocity, and then no matter what computer you're on, it's going to be moving at a similar or the exact same speed. Okay, so we're moving, but notice here that I can actually move completely off the screen. We obviously don't want that for our game, otherwise you can just dodge by going off the screen. So we need to make it so you can't move if you're hitting the edges of the screen. To do that, we just need to come here to our conditions where we're checking if you're pressing the left arrow key and right arrow key, and add a guard clause that makes it such that you cannot move if you're going to be moving off the screen. So the way we do this is we add another condition here with and. We say if keys pygame.k_left, and we have the player.y minus the player_velocity is greater than or equal to 0. Now, the reason we're putting this here is we're saying, okay, we're about to subtract the player velocity from the x coordinate. So if when we subtract this, the player is still above 0 or greater than 0, so their x coordinate is greater than 0, then that's okay, we can subtract this. But if it's not, so if we're going to be like -1, -2, -3, etc., don't let them move. Hopefully that's clear why we're doing that, but that's why we have this code here. Now let's copy this and put the same thing here, except now we need to change this a little bit because we're adding to the velocity, or we're adding to the x coordinate, sorry. So we have player.x, apologies, plus player.vel, and then we're going to say plus player.width, and this is actually going to be less than or equal to the width of the screen. Now this one is a little bit longer because we have to account for the fact that player.x is the top left-hand corner of our player. So we need to add the velocity, kind of like we did here, but in the opposite direction because we're increasing it, not decreasing it, and we also need to account for the width. Again, this is the top left-hand corner. Then we have a width of, in this case, 40 pixels. So we need to make sure the x-coordinate plus the width plus the velocity is going to be less than the width of the screen before we allow the character to move to the right. Okay, now let's run this and see if it works. And notice when I go to the right here, I can't move any further than the very edge of the screen. And same with the left-hand side. Okay, we now have a character that is moving around. The next thing we need to do is keep track of the amount of time that has elapsed. We then need to create some projectiles that are coming down on the screen and then check for collision with those projectiles. Currently, we're about halfway done. If you're still following along at this point, congratulations. Give yourself a pat on the back. Believe it or not, most people do not make it this far. All right, so there's a few different kind of directions we can go in here in terms of what we want to write next, but I think the easiest is going to be to handle the time, so we know how much time has elapsed. To do that, we are going to create a variable here called start time. Start time is going to be equal to time.time. Time.time is going to give us the current time. So we're going to grab the current time when the game started, and then we're going to create another variable here called elapsed underscore time and make this equal to 0. Then beneath our clock.tick, we're going to say elapsed underscore time, and this is going to be equal to time.time minus the start time. So we're essentially storing what time we started the while loop at. Then every time we iterate, we're getting what the current time is and subtracting that from the start time, which will give us the number of seconds that have elapsed since we started the while loop or since we started the game. Now that we have the elapsed time, we can pass that to our draw function, and we can draw the elapsed time on the screen. So we're going to go to our draw function. We're going to take elapsed underscore time as another parameter here, and then we're going to draw this. Now, to draw this, we actually need to use a font because we're going to have text on the screen that says time, 2 seconds, 3 seconds, etc. So what we need to do is initialize our font module, create a font object, and then use that font to render some text on the screen. So at the top of our code, we're going to say pygame.font.init. We just need to initialize the font module. Don't ask me why we need to do this. It's a requirement from Pygame, so we just do that at the top of our program. Then we're going to come down here, and we're going to say font is equal to pygame.font.sys font with this capitalization. And then we can pass any of our system fonts. In this case, I like to use Comic Sans, and the size of our font, which I will choose as 30. You can change this to be whatever you want. There's different types of fonts you can put in here, Times New Roman, Arial, etc. And then whatever the size is, I'm just going to make it 30. So again, the procedure is initialize the font module, create a font object here, and then use the font object to create some text, which you can render on the screen. So to do that, I'm going to say my time underscore text inside of my draw function is equal to font.render. And then I'm going to pass the text I want to render. Now, in this case, I'm going to say time, colon, and then inside of my f string here, I'm going to say round, and then elapsed underscore time, and then I'm going to put an S here. Then I'm going to put a 1, and I'm going to put the color, which is white. Don't worry, I'll go through this slower. I know that was pretty fast. So we have render. The first thing we do is pass the string or the text that we want to render on the screen. Now I'm using an f string available in Python 3.7 and above, and this allows me to embed a variable directly inside of the string and have it rendered as a string. So I'm saying time, colon, and then I am rounding the elapsed time to the nearest second, and I put this inside my curly braces so that I can directly use this variable in this round function. Then I put an S so that I have, 3, 4, 5, whatever seconds. Next, I put 1. 1 stands for anti-aliasing. Don't worry about this too much, but it just makes your text look a little bit better. And then you pass the color that you want this text to be. In this case, I want white. Okay, now that we have our text, we need to render this on the screen. So we're going to say win.blit, and then we're going to blit the time underscore text, and the position we're going to blit it at is 10, 10. So just so we have a little bit of padding from the top left-hand corner of the screen, 10 pixels X, 10 pixels Y, just moves us a little bit off the edge of the screen so it looks a little bit better. All right, now we should be rendering the time. So let's see if that works by running our code. And notice that we have our time. It is counting up, and it will keep displaying whatever the current time is. Awesome. So now that we have our time, the next thing we need to do is generate some projectiles. Now we're going to generate our projectiles on kind of a counting increment where the increment at which we generate them gets shorter and shorter, meaning we kind of generate more of them more quickly as the time progresses, making the game a little bit more difficult. Obviously, you can mess with this mechanic however you'd like, but I wanted to show you how we do some kind of dynamic rendering here so we're not just putting one on the screen, say, every 1 second. It gets a little bit more complicated than that. All right, So to do this, we need to have a few variables. We're going to say star. I'm going to call those little projectiles stars, even though I know they don't really look like them. I'm going to say star add increment is equal to 2000 milliseconds, which means the first star that we add will be added in 2000 milliseconds. Then we are going to have star underscore count equal to 0. And this is actually just going to be a variable that tells us when we should add the next star. I know it's a little bit misleading. It's not telling us how many stars we have. It's going to be counting so that we know when we get to this increment and when we should add another star to the screen. Okay. Then we're going to have an array here called stars, or a list, sorry. And this is where we're going to store all of our different stars that are currently on the screen. Then we'll draw all of them that are inside of this list onto the screen. Okay, so at the top of our code here, although it doesn't really matter where you put this, we're going to generate some of our stars. So we're going to actually say that our star underscore count plus equals clock.tick. Now, I know this seems a little bit weird, but what clock.tick does is return the number of milliseconds since the last clock tick. So you need to actually do it in this way to keep track of the time accurately. In my case, it's about 16 or 17 milliseconds between every clock tick, but for you, it could be slightly different. So we say star count plus equals clock.tick, and what this is doing is essentially counting how many milliseconds have occurred since, again, the last clock tick. You could use this elapsed time variable, but it gets a little bit more complicated based on how we're kind of keeping track of the time with this variable. I know that I'm probably confusing you a little bit. Again, this is just returning number of milliseconds since last tick. So you do that to keep track of kind of the precise time in this variable. All right, now we're going to say if the star count is greater than the star add increment, then we're going to add stars to the screen. So hopefully you see what I'm doing here. This is 2000. The star count is 0. As soon as we have 2000 milliseconds that have elapsed, then we trigger this and then we add a star. Now I'm actually going to add 3 stars at a time, but you could add a random number, you could add 20 stars, you could add 1 star, you can add as many as you want to the screen. So I'm going to say for underscore in range 3 because I want to add 3 stars. And by the way, this is a placeholder variable that you use when you don't want to have an increment variable like I. I don't actually care about the iteration count. I just want to do something 3 times. So I say for underscore in range 3. Okay. Now I'm going to generate the X position of my star because I want to randomly position them on the screen. So I'm going to pick a valid X coordinate and then we'll choose a Y coordinate and place the star on the screen. So star X is equal to random.randInt and then 0 width minus the star underscore width, which is a variable that I don't believe we've defined yet. So let's add that variable to the top of our screen here and make that equal to, let's go with 10. Okay. So again, star underscore X is equal to random.randInt 0 width minus star width. Now, the reason we're doing this is because we want to pick a random integer in the range of 0 and width, again, minus the star width, which is a valid position for the X coordinate of the star that we are generating. Okay, we can do this because we imported the random module at the top of our program. We're then going to say star is equal to Pygame dot rect, and we're going to place this at the star underscore X and at the negative star underscore height, which is another variable that we need to define. So let's go here and make this equal to 20. Okay. Now, the reason I'm doing this is I want my star to start off at the screen and then move down. So when I do negative star height, that means I'm going to get a negative Y coordinate. So my star starts not at the top of the screen, a little bit above the top of the screen, and then as we move it down, it looks like it enters the screen. If instead you were to put 0 here, then you would see the star kind of appear right at the top of the screen and then start moving down. Instead, we want to see it slowly enter the screen, so we do that by giving it a negative height to start. Okay, next we pass the star width and the star underscore height. And now we add this star to our stars list. So we say stars dot append star like that. Okay, so this now generates 3 random stars for us. Now that we have that, we want to adjust our star add increment and we want to set our star count back to 0. So we say star count equal to 0, And before that, we're going to adjust this increment so that it's slightly less than what it currently is, so that we generate stars faster. To do that, we say star add increment is equal to the maximum of 200, and the star add increment minus 50. Okay, so let's just quickly go through what I did here. I'm essentially saying with this maximum function, pick the maximum value out of this and 200. Now, this makes it so that the minimum star add increment I ever have is 200, right? So if star add increment is equal to 200, rather than setting it equal to 150, then 50, then 0, then negative 50, we always keep it at 200, okay? So this is just the minimum value. That's what I'm setting here. Then, in most cases, what will happen is since star add increment is going to be much larger than 200, in the starting case equal to 2000, we're going to subtract 50 milliseconds so that every time that this runs, 50 milliseconds kind of faster, we generate another star. Hopefully that makes a little bit of sense, but we go from 2000 to 1950 to 1900, etc., and it gets faster and faster and faster the time in which we're incrementing a star. And you can obviously adjust this and change it to be whatever you want. Okay, so that will generate our stars for us. However, if we want to see our stars, then we actually need to draw them on the screen, and we need to move them downwards. So we're going to do both of those steps before, unfortunately, we can see what's going to happen here. So now after we generate our stars, after we do our events, and after we do our movements, we're going to move our stars. So we're going to say for star in stars, and then we're actually going to make a copy of this stars list. The reason I'm making a copy of the stars list is that I'm going to be removing stars from this list that have hit the bottom of the screen or that have hit our player. If that happens, if they hit our player, hit the bottom of the screen, we want to get rid of them because we don't want to be rendering them and moving them when they're not on the screen. That's a waste of resources. So I need to make a copy of this list because if I'm modifying the list while I'm working on it, I can get all kinds of weird errors. So rather than doing that, I make a copy of it so that I'm looping through the copy, and then I can adjust or mutate the original list as I go through this for loop. So I'm going to say star.y plus equal the star velocity. Okay, so this moves the star downwards in the y direction by this velocity because we're adding to it, meaning it goes down. Then I'm going to say if the star.y is greater than the height of the screen, then what I want to do is remove this star. So I'm going to say stars.remove, and then I remove the star, which will remove the first instance of this, or really the only instance of it, from the original stars list. Nice. Next, we're going to say elif star.y is greater than or equal to the player.y and the star.collide rect player. Then we are going to remove the star again. So stars.remove star, and we're going to say hit is equal to true. And we are going to break out of this loop. Okay, you'll see why I'm doing this in a minute. But essentially what we're doing with the second elif statement here is we're saying, okay, if the star.y was not greater than the height, then we're going to check if the star.y is greater than or equal to the player.y. Now, the reason we're doing this check here is because I only want to check to see if this star is colliding with the player if the star is at the bottom portion of the screen. So if it's in the same Y kind of plane as our player. If it's not, there's no point in me checking if the star has collided with the player, right? That just doesn't make any sense because if it's way above the player, I don't need to check for collision because I know it can't be colliding. And in fact, I need to add something here, star.y plus star.height, because again, we need to account for the fact that the star has a height, not just a y coordinate. Okay, so we say star.y plus star.height. If that is greater than or equal to the player.y, then we're going to check if the star has collided with the player. So since both of these are Pygame rectangle objects, that allows us to use this fancy function called collide rect, which just tells us if two rectangles have collided. So if they've collided, then I want to remove this star because it hit our player, and I'm going to set a variable hit equal to true because we'll then look at that variable later on to see if our player has been hit by a star. Okay, now we just want to go up here and say hit is equal to false, just so that if we do end up checking this variable later on, we don't get an error where it's undefined. Okay, so I know I've done a lot there, but we started by generating all of our stars. We then moved all of the stars. Now we need to draw all of the stars. So I'm going to pass my stars to this draw function. I'm going to go to my draw function, and I'm going to start drawing them. Now, it doesn't really matter where you draw them, but if you draw them after the player, they'll appear on top of them. If you draw them before the player, they'll appear behind the player. So pick where you want to draw them. I'm going to do it after so you can see it on top of the player. Okay, so fairly straightforward here. We're going to say for star in stars, Pygame dot draw dot rectangle on the window with the color white r star. Okay, straightforward, same as our player. We're just doing it for every single star. All right, so that's going to be a majority of the game done. Let's run it, make sure it works, and then we'll handle showing something on the screen when the player gets hit by a star. Okay, so let's run, and you should see that we get some stuff appearing on the screen, but it looks like we got an error. So what is our error here? It actually didn't show up for me. So let me run this one more time, and we'll wait for the error message. And it says star velocity is not defined. Okay, so that's a variable that we need to define. So let's say star vel is equal to 3. Again, feel free to adjust that to be whatever you want. Okay, now let's try it and see if our stars start moving. And there you go, 3 stars are generated, and they start moving on the screen. Perfect. And notice that they kind of disappear when they hit the player or when they hit the bottom of the screen. Okay, fantastic. So now the last thing we need to do is just put something on the screen that says, hey, you collided with a star, you lost the game, and now we'll be finished. Okay, great. So to do that, we're going to go down to the bottom of our while loop here. And before our draw statement, we're going to check if the player was hit by a star. So we're going to say if hit, then we're going to do something. Now, really, all we're going to do is just generate some text that says you lost, put it on the screen, kind of delay for a few seconds, and that'll be it. And if you want to adjust this game and kind of make it longer, add levels, you can do that from here. So we're going to say lost underscore text is equal to our font dot render. You can make a different font if you want. I'm just going to use the same one. I'm going to say you lost exclamation point, and then 1, and then the color of white. Okay. Now I'm going to draw this on the screen. So I'm going to say win.blit, the lost underscore text, and I'm going to draw this in the center of the screen. To draw this in the center of the screen, we do the following. We say width divided by 2 minus the lost underscore text dot get underscore width, which is a method you can use to get the width of your text object, divided by 2, and then we do the same for the height. So we say height divided by 2 minus lost underscore text dot get underscore height divided by 2. Okay, so let me just quickly explain why we're doing this. We want this in the middle of the screen, but we need to pick the top left-hand position of the text that puts it in the middle of the screen. So you might naively think that you can just do width over 2 because that's the middle position of the screen, but you can't. You actually have to get the full width of the text object and then divide that by 2 and subtract that from width over 2. Right? So if we have, can I kind of run this? Let's run this and see. So let's say 500 is where my mouse is, right? If I draw my text, it's going to go this direction from my mouse. So I need to shift it back half the width of the text and then draw it so that it fills the screen completely in the middle. And then obviously the same goes for the height. Okay. Hopefully that's clear. That's why we're doing that. All right. So now that we've blit this on the screen, we need to update the screen. So pygame.display .update, then we are simply going to pause. So we're going to say pygame.time.delay. I'm going to delay for 4,000 milliseconds, which is 4 seconds. And then I'm going to break, which will break this while loop and will end the game. Okay, so let me quickly run through. We generate the text. We draw it onto the screen. Now, since I'm not doing this in the draw function, I need to manually update the display so we actually see that appearing. Then we just freeze the game. So this is just delaying everything for 4 seconds, just so you can see the text. And then we break and the game ends. If you wanted to, you could call the main function again, or you could have the game run a second time. You can do whatever you want here. You could say how long you've lasted, whatever. You can add a scoreboard, but this is where I'm going to leave it for now. So let's just run, make sure this is working, and then that's pretty much going to wrap up this tutorial. Okay, so let's just see if we can collide here. And we do, and notice it says you lost. And then the game is going to end, and we can run it again. Okay, fantastic. So let me zoom out a bit here so you guys can read some more of the code. I'll kind of scroll through it slowly. Obviously, all of this code will be available from the link in the description at my GitHub. but that was an introduction to Python game development. Hello everybody and welcome to another YouTube video. So in today's video, what I'm going to be doing is going over Pygame for beginners. So as you can already see here, I have a little game on my screen. The purpose of this video is going to be to introduce you to the module called Pygame in Python. I'm going to cover a lot of stuff in this video, including sound effects, images, moving objects, collision, most of the fundamental and main things you need to know to actually create a game. And well, to give you an idea of what we're going to be building, it's nothing complex. This isn't meant to be fancy. Again, it's just meant to teach you how to work with this module, and I figured we could do this kind of really simple two-player game to give you an idea of how everything works in Pygame. So you can see we kind of have two spaceships here. They can move around the screen, and I'm moving these with the same keyboard. So I have WASD moving the one on the left, and I have the arrow keys moving the one on the right. And when I press the left or right control key, that is actually firing bullets. Now there is sound effects. I don't know if you guys can hear them. I'll stop talking and hit it for a second. So you might be able to hear that. Either way, there is sound effects. We'll be adding that in there, and I'll show you how this works. And you can see that once one of the enemies loses, so they run out of health, you can see that at the top, it says boom, yellow wins. And even though I have these on the wrong side, we'll fix that in the original video. Anyways, you get the idea. This is the yellow spaceship. This is the red spaceship. Really, they should be on opposite sides. For the tutorial, we'll fix that. So the first thing we need to do when we're going to be working with the module called Pygame is we need to install it on our computer. Now, for some people, this can be tricky. It really shouldn't be that difficult, but what you need to do is open your command prompt or open some terminal window, depending on what operating system you're on. If you're on Windows, you're going to open command prompt. If you're on Mac or Linux, you're going to open your terminal. Now, this command may vary based on your operating system. I'll go through all of the different variations, but the first thing you want to type inside of your command prompt, doesn't matter what directory you're in, is pip install and then simply the module Pygame. Go ahead and press enter. That should install Pygame in your Python interpreter and your Python environment. Then you should be good to go. Now, if for some reason this isn't working, or when we get to the next step, which is just testing our code and importing Pygame, you don't see anything happening, try the following command, pip3 install Pygame. So just add a 3 to the end of pip there. Oops, I didn't mean to delete the 3, but pip3 install Pygame. Hopefully that one should work for you. And if neither of those work for you, then try the following, python-m pip install and then Pygame like that. And if this one doesn't work either, then do the same variation. So add python3-m pip install Pygame. If none of those 4 commands work for you and you can't install Pygame, I'll leave links to videos in the description that show you how to fix your pip. They're not directly called that, but actually this will be perfect for this because they are how to install Pygame on Mac and Windows respectively. Anyways, let's continue. Now we have Pygame installed. We're going to head to some environment that we're going to write code in. You can do this in the default IDLE, so the thing that just comes with the basic Python installation, or you can use something like VS Code, Sublime Text, whatever you want. So I'm going to be using VS Code. This just makes it easy for me to run my code by pressing the run button up here. But again, feel free to use whatever you want. You don't need to use VS Code. It doesn't matter what you use. We're just going to do everything in one file anyways. Now that reminds me that before we actually jump in, we need to download some assets for this game. So you saw I had a background, I had those spaceships. All of the stuff, including the code for this tutorial, is going to be available on GitHub. So I will leave a link in the description. What you're going to need to do is download this assets folder mainly. You can download the code file as well, which will be uploaded here with the entire code for this video afterwards. But to do that, you're just going to press the link. It should bring you to a page that looks like this. You're going to press code and then download zip. Now, if you understand how to use GitHub, obviously I don't need to tell you how to do this, but downloading the zip file. So let's actually just do it on here to make sure everything's going to be all good. So I'll put that into my downloads. Then you're going to open up the zip folder. You're going to go inside the interior folder. You're going to grab the assets folder. On Windows, I usually like to just cut it. So Control X, you can also copy it, and you're going to paste it beside wherever your Python file is. So if you have your Python file on your desktop, I would recommend, first of all, you put it in a folder called, Pygame for beginners or whatever. Then just put this file beside it so that you have the assets folder, and then whatever your main Python file is in the same directory. That's really important. So anyways, do that, and then we can go ahead and continue. All right, so apologize for the intro, but let's get into this. The first thing we're going to do now, and notice that I have Pygame tutorial, and then I have my assets in my main.py file. Obviously, create a new Python file, and inside of that file, you're going to type import Pygame. This is just to make sure that this is working. So we're going to import Pygame, then we're going to run the code. You can see it kind of pops up a little terminal right here. And notice it says module not found, no module named Pygame. Now I'll fix that on my end, but make sure you guys don't get this message. If you get, hey, welcome to Pygame or some little text like that, you're good to go and you're ready to continue. So I'll be back after I fix this for myself. All right, so I'm back. You can see I'm now getting the message Pygame 1.9.6, doesn't matter what version you're using. Hello from the Pygame community, and we're all good to go and get started. Now, one last note here. I'm just trying to cover all of the issues that happen. Do not name your Python file Pygame. If you do that, it will not work. So just name it anything other than Pygame. Very important. Okay, now that we have that, let's get started. So first of all, what is Pygame? Well, Pygame is a 2D graphics library that lets you make little games. It's actually really powerful. I've created a ton of awesome projects using Pygame, and well, it's pretty simple to actually set up. The first thing that we need to do whenever we kind of start making a game in Pygame is we need to make the main surface. Now, I usually just refer to this as the window. Again, you can call it whatever you want, but in Pygame, everything that we're working with is usually referred to as a surface, so you might hear me use that term. But anyways, I'm going to start in all capitals. I'll tell you why in a second. I'm going to say win equals Pygame dot display dot set underscore mode. And then inside of here, we're going to put a tuple, and we're going to put the width and the height that we want the window to be. So it's usually good practice to define two variables above this that says width, comma height, and then is equal to whatever you want the width and the height of this game to be. Now, I'm going to make mine 900 by 500. If you're on a really low resolution display, this might take up like a large chunk of the display. So feel free to scale these numbers down. It doesn't really matter what you make the width and the height, but it might affect what you want to make the dimensions of, say, the background or the images later on. Anyways, we're going to say width height equals 900, 500, win equals pygame.display.set underscore mode. And then inside of here, I'm going to say in all capitals, width height. So I'm pretty much telling Pygame, hey, let's make a new window that is of this width and this height, and I've defined those both above. The reason I'm using all capitals here is usually it's just good convention to define all of your constant values in capitals. So our window, even though it may potentially change, is fine to be in all capitals, and our width and height, those are constant. They're not going to change, so I'm making them all capital values. All right, so now that we have that, let's actually start creating our first like Pygame event loop and having something pop up on the screen. So usually what I like to do is I like to define a main function, and inside of this function, I'm going to put all of the code that kind of handles the main game loop in Pygame. So usually when you create a game, you have a loop, and this loop is doing things like redrawing the window, checking for collisions, updating the score, whatever it may be. And anyways, we're going to put that inside of this main function right here. So the first thing that we need to do is set up a while loop. This while loop will be the game loop, and this will actually let our game not just instantly open and then close. So think of it as like an infinite loop, and then we'll terminate it whenever the game ends. So I'm just going to make a variable. I'm going to say this is run, it's equal to true. And then I'm going to say while run. So until we set run equal to false or we break out of this loop will keep running. The first thing that you always do inside of your event loop in Pygame is the following. You say for event in Pygame dot event like that, and then dot get. And inside of here is where you check for the different events that are occurring in Pygame. So don't worry about the fancy syntax, but this is just getting us a list of all of the different events. We're looping through them, and then we can check what these events were, and based on what they were, we can do something different. So the first event that you usually check for is if the user quit the window. So again, I'll show you how all this works later, and we'll go into more detail. But just to get right into it, we're going to say if event.type equals, and then pygame.quit in all capitals. What we're going to do is we're going to say run equals false like that. And what this will do is end this while loop. So effectively quit the game. Now at the very end of this while loop, what we're going to do is say pygame.quit, and this will quit Pygame for us and close the window. So hopefully this is clear so far, but that's all this is doing. We're getting all the events. If quit is an event that occurs, then we'll exit the while loop and we will quit. Now I'll show you what that event is in 1 second, but let's continue. So now that we have that, let's actually go down to the bottom of our program, and let's say if underscore underscore name underscore underscore equals underscore underscore main underscore underscore, then we're going to call the main function. Now, what this is doing, for anyone who's confused, is just making sure that when we run this file, we didn't, it's hard to describe this, but it's making sure that we're only going to actually run this main function if we ran this file directly. So in Python, if you're not aware, you can import modules, right? So let's say I imported this file from another file. Well, if I did that and I didn't have this if name equals main thing, and I just had the main function, in the main line like this, then it would automatically call this and start running the game. Now, we might not want that to happen, and I only want to run the game if we run this file directly, not if this file is imported from somewhere else. So that's why I'm doing this. You don't have to really understand what this means, but the name is simply the name of the file, and main is telling us, hey, this was the main file that was run. That's the best way I can explain it without going into too much depth. But anyways, enough of this. We haven't seen anything yet, so let's run it and see if anything pops up. So we're going to run, and there we go. We get some window like this, right? Black window, nothing, just says Pygame at the top. Now, the quit event is when we press the X on this window. So when I press that, notice that boom, we quit, we're all good because we handled this quit event. If we didn't do that, it wouldn't have quit the window and we would have had to force quit this application, which obviously we don't really want to have to do. So there we go, we've got our first Pygame window popping up, but that was kind of boring. Now I want to show you how we can draw stuff onto the screen and how we can change the name of that window. So usually what I like to do is I like to go up to the top of my program and say pygame.display.set_caption, and I like to give it some name. So here, this will set that little name caption that you saw that said Pygame window or whatever it was. So you can set this to whatever you want. For simplicity, I'm just gonna say first game like that. I'm gonna save, gonna go ahead and run this, and notice that now it says first game where my mouse is here at the top left-hand corner. All right. So now that we've got that, let's start drawing some stuff onto the screen and doing some more advanced stuff. So the first thing I'm going to show you is how we can fill the screen with a specific color. Then we'll start drawing some rectangles and all of that and getting into the game. So to fill the screen with a specific color, this is pretty straightforward. You're going to use the window. So you're going to say win like that. And then you're going to say dot fill, and then you give this a color and it will fill the screen with this color. Now the question is, how do we actually give this a color? What do we type in for the color? Well, in Pygame, all of the colors are RGB, meaning red, green, blue. So what you need to pass is a tuple with 3 values, 1 value for red, 1 value for green, 1 value for blue. If you're not aware of RGB, the ranges of numbers that you can pass in here are between 0 and 255 inclusive. So that means you can include 0 or 255. So I could say something like 255, 255, 255. Funny enough, this is actually white when you look at RGB because you have the most red, the most green, and the most blue. So anyways, I'm not going to actually pass in a tuple like this because this is kind of hard to understand that this is white. I'm going to make a variable at the top of my program here in all capitals. I'm going to call it white. And I'm going to set that equal to 255, 255, 255. Now, instead of passing that, I'm simply going to pass white inside of here. So this way, if someone else is reading my code, they know that, hey, this is the white color. That's what we're filling the screen with. So let's test this out. I'm going to run the program. And why is it not working? Well, the reason this isn't working right now is because we did not update the display. So in Pygame, the way it works is we can draw a bunch of stuff onto the screen, and you'll see that when we start doing that. We draw all these different things, but the display will not be updated. It won't show the most recent things that we drew unless we manually update it. So what we need to do is say Pygame, like this, .display, .update. So now when we update the display, after we fill the display, it will update and it will show us the white. So let's have a look. There we go. Now we are getting a nice white background. You're welcome to mess around with the color and you'll see different colored backgrounds. All right, so there we go. We have white. Awesome. We are making good progress. Now, the thing is, I usually don't like to do all of my drawing inside of this kind of main game loop. I usually like to have the main game loop handling like all of the collisions, all of the logic in the game, and then having some functions outside of that that handle specific things that I can easily call. So what I'm going to do just to clean this up and make it easier, because we're going to be drawing a lot more stuff than just this, is say define draw underscore window. Now inside of here, what I'm going to do is just take as an argument whatever I want to draw. Now in this case, we don't really have anything specific that we want to put on the screen. We're just filling it with a background color. So I'm not going to take any arguments. I'm going to take these 2 lines of code right here, place them inside of this function. So let's do that. And now, right before, inside this while loop, before the pygame.quit, I'm just going to call this function. So now, every time I loop through this loop here, I'm calling draw window, and well, this will draw stuff onto the screen. So let's run this, and there we go. We get the same thing. It is still indeed working. Awesome, so that is great. Now the next thing we need to talk about is frame rate, or essentially how do we control how much this is refreshing? Because if we have a look at this right now, we have an infinite loop, we have some event loop going on right here. And then every time in the loop, we're just drawing something onto the screen. That's fine, but right now we are drawing this white background as many times as we possibly can per second onto the screen. It's solely based on the speed of our computer, right? On my computer, I have a pretty fast machine. This is drawing probably hundreds of times per second. In fact, we could measure it, but I would guarantee it's hundreds of times per second or even thousands. Now, we obviously don't want that because that means on different computers, our game is going to run at a different speed because it's based on how quickly this while loop is running. So to control this, we need to implement something called FPS or frames per second. So I'm going to define a variable up here. I'm going to say FPS. I'm going to make it equal to 60. And this pretty much will define how quickly or how many frames per second we want our game to update at. Now, most standard games that are not like your big AAA games are running at 60 FPS. So we're going to go ahead and just implement a hard-coded FPS of 60. So now what I'm going to do is I'm going to define a clock object in my main function here. I'll discuss what this is in a second, but I'm going to say clock is equal to pygame.time.clock. And inside of my while loop, I'm going to say clock.tick, and then I'm going to put FPS. Now what this is going to do is control the speed of this while loop. So this will make sure that we are going to run this while loop right here 60 times per second, no matter what, unless our computer can't keep up with that speed, in which case it will run as fast as it can. So clock.tick is just ensuring that we never go over this capped frame rate of 60, which is good. That's what we want. It makes our game controllable and we know it's consistent on different computers. So now if we run this, actually, let's just go up here. You notice that nothing's going to change except just internally, it's only running at 60 FPS. Okay, so that's great, but our game is pretty boring right now. We have nothing on the screen. So let's actually go ahead and implement some characters. So I want to have two spaceships, one on the left-hand side of the screen, one on the right-hand side of the screen. I want them to face each other and I want them to be able to move. So let's tackle that next. So what I'm going to do is I'm going to start importing the images that I'm going to use for these spaceships. So I'm going to start by just saying yellow underscore spaceship underscore image. And this is going to be equal to pygame dot image dot load. And inside of here, we're going to load the yellow spaceship image. So if we go inside of assets, we can see that we have 5 things. We have spaceship yellow, spaceship red, space PNG, that's the background, and then 2 sound effects, which we'll get to later. Again, you can download this from the link in the description. It's the GitHub link. So what we need to do is import these images right here. So the red spaceship and the yellow spaceship, we need to load them into Pygame so we can draw them onto the screen. So what I'm going to do at the top of my program is I'm going to import OS. The reason I'm importing OS is because I'm going to use OS, which is operating system, to help me define the path to these images. So these images are inside of the assets folder. The assets folder is in the same directory as our Python file. Remember, that's very important. And then what we're going to do is we're going to look inside the assets folder and then look for these specific images. So to do this, we're going to say os.path.join. This is just a thing that you can do in Python. The reason I'm doing this rather than just separating things with slashes is because depending on what operating system you're on, the directory separator might be different. So this will handle that for us. But os.path.join, I'm going to join the path to the folder assets with the path to the image. So I'm going to say assets and then spaceship like that underscore, and I guess we're doing yellow first, .png. So I apologize that it's hard to read. Let's actually just zoom out a bit so you can see this. We get yellow spaceship image equals pygame.image.load, os.path.join, assets, spaceship yellow.png. So let's copy that line. And I'm going to do the same thing now, except instead of yellow, we're going to do red. So red spaceship image. And now all we have to do is just change this to red because we have the red image right there. So now we have our 2 spaceship images. My formatter's helping me out here by putting them in a way that we can read them. Now what we want to do is draw these onto the screen so we can actually see them. So before I get too complicated and talk about anything more, let's just show these up on the screen or draw them on the screen and see what they look like. So we'll say win.fillWhite. Remember, I'm doing all my drawing from inside of this draw window. And now I'm going to say win.blit. Now you use blit when you want to draw a surface onto the screen. So technically, these images, when they get loaded in by Pygame, are known as surfaces. So we have to use blit to blit them onto the screen. Now, that's kind of a misleading explanation, but you can kind of imagine that anytime you have text or images, you're going to use blit to put them onto the screen, but I'll go through that later. So anyways, win.blit. We're going to say yellow spaceship image because that's our image right here. And then I'm going to define the position on the screen in which I want to draw these images. So remember that our screen is 900 by 500. So 900 width, 500 height, which means that I really should be drawing my spaceship within those dimensions so it shows up on the screen. Now I can draw it off the screen at like a negative coordinate or something, but obviously that doesn't make much sense to do. Now, another thing to note in Pygame is that when you draw something onto the screen, it draws from the top left-hand corner. In fact, it's probably a good point in time now to talk about the Pygame coordinate system. So excuse me because I'm on a mouse. This is going to be really rough drawing, but let's imagine this is our Pygame window. You know, traditionally when we look at like an axis, right, or we look at a graph, you would say that 0, 0 is right here in the middle of the window. Now in Pygame, that is not the case. We don't have that because we don't have these kind of coordinate systems. So in Pygame, the top left, or 0, 0, is the top left. Sorry, so 0, 0, trying to do 2 zeros here with the mouse, is the top left-hand corner, which means as you increase your X, you're going further to the right. And as you increase your Y, you're going further down. Of course, Y being, you know, vertical and X being horizontal. So if I wanted to be at the bottom of the screen and my height was 500, I would draw somewhere like 400, right? And maybe that would put me, you know, like somewhere around here. So just keep that in mind. This is the coordinate system for Pygame. And when we draw an object in Pygame, we draw it from its top left. So it's consistent. If I draw an image at, let's say, what would this be reasonably, like, you know, 500 by 200 or something like that, we will start drawing it from the top left. So the width of the object, or the width of the surface, will, you know, be going to the right, if that makes sense. And then the height will be going down. So even though it's at this position, we're not drawing it from the center, we're drawing it from the top left of the image. So keep that in mind. Okay, now we went through that. So let's draw this image. So we want to draw the top left of the spaceship, or we're picking where we want to put the top left of the spaceship. So in this case, let's just put it at like 300, 100, just to see what it looks like. And in fact, for now, let's just draw the yellow one. So we're going to go ahead and draw this, and that's great. Okay, so it's taking up a good chunk of the screen. This is obviously too big. We're going to have to shrink this down, but there you go. You can see the spaceship showing up on the screen. Awesome. Now keep in mind though, if I were to draw this spaceship before I were to fill the screen, so if I do something like this, then what do you think is going to happen? So I'd go ahead, I'd draw the spaceship, then I fill the screen with white, and then I update. What do you think is going to happen? I'm going to run, and we don't see the spaceship. The reason we don't see the spaceship is because we drew the spaceship before we filled the screen. So the order in which we draw things matters, and we can draw over top of something. That's totally valid. That happens all the time. Okay, so just keep that in mind. So now we have the yellow spaceship. And what we want to do now is resize this spaceship so it's a bit smaller. So we should pick the dimensions we want to resize it to. And then we also should rotate this spaceship so it's facing the correct direction. So I'm actually going to start by resizing this image, and then I will rotate it. So I'm going to say yellow underscore spaceship like this. And this is going to be equal to, and then I'm going to resize and rotate this image in the same line. I'll show you how to do both of them. So in Pygame, to resize something, you're going to say Pygame dot, not image, sorry, dot dot transform like that, dot, and then scale. And inside of here, you're going to pass the image that you want to resize. So we're going to pass yellow spaceship image like that. And then you're going to pass the dimensions that you want to resize this to. So our spaceship was pretty wide. It wasn't that tall. We could look at the aspect ratio to determine what we want to resize this to, but I'm going to go with 55 by 40. So 55 width and 40 height. If we consider that the dimensions of our screen are, or what are they here, 900 by 500, that seems like a reasonable size to make our spaceship, but feel free to make this larger, feel free to make it smaller, feel free to make it square, mess around with it and see what you get. But anyways, that's going to scale our spaceship now, so it'll be much smaller. So let's do the same thing for the red spaceship. So let's say red underscore spaceship like that is equal to pygame.transform.scale, and then red spaceship image. We're going to resize it to the same thing, 55 by 40. Now, since I'm using these numbers multiple times, and I might use them later on, makes sense to just throw them in a variable. So I'm just going to say, spaceship underscore width, and then spaceship like that underscore height is equal to, and then 55 by 40. And now I'll just replace these values just in case we ever want to change this. It will work everywhere in the program. So spaceship width, and then spaceship height like that. Let's copy this, and let's simply put it here. Okay, so now that we have that, before we rotate it, let me actually just update this. So instead of drawing a yellow spaceship image, I'm just drawing yellow spaceship, because yellow spaceship, I know it's kind of messy to see here, is now the one that is scaled down. So let's go ahead and run this and see what we get. And now we get a much smaller spaceship. That looks much better to me. Maybe it needs to be a bit taller, but honestly, totally fine. So let's leave it at that. Okay, so now we need to rotate this image. So to rotate it, I'm actually going to go and find yellow spaceship. And in fact, let's separate these to make it easier to see. And I'm going to wrap this scale within a rotate. So you'll see how it works, but let's go Pygame dot image dot rotate. Oops. Like that. Okay. And now, I know it's confusing with the brackets. I'll go through it. We're going to pick the angle that we want to rotate this at. So I'm pretty much saying pygame.image.rotate. This is the ending bracket at the very end there. We're plugging in this as the thing that we want to rotate, which is the scaled down yellow spaceship. And we pick how much we want to rotate it. So rotate it. I want it to rotate to the right, and I want to rotate it 90 degrees. Now let's see if that's correct. We might have to rotate it 270. I forgot which way it was facing originally, but let's see if this actually gives us the rotation. So let's run. And there's no Pygame. Oops, sorry guys. This is not pygame.image.rotate. I just got an error there. This is pygame.transform.rotate. So make that fix there on line 15. Okay, so run now. And there we go. We can see it's facing the correct direction. Okay, so we've done that successfully now with the yellow spaceship. Now we want to take the red spaceship and rotate it, but so it's facing the other way. So let's copy pygame.transform.rotate. Let's wrap this here again. And then let's go comma, and let's rotate this one 270 degrees because we want it to face the other way. So now we can draw the red spaceship as well. So let's go down here and let's say win.blit. Oops, didn't mean to open that. Win.blit. Let's blit the red spaceship. And let's put it a little bit further away. Let's put at 100, 100. Or actually, let's put at 700, 100. Okay, so take a quick look at this. Make sure your code matches. Now let's run. And there we go. We have our two spaceships facing each other. All is looking good. Okay, so now we have the spaceships. Now I want to show us how we can move these spaceships around. So to move these spaceships is not actually super complicated, but we need a way to keep track of their X and Y position, I guess, as well as their width and height, and then to change that position and pretty much just change where we're drawing them to be at their X and Y position. So what I'm going to do now is I'm going to write a little bit of code. I'm going to go a bit faster than I've been going. And then of course we'll stop and go over everything to make sure that you guys understand. Let's go down into our main function. And now what I want to do is I want to define two rectangles, which are going to represent my yellow spaceship and my red spaceship so that I can control where they're moving to. So just follow along and then we'll explain what it is. So red equals, and I'm going to say red, this is going to represent our red player, is equal to pygame.rect, like that. And inside of here, what I'm going to do is simply define the position or a rectangle that represents this red spaceship. Now you'll see why we're doing this, but the arguments, for the rectangle are X, Y, width, and height. So I define the X position, the Y position, and the width and the height that I want my red player to be at. So we already know what the width and the height are going to be because that's going to be equal to whatever we scaled our spaceship to, right? Which was spaceship width and spaceship height. Good thing we stored that in a variable. But the X and Y we can pick. Now we want the red spaceship. I mean, we can decide this, but let's say we'll put it on the left-hand side of the screen. So in that case, let's make its X and Y something like this. So we'll make its X position 100, and let's make its Y position 300. And then for its width and height, we already know what this should be, spaceship width and spaceship height. Okay, so now we're gonna do the exact same thing for the yellow player here. So let's, instead of red, let's change this to yellow. And then let's just change its X position so it's over near 700, so they're far away. All right, so now we have red and we have a yellow rectangle. All I'm gonna do now is I'm gonna pass this rectangle, so actually both of these rectangles, red and yellow, over to my draw window function. So now inside of draw window, I'm simply gonna take red and I'm gonna take yellow. And rather than drawing my yellow spaceship and my red spaceship at a kind of predefined position, I'm going to draw it at whatever position my red and yellow argument are at. This way I can modify red and yellow, and when I pass it to draw window, it will change where we're drawing these rectangles. So or these spaceships, sorry, rectangles just because we're representing them with rectangles. But for our yellow spaceship, we're going to draw this at yellow.x and yellow.y. Now, the reason we have access to .x and .y is because yellow is a Pygame rectangle, and it defines that the x is this and the y is this, so it just makes it really nice for us to use. So yellow.x, yellow.y. Now for red, we're going to say red.x and red.y like that. So now we draw a red in our yellow spaceship. Now to show you how this would actually move around, let's just do something really simple. Every single loop, I'm going to move my yellow spaceship 1 pixel, just so you guys can see it moving on the screen. So I'm going to say yellow.x plus equals 1. All this is going to do is add 1 to the yellow x position and move it. In fact, let's actually change this to red because red will have more time to move. So this will move 60 pixels per second because the clock is ticking at 60 FPS, and we're updating the X position 60 times and adding 1 to it. So hopefully that's clear, but let's run this. And now notice that we have a red spaceship moving in the incorrect direction on the screen. And I noticed that I actually put these spaceships on the wrong side because of the way that they're facing. So we have two options. We can change where they are. So we can just change 700, 100, or we can change their rotation. I think it's easier to just change this right here. So let's change 700, 100, so they are on the right side of the screen. Let's run this. And now you can see it's moving backwards, but they are on the correct side of the screen. Now, the reason this is moving again is because we're updating the X position and we're drawing it at the X position. So as we change red here, well, we're passing that updated red over here, and then it's moving, right? So hopefully that's clear. But anyways, that is how we would move it. So now what we need to do is we need to actually change the X and Y position when we press the arrow keys, right? So that we're moved based on the user input. So we have two things that we need to check. We need to check whether the red spaceship is moving or whether the yellow spaceship is moving. Now, let me just run this one more time. Yellow spaceship is on our left, red is on our right. So we want to use WASD for the left and the arrow keys for the right spaceship because that just intuitively makes sense on the keyboard. So let's start doing this. I'm going to start doing it for the WASD keys. So for the spaceship on the left, which I can never remember. I think it's the yellow one. Yeah, it is the yellow one. And then I will show you how we can do it for the red and how we can kind of clean up the code a bit. So there is multiple ways to do this in Pygame. You may have seen if you've watched other Pygame tutorials of mine that I don't use the method I'm going to use here. The reason I'm going to show you this method is because this allows you to press multiple keys at the same time, whereas the other method I've shown previously, which I'm just not even going to bother showing here, only lets you press one key at a time. And actually, we'll show it later in the video, so I can talk about it then. But anyways, what we're going to do is say keys underscore pressed is equal to Pygame dot keys, actually, sorry, just dot key dot get underscore pressed. What this is going to do is every single time this while loop is running and we reach this line, so 60 times a second, it's going to tell us what keys are currently being pressed down. This way, we can just look at all of the keys, check if the ones that we're looking for are pressed down, and if they are, respond to that press. This also means that if the key stays pressed down, it will still register that it's being pressed. So it's super useful, and well, you'll see as we get into this how this works. But all we have to do is say if keys underscore pressed, and then inside of here, pygame.k underscore, and then the name of the key that we're checking for. You can kind of see a list is popping up on my screen here on how they work. The ones that are special keys are in all capitals, and the ones that are just letters or numbers are usually just lowercase, although I guess you can't really capitalize a number. But anyways, we're going to start by checking up, down. No, we'll go left, right, up, down. So the first key is going to be A, so this would be left, right? So let's just leave a little comment here. Let's say this is left. So if we press the left key, what should we do? Well, we should move the spaceship to the left. How do we do that? Well, if we looked at the top left being 0, 0, that means if we're going to the left, we're moving closer to 0, 0 on the x-axis. So let's subtract from our x value to move us backwards or to move us to the left, right? So closer to 0, 0. So this, since this is for the yellow spaceship, we're going to say yellow.x minus equals, and then what should we minus here? Well, how much we want them to move when they press down this key. Now, since we're going to use this multiple times, it makes sense to go to the top of our program. Right after FPS, we can say velocity or vel is equal to, and then I'm just going to set this equal to 5. Feel free to change that around and make that whatever you want. But let's make that 5. And now let's say yellow.x minus equals velocity. Now, before we go any further and get into more keys, let's test this and see if this is working. So keys pressed equal pygame.key.get_pressed gives us a list of all the keys. We check with this expression right here if the A key is being pressed. If it is, we modify the X, so subtract values from it, which will move us to the left. So let's try this. I'm going to press the A key and notice that I can move left. Obviously, I can't go anywhere else. There you go. And now I'm off the screen. So that's something we're going to have to check as well. If we're off the screen, we're not going to have to let someone, or we're going to have to disallow someone from moving if we're off the screen. But for now, that's fine. We'll do that after. So now let's handle the other keys. So we can actually copy this line right here. Let's fix the indentation. Now, instead of the A key, let's do the right key, which is going to be D. So let's change this comment to right. I actually just want one space for my comment here. And now yellow.x, since we're moving right rather than subtracting the X, we want to add to the X. So let's add to it like that. And now let's try both these keys. So now I can move left and right, but I cannot go up and down. And keep in mind, I can go off the screen in either direction. So again, something that we're going to have to check. Okay, so we've done that now. Now let's do the up and down key. So we can copy this again. And this modification will be pretty easy. So now for up, that's going to be W. For down, that's going to be S. So let's change this comment to be up. Let's change this comment to be down. And now instead of the Y being modified, or sorry, instead of the X being modified, I kind of spoiled it, the Y is going to be modified. So that's actually all we have to do. But what this is doing now, if we're moving up, we need to subtract from the Y because the top left is 0, 0. So when we go down, that's adding to the Y. So when we go down with S, we add to the Y value and that will move us down. So let's save that. Let's check this. I'm going to run. And now I can move up, down, left, and right, and kind of on diagonals because I can press the same keys at once, right? So if I press down and left, or I press up and right, you can see that I'm moving diagonally. So that's great. Now what I want to do is actually take this, and I want to put this in a separate function because it's going to get kind of messy if I'm doing this twice inside of this loop right here, right? So I'm just going to copy all of this code that I just wrote. I'm going to write a function here. I'm going to say define yellow underscore movement like that. Now, actually, we could say yellow handle movement or something that makes more sense. Yeah, yellow handle movement. Inside of here, it's going to take an argument called keys. And all I'm going to do is the exact same thing that I had before. And actually, this argument is going to be called keys underscore pressed. And I'm also going to take in yellow. Now, it may seem that this is overcomplicating things, but trust me, it's going to be nicer when we do the other movement for the other character. We're taking in that keys pressed list. We're also going to take in the yellow character. Our code doesn't change whatsoever. We've just moved it so that it's kind of separated and it's easier to see. So now what I'm going to do inside of this loop is I'm going to call yellow underscore handle movement like that. Really, I probably should have called it handle yellow movement, but that's fine. We're going to pass keys underscore pressed, and then we're going to pass yellow like that. Now what this will do is it will give the keys pressed list that we need, and it will give our yellow character, and then we'll just do everything we were doing before, but inside of this function. Now, you can probably guess how we're actually going to handle the right players, or what am I saying, the right players, the red player. All we need to do is copy this function. We'll just do a paste like that, and now we're going to do the exact same thing, except instead of yellow, it's going to be red, and instead of ADWS, it's going to be up, down, left, right, or I guess left, right, up, down. So let's change this to red. Let's change the name of this function to red as well. And then we can just change all of these yellows to be red. I'm just going to do them manually, but if you're fancy, you could use the find and replace. All right, so exact same thing. Now we're going to change our left, right, up, and down. The arrow keys are really easy. It's literally just K underscore left, K underscore right, oops, K underscore down, and K underscore, oops, well, I did in the wrong order. K underscore down, K underscore up. All right, so that should be good. We don't need to change anything else. Now all we need to do is call this. So let's call this function red underscore, if we could do it in the right case, red underscore handle movement. Let's pass it the same thing, keys underscore pressed like that, and then red. Now the red movement will be handled. Let's make sure this is all working. So let's run this. And you can see that I can move my left guy, and now I can move my right guy, and they move at the same time with no issues. Awesome. So that is great. We're making good progress, but now we can move off the screen, right? So we need to handle this so that we can no longer move off of the screen. But before we do that, just because it's going to make this part easier and less repetitive, let's handle the fact that in the middle of our screen, we want a border, right? So I don't really want my red and yellow spaceship, because you remember the game we made at the beginning, to kind of be able to face like right beside each other. I want them to have their own halves of the screen and not be able to cross over. So let's make a rectangle that's kind of a border and divides the middle. And then we'll draw that on the screen and make it so that our characters can't move past that border. So let's go to the top of the program. And we're just going to define wherever we want. It doesn't really matter. I'm going to say border in all capitals. And this is going to be equal to Pygame, you guessed it, .rect. This is just going to be a rectangle. And we'll just draw this rectangle onto the screen. So I need to pick where this is going to be. So let's be clever about this. Where should my rectangle be? I need the X and Y position, and then the width and the height. Well, the X position we'll need to figure out. The Y position is obviously going to be at 0 because we want to start at the top of the screen and go all the way down. So we're going to say Y is equal to 0. The width and the height. So the width, we can kind of pick what we want the width to be. I'm just going to make it 10. The height needs to be the height of the screen because we're starting at 0, so it needs to fill the entire screen. And then the X is what we need to figure out. So I want this to be exactly in the middle of the screen, which means I can say width over 2. That's going to give me 450, right, to be in the middle. But then, since we have a width of 10, let's just go to paint here quickly. I'll show you what happens if we do that. So let's say we have our screen. You know, this is width over 2, and this is like right in the middle of the screen, okay? So this is me trying to do a 5 with my mouse. This is 450, okay? Now, if I draw a rectangle here that has a width of 10, what's going to happen is, I know this is like a really exaggerated width, but we're going to draw it like this, right? I don't want to draw it like that. I want to draw it like this. So how do I do that? Well, I need to subtract half of the width so I can figure out where the 0, 0 position of my rectangle should be. Because really, I'm not drawing the rectangle from the middle, I'm drawing it from 0, 0. So I need to draw it such that it will be in the middle of the screen when I draw it, if that makes sense. So anyways, the point of this is saying that if we have a width of 10, I need to subtract 5 from its X position, so put it at 445, so that way it draws in the middle. So let's do that. Rather than, I guess, since our width is hard-coded, I'll just subtract 5. And now, once we draw this on the screen, you'll see that it is right smack in the middle. So let's draw this. Let's go here, and let's say win.blit. No, it's not going to be... Actually, okay, you guys are going to be confused by this, but we're going to draw this another way. So we're going to say Pygame.draw.rect. So we're taking a rectangle. And what I'm going to do is I'm going to say we're drawing this on the window. So the arguments for this specific Pygame function is the window or the surface that you're drawing this onto, in this case, just our main window. Then we need to pass a color that this rectangle is going to be. So I actually want this to be black. So what I'm going to do is define another color here. I'm going to say black is equal to 0, 0, 0, because, well, that's the color code for black. It's just none of red, green, or blue. So anyways, we define black. So now we're saying we're drawing on the window. It's color black. What are we drawing? Well, we're drawing a rectangle. So I just pass in my rectangle, which is border like that. Because border is equal to a Pygame rectangle. So that's all we have to do. So let's go ahead and try this. I'm going to press run. And now we get a nice black border right perfectly in the center of the screen. Now, of course, I can still go over it. Notice that we're drawing actually below the border. Are we on top of it? No, we're on top of the border. Okay, that's fine. It doesn't really matter if we're on top of the border or not. But now we need to make it so that we can't actually cross this border. So really, all we have to do to make it so that we can't go off the screen is not let our player move if they're going to move off of the screen. So we just check if pressing this key would move them off the screen. And if it will, then we'll just not let them press it. So inside of my yellow and red handle movement, it's kind of annoying. I should have done this before so we could have just copied it in. We're just going to make sure that we can't move off the screen or into the border. So for yellow, on the left-hand side of the screen, yes, on the left-hand side of the screen, what we're going to say is and, just in this if statement right here. And we're going to check if by moving to the left, we would have a position that is in the negatives. So that is not equal to at least 0. That would tell us that we're off the screen because the 0, 0 of our image would be, well, not on the screen. So I'm just going to say and yellow oops, did I mean to press that? Yellow.x minus velocity is greater than 0. So what this will tell us is if when subtracting the velocity from our current y position, that will be greater than 0 or not. If it is, we won't let ourselves move any further to the left. So the reason I'm doing minus is because we're obviously going to subtract to move to the left. Now we'll do the exact same, well, actually, we're going to do a different thing for the right. We're going to say and yellow.x plus velocity. The reason it's plus is because now we're moving to the right. Now in this case, we don't want to check if it's greater than something. We want to check if it's less than something. Now what do I want to check if it's less than? Well, I want to check if it's less than the border in the middle of the screen, because if we look at the screen, right, this is on the left-hand side, we don't want to be able to move past that border, which is in the middle of the screen. So we'll get the border's x position and we'll put that here. So we'll say border.x. So this will not let us move past the border's x position. But the issue with this is you have to remember that we're drawing the image from the top left. So technically the width of the image can still move over the border because the 0, 0 position wouldn't be past that x. Now, hopefully that makes sense, but to show this to you again, we go back to trusty paint. We have our border in the middle of the screen. Let's say this is our rocket ship like this. Technically, this 0, 0 is less than this border's x, but its width is over top of it. So what we need to do is check the width of the image as well and make sure that the 0, 0 plus the width of the image isn't going to be over top of that border. So a lot of explaining here, but all we have to do for that is simply say yellow.x plus vel plus yellow.width like that. And again, this is another property of the rect. We can call it .width, and that will make sure that we are not over the border. Okay, now we'll do the same thing for up and down. So for up, it's really easy. We're going to say yellow.y minus the velocity is greater than 0. And we'll do the exact same thing here, except instead of the width and the x's, we're just going to check the heights. So we're going to say yellow.y, yeah, plus velocity, plus yellow, not .width, but .height is less than, and actually, in this case, it's not going to be border.y. This is simply going to be height, because it gives us the height of the screen. So this is making sure that the height and our image cannot move further down past the screen. Now let's just test this, then I'll do the same thing with red. So run, and now notice that I can't move any further down the screen, okay? I can't move left off the screen. I can't move right off the screen, and in fact, this is blocking quite a bit, and same thing here. Now, there's a slight problem going down. I'm not sure exactly what that is. All right, so I just paused for a second because for some reason my yellow guy can move further down the screen. I'm not actually really sure why that is. So a simple fix for this, I don't usually recommend this, but since it's not that important based on the game we're making, I'm just gonna add a few pixels to this right here. So I'm pretty much gonna say and yellow.y plus velocity plus yellow.height is less than, and then height minus 5. Now what this should do ideally is just make it so that we can't move as far down. So let's just rerun this. And actually, sorry, this is already running. So let's close that and run again. Okay, now we can move. Okay, so 5 clearly wasn't enough. We can't move as far down now, but let's just make this 10. So let's go height minus 10. Now let's run the game. And same thing, eh? Okay, so let's make this a bit more. Let's make this 15 pixels. Let's run. Let's see it. And there we go. Now we're like perfectly at the bottom of the screen. Okay, so that's what I wanted. Now you might be wondering why on the other edges we're not like touching them immediately. That's because the actual size of this image is a bit bigger than what's showing up on the screen. That's sometimes a problem. Like if you take an image and it's like really small compared to the actual dimensions of the image, then the rectangle around that image is going to be bigger than what the actual image is. So that's pretty much why we can't cross this border here, because this image actually kind of extends further out. You just can't see it because it's a transparent background. Anyways, hopefully that makes sense. Let's do the same thing for red now, and then let's get into firing bullets and some more fun stuff. Okay, so close that. Oh, I launched this game like 12 times. Okay, great. Okay, close it. All right, so now we're just going to copy this and do the same thing for red. So instead of yellow, just change this to red. We can literally copy everything and just change all the yellows to red. So and red, oops, not like that, and red.x, and red, copy this one here. This one will be red, and same for this. Okay, and red, and red. All right, so now we have that. Let's just test this last time, make sure all is good. Come on, run. What's happening? Invalid syntax. Where did I make a mistake? Let's see. It is saying, I can't even see because my window's not big enough, at red.x. I forgot the and sign on all of these. Great. Let's add the and sign back, or the and word, I guess. Okay. Run now, and there we go. There. So now yellow's good, red's good. But red, see, so red can move across the border. Now, the reason red can move across the border is because I forgot that we need to limit how far it can move to the left, not to the right. So let's go to red, and actually we do need to change some of these things. So for moving to the left, rather than checking if it's greater than 0, we want to check if it's greater than the border dot x plus the border dot width. Okay, so we're going to have that there. Then for moving right, this isn't going to be reliant on the border. This is going to be reliant on the edge of the screen, which is simply going to be the width of the screen. So hopefully that's clear why we're doing this, but now we're making sure that we can't move further left than the border, and going to the right, this is different than yellow, obviously. We can move as far right as we want so long as we don't go off the screen. So let's run this now, and let's try red. And there we go. We can't move to the back of the screen. And the border, yeah, we can't move past the border either. Down is good. Up is good. Awesome. We are looking good. All right, so now what I want to do, since we've just finished that, is I actually want to start talking about bullets. So how we can actually have projectiles firing around the screen. Now, this is a little bit more difficult than what we just did, but of course it's important to cover in this tutorial. So to handle bullets, what we need to do now is have a separate key that each character, each person can press that will fire a bullet or a projectile from their character. So to do this, we need to maintain a list of all of the bullets. So the first thing I'm going to say is bullets is equal to an empty list like that. We also need to decide how fast we want these bullets to go. So I'm going to make a variable here. I'm going to call this bullet underscore velocity. And we can either decide to make this slower than the characters or faster than the characters. But since I want this to be faster and make it a bit harder, we're going to make it 7. Again, feel free to play with these numbers. So we're going to say bullet vel equals 7. So now what we need to do is make a way for us to actually create a bullet and have it kind of fired around the screen. So I'm going to show you now how we can handle the presses of the left and right control. So usually I would use something like the space key to fire a bullet, but since we have multiple people playing on the same keyboard, we can't use space because only one person can press that. So I think it makes sense to use the left control and the right control to press to fire the bullets. This way, you don't get sticky keys when you're pressing the shift key, which is what I would have done previously. And obviously, we don't want to use enter and caps lock because, well, caps lock is not an intuitive key to fire a bullet. So we'll go with right and left control. Now, we're going to do that, but the thing is, I want each player to have a limited number of bullets. So I don't want them to be able to just spam bullets as many as they want or fire them like rapid fire on the screen. So that also means that I don't want players to be able to hold down the key to shoot bullets. I want them to have to press the key each time so they have like a very methodical shot, right? Not like, say, in Call of Duty where you're just holding down the trigger the entire time. I want them to have to actually press it each time. So let's do that. The way we're going to do that is by not handling the key presses this way. We're going to handle it this other method. There's not really names for them, so it's hard for me to describe them, that I talked about at the beginning of the video. So what we're going to do is say if event.type equals Pygame.keyDown like that. Now this is telling us, hey, we pressed a key downwards. Then what we're going to do is fire a bullet. So we need to check whether we press the left control or the right control. So if event and then, oops, like that, dot key is equal to Pygame dot, and then this is going to be K underscore left. I think it's LCTRL. Yeah, LCTRL is left control. And then otherwise, we'll say if event.key is equal to Pygame.k underscore R CTRL, standing for right control, then we will kind of create a bullet for our character. So the idea here is that I want to have a list of bullets. This list is going to store all of the red player's bullets and all of the yellow player's bullets. Or in fact, to make this easier, let's actually just do 2 lists. Let's say red underscore bullets equals that, and let's say yellow underscore bullets equals that. So what we'll do is we'll have the red bullets list store all of the red players' bullets, yellows will store all of the yellow players' bullets, and then we'll move these bullets around the screen and kind of add them to the list. So to create a bullet, we'll just add one to the list, and then we'll draw these bullets at their X and Y position, and we'll automatically move them so that they're going kind of in the direction that they were fired. So the first thing is to create the bullet, obviously. So to do this, for left control, we want our bullet to be going to the right. So let's do that. So we're going to say, I guess, who is on the left? I always forget. I think it's yellow. Yeah, yellow is on the left. We're going to say yellow underscore bullets dot append. And just to make this easier to read, I'm going to say bullet. And the bullet is just going to be equal to a Pygame rectangle. I don't have any fancy images for this one. So we're just going to say Pygame dot rect like that. And we're just going to create a rectangle that is at the position that we want to fire it from. So if we think about this, where should we place the bullet? Well, the bullets really should be placed at wherever the yellow character is, right? We want the bullet to come from their body. So since the yellow character is facing to the right, the bullet should kind of spawn or appear at the edge of their body. So at their X position plus their width. That way, immediately when you press the fire button, you see the bullet kind of coming out of the character. So to do this, we're going to say that the X position of our bullet, and we're just going to make it a rectangle again, is going to be at yellow.x plus yellow.width, like that. Now, if we think that this is too far away from the character, because remember, the width of the image is a little bit further than the actual character itself, we could subtract a few pixels and it would be like more inside. Doesn't really matter, but anyways, we'll just say bullet equals pygame.rect yellow.x plus yellow.width. Now for the height, we can say this is going to be yellow dot y. Now this is going to be weird, but we're going to say yellow dot height over 2. So we're taking the yellow dot y position, which is the top left-hand corner of the image, and then we're adding the height of it over 2. The reason for this is that so that it comes directly in the middle of the character, because if we did it from yellow.y, it would come from the top left of the character, which we don't want. We want this to come from the middle of the image. So we simply add half of the height to put it in the image, to put it in the middle. And really, if we want to be even more precise, we should then subtract, or we should then add, depending on what, actually, it's going to be subtract in this situation, half of the height of the bullet. So the height of the bullet, I think, is just going to be 5 pixels. So I'm just going to subtract 2 because I don't want this to be a decimal number. But anyways, you guys will see. I apologize. This is a lot to take in at once, but I just want to make sure this is perfect. So yellow.x plus yellow.width to put that in the middle X position, or sorry, to put that on the edge of the image. Then yellow.y plus yellow.height over 2 minus 2. This is so the bullet comes directly from the middle of the character. Then the width of the bullet is going to be 10 pixels and the height is going to be 5. So that is our bullet. And then all we're going to do is append this into the yellow bullets list. Perfect. So let's copy this and let's do the exact same thing except for red for our right control button press. So now instead of having yellow.x, this is just going to be red. And we'll literally copy the same thing, except we need to remove this plus red.width. The reason for this is the red character is facing to, I guess, the left of the screen. I know my hand positions are probably wrong, but it's facing to the left. So its bullets are going to move towards 0, 0, which means we want the bullet to come out of actually the left side of the character, not the right side of the character. I would run this, but there'll be a crash right now if I do that. So let's actually, I'm just going to try to go through this. The character is facing to the left, so we want to start drawing the bullet at its actual left edge, which really is its just X position. So instead of adding the width to it like we did with yellow, we're just going to put red.x. Now the height will be the same thing because we do want it to be in the middle for the height, so red.y, and then red.height, and then literally everything else is the exact same. It's just the edge in which this bullet is appearing, we want to be different. Okay, perfect. Now, last thing, and there's actually more before I can show you these bullets firing. We want to make sure that each player has a finite number of bullets. So to do this, we need to define another variable, and we're just going to call this num underscore bullets like that. Or actually, to make it more clear, we'll say max underscore bullets. And we'll set this equal to whatever we want. I like 3. You guys can change that, but I like 3 bullets. So now, before we actually go ahead and check if we can do the left control or we can do the right control, we want to make sure that we don't already have 3 bullets fired on the screen, because if we do, we need to wait until those bullets disappear, go off the screen, whatever, before we can fire another one. So I'm going to say, and the len of right, what am I saying? Right. Red, no, this is yellow. Yellow underscore bullets is less than max underscore bullets. So if the amount of yellow bullets that we have, which is defined by the length or the number of bullets in this list, is less than our maximum bullets, we can go ahead and fire another one. Otherwise, no, don't add another bullet to the list because we already have the maximum on the screen. Now, same thing here. And the len of red underscore bullets is less than max bullets. Perfect. Now, this will allow us to actually fire bullets on the screen. Now, because it's going to take a second before we actually see these, I'm just going to print out red underscore bullets and then yellow underscore bullets. So this way, when I start pressing the right and left control key in my console down here, where all this gibberish is appearing, you will see it popping up the bullets list. So let's do this. You can see that it's empty. Now, when I press control, boom, there you go. We have a button or a bullet inside of the list. I press control again. I press the other control, and you can see that there we go, going ahead and adding to the list. Now I realized as I did that, and good job we did, that here, instead of having yellow bullets, this needs to be red bullets dot append, because obviously that just wasn't working with yellow. It was adding all of them to the yellow list, which we didn't want. So hopefully that's clear, but that's how we have the bullets. Now they're in the list. When I press left and right control, boom, they're getting added. And well, it will work the maximum. It just wasn't working before because we had a bug. This was yellow instead of red. Okay, perfect. Now we have that. Now we need to move the bullets and we need to see if they hit any of the characters. So what I'm going to do is I'm going to make another function that can handle this for us because it makes sense to kind of separate everything out. So what I'm going to do is I'm going to make another function down here. I'm just going to start typing it out, then I'll define it above. And I'm going to say this one is handle bullets like that. Now we're going to pass the yellow bullets, the red bullets, and the yellow character, or the yellow rect, as well as the red, I guess as red as well. The reason for this being that we want to check if any of these bullets collide with either of the characters, because if we do, well, we'll need to do something about that, right? And same thing, we need all of the bullets so that we can handle moving them around the screen and drawing them and all that. All right, so now let's code out this handle bullets function. So let's go here. It doesn't really matter where we put it. And let's say define handle underscore bullets. Let's have this take the yellow bullets, the red bullets, the yellow character, and the red character. Okay, so what this function is going to do is move the bullets, handle the collision of the bullets, and handle removing bullets when they get off of the screen or collide with a character. So what we'll do is we'll loop through all the yellow bullets, check if they've collided with the end of the screen or with the red character. Then we'll loop through all the red bullets and do the same thing except with the other character. So let's do this. I'm going to say for bullets in yellow underscore bullets like that. Then I'm going to start by moving the bullet. So since it's a yellow bullet, it's coming from the left, which means we need to move it to the right because it's coming from the character on the left. So we're going to say bullet.x plus equals the bullet velocity to move it to the right. So we move it, and then after we move it, we're going to check for collision. So we're going to say if yellow, now there's this fancy thing in Pygame called collide rect, and we can pretty much check if the rectangle representing our yellow character has collided with the rectangle representing our bullet. So this is pretty easy. All we do is just pass bullet right here, and what this does is tell us that, hey, yellow did collide with the bullet, or the bullet did collide with our yellow rectangle, or it didn't. So this is true or false, but this is a really easy way to check for collision. Use collide rect. Keep in mind this only works if both objects are rectangles, which they are, and that's why I used the rectangles. Okay, so now that we have that, we're going to do something kind of fancy. If we collide with the yellow character, the first thing that we need to do is remove this bullet. So we can just say yellow underscore bullets dot remove, and we can remove the bullet. That's fine. We're going to delete the bullet because it's gone. It collided. But we need to tell our main game loop down here, somehow that we collided with the red character, right? We need something to pop up. We need to remove health, whatever it is. We need to do something. But I can't directly modify anything in my main game loop from this function, right? Other than the stuff that was passed to it. So what I'm going to do is I'm going to post an event. Now in Pygame, there's these things called events, right? Just like event.quit, just like event.keydown, right? Whatever. We're checking the types equal to pygame.keydown, pygame.quit. So I'm going to post an event, create a new event, and then we can check for that event inside of here and do something if that event occurs. Now this event is going to be red collided, or, you know, bullet hit red, or red hit, or whatever we want to call it. We'll do the same thing for yellow, but we're going to post an event that we will then check for in this while loop. So to do this, we need to first create this event. So I'm actually going to go up to the top of my program here. We'll do like kind of a new section. I'm going to say, in all capitals, yellow underscore hit, and then we'll say red underscore hit, like that. And this is going to be equal to something that's kind of weird, but pygame.user event +1. And for this one, pygame.user event +2. This just represents the code or the number for a custom user event. Since we're going to have multiple user events, we can add 1 to this one and add 2 to this one. So now we have 2 separate user events that we can check for and handle. I know this is strange, but this is how you create a new event. You say pygame.user event plus some number, obviously going up in sequence. So +1, +2, +3, +4. If these were both +1, they would be the same event because they would have the same underlying number representing them. This right here, to my understanding, is really just a number. Like it's, you know, 450. It's some number. We don't know what it is. We just add 1 to it to make sure we have a unique event ID. That's pretty much what we're doing. So yellow hit and red hit, those are my 2 events. So we're going to go down here. We're going to go into here, sorry. And up here, we're going to say pygame, like this, .event.post. And we're going to post a pygame .event. I think it's .event like that. And inside of here, we're going to pass the event that we want. Now, actually, sorry, this should have been red, not yellow. So red.collide rect, because we're checking if the yellow bullet's hitting the red character. So you guys probably saw that, but that should be red. And the event we're going to pass is, or post, is red underscore hit. So this is telling us, or we're making a new event that's saying that the red player was hit. Now we'll literally copy all of this and do the exact same thing for not our yellow bullets, but for our red bullets. So we'll say red like that. We'll change red to yellow. And then instead of yellow bullets, this is going to be red bullets. Instead of red hit, this is going to be yellow hit. Now this is the exact same thing, except now we're checking the red bullets, but we need to move the red bullets in the other direction because we're firing from the right of the screen, moving to the left, closer to 0, 0. So we subtract the bullet velocity. So this handles our yellow bullets. This handles our red bullets, and that should be it for moving the bullets. So let's actually try this out, and let's see how many mistakes that I've made, assuming we made any. So refresh. We have our 2 ships now. I'm going to press Control, and we got an issue. Deprecation integer is required, but got type float. I'll be right back. Just going to have a look at what the issue is here. All right, so I found the error, pretty silly one. I should have came up with this. Pretty much we cannot have floating points when we create a new Pygame rectangle. So for both of our bullets, we need to actually put 2 slashes here for integer division. It's fine. This is going to round anyways. It'll be okay. But we just need to do integer division. So red.height integer divided by 2, yellow.height integer divided by 2. So that way we don't get any floating point issues. Now, same thing here with this border. So I'm going to go to our border and we have width over 2. We're just going to change this to over 2. So that way, again, we don't have that floating point issue that we were running into before. But this was indeed working despite of those 2 issues. So just fix those division signs to be 2 division signs, so //. But I realized that we're not drawing any of these bullets. So let's draw these bullets onto the screen because it's going to be hard for me to show you that it's working without drawing them. So inside of our draw window now, I want to take, let's just take a list of bullets. So what we'll do is we'll combine the, you know what, I can't do that because it's going to be drawing the wrong color. Let's take red underscore bullets and let's take yellow underscore bullets. Doesn't matter what order we take them in. And let's draw these bullets onto the screen. So after I draw everything else, we'll draw our bullets. So we're going to say for bullets in red underscore bullets. Then what we'll do is we'll say pygame.draw dot rectangle. We'll draw these onto the window. These are going to be red, so this is an opportunity to create another color called red. So let's go here. We're going to say red is equal to 255, 0, 0, because red, well, is all red and nothing else. We also need yellow, so let's go ahead and do that. Now, can I remember my primary colors? I'm just going to look so I don't mess this up. I mean, I believe this is red and green creates yellow. I think that's correct. So let's go here with yellow. So 255, 255, 0. Okay. And now we have red and yellow. So we can draw pygame.draw.rect, window, color, red. And what are we drawing? Well, we're going to draw the bullet, which is really just a rectangle. Copy this, do the same thing. And the only thing that we need to change is the color. So this is going to be yellow, and this is going to be yellow. There we go. So we have our two colors defined. We're now going to draw all the red bullets and all the yellow bullets on the screen. So we just loop through them and just draw all of them out. Okay, so let's refresh, or let's run this and draw a window missing 2 required positional arguments, red bullet and yellow bullets. That would make sense because I forgot to pass them. So let's go down to our main function here. See where we have draw window. We're going to pass the red bullets. So lowercase red bullets and lowercase yellow bullets. Awesome. Quickly, just so you guys can see everything, I'm going to zoom out, give you an idea. This is what the main function looks like in case you guys are on a larger display and you want to see all of it. This is what the other functions look like. Just going to kind of scroll through so you guys can have a look here and pause the video if you need a specific part or if I'm going too fast for you. Okay, so let's zoom back in. Let's run and let's see if this is working now. So I'm here on my left guy. I press Control. Boom, we fire a yellow bullet. Kind of hard to see on the white background, but also notice, let's go with the right one because you'll be able to see the red, that this bullet, when it hits my player, it's disappearing. That's awesome. This is working, and boom, we're good to go. So now what we need to do, and also notice if you try to hit Control a bunch of times, it only lets you shoot at most 3 bullets at a time, right? Which is exactly what we wanted. If I go up here, now I can't shoot any bullets until these go off the screen. And in fact, I forgot to handle the fact that the bullets go off the screen. We need to remove them. So let's do that next. Awesome. So much stuff. I always forget how much stuff we actually need to do. So now, after we check this collide rectangle, we're going to check if any of these bullets are off the screen. So to do this with the yellow bullets, all we have to say is if bullet.x, and this one is going to the right, is greater than, and we're not going to bother with the width of the bullet or anything. It's fine. We'll just make it disappear when it gets to the edge. We'll say bullet.x is greater than the width of the screen, then yellow bullets dot remove bullet. But we'll just do an else here to make sure that we don't, so this will be elif, so that we don't potentially remove the bullet twice. Anyway, so we'll do that. Now we'll add an elif here. We'll say elif bullet.x is less than 0, because that would be when it's off the screen if we're subtracting the velocity. Then same thing here, red bullets dot remove bullet. So that should be good, just checking if it's going off the screen in either direction. Okay, so let's try this now. When I press Control a bunch of times, boom, I should be able to press it again. Awesome, they're getting removed. All is good. All right, so before we do anything else, let's actually just change the background because my eyes are hurting with that yellow on white. So we'll change it to that nice space background that I showed you at the beginning. So to do this, we need to load in our space background. If we go to our assets folder, we can see we have space.png. So we're just gonna say space is equal to pygame.image.load, and then we're going to load in os.path.join. So os.path.join with the assets folder like that. And then we want to load in space.png. Now that's fine. We can do that, but I'm also going to rescale this image because it's really big to be a lot smaller just so it looks nicer. So to do that, we'll say pygame.transform.scale, and then we'll wrap this image around, and inside of this, we'll put the dimensions. Now, we have perfect dimensions for this. We can just make it the width and the height of our window. Now, this might make it a little bit kind of stretched. We'll have a look at how it looks, but I'm just going to make this width height. So we're resizing it to that. So now, rather than filling the screen with white every single iteration, and actually, let me show you what happens when I don't do that, because that's interesting. So before I draw the background, I'm going to show you what happens when we don't fill the screen with white. Look, you can see this. I'm just moving around all over the place. The reason this is happening is because Pygame does not remove the last drawing that we made, right? It just keeps drawing stuff onto the canvas. So if I don't draw a white background every single frame, or I don't draw something that covers the entire screen, then you get all this kind of movement stuff because it's not erasing anything that it previously drew. So anyways, I just thought that was interesting. So let's now put that image onto the screen. I'm going to say win in all capitals dot blit. We're going to blit space, and then we're going to put it at 0, 0 because this is the background. So we can just start at the top left and fill the entire screen because we already know its width and height is that. So let's go ahead and run. And there we go. We get a nice space background. Actually, it doesn't look bad at all. In fact, this looks pretty nice. So I'm going to leave it like that. Awesome. Then we can go. There you go. Yellow looks a lot nicer on that background. Awesome. So now let's handle those events. So when we actually get hit, we need to do something. We need to have some health or something like that. Then we're going to add sound effects. We got a bunch of stuff. Well, actually not that much, but a few more things to do. So now inside of my main event loop, remember, just a quick refresher, we're posting these events, right? Yellow hit and red hit. So when we post these events, they just get added to this pygame.event.get queue that's kind of appearing with all of the events. So all we have to do is just inside this for loop, check for these events. So if event.type equals red underscore hit, then we'll do something. And if event.type equals yellow underscore hit, like that, then we'll do something else. So this is a perfect time to implement a notion of health. So we want to have both characters have some number of health, and every time they get hit, that's obviously going to subtract. So to do that, pretty straightforward, but we're just going to make two variables here. We're going to say red underscore health is equal to 10, and yellow underscore health is also equal to 10. Whenever a player has 0 health, again, feel free to change these numbers, then we'll say that the opposite player has 1. So that'll be kind of the objective or how you win or lose our game. So if red is hit, what's the obvious thing to do? Subtract red's health. So red health minus equal 1. If yellow is hit, then we'll say yellow underscore health minus equals 1. Then what we want to do is now check. Actually, we don't need to do it inside of this for loop, but we can do it outside of this while loop if either player has health that is equal to 0. And if they do, the opposite player will win. The way I'm going to do this is interesting, but I'm going to say if, let's say if red underscore health is less than or equal to 0. And then I'll say if yellow underscore health is less than or equal to 0. I'm actually going to define this variable. I'm going to say winner underscore text equals, and I'm going to say yellow wins like that. Now on the other side, I'm going to say winner underscore text is equal to red wins. This is the text that I want to appear on the screen when either of these situations happen. We'll get into this in a second, but I just want to start defining it. Now above here, I'm going to say winner underscore text equals a blank string. And I'm going to check in one more if statement. If winner underscore text does not equal blank, then inside here, someone won. So the basic logic behind this, we have this variable called winner text. It's equal to nothing. If either the red player or the yellow player has lost, so they have 0 health, then we will set the winner text to be something other than empty string. In the situation where winner text, after we check both of this, is not equal to an empty string, someone won, we should display that winner. So we will get to that in a second, but now what we want to do is show both of these scores on the screen. And then once we've done that, we just have to add sound effects, handle someone winning, and we're pretty much done. We're getting very close. So let's do this. Let's start showing the score. To show the score, that means I need to pass the score to my draw window, and I need to somehow draw that score in the window. So I'm just going to pass the, I guess it makes sense to pass red first. So we'll pass red health and yellow health like that to my draw window. Now let's go to draw window. Let's now take inside of draw window the red underscore health and the yellow underscore health like that. And now inside of here, what we'll do is we'll actually draw their score or their health on the screen. Now to do this, this involves using fonts. We have to actually render some text on the screen. So this is where we get into our next step. So what we're going to do at the very top of our program is we're going to say Pygame pygame.font.init. Now I just took a quick pause there because as you guys can see, I spilt water on myself, so that's great, but we'll continue, that's fine, I will survive. Anyways, you're gonna put pygame.font.init at the top of your program, and this is going to initialize the Pygame font library or whatever it may be. Then what we need to do is define a font that we are going to use. So it's getting kind of messy up here. I'm just gonna do another kind of little section, and I'm gonna say that the health underscore font is going to be equal to pygame.font.sys font with these specific capitals. We're going to define the name of the font, which I'm just going to use Comic Sans, and then the size, in this case, I'm going to pick 40. So what I'm doing here is I'm just defining the font that I want to use, Comic Sans, size 40. We're all good. We can continue. All right, so now that we have the font defined, we need to use it. So we're going to go inside of Draw Window. I'm going to show you how we can actually put font onto the screen. Now draw this wherever you want, just obviously after the background's drawn. I'm just going to draw it after the spaceships, meaning that it will overlap our spaceships. Actually, you know what? Maybe that's not the best idea. Maybe we want our spaceships to go over top of this font if that situation occurs, which it could. So let's start by doing this. Let's say red health underscore text, and this is going to be equal to Pygame, or sorry, not Pygame. We're going to say score, not score. Health underscore font, finally got it right, third try, dot render. Now, we just defined this font, right? We're going to use this font to render some text. Now, the text that I want to render is the following. I want to render health, colon, and then space plus the string of red health. So we'll take whatever that number is, convert it to a string, and concatenate it with health. Then we need to say 1 for anti-aliasing. I'm not really going to talk about what that is, but you just always put 1 as the middle argument for our purposes. And the color of this text, which is going to be white. So red health text is health font.render. It's equal to health plus whatever the health is, and then 1 white. Same thing now for the, not red text, but for the yellow text. So we say yellow health text. Now what we've done is we've created kind of 2 text objects, and we want to draw these on the screen. So to draw them on the screen, we're going to say win.blit. We're going to pick, well, I guess we already know the window. We're going to pick what we're blitting, which in this case is red health text. And we need to pick where. Red is on the right side of the screen. So that means I want to blit it at an X position that is like right at the edge of the screen. I'm going to do this dynamically. You can hard code a number if you want, but the correct way to do this, or the way that will look the best, is width minus and then red underscore health text dot get underscore width. This will get the width of that text and subtract that from the width of the screen. So the top left position where we're blitting this will be like right at the edge. And then I'm also just going to subtract 10 pixels just so this has like a 10 pixel pad from the very edge of the screen. Where do I want to blit it on the Y? I'll blit it at 10 because it's going to be right at the top of the screen. We'll just make it 10 pixels down. By having this -10 and this 10, we're padding it so it's 10 from the right wall and 10 from the top wall. Now we'll do the same thing or a very similar thing for our yellow text. So win.blit, we're going to say yellow health text. And then where do we want it? We're actually just going to put it at 1010. Reason we can do this is because we don't really care about the width of it because it's going to be the left border that we want padded from the left wall and then 10 pixels down as well from the top. So that's what blitting it at 1010 will do. Anyways, this will give us the red health text, the yellow health text. It'll be showing up on the screen. So let's try this actually. We handled the events. We're passing in the health. Yeah, we're like very close to done. So let's run this. And now you can see the health is showing up. So we have it in the corner. Boom, move that like that. And then notice that the health gets updated. But for some reason, the health is changing for both of them. So I think I just have a small bug. So let's have a quick look here. We have that red health, so yellow health -1, red health -1, red hit, yellow hit, okay. We're passing red health, we're passing yellow health, okay. For some reason, they're both getting updated. So I guess that means that this event must be triggering for both of them. So let's try to see why that's happening. So I'm just scrolling around wondering why this isn't working, and I'm realizing that, well, red health is in both positions here. So this needs to change to yellow health. Because I had red health, so obviously it was drawing the same thing. So anyways, let's try this now. Run. And now if I hit someone, only the health updates on one side, which is what we're looking for. So we're very close to done. We just need to handle the situation where someone wins and add sound effects. So let's do someone winning first. This is actually really straightforward. I'm just gonna make a function. What this function is gonna do is just draw text on the screen that says blank person won, and you'll see how this works. So I'm gonna say define draw winner. We're gonna take in some text that we wanna draw, and then we're gonna make a new font. So let's go to the top. Let's go with our other font. Let's say winner underscore font is equal to Pygame, like that, dot font dot sys font. This should be Comic Sans. Well, you can make whatever you want. And then I'm going to make this size 100. We'll make it nice and large. So now we'll use the winner font to actually render the text. So we'll say winner underscore font dot render. We'll render the text, anti-aliasing 1, color white. And then we'll draw this onto the screen. So we'll say win dot blit. We'll blit the winner font. And we're going to do this nice and fancy and have it perfectly center in the middle of the screen. So I'm going to go inside of here. I'm going to say width over 2. Now we'll actually double divide it by 2. Did I do that somewhere else? I'm not sure, just to make sure we don't get any errors, although width over 2 is an even number, so I think that's fine if we do that. We'll say width over 2 minus, because width over 2 again is the direct middle of the screen, minus the, I need to, I've made a mistake here. Okay, let's go text. Draw underscore text equals that. We need a variable. Draw underscore text equals that. I don't know why I thought blitting winner font was going to work, but draw text is equal to winner font dot render. That's better. So now we'll say width over 2 minus draw underscore text dot get underscore width. This will get the width of the text, so how wide it actually will appear on the screen, over 2. This will put it directly in the middle of the screen, because it will take whatever half the width of this is and subtract it from the X position. So that way, when we draw this, it will be perfectly in the middle of the screen. I kind of went over this before. We'll do the exact same thing for height. So we'll say height over 2, and then minus draw underscore text dot get underscore height over 2. Again, get height is just going to give you the height. Might be smart to do integer division here, but I think this will be fine. Then we're going to say pygame dot time dot delay. And we're going to delay this for 5,000 milliseconds, which is 5 seconds. You'll see why, but what this will do, and sorry, we also want to update the display. So before we start delaying, we're going to say pygame.display.update. So what this is doing is we're going to call this function when someone wins. So for 5 seconds, we are going to show the winning text, and then we're going to restart the game. So the reason I'm doing this, and I'm not doing it inside of draw window, is because I want to just pause the game whenever someone wins, show this text, and then just restart it immediately after. That's why I have this pause. If you want to change the pause to be longer or shorter, just 1,000 multiplied by whatever seconds you want to pause it for, and that's how you pick the delay. Okay, so now inside of winner text here, we're going to say draw underscore, no, not window, draw underscore winner, and we're just going to pass it the winner text. Because what this will do is then give it the winner text, it will draw it on the screen, we'll pause for 5 seconds, it will appear, and then we will break. Now when we break, this will bring us to pygame.quit, which would usually quit the game. Now, we can do that for now, so let's actually just do that, and then I'll change it so it just restarts the game. So here, let's just spam control a bunch of times, and make it so that we actually win. So there you go, boom, we hit it, it says yellow wins, appears on the screen, wait, it's going to close the game in a second, and boom, go ahead, or the game goes ahead and closes. Now, if we don't want the game to quit, what we need to do is make it so that we don't quit the game here, but we just restart it. How do we restart it? How we started it originally, just by calling this main function. Since we define any game-specific variables in here, when I just recall the main function, it will redefine these variables and the game will just restart. So instead of having pygame.quit, I'll just say main like that. But that means that what I need to do now when we actually do quit the game is say run equals false, as well as pygame.quit right inside of here. So hopefully that's clear, but this means now whenever we press the X, it will actually close, because if I removed pygame.quit from here and I didn't quit, then we would just stop the while loop, but we would restart the game whenever you press the X button, which obviously isn't what we want. So we have that now. We can do one last test. Then we're adding sound effects and we're done. So let's do this. Let's just test this out. And let's keep going. Boom, yellow wins. Give it a few seconds and it should just restart the game. Okay, there we go. Restarts the game. We get put back in our original positions. We have 10 health. We can fire our bullets and we're all good. Awesome. So let's now add the sound effects, which are super simple, and then we will be done. So the first thing that I need to do is load my sound effects. Second thing I need to do is load my sound effects. First thing I need to do is initialize kind of the sound effect library in Python. So I'm gonna go to the top here. I'm gonna say pygame.mixer.init, and this just starts kind of like the sound aspect of Pygame so that it will work. Anyways, now that we have that, we're gonna load in a mixer sound, which will allow us to start and stop a sound whenever we want. So the first thing I'm gonna do is I'm gonna make a variable. I'm gonna call this bullet _hit _sound. And this will be when we actually hit something, that'll be the sound. And then we'll say bullet _fire, like that, _sound. And now let's load these in. So we're gonna say pygame dot, and then in this case, we're gonna say mixer dot load. And we're gonna load from os.path.join. The start of the path is assets, and the end is simply the name of what we want. So the gun silencer, funny enough, these are the sounds I've used, right? The gun silencer is the one for when someone collides, and the gun silencer is for when someone shoots, and the grenade is for when it collides. So I'm just gonna say grenade +1.mp3, and then we'll just copy this line, do the same thing, but change grenade +1 to be gun plus silencer. Did I spell silencer right? Yeah, .mp3. So now we have both these sounds, and if we want to use them, it is really easy to do this. All we have to do is go down, and I'm just going to make it so that whenever we fire a bullet, so whenever this happens, we actually put that sound, right? So now I'm just going to say bullet _fire _sound .play. Or is it .start or is it .play? I think it might be .start. Let me look at my other code here. So actually, no, I've been lied to. It is .play. Okay, so we're gonna play the sound like that. So bullet fire sound .play, and the same thing here. So whenever we fire the bullets, we'll play the sound, and then whenever we get hit, so whenever we lose health, we'll play the collision sound. So we'll say bullet _hit sound .play. Copy that and paste that there. So that's it. That adds the sound effects. This should be our game. So let's run, and pygame.mixer has no attribute load. Okay, so let me see what this is actually called. I thought it was called load, but I guess it's called something else. So I've made a mistake. This is actually not supposed to be load. Where is load? This is supposed to be sound with a capital S. So just change that there. This happens all the time. I just forget the syntax. Pygame.mixer.sound. And then this should work. So let's run this now with the proper syntax. Let's run. And bullet sound, unable to open file, assets, grenade +1.mp3. Now it looks like I do have grenade +1.mp3. For some reason that's not working. I'm just gonna go ahead, and I don't usually recommend doing this, but since I don't know the mistake, I'm gonna try assets / grenade1, and then we'll just do the same thing here. So we'll remove the os.path.join. I don't think we actually need it for this specific sound, or for the way that we're loading these. And then we'll just do that. So we'll just kind of, make the path ourselves, assets / grenade +1, and so on. So let's try this now, see if all is good. Unable to open file. Okay, so give me 1 second. I will be right back. Okay, so it turns out that there's actually a corruption of these MP3 files. Of course, that's going to happen to me at the very end of the tutorial. But I promise you that the code I just wrote, and I'll zoom out so you guys can kind of see all of it. And I'll just slowly scroll through as I conclude here. The code that I just wrote, so the way I loaded that's totally fine. Like even the os.path.join, that should work. And then to play the sound, all you do is .play. So just trust me that this does work. For you guys, if for some reason when you download the MP3 file, they're corrupted as well, then just find your own sound effects and just load them in. So throw them in the assets folder, name them something, and then load them. I think it's just an issue with downloading the files from GitHub. You can't download MP3 files. But do that, load them in, pick your own sound effects. They should work with .play. It's a really minor part of the tutorial, so I'm not too worried about it. But then you should hear the sound effects when you press those buttons. And well, it does obviously add a lot to the game. Now, I will quickly mention before I leave off here, because this is all we're doing for this tutorial, that there's a lot more stuff in Pygame that you can do. The point of this was really just to get you up to speed, nice and fast, show you how to create a simple game, and show you how to do most of the things that you usually want to do. You know, projectiles, moving characters around, handling collision, all that kind of stuff, loading images, loading sound effects, although that didn't really work, and all that kind of stuff. And keep in mind, like, you know, usually you can separate things out into different files. This isn't perfect what I did, but again, just to give you an idea and really get you kind of started in Python and Pygame. Hello everybody, and welcome back to another Pygame tutorial. Now, it's been a long time since I've done one of these, but you guys know that the foundation of Tech with Tim, my YouTube channel, was really built around making all kinds of fun little Py games. Like, I've made Tetris, Snake, some platformer games, stuff like that, which you guys can check out as well if you wanted to see those. And I wanted to bring another one back here to all the old subscribers and just show you guys, you know, this is another cool Pygame we can make, especially with quarantine happening. Pygame is just such a great module for making some fun 2D games that don't take you that long to kind of get up and spinning. And of course, you know, we can use Python for this, which is a great and a pretty fast language to write code in. So the game that we're going to be creating today is a space shooter game. Now, this is inspired or kind of based off of that old original Atari game where you have those spaceships coming down the screen and you're this big shooter and you're trying to shoot them all out of the sky. I know that that version is a lot different than what I'm going to show you here, but this is the inspiration. Now, stick with me here for another minute or two. I need to give you this introduction so you really have all the tools you need to work through this project. The first thing I'm going to say is these videos take me a really long time to make, and I really want to make sure that you guys are able to actually create the game. So please do me a favor, go like the video and make sure you're subscribed to the channel. If you're not, just show your support. And if you guys really want to give me an extra big thank you and show your appreciation, I'd really appreciate it if you go subscribe to my new YouTube channel, which is called Time Out with Tim. That's where I'm going to be posting a weekly podcast where I talk about tech, programming, finance, just myself, lifestyle, stuff like that. And I would really appreciate it. Even if you guys don't want to watch that, you just go over and subscribe and support me over there. So anyways, let's demo the game, and as I demo the game, I'll talk about some other important things for this tutorial series. So first of all the assets you see here, those little pixelated assets, are available from the description down below. I've made a really easy link on my website, so all you have to do is just click it, and it will automatically just download a zip folder that has all the game assets and the code as well. I get comments all the time with common problems, which I'm going to go over at the beginning of this video to hopefully make sure you guys don't run into those. But if you're running into problems, just click that link. The code will download. You can open up that code and you can steal whatever code you need and reference it and make sure that, you know, it really was my mistake maybe and not yours, and that you can see if anything's going wrong. But this code that I'm showing here is what we're going to be recreating. I already have it written, full disclaimer, on the left-hand side of my screen. So if you see me looking over there during this long tutorial, that's what I'm doing, just making sure I haven't messed anything up. So the idea behind this game is that you're this ship, you know, you can shoot bullets, and you want to just make sure that these little ships here don't get to the end of the screen. And if they do, you lose a life. The idea behind what I've created here is this is kind of a basic guideline. It's setting up the main functionality. And then what you guys can do is add your own features to it. And I'll talk about some extensions you can put on so that you guys can make this game as custom as you want. So the idea is to give you the core functionality, show you how to do everything, and then you guys can add and make it your own game afterwards. So with that being said, I think that has pretty much been it for this introduction. What we're going to do now is actually get into coding and just do a little setup for the project, and then obviously start writing some code. All right, so the first thing we need to do for this project is actually install the module called Pygame. Now, Pygame is this third-party module. It's what we're going to use to make this space shooter game, and you do need to install it. Now, a lot of people have difficulties with this. This is probably the most difficult part of the tutorial for someone who doesn't work in Python very often, doesn't understand how all of this works. So what you need to do, if you're having troubles with the steps I'm about to show you here, is click the card in the top right-hand corner, or click the link in the description that says how to install Pygame. That's an older video, but it goes through exactly how to install Pygame, all of the common issues and problems, and you should, after watching that, be able to come back here and follow along with no problem. So what we're going to do, and just first of all, obviously we need Python downloaded and installed. I'm using Python version 3.7, and the text editor that I'm going to be using is Sublime Text. Now you can use whatever you want. You can use the standard Python IDLE. You can see I have that installed on my computer as well. Doesn't matter what you write in, but just because I get asked all the time, I'm using Sublime Text. Now, obviously, download Python if you don't have that. 3.8 should work. If you're having issues with 3.8, download 3.7. And then what we need to do is use pip to install Pygame. Now, pip stands for Package Installer Python, I believe, or Python. Yeah, I think that's what it is. Anyways, that comes by default with your Python installation. So usually what you can do is open up a command prompt window if you're on terminal, or open up a terminal window if you're on Mac or Linux and type pip install Pygame like that. Now, if you hit enter and you see something like this, like requirement already satisfied or finding module, installing module, you're good. You installed Pygame, you're ready to go. That's all you need to do. If you see an error that says pip is not a recognized command, go watch that video. It'll show you how to install pip properly. Now, if you're on Linux and if you're on Mac, what you might need to do is type pip3. Pip3 stands for pip Python version 3, because on those distributions or on those, I guess, operating systems, they have Python 2 built in automatically. So when you type pip, that actually accesses the Python 2 interpreter, not the Python 3 interpreter. So try pip3, try pip. If this doesn't work, again, watch that video. I have one for Mac and for Windows, which I'll link in the description. And once you get that, what we're going to do is just type Python in here or open up your IDLE. Wherever you usually do your Python stuff, just try to import the module Pygame like that. And if it works and you get this welcome message, then you're ready to go, and we're going to get into the video right now. So once we've done that, what we're going to do is actually, and I'm going to close this now, set up a project directory or a folder on our computer where we're going to store all of the stuff for this project. So what I've done is I've made a folder. I've called it Space Shooter Tutorial, and you can see I've already dragged in the image assets here. So what you need to do, if you don't have these assets, which you won't, is go to the description, hit the link that says download image assets. It will download a zip folder. So you'll see, I'll put this into a compressed one so that everyone can follow along here. If we go, what is it, send to compressed zip folder, it'll be in a zip folder like this. What you need to do is unzip it, take this folder out, so extract it, and put it into the directory that we're going to work in. It's very important that when we do this, the Python file we create is in the same directory as the folder that has the assets. The assets are the images. You can see I have things like this yellow ship, which I'll bring up onto my other screen here. We have the green ship, the red ship, and all of that, okay? So just make sure that you do that. Otherwise, that's not going to work. Okay, so once we do that, what we're going to do is open up a Python window where we can write code. So in this case, I have Sublime Text, but if you want, you can open up IDLE like that. And IDLE is perfectly fine to write code in as well. But this is Sublime Text, which is just a nicer editor. So what I'm going to do in here is make a new file, and I'm going to call this main.py. Now, very, very, very important, do not name this file Pygame. If you name this Python file Pygame, or any file in this directory is named Pygame, your script will not work. I learned this the hard way when I forgot to tell people that in a previous tutorial and I got 100 comments. Do not name it Pygame. I know it's a tempting name, just do not do that. Now again, what we're going to do to make sure everything's working here is just import Pygame. Now fortunately for me, in Sublime Text, I can click Control plus the B key to run my script, so that's what I'm doing here. But for you guys, if you need to run your script and you're in IDLE, obviously hit F5, or you can use the terminal window on Mac, Linux, whatever, and do Python 3 or Python, the name of your file when you're in the correct directory. Okay, so once we import Pygame, what we're going to do is import a few other things. So we're going to import OS, we're going to import time, and we're going to import random. So now we're actually ready to start writing some code, so let's get into it. All right, so the first thing we need to do is actually load all of our image assets into our script so that we can use them and display them on the screen. Because the first thing I'm going to do after we load these images in is actually start setting up the Pygame window and talking a bit about some basic Pygame syntax and how all those things work, because obviously this is a module, which means now we have some different syntax and some different tools we can use that aren't native to the Python language. So notice again that this main.py file is in the same folder where this assets folder is. I don't have all these images inside directly with the main.py. The main.py is in the same level as assets. That's really important, and that's a big mistake if you don't have that, so make sure you're listening, pay attention, and do that. The first thing we're going to do is load all these images. So I'm going to make a comment. You don't have to do the comments if you don't want, but this is just to make it a little bit cleaner. We're going to load the images. What I'm going to do is use all capitals for my variable names here, and I'm going to say red spaceship equals, in this case, Pygame, and not in all capitals, Pygame.image.load, and I'll go through this after, so don't worry if you're confused, os.path.join, and we're going to do assets in here. And then in here, what we're going to do is, what was this file called? I need to look at my other screen. Pixel underscore ship underscore red underscore small dot png. Okay, so what this is doing, this line of code, and we're going to do a bunch of these lines of code, which I'll speed through in a second, is we're saying from the Pygame module, use the image.load method, and then in here, we're going to load the image, which is located at os.path.join. This is the name of the folder that our images are in. Notice that's assets right here on the left-hand side of my screen. And the name of the file is pixelshipRedSmall.png. So if you look inside of here, we can see we have pixelshipRedSmall.png. This is what it looks like, a very basic, 5-pixel thing. And you can see that that's how we load this. If we want to add a folder name to a file name, because we're loading from a folder, we can use os.path.join. Although note, I could completely omit this line, and some of you might be like, well, why aren't you doing this? This is just the proper way to do it, is to do assets / and then the name of the file like that. That works, but we're going to use os.path.join to make sure everything's clean. So I'm going to copy this a few times because we're going to need to load all these files in, right? And they're going to have all their file names. So we have red spaceship, we need green, we need blue, and we need yellow, right? So the yellow is going to be our main player. So I'll tab it down and say player ship like that, just so we know. And all we need to do for these ones up here is change red to the appropriate color. So in this case, that's going to be green. That's going to be blue. And I believe this one is just pixel ship yellow. It doesn't have that small afterwards. So pixel ship yellow, we can check that just by looking here. Yep, there we go, we got it. And just make sure that you have that PNG extension. Otherwise, obviously, that's not going to work. So what we're going to do now is we're going to load in the bullets and the other assets. So we need to load in the background and we need to load in the bullets. So let's say lasers is what I'm going to call them. And we'll say red_laser equals, this case, we'll copy this line up here, paste it in. And assets, in this case, I believe it's something like laser_red or something. So let's look at this. Pixel laser red. Yes. Okay. So pixel_laser_red.png. Let's copy this a few times. And of course, just change the colors to what they need to be. So red, green, blue, and yellow. Need to make sure that's all capitals. Let's change the file names now. So pixel laser green, pixel laser blue, and pixel laser yellow. Okay, so let's spell that correctly. And now let's load in the background image. So let's say BG or background. I'm just going to call this one BG. Notice I spelt that comment wrong. And BG is going to be equal to, in this case, pygame.image.load, os.path.join. Assets, and then what is this called? Background-black.png. So let's punch that in. Background-black.png. Okay, so now, assuming we spelt all this correctly, we've loaded in all these images. To make sure this works, we can run the code. If we don't get any errors, this was successful. Now, if any of you have like corrupted images or something like that, just try re-downloading, because sometimes that happens where it says it can't open the file even though it does exist. But make sure again that they're in the correct folder, they're named the right thing, and you're loading them in like this. If you want to use your own image assets, put them inside the assets folder, and then name them what you need to name them and load them in like this. Okay, so now that we have all of these loaded in, what we're actually going to do is set up our Pygame window. So the first thing we do when we're working in Pygame is we create a width and height for our screen, we set a name for the display, and we just run it and make sure that it's working fine. So the standard, and the reason I've named these all capitals, by the way, is because these are going to be constants. They're not changing, and the convention in Python is to name constants with a capital. But what we're going to do to make our windows, we're going to say win equals pygame.display.set_mode. And inside of here, we're going to put a tuple with a width and a height. Now we're going to define the width height up here like this. So width height equals, in this case, we're going to do 750 by 750. Feel free to change this if you want. And that's how we're going to get started. So width height equals 750, 750. This just means width is 750, height is 750. We're going to say win, which stands for the window, is equal to pygame.display.set_mode width height. And width height just tells it this is how big our window is going to be. Once we do that, we're going to set the caption or the name of our window. So we can do that by saying pygame.display.set_caption. And inside here, we're just going to call this space shooter. And in my version, I'm just going to call it tutorial. But you guys can call it whatever you want. So there we go, space shooter tutorial. Now, if we run the script, we will see that a Pygame window pops up and then just disappears because we're not doing anything else. So if we've got that successfully, Things are looking good. Again, feel free to change these numbers. I'm on a 4K display, so it's going to look a lot smaller on my display than it is on yours if you're on 1080p, right? 750 by 750 will take up most of your screen if you're on a 1080p display, but I'm on 4K, so it's going to be, 1/4 the size. Is that how it works? I think so. Maybe something like that. All right, quick water break there, and now let's get into the next stuff that we need to do, which is actually drawing and getting our main loop kind of set up. So whenever we're working in Pygame, what we need to do is create a main loop, which is going to be kind of what handles all our events. So it's going to be what handles collision, it's going to be what calls things to be drawn on the screen, it's going to be what allows us to quit the game, to move a character, stuff like that. So what I usually do is I define a function. I'm going to call this main, which stands for main loop, and inside of here I'm going to set up a few variables that we're going to need for the game. So the first one we're going to need is run. Run equals true is just going to dictate whether this while loop is going to run or not. And then what I'm going to do is create an FPS, which stands for frames per second, and set that equal to 60. Now, of course, you can change this to whatever you want. The higher this number, the faster your game's going to run. The slower this number, or the lower this number, the slower your game's going to run. Now, just keep in mind, you don't want to make this number too low, because if you do, then that means that you're only going to be checking for collision and checking for events once every whatever this number is. So in this case, if we say 50 frames per second, what that means is we're going to show 60 frames every second. And that means that we're going to check collision, we're going to check if we're moving the character once or 60 times every second. So the way that we can set that up in Pygame is by making a clock object. So we're going to say clock equals Pygame.time.clock with a capital C like that. And then inside of here, we're going to say clock.tick and make sure this is at the top of your while loop FPS. So we're essentially saying we're going to tick this clock based on this frames per second rate, so 60 FPS, and what this allows us to do is make sure our game stays consistent on any device that we give it to. So if we run this on a really fast computer or a really slow computer, doesn't matter, it's going to run at the same speed because we've set that clock speed of 60 FPS. Now, what we typically do inside of here is start drawing stuff on the screen and start checking for events. So what we need to do first is check for events. And the first thing we actually want to do is check if the user has quit our window. So to do that, we're going to say for event in Pygame.event.get. And what this is essentially saying is every time we run this loop, so once every, or 60 times every second, we're going to loop through all the events that Pygame knows, and we're going to check if an event has occurred. If that event occurs, do something, right? So an example of an event is like pressing a key, is pressing the quit button, is pressing the mouse button, something like that. You can look up the events from the Pygame website if you're trying to do something different, but most of what I show you is pretty much all you'll need. So now what I'm going to say is if event.type equals Pygame, like this, if I could spell correctly, .quit with all capitals, then what we're going to say is run equals false. So what this means, this Pygame.quit, is if we press that top right, the X in the top right hand corner of our screen, quit the screen, like quit Pygame, stop running. So that's why you'll notice I set run equal to false. So the next time we get to the top of this loop, we won't loop anymore because we quit, right? And that's the idea behind that. So we could check for other events in here. In fact, I'll show you another common type of event. So if event.type equals Pygame.keyDown, what that means is we pressed some key downwards. If we did that, we'll trigger an event. That's what this means. Now, we're not going to use that inside the event loop because I'm going to show us a different way to move things around. But this is the basic loop that we need right now. So let's actually go ahead and call this function and run it and just make sure that the quit button's working and show you what I mean. So you can see that it pops up now, our window. We have Space Shooter Tutorial, and we can click the X button, and if we do that, it exits the window. If you don't have this event here, it will not exit the window when you press the quit button. So that's just something to keep in mind, that you need to make sure that you make run equals false and exit out of our infinite loop that's going to happen here that's running the entire game. It's handling collision, movement, all of that when that starts happening. Okay, so now that we have that, we should probably start drawing some things onto the screen. And the first thing that comes to mind for me is the background. So I'm going to do something that might seem a little bit confusing to you guys. Try to look past, really the inner workings of how this works and just understand that this is possible. I'm going to make a function inside of this main function that I'm going to call redraw window. Now, the idea behind this is that when we do things like in games and just in programming in general, we typically want to separate things out into their own functions and create small pieces of logic that do things quite well. They do one or two things, like just one thing quite well. So rather than drawing all the different things, because we're going to have to draw a lot of different things within this while loop, we're going to put it in a function that's inside of a function and just call that when we need to use it. So just treat this like a regular function, but just understand that since it's indented and it's defined inside of this main function, we can only call it when we're in this function. And that's totally fine. That's all we need to do. But this is going to allow us to access all of these variables defined inside of the function, rather than making it its own function and having to pass them all through as parameters, which can get quite annoying when we have a lot of things that we want to pass. So again, yeah, the idea is that this is going to draw everything for us on the screen. It's going to handle all our drawing, anything that needs to be rendered, stuff like that. So it can just be in its own separate piece. So if something goes wrong with drawing, we know right away where that is. It's in redraw window. So the first thing we need to do is do pygame.display.update. And in fact, what this does is refresh the display. So the way Pygame works is we have a bunch of things called surfaces. Now, these surfaces can be drawn on. We can blit things onto them, which means like put an image onto them or something like that. And the way that it works ideally is we have this one surface, and every time that we loop, so we run one of these while loops, so 60 times a second, we're going to redraw everything onto the screen and then refresh it so that it has the updated version. So the first thing we need to do, since we're going to be redrawing everything, is draw a background image as our first thing. So what that will do is it will cover any stuff that was behind or drawn before, and then we draw everything on top of that background image that's going to be shown for the next frame. And you'll understand what I mean in a second, but just bear with me here. So what we're actually going to do is do win.blit bg, 00. Now what this is saying is win is a surface, right? It's this Pygame surface that we've set up as our main Pygame window at the top of our screen. So a method that's available on this is called blit. Now what blit does is take one of these images, so one of these Pygame images, it can be some other things as well, which really have been turned into what's called a surface in Pygame, and draws it to the window at the location that we defined here. Now an interesting thing with Pygame is the way that we actually use a coordinate system. So I'm going to bring up my drawing tablet here to show you what I mean. I've got some networking stuff on there and show you what I mean by the coordinate system. So let's say this is our Pygame window, and just excuse me because I am drawing with my mouse. We know we have an X and a Y, right? So this is our X-axis, this is our Y-axis, and typically we think that 0, 0 is the bottom left. Well, that's actually wrong or different in Pygame. In fact, 0, 0 is the top left. So what that means is that our X coordinates are the same as we would assume. If we want to increase X, we're going to the right, or if we want to go to the right, we increase X. So X goes like that, but Y actually goes down, which means that if you set something at position Y0, it's at the very top of the screen. And if you want it to go downwards, you need to increment the Y. So let's say I want to move a character down, I need to increase its Y value. That's what I'm getting at here. Now this is the same for objects. So let's say we have a little square and we want to draw it on the screen. Well, the top left-hand corner is where we're going to draw this object from. So if I say I'm drawing a square at 25, 25, what that means is that I am going to draw this square starting at the top left position of 25, 25. So if the width of our square is, say, 30, if I can't draw 3, this pen size is too thick. Let's see, if we go, let's do 20. That's my rough version of a 20. That's a 2. If the width is 20 and we draw it at 25, that means that this corner here, right? So this right corner is actually going to be at, quick math, 45, right? So that's what we need to understand. Top left-hand corner is the coordinate system for Pygame. So just keep that in mind when I'm drawing things. So when I say win.blit background at 0, 0, that means take that background image and draw it at 0, 0 in the top left-hand corner of our screen. And since we're going to draw the image starting at the top left-hand corner, it will fill the entire screen. Now, the only thing is, though, we're going to see when we run this. Well, actually, if we win.blit, if we call this function, one second, sorry. So let's call this function now from inside of here. So redraw window. So just inside this main loop, we're going to go clock.tick, immediately call the redraw window. In here, it just splits the background and updates the display. So let's run this. Notice that the background is not the correct size. So what we're going to do is actually scale this background up. You can see it's about 1/4 the size it really needs to be. So we're going to make it 2 times bigger, just about, so that it fills the entire screen. So to do that, we're going to go up to where we loaded in on background, and we're going to use another method. So we're going to say pygame.transform.scale. And what we're going to do now is put this entire image, so this whole line we had before, as the first argument. And then as the second argument, we're going to put what we want to scale this image to, so the dimensions. So in this case, it's going to be width, height, where width, height is those variables we defined earlier for the width and height of the screen. So if we run this now, notice that it fills the entire screen because we scaled that image, and then we're drawing the scaled image onto the screen now, and you can see we get some little pixelated stars and some fun stuff like that. Okay, so I guess the next thing to do is to actually deal with drawing a few things else on the screen. We'll get into characters and stuff in a second, but like the score, the level we're on, things like that. So let's do that first. We're going to say score. Well, actually, I guess it's not score. We're just going to have level and lives. So we'll say level starts on level 1, and we'll say lives starts on 5. Feel free to increment that if you want. Doesn't really matter to me. And I'll show you how we can draw those to the window. So how can we actually draw text? So you saw I had lives and I had level at the top right and left-hand corner of the screen. How do we do that? Well, what the first thing we need to do is actually create a font in Pygame. So a font allows us to kind of render that font. So for example, Comic Sans is what I'm going to use. We need to create the font object and then use that font object to actually render the text to the screen. So the annoying thing in Pygame is that you need to initialize fonts for them to work. So that's pretty easy, but at the top of our program, right after we import Pygame here, we're going to say pygame.font.init. This just tells Pygame, okay, get set up, get the font ready to go so that there's no issues when we want to start using it. So that's what we'll do, pygame.font.init. And now inside of our main here, I'm going to define main underscore font, so that's a variable name, is equal to, in this game, pygame.font.sys font. And here we're going to name the font. So there's all kinds. I'm not going to go through them, but the one that I usually use is Comic Sans. And then the size of this font. So the size that I'm going to use is 50. Make it smaller or bigger depending on what you want. And now I'm going to show you how we can use this to actually draw the lives and the level on the screen. So here I'm going to make a comment. I'm going to say draw, text like that. And the first thing we need to do is make a label and then blit that label to the screen. So you saw how I blit this surface, which is the background, to the screen. What I need to do is turn some text into a surface and then put it on the screen. So I'm going to say, I guess this would be lives underscore label is equal to main underscore font, which we've defined up here, which is Comic Sans size 50, dot render. And here I'm going to type what I want to render. So in this case, I want to render an F string. If you're not familiar with F strings, what this allows you to do is embed variables inside of brackets like this. So left brace, right brace, like the curly brackets. So I can do something like level colon level. And what this will do is take the value of the variable level here and just show that. And so that's with an F preceding this string. Now that only works in Python 3.6 and above. So just keep that in mind when you're running through this. Okay, so then our next arguments are 1 and color. So 1 stands for anti-alias. You can see that's popping up here. I'm not going to explain really what that is. You're just pretty much always going to use 1 if you're blitting something or rendering text, sorry. And then color is an RGB color. So RGB stands for red, green, blue. It's a value between 0 and 255 inclusively. That means you can use 0 and you can use the value 255. And if you wanted to make, say, red, well, it's red, green, blue. So you say, I'm going to use the maximum amount of red, the minimum amount of green, and the minimum amount of blue. That would give you red. If you wanted RGB, if you wanted blue, then you would do 0, 0, 255. If you want white, funny enough, it's 255, 255, 255, because white is actually a combination of all colors. So that's why, or combination all of red, green, blue. So that's what you do like that. If you wanted black, it would be 0, 0, 0. And, you can look up RGB color codes and find them quite easily on the internet. So lives label will be that. We'll say level. Oh, I just realized I called this level. It should be lives. My bad. So lives. Let's do level label. So level label equals main underscore font dot render. We'll do an F string again. Not a D string, an F string. And we will do level colon, and this time we'll do level, and then we'll do 1, 255, 255, 255. So to summarize, this has created text, which is white, anti-aliasing of 1 that has these contents, and now we need to put it on the screen. So to put on the screen, we're going to say win.blitz. First one, what do we want? The lives label, okay? Lives underscore label. And the position that we want to put it on, we need to pick an XY. I want it in the top left-hand corner of my screen, but not like directly in the top left-hand corner, just a little bit offset. So I'm going to say 10, 10. So 10 pixels down, 10 pixels right is where the top left-hand corner of the label will sit. So it will sit just barely offset from the top of the screen. And then we're going to win.blitz, the level label, of course. And here, for our XY, it's going to be a little bit different. I want this on the right-hand corner of the screen. So I'm going to take a guess that, actually, you know what? Let's do the mathematical way, because we're going through some in-depth explanations here anyways. If I want this to be 10 pixels from the right-hand corner of the screen, what I need to do is determine the top left-hand corner of the label. So where should I put that, right? Let's say, like, I want the label to sit so that the edge of the label is only 10 pixels from the far right-hand side of the screen. So to do that, I need to figure out the top left-hand corner position. Well, what I can do is find the width of this label. I can find the width of the window, and then I can take my padding, whatever I want the padding to be, and use some mathematical equation to figure out where that should be. So thinking off the top of my head here, it's going to be width, which is the width of the window itself. So width minus, in this case, it's going to be level underscore label dot get underscore width. So get underscore width is a method you can use on surfaces that tells you the width of that surface. So since I don't know the width of this level label, because I don't know how big or how long this text is going to be, I need to call that method. And then I'm going to subtract another 10 pixels, because if I left it at this, that would mean that it would be right on the edge. So like the L, or like whatever this level number is, would be squished right on the edge. So we'll subtract 10 pixels to move it off. And then we'll pick a Y value, which is going to be the same as what we used before as 10, and blit that to the screen. So let's look at this now. And notice we get lives 5, level 1, perfectly in the right position. I mean, say that, you know, we changed the width. So actually, let's do that. Let's change the width to be 800. So let's go like this. If we change the width, everything works fine. And in fact, I can change any numbers I want. Because we've done this in a dynamic fashion, everything will stay consistent and it will stay totally fine. So we'll put them back to 750, 750, but that's why I've been doing things maybe in a more tedious way rather than just hard coding, because I want this to work for any width height that I choose. So let's zoom out a tiny bit there. Let's move that over. And now let's get into some more stuff. So we've displayed the lives, displayed the level. Now we need to make a character. And in fact, we want to be able to move a character around the screen. So the first thing I'm going to do is set up a ship class. So I'm going to say class ship. This is going to be what we call an abstract class, which means we're not actually going to use this class. We're going to inherit from it later. Because keep in mind, we have enemy ships and we have player ships, right? Those are the two parts of our game, really, right? And they're interacting with each other. So the enemy ship probably has some similar properties to the player ship, so we can share that in one kind of upper level class. And you'll understand how this works more, but just follow along with me for now. So we're going to make an init method. And we're going to say, okay, so what are some properties of a ship that we want to store in this game? Well, we need the X position and the Y position of the ship. So where is the ship starting? Is it starting at the top? Is it on the left? Is it in the middle? So let's go X, Y, like that. What color is this ship? That's something that's important, right? So what color? And what about the health? Does this ship have a specific amount of health? In fact, I'll make this an optional parameter of 100, which just says that our default ship has a health of 100, right? So the reason that we need to put color here is because when we have an enemy ship, we don't know what color it's really going to be, right? So that's what we'll define with this color parameter when we create a new ship. Is it red? Is it green? Or is it blue? It can't be yellow because yellow is going to be the main ship, the one that we're using to shoot at the other ship, right? All right, so actually what I'm going to do is remove this color parameter for now, just because since this is a general ship class, for our player ship, we already know what color that's going to be. It's only the enemy ship that will, you know, change its color on initialization. So we'll define that later. But let's just ignore, if that confused you at all, the color aspect that I was talking about. So we have self.x equals x and self.y equals y. These are setting up attributes for the class so that each ship we create can store, its X value and its Y value, right? And I'm going to try to go through basics of OOP here, like give you a little bit of an explanation in case some of you aren't familiar with the syntax, but just follow along and understand that what I've done is made a ship. What this class allows me to do is make objects of it, so I can have multiple ships that all have these attributes. So they all have an X, they all have a Y, and they all have a health. That's what the class is letting me do, is later we'll create an instance of it, which means that we can have multiple instances of a ship that all store their own health value, their own X, and their own Y, and they all move on their own kind of terms, right? And that's the idea here. We're gonna have multiple things, so let's put it into objects and classes. Okay, so we've done that. We're gonna say /ship_image equals none. Talk about this in a second. /laser_image equals none, and self.lasers equals blank, and self.cooldown counter equals 0. Now, the idea behind this is that when we start shooting lasers, we want to make sure that we can't just spam the lasers. So I'm going to define a cooldown counter here, which essentially means we're going to count and we're going to wait like half a second before we let the user shoot another laser. We'll get into that more later, but we're just starting to class these things out just so that we have that. Okay, so we have that now. Let's define ship. And what we can actually do in here is define a few methods. So the first one that I want to do is draw. So actually, let me go back here for a second just because I feel like some people might be confused on this. So self.shipImage and self.laserImage are what is actually going to allow us to draw the ship and draw the laser. So we need to pick what image from the ones up here that we've loaded in are we going to use for this specific ship. Since this is a general class and it's not going to be instantiated, I'll show you what I mean in a second, we just define them as none for now. But when we actually set up our own ship later and start creating ships, we'll define those images so that we'll be able to use them. Okay, so we have draw. So draw is going to be important for now. And what I actually want to do, because I just want to show you guys how we can move around the ship before we get into anything too complicated, is just draw a rectangle for now. So I'm going to say, we're going to take a window in the parameter. So this is going to tell us where do we draw this, like where are we putting this. And we're going to say window, no, not blit. We're going to say pygame.draw.rect. What this says is Pygame, use the draw module, .draw rectangle. We're going to pick where, so we're going to draw that on the window. We're going to pick a color. Let's make this red for now, so 25500 for red. We need to put a rect in here. Now this is a X, Y, width, height, which tells us how big is this rectangle and where is it on the screen. So where is it going to be? Well, it's going to be at self.x, self.y, because that's the position of this ship. And how wide is it going to be? Well, for now, since we're just testing things, let's make it 50 by 50. Now, if we wanted the rectangle to not be filled in, we could define a width. So let's say we define a width of 2. That's going to give us a hollow rectangle with 2 pixel size for the pen size around. But if we want it to be filled in, we can leave it as nothing or put 0 explicitly, which tells us that that means this is a filled in rectangle. Okay, so now that we have that, I'm going to show you how we can use this ship, and then we'll start getting into some more advanced things, but I want to show you moving it around first. So let's make a ship. Let's say ship equals ship, and here we need to pick an X and a Y value to start the ship at. So I want to start it near the bottom of the screen. So what I'm going to do is pick like 300 by 650. And then what we'll do, we don't need to define a health because that's an optional parameter, right? We've already have that defined. Is inside of my redraw window, I want to draw this ship. So what I'm going to do is a ship dot draw window. Now the idea behind this is that this draw method draws the rectangle for us. All it needs is a window. So what we can do is just call that draw method. If there's any more advanced stuff that needs to happen, we don't need to deal with it here. The ship can deal with that itself in its own draw method. So let's just call it with the window. Now we'll see the ship. So let's run this. And we notice that I've made a mistake. Let's see what this makes. Window is not defined. My bad. We need to put capital win in there. Window is the parameter name. I'm messing it up. So let's do win. If we run this, we get this red rectangle popping up at the bottom of the screen. So if I want to start moving this rectangle around now, I need to modify its X and Y position based on what keys I press. So let's do that now. So to do that, we're going to set up a way to track what keys are being pressed by the person. Now, I could show you how to do it inside this event loop, but the issue with that is it only registers one key press at a time. So let's say I press like the side key and the top key at the same time. It won't move both ways. It will only move one of them, whatever one you hit first. I want it so I can move diagonally as well, so I can move at the same time by just holding down keys. So we'll be allowed to do that by pressing both keys at the same time with this method. So what I'm going to do is I'm going to say keys equals pygame.key.get_pressed. What this does is return a dictionary of all of the keys and tells you whether they are pressed or not at the current time. So since this runs once or 60 times every second, I'm going to mess that up every time I say it, so just get used to it. We'll check 60 times every second if we're pressing a key. If we are, we'll move in a certain direction. If we're not, we won't move. So let's say if keys, and in here, pygame.k_. So k underscore is just the prefix for what keys you can use. So you do pygame and then, or keys. Since it's a dictionary, we're going to access the value and see if it's true. Pygame.k_, and then whatever key it is that you want. So if you want A, you type lowercase a. If you want to check if the left arrow key is being pressed, you do left. If you want enter, it's actually going to be return. If you want space, it's all capital space. You can see I have this nice autocomplete that's telling me, but ideally you can kind of guess with just lowercase letters, and anything that's like a full word, like enter or something, or return, is going to be all capitals. So if we want to move left, we're going to say if keys pygame.k_a, then we'll go hashtag left. I'm just going to do a comment so that tells me we're moving left. And to move left, I need to subtract from the x value of my player. So I'm going to say ship.x minus equals 1. Now, minus equals 1 means we're going to move 1 pixel to the left. Now, ideally, what I should do actually is define a velocity variable, which tells me how fast I'm allowed to move in every direction. So let's do that. At the top here, I'm going to say player_vel equals, and let's pick some number. I'm going to pick 5. What this means is every time I press this key, I can move 5 pixels. So you'll figure out how fast that is when we start testing the game, but that will also be dependent on your clock speed, right? So if you had a lower clock speed, you probably want a higher velocity because this loop is only running so often. So if I held down my key with a higher clock speed, I'm going to move more because this is going to trigger and happen more times and move me more to the left, right? So let's do minus equals ship_vel or player_vel, like that. And now let's do the other keys. So I'll go a little bit faster here. If keys, as I say, I'm going faster, makes a bunch of mistakes. Pygame.k_d. So this is to the right, like that. Make sure I don't forget that colon there. Then we'll say ship.x plus equals player_vel. Then we'll say if keys pygame.k_, and this is going to be w's for up. We're going to go up like that, and then ship.y minus equals player.vel, because remember, we're moving up, so we need to subtract the velocity because the starting position is 0, 0 in the top left. And then we're going to say if keys pygame.k_s, which is going to be down. Notice I'm using WASD. You could use the arrow keys if you want by changing this to be all capital left, all capital right, all capital up, all capital down. So let's do this. We'll do down, then ship.y plus equals player_vel. Okay, so now that we have that, what this will do is move our player. So let's run this and let's have a look. So if I use my WASD, you can see that this cube now moves around the screen. So let's now start restricting how this cube can move, because notice I'm going to go completely off the screen. I can go any direction I want, right? And maybe you might think this is a bit too fast as well. So let's make sure that we can't move off the screen. So to do that, what I'm going to do is say if keys pygame.k_s and ship.y plus player.vel is less than height. So what this is saying is if I add, sorry, not vel, what am I saying? Player_vel. If I add this player velocity value to the current value of my y, will I be off the screen? If I'm not off the screen, let me move, because I'm less than height, which means I'm not off the screen because I'm trying to move down, right? Otherwise, don't. That's what that's saying. So that's that line. So now let's see the other ones. And ship.y minus player_vel is greater than 0, because we're moving up. So we want to make sure that we're not going to be less than 0 when we're doing that. And for right, we'll say and ship.x plus player_vel is less than width, right? And we'll say and ship dot, in this case, x minus player underscore val is greater than 0. So now if we run this, you'll notice that I can't go down. Well, I can, but it stops me. I can't go left, right? If I try to go up, I can't go up. If I try to go right, though, I can go all the way off, but just not like only here. Now, the reason why I can go this far off is because the top left-hand corner is what I'm checking. So right now, technically the constraint that I've plugged in here that's in my code is valid because the top left is still in a valid position. What I need to check, though, is if the edge of this cube is hidden. So the way I do that is by getting the width, right? So what I can do as a quick fix here is say if I'm moving to the right, let's add 50 because that's the width of the cube, and make sure that the top left-hand corner is further enough to the left such that, you know, even if I'm adding this width, it won't go off. So that's the idea here with going right. And now same thing with the bottom. So if I add 50 to the bottom, so when I'm going down, I want to make sure that the bottom edge doesn't go off the screen. So that's how you do that, is you just add the width to that equation. So now notice I can't go any further than that. And if I go to the right, I can't go any further than that. Now, obviously we're going to change this because we're going to use like proper graphics in a second, but I wanted to show you how to move first in a more fundamental aspect, so you understand the mechanics behind what I'm doing. Okay, so now that we've done that, let's actually make a proper ship. So let's make a proper player ship rather that has the proper graphics rather than what I've just done right here. So in draw, what I'm actually going to do here is go window.blitz, and I'm going to say ship or self.ship underscore image. This is just how I reference the attributes that are specific to this ship. So the one that's being drawn. And I'm going to draw this at self.x, self.y. Like that. So draw, window.blit, self.ship, self.x, self.y. We'll get into the laser stuff later, but that's like further on once we have the graphics working. Okay, so we'll do that. And now what I'm going to do is define a new class. I'm going to call this player. Now the player is going to inherit from ship, which means that it's going to take this initialization and it's going to take this draw method and use it. We're going to add more stuff to the ship class later that will make this make more sense, this inheritance. But for now, just understand that any methods in here, because I've defined this inheritance, means I can now use them inside of player. So what I'm going to do is define a init inside of player. So define underscore init self x y health, like that. Health will be a default parameter of 100 once again. And what I'll just do immediately is call this initialization method from inside of here. So to do that, I'm going to say super dot underscore init underscore self x y health, like that. I don't know if this takes self. I don't actually think it does. I think it's just x y health. What this says is super is this parent class ship. Let's use ship's initialization method on this. So we define our own initialization method because we're going to need to change a few things in here, which I'll show you in a second. But let's use the super method so it creates all of these different variables that we need and it initializes things, right? It just runs that code. And now let's add our extension. So we're going to say self.ship underscore image equals yellow ship, and self.laser underscore image equals yellow laser. So we've defined now these two none parameters. So now we have those, we're good to go. And what we need to do next is create what's called a mask. So what a mask is going to let us do is do pixel perfect collision. So you may notice in other games where there's like weird hitboxes, and if you hit like the edge of something, but there's actually not a pixel there, it still counts because it just does a square hitbox. Well, Pygame has this thing called masks, which let us do pixel perfect collision, which we'll get into later, but we need to define a mask. So we're going to say self.mask equals pygame.mask.fromSurface, from surface self.ship image. Now, what that means is, okay, take this surface, which is the ship image, and make a mask of it. This mask just tells us where pixels are and where they aren't in this image, so that when we do collision, we know if we actually hit a pixel or not. Then what we're going to do is say self.max underscore health, because we're going to add a health bar later, is equal to 100. Or not 100, sorry, is equal to health. So whatever health we start with is the maximum health we can have as a player. Now, the reason we need that is because we're going to decrement the player's health, right? Because we define health up here, but we need to still store what it started with so that we can figure out what its maximum health was when we want to draw the health bar and figure out the percentage to decrement it by. So there we go. We have the player. And now I think that should actually be okay for drawing. So let's just change everything from ship now to player. Now, an easy way to do this in subline text is do Command H and find anywhere that says ship, make sure it's case sensitive, and replace that with player, like that. So we're gonna say ship, player, which means now all these things that are highlighted, right, and you can see them, it's not highlighting the capitals, will change to player. So player will be equal to, well, that'll have to change, but anyways, you get the idea. So let's hit replace all, and now all of those are changed to player. So player.x, player.y, all that. And let's now change, instead of ship, this is going to say player. So we're going to initialize a new player, which is equal to a player object starting at 300, 650. And now we've changed all that, so now we'll draw the player. So let's run this. And notice now I have the ship, and it's moving around. Now, no fancy animations here, but that's fine. We're not going to do any animations in this specific video. Let's fix this now so that we can't go off the screen with the ship. So to do that, what I'm going to define in ship is actually a way to get the height and the width of the ship. So I'm going to define inside a player. Actually, let's do it inside a ship because this will be fine. Let's define get underscore width like that. So this is a method. And what we're going to do is return in here self.ship underscore image dot get underscore width. So remember, whenever we have a surface, we can call get width and get height on it, and it'll give us that. So here I'll also define get underscore height self return self.ship image dot get underscore height like that. Okay, so these are two methods. They're just getters. They're literally just returning a value to us because we're going to want those in the main loop. I've defined this in ship, not player, because player inherited from ship, and we're going to want to use these inside of the enemy ships, which we create later. So let's just go ahead and add them to this, base class that we have above. Okay, so now that we've done that, rather than plus 50, all we need to do is go player dot get underscore, in this case this is height, and player dot get underscore width. So before we had 50 there, because 50 was the height and width of our rectangle, but now since we have the actual image, we need to get the height and width of that image and use that as the offsetting value in this equation, right? So that's why we're adding those into there. So let's run this. And now notice that I can no longer go off the screen to the right. I can't go down, can't go left, cannot go up. You may be like, oh, well, why is it only like on this side? It's a little bit different than this side, all of that. You can modify those numbers, like add a few pixels if you want. It's just based on where you start. So like say I start at some location, right? Well, moving to the left, it's hard to explain this, but if you start at pixel value 11, and then you can move back 5, right? So you're at 6. But if you go, so you can move back even more from 6 and you go to 1 pixel, but you can't go any further than that. But if you're going to the right, say the boundary's at like 20, then you can go to 16, but you can't go further than that, because if you're at 16 and you add 5, which is the velocity, you'll be greater than the width, which is 20 pixels in that example, so you can't move that far over. Because I get that question sometimes, like why is it different on the left and right side? I don't think it's a big deal, but some people do. It's just based on where you start the object, and you're subtracting a certain pixel value of like 5 or 4, so you're only going to be able to move in a certain direction so far. I hope that makes sense, that explanation. Okay, so now that we have that, the ship's moving around. Like we're making pretty good progress here. Let's do the enemy ship. So let's get that one running. So we have player, so let's define enemy. So class enemy ship like that. It'll inherit from ship. And in fact, we don't really need to call it enemy ship. We can just call it enemy like that. And inside of here, we'll say define underscore underscore init underscore underscore self x y. We're actually going to put a color parameter here. Remember, I was talking about that before. And then health equals 100. So inside of here, we're going to do the same thing we've done before. I'll go through this slowly after, but I just like to type it so that you don't hear my keyboard the entire time that I'm talking. And then we'll pass x, y, health. Okay, so what I've done is I've defined a new initialization. I've said this time we need to pass a color because our enemy ship will be different colors, right? It'll be red, green, blue. It will not be yellow. And we'll pass the health as well. And we'll call the super constructor. So this one right here to set everything up. And then we will add our own images and stuff after. So what I'm actually going to do in here is make a class variable. And I'm going to call this ship. I'm actually going to call it color underscore map. Now, the idea behind this is that what I want to do is make a dictionary where a specific string, because what I'm going to do is pass a color as a string. So like we'll pass the string like red, green, or blue based on what color it is we want. So if they hit red, I need it so it gives me the red images. So this enemy will have the red images, right? If they give me green, I need them to have the green images. So I'm going to make a map, which is just a dictionary that says, okay, if we type red, right? So if we do red, then what that maps to is the red spaceship image and the red laser. So if we have the red ship, it's going to use the red spaceship image and the red laser, right? If we have green, then what this is going to give us is the green spaceship and the green laser, right? And same thing for blue. So if we go blue, this will be blue spaceship and blue laser. Now, that's like pretty straightforward. I need to make sure I add commas here because this is a dictionary. Let's hit enter one more time so that's proper. And now what I can do is just use this map. So I can say something like self.ship_image, self.laser image is equal to self.colorMap color. So all I need to do is just pass that color, the parameter that we passed in, to this map, and then that will return to me the images that we're going to use. So that's what we have. So we'll do self.shipImage, self.laser image is equal to self.colorMap. There's not really much more I can do to explain that. That's the basic concept behind that. Okay, so once we have that, we need to make a mask. So to make the mask, we're going to say self.mask is equal to, in this case, pygame.mask.fromSurface, like we did before, except this time, well, actually, I guess it's going to be the same thing, self.shipImage like that. So we have the mask, we have the colors set up, we have the images, and all we need to do now, actually, I don't even think there's much we have to do here. We're going to implement a method that allows us to move the ship, but I think that's all we really need for the enemy. So let's have move and let's have vel. And what this is going to do, because the enemy ship will only be moving downwards, right? It's going to start at the top of the screen and move down. This is just going to say, okay, self.y plus equals vel. So if we pass a velocity to this move method, we'll move the ship downwards. Okay, so looking at my other screen, I think that's all we need for the enemy ship. So let's now figure out how we can start spawning enemy ships and have them moving down the screen. And then we'll do lasers, we'll do collision, a main menu, and I guess an end screen, like if you lose, and we'll pretty much be done with this application. Although that is in a little bit because the lasers are the more complicated part of this. So let's start moving the enemies. So what we're going to do is make a list here. I'm going to call this enemies. I'm going to say enemies equals blank list. What this is going to do is store where all of our enemies are. And in fact, I'm going to make another variable. I'm going to say, oops, not static method. I'm going to say wavelength is equal to 5. So we're going to start with a wavelength of 5, and then we're going to increment that every time. And in fact, I'm going to set level equal to 0 because I'm going to do something cool in a second. You'll see why I'm doing that. But what I want to do is every time that we get to the next level, generate a whole new batch of enemies and have them start moving down the screen. So every level we generate a new wave. That wave will be in random positions, and then they'll start moving down slowly based on a certain velocity, which is going to be called the enemy vel. I'm going to set that equal to 1 pixel, so they move quite slowly downwards on the screen. And we'll see how this works. So that's the idea here. What I'm actually going to do is I'm going to get ahead of ourselves a bit. Inside of the redraw window function, I'm going to say for enemy in enemies, enemy.draw win. The reason this works, right, because you're like, well, I don't have a draw method inside an enemy. The reason I can do that is because this inherits from ship. Ship has a draw method where it draws the ship image, and we've defined a ship image here so we can draw that for the enemy, right, based on whatever color it is that that enemy is. So for each enemy, let's draw it onto the screen. That's what this says. In fact, I'm going to make sure that I draw them behind the player, just so that, say, an enemy and a player in the same position, the player's over top of the enemy, because ideally you want to see your own character, not the enemy if you're overlapping. So that's the idea behind that. Okay, so now that we have that, we need to move the enemy and spawn them. So the first thing I'm going to do is actually move this redraw window to the bottom. We might be moving it around quite a bit throughout this, but let's put it at the bottom now to keep it kind of out of the way. And at the top, I'm going to say if the len of enemies equals 0, level plus equals 1. So essentially, as soon as no more enemies are on the screen, because once they hit the bottom, once they're off the screen, this list is going to be empty that represents our enemies because we're going to delete them. I'll show you how that works in a second. Let's increment the level because we beat the current wave of enemies. Let's increment the amount of enemies we're going to have. So let's say cur_wave or wave length, yeah, plus equals 5. So if we start with a wave length of 5, every time let's add 5 more enemies. That's what I'm going to go with, but you guys can add as many or as few as you want. And then let's now create this many enemies. So let's say for I in range wave length, like that. Let's spawn some new enemies and append them to the enemy list and start moving them down. So what I want to do when I spawn these enemies is pick positions for them so they don't all come down at the same time. Ideally, I want them to come down. So I want to spawn all of them here. I want to create all of them here, but I want them to move down and look like they're coming at different times. So to do that, I'm going to pick random positions for them that's way above the screen. So the idea is, I'll go to my drawing tablet here to show you quickly. If this is our screen, right? And I want my enemies to all be moving at a consistent rate. I want to spawn them all at once, but I want them to look like they're moving at a different duration. I can put them above the screen in a negative position and move them down slowly. So what happens is these will all move at the same time, right? They'll move at the exact same velocity downwards, but since they started at different heights, it will look like some of them started coming down before the other ones, when in reality, they just started higher up. So that's the concept that I'm going to use here, is I'm going to randomly spawn them at different heights and different X values. They might overlap with each other. That's just the principle of random. There is ways to fix that, but we're not going to do that here. So that they look like they're coming down at different speeds or different areas, right? So that's the idea. So let's do that. So what I'm going to do is I'm going to say enemy equals enemy. Here we need an X and a Y. So random.rand range. Remember I imported random at the top. The range that I want for the X position is going to be 100 and width minus 100. So this is pretty much saying I want to spawn my enemies at a maximum left side of 100. Actually, let's make this 50. And a maximum right side, so their top X position or top left X position at width minus 100. That's just to make sure they don't go off the screen, right? And then we need a Y value. So let's do random.rand range. In here, we need a Y. So I want these to start negative, so they start off the screen. So my first value is going to be the smallest value that I want them to start at, which is going to be 1500. And the next value will be the closest. So I want them to start between negative 1500 and negative 100. Now you could, in theory, have the possibility that they all start at the same level because this is random. But the idea is that they probably won't do that because it's such a large range. So some will be up higher, some will be down lower, and they should be in kind of relatively different positions so that they come down at different times. Now you can change the way you spawn these if you want, but this is my idea. This is what I want to use, but again, you guys do whatever you want. This is your game. So random, because now that we've done the X and Y position, we need a color. So let's do random.choice. And inside of here, we're going to make a list of colors. So in this, it's going to be red, blue, green. Now what random.choice does is randomly chooses one element from a list. Pretty straightforward. So this is the list of colors that we want that are valid, red, blue, green. So randomly pick one from that for the ship. That's just because I want some variety. I want some different ship colors. If you want to have like red ships have more health or something, go ahead, feel free to do that. But I'm not going to do that for this. I'm just going to make them all the same, but just different colors, right? So that spawns them. And now what I need to do is just add them to the enemy list. So enemies dot append enemy like that. And now that I've done that, they're in the enemy list and I can start accessing the enemy list to move my enemies. So we've done that. We've spawned them in. If the len of enemies is 0, we'll increment the level, increment the wave by 5, spawn all of the enemies that we need, and then, move forward. Now you could say, all right, well, if we get to a really high up level, this might be slightly flawed because you're going to have so many enemies within this smaller range. So you could do something like negative 1500 times level over 5 or something. Like you can change this value if you want. Level over 5 will be a bit of an issue, but you can do like a more dynamic approach to this range if you want to multiply by some constant value or something like that. But that's just, I'm just throwing that idea out there in case you guys want that. So if we want to move these enemies, essentially what we're going to do is every time that they're on the screen, so there's any enemies in our list, we'll move them down by their velocity. Pretty easy. We're going to say for enemy in enemies, enemy.move, and in this case, it's just going to be enemy velocity, like that. Now you see how neat and nice our code is reading right now because we've implemented these methods. Keep that in mind that, that's the nice thing about making classes and methods, is that when we use a main line like this, it's really easy to read because we have these nice methods that literally are reading out and telling us what it is we're doing. So I think that should work. Let's run this code. What's the issue here? What have I done wrong? Random.choice, key error green. So it would help if I spelt everything correctly. So the green needs 2 E's. The issue there was I spelt that wrong. So when it tried to create an enemy that was gren, not green, it couldn't do that. But let's run this now and see that if we wait a second, because they spawn quite high, right? Now all these enemies start coming in. Now, we got unlucky here. They kind of came in a batch, but we can, again, do whatever we want. If we want to spawn them like every 100 pixels upwards, you guys can figure out how to do that. But the issue we're seeing immediately is we're not losing any lives when these enemies go off the screen, and they're not actually being removed from the list, which means that we're never going to make new enemies once all the enemies are off the screen. So what we need to do now is every time we move the enemy, make sure that they are not off the screen, and if they are, decrement the lives and remove them from the list to show, hey, this enemy is gone. So to do that, we're just going to check the position of the enemy. So if enemy .y plus enemy dot get underscore height. Notice we've used this method now that we needed. Plus, actually, I guess not plus because we already moved them, so we'll just check. Is greater than height. Then what we'll say is lives minus equals 1 because we lost a live. They hit the checkpoint at the end of the level. Let's delete them then. So if we want to delete them, since we're looping through this list, I need to make this a copy of the enemy list and just do enemy dot remove, or not enemy, sorry, enemies dot remove enemy. What this does is remove the object, which is this enemy, from the enemies list. I've made a copy here so that it doesn't modify the list we're looping through, because sometimes that leads to issues. And that will mean that then once all the enemies have gone off the screen, there'll be none left in the list. So we're able to hit this len equals 0 condition, increment the level, and increment the wave. So let's do that and let's run this and let's see if they actually go off the screen. I guess I'll fast forward and we'll go through this. Okay, so we can see that the lives now, obviously we're going negative because, we've lost at this point. But just notice that once we get to -5, because we started with 10, the level increments and now more enemies start coming onto the screen in different positions, and these seem to be working fairly well. Now, obviously, what we need to do is make sure that we don't have a negative live score. So we'll implement something that will fix that for us, which is just going to tell us if we lost. And then we'll get into shooting the lasers. And after we do the lasers and the collision with the lasers, I think that's pretty much all we'll need for this game. So let's do the thing if we lose now. So essentially, if lives is less than 0, or I guess less than or equal to 0, and in this case, I'm actually going to say or player.health is less than or equal to 0, because we are going to implement a health bar. That's what I forgot. We'll need to do that next with the player. Then we'll say that we lost. So we'll just say lost equals true. We'll define a lost variable up here. We'll say lost equals false, like that. And now, if we get spelled lost correctly, what we'll do is if lost is equal to true, we're going to increment some kind of counter system that essentially says we're going to show a lost message on the screen for a certain amount of time, and then once that lost message is done, we'll go back to like the main menu, which we're going to create later. So lost equals true. Let's actually just do something inside of redraw window here. So we'll say at the bottom, if lost, so if lost is equal to true, we can access that because it's up here. What we'll do is we'll say lost font, which we're going to need to make a new font for. So instead of main font, we'll say lost font, like that. Make this a font size of 60, so just a bit bigger, a bit more emphasis. And we'll say lost underscore label equals lost font dot render. In this case, the text is going to say you lost exclamation point 1 color, that'll be white, 255. Then say win dot blitz lost label. And if we want to put this perfectly center in the screen, I'll show you some math magic to do that. That's going to be width over 2 minus, I'll explain this in a second, don't worry, lost underscore label dot get underscore width over 2. So the idea behind this, and let's put it at a Y position of 350, is that if we want this to be in the center of the screen is the width over 2. But since this has a width, like the text itself, and we draw from the top left, we need to make sure that we're drawing so that the width, right, when we include that width, will still be centered. So if we do width over 2, and then we subtract from that to go left so that we account for the extra width, half of the width of the text, that'll be perfectly centered. Because that's like, I don't know a really great way to explain it, but essentially if we have center here, if we draw, it's going to come all the way over to one side or all the way over to one side. So if we can move this position over slightly so that it's half of where the width is, then it will be perfectly center in the middle of the screen. That's my somewhat visualization using my hands. Hopefully that made sense. But that's the math there to put that in the middle. And there you go. So now we'll check what happens if we do lose. I'll show you that the game is going to still run when it says you lost, which we'll fix in a second. But the idea here is that it's just like, you know, it's going to say that we lost. So let's speed this up. We'll get through it and then I'll show you. Okay, so we're coming down to 1 life. We see you lost now pops up in the middle of the screen. Obviously the game keeps running, but I'm going to show you how we fix that now. So to fix this, we need to increment some kind of like timer that tells us how long to show the lost message for before we just reset the game, and also pause the game, right? So it doesn't keep moving and decrementing the lives once we lose. We want to just pause the game once we lose. So we're going to say, after lost, we're going to say lost underscore count equals 0. And what we're going to do now is if we've lost, right? Lost equals true. We'll say lost underscore count plus equals 1. So increment 1 every time. And then down here we'll say if lost, like that. Say if lost underscore count is greater than, in this case, we're going to do 60 because that's our FPS. So actually we'll do FPS multiplied by 5. So if we wanted to say show the message for 5 seconds, we would do FPS multiplied by 5 because FPS is how many frames we show per second, you know, and then how many seconds we want. So in this case, let's do 3. So if it's greater than that, then what we'll do is we'll break this while loop. So we'll say run equals false and we'll quit the game. Otherwise, so else, we'll continue. Now what this is saying essentially, and we're going to have to move this redraw window to actually be at the very beginning of the loop. So I should have left it there, but that's okay. What this is saying is if we've lost, so if lives is less than equal to 0 or player health is less than 0, lost equals true. Lost count plus equals 1. And then we say if lost, so if we have lost, if the lost count is greater than FPS times 3, then run equals false, which means we've now got past our 3-second timer. Let's quit the game. If it's not, so if it's still looping, we're still waiting to hit 3 seconds, continue, which means don't do any of this. Don't let us move. Don't move anything. Go back to the beginning of this while loop and keep running. And then we're redrawing the window every time. So we'll look like that lost just sits there for 3 seconds and nothing else happens. Let's run this. I'll show you what I mean. So again, I'll speed up. We'll get to when we lost and I will show you. Okay, so we're getting down to it here. We can see 2, 1, you lost, boom, level freezes, wait, 2, 3, boom, game ends. Okay, so that is how that works. We've got the loss counter going here. We can add a main menu pretty easily later on, but now time for collision and lasers. Now, the lasers and the bullets are a little bit more complex in terms of how they move because we need to shoot them from the enemy ship or from the player, but we'll get into that, I guess, right now. All right, so the first thing we need to do if we're going to be shooting lasers is we need to create some kind of laser object. So in this case, what I'm actually going to do is make a new class called laser. So let's type this out, class laser. We're going to do an init, and what this is going to represent is just one laser object. Now, the idea is that we're going to have multiple lasers being shot from each player, right? So if I shoot a laser going upwards, I need to make sure that it keeps going in that same upwards angle, right? It's not following what the player is moving, because a common issue people will do is they'll make like the laser follow the X position of the player, which means that if I press the left arrow key once I've shot the laser moves to the left, which is not what we want to do, right? We want to make sure each of these items are independent of the person or the player or the enemy or whatever it is, so that they can kind of act on their own and they can collide with things on their own and they're their own entity. So that's the idea. So what we're going to do here is have a laser. It's going to have an X, Y. It needs an image. We're going to pass that image from the ship class. So the idea is that when we make a new laser object, so when we shoot this laser, the player will create the laser object, add it to its laser list. So you can see we have lasers here, and then it will control how those lasers are moved. So that's kind of the concept. But we'll get into that in a sec. So let's say self.x equals x, self.y equals y, self.img equals img. And of course, we need to make a mask for this as well, because this is what's going to be colliding with different things. So self.mask equals pygame.mask.fromSurface self.img. No, you could put img there as well. Doesn't really matter, but we're going to do that. So now what we're going to do is make a draw method. So the draw method will take self window like before, and we'll say window.lit self.img, and then self.x, self.y. Now what we'll do is we'll do define move. So define move self-vel, which will move this with the velocity. So the velocity will be going upwards or downwards based on what we pass in here. So in this case, we'll just say self.y plus equals vel. If we want to go down, we'll give a positive vel. If we want to go up, we'll give a negative vel as the parameter. And if we add a negative value, obviously that means we go up. So we have move. Let's define a few more methods. We're going to define off underscore screen, which is going to tell us if this laser is off the screen based off the height of the screen. So we're just going to return from this. Return self.y is less than height, and and self.y is greater than 0. We'll do greater than equal to, less than equal to as well, I guess, and that should be good for this right now. Now we're going to find one more method, which is going to say collision, which is going to tell us if this collides with an object. So laser collide object. And what this is going to do is call a function that we've yet to define, but we'll define in a second, called collide. So all this will do is return the collide of object self. Now let's actually go ahead and create this collide method collide function, I guess, because what we're going to need to do is check if things are colliding when we're moving the lasers. So it makes sense to do that before we start actually moving the lasers. But essentially what we're going to do with the collide is use these masks to determine if two objects are overlapping, if the pixels between them are overlapping. And if they are, then we'll say, yes, these two objects are colliding. So I'm going to define a function here called collide. It's going to take object 1. Actually, we'll just do obj1 and obj2. And what we need to do here is use something in Pygame, or use this mask property called, actually, I got to look over here to see exactly what it's called because I'm blanking on it right now. I believe it's like overlap. Yeah, that's what it's called. It's called overlap. So what we need to do when we call an overlap, and actually, let me go to my drawing tablet, give you my beautiful drawing skills with my mouse again to show you what I mean. So what a mask is essentially if we have like this, right? So this is my object. An object has a width and a height. Now we know that when we're drawing these objects, only some of the object is actually taken up with pixels, right? So in the example of our ship, we have something, this is going to be my very crud ship, right? This is like my rocket ship, say it looks something like that. Maybe it has like a little tail. But the idea here is that these are where the pixels are, and all of this blank space here is not where any pixels are. But based on the way that we've loaded this object in, if something hits like right here, we'll say that it's hit the object because it's inside of this width height hitbox, like this WH hitbox. I'm not sure if I explained this before, but essentially, let's say we bring in a circle. It's really hard to draw with this mouse. Let's say we bring in a circle, right? Well, what actually happens is it makes a square around this circle, and that is what the surface of the circle is. It's rectangular because it's very difficult to have circular objects in computer graphics, like when we're rendering and drawing things and creating surfaces. So the idea is that we have this circle, but really it's represented by a square where all these other things right here are transparent, but the actual circle itself is the pixels, right? So we want to make sure that when something hits our object, we're not saying it hit unless it actually hits some of the pixels of our object, not the transparent background that may exist that's a part of that object. And you will see this quite often when you load in sprites, is it'll load in with width height, right? Like say we load in a little character. It'll load in like this will be our character. And if you hit this side, like anywhere on this box, it will say we hit the character, even though it's not touching the pixels. So it's misleading to the player. So the way that this mask thing works is if we have two, let's say objects like this, and they're overlapping like this. what we do is we ask Pygame, we say, okay, so if there's like pixels here, and there's pixels here, and there's pixels in the same area. So if there's pixels inside of this overlap in both objects, we'll say that this collided. If there's not, we'll say it didn't collide, it did not collide because these two objects are not overlapping where their pixels exist. I think that makes sense, but like the idea is if we have, Stickman, right, and he has his thing like this, and then we have, I don't know, say a laser like that. Maybe the laser's hitbox is something like that. Even though these two boxes are colliding, we're not going to say they collide unless the pixels hit the other pixels. So the way that we need to do this, though, is we have these two masks, which represent where pixels are. That's why we created that mask object. But in order to determine if they're overlapping, we need to come up with something that's called an offset. The offset essentially tells us the distance between the top left-hand corner of both of these objects. We need to know that because given that information, we'll be able to determine if they're actually colliding with each other and where their point of intersection actually is. Because what the overlap method will do in mask, which we'll use in a second, is tell us where these two objects collide. So a point of intersection between them. Now, we don't really need that, but we're just going to see if we get a point of intersection. And if we do, we'll say, yes, these objects collided. If we don't, they did not. But the idea is we need this offset, which tells us how far away object 2 is from object 1 based on their top left-hand corner coordinates. So to calculate that, what we're going to say is obj1, actually I will say offset underscore x equals obj2.x minus obj1.x. This will tell us the distance from object 1 to object 2. It's fine if this value is negative, which it may be sometimes depending on the coordinates, but that's how we do that for offset x. Now, offset y is going to be equal to obj2.y minus obj1.y. So again, that just tells us the difference between them. Since this is xy, I mean, you can consider that a vector with two components. We need to do these separately and subtract like that. So now that we have that, what we can just do is return obj1.mask. I believe this is overlap. Yeah, I've said that so many times. .overlap, and then here we're going to say obj2. So is object 1 overlapping object 2 with the offset of offset x, offset y. So that's what this collide function will tell us is given two masks, right? So given object 1 and object 2, if they both have a mask, so mask here, and sorry, this needs to be object2.mask. If these masks are overlapping based on the offset that we've given between the difference of their top left coordinates, then we'll return true, otherwise we'll return false. And actually what this needs to be is return does not equal none, because if they're not overlapping, this whole thing that I'm highlighting here will return none. If they are, it will return to us actually a tuple or a tuple that looks like this, xy, that tells us the point of intersection. So hopefully that wasn't too confusing and I didn't go too crazy fast. It's kind of hard to explain masks without my drawing tablet out, which I don't really want to get out right now, but I think that's a good enough explanation for the collision. So if we go back to where we actually called that, which is here, we can see that all this is doing is returning the value of this collide function. Now, the reason I've called self here is because I want to see if the object is colliding with myself, right? And I could call it in the other method, or the other order, which is self obj. But all self does is give access to this specific instance. So in this case, it'll be a specific laser. So we'll just pass those two things in. So the self, which is this object, and then the object that's giving us here that we want to check if there's a collision with, and then it will return to us if it's collided or not. Okay, so now what we're going to need to do is implement a few things inside of the enemy and player class in terms of creating a laser, as well as creating a cooldown for the laser so we can't shoot it too fast. So the first thing I'm going to do is implement a shoot method inside of this base class ship, because both of our methods or both of our classes will be able to use this. So define shoot self. We're going to say vel like that. Is it vel? No, I think we literally just need self. I think we'll literally just have shoot self. And then what we're going to do is say if self.cooldown counter equals 0, which means we're not in the process of counting up to a specific cooldown or keeping track of how long until the next shot, then what we will do is create a new laser and add it to the laser list. So we'll say laser equals, in this case, laser. We'll give it our XY value, so XY, and then what else does the laser need? It needs an image, so the image we'll pass is self.laserImage, because the laser image is what we're storing here as the image for the laser. Then we'll say, in this case, lasers.append laser, like that. And the next thing we'll do is reset the cooldown counter so that it starts counting. So I'm going to say, or not reset, we'll start the cooldown counter so it starts counting up. So self.cooldown counter equals 1. So the idea behind this is that we will make sure that we are at 0 for the cooldown counter, so it's not at a certain value, like waiting to go down or waiting to go up or whatever it's going to be. And if it is, we'll create a new laser at this current location, which will move later on. We'll add it to the lasers list, and then we'll set the cooldown counter to start counting up. Now, what I'm going to do here is say define cooldown. And what this is going to do is just handle counting the cooldown. So we're going to say if cooldown counter, so if self.cooldown counter is greater than or equal to, in this self.cooldown, all capitals, and I'm going to define that as a class variable up here. So cooldown equals 30, so that's half a second, because the FPS is 60, right? So if that's greater than self.cooldown, self.cooldown counter equals 0. Say else self.cooldown counter plus equals 1. And we will only increment this cooldown counter if, not else, say if self.cooldown counter, so elif self.cooldown counter greater than 0. So essentially, if this cooldown counter is 0, we're not doing anything, right? Because it's not greater than or equal to self.cooldown, and it's not greater than or equal to 0. But if it is greater than 0 and it's not past the time limit, increment it by 1. Okay, so now we need a way to draw and to move our lasers. So the idea is that we're going to call this shoot method that creates the laser from down here. So essentially, if we hit the space bar, we'll call shoot, which will create a new laser object. So actually, let's implement that now. Let's say if keys in this Pygame .k underscore space, so we're going to use the space bar, then what we'll say is player.shoot. So that will call that method and we'll create a new laser. Now remember, this is only going to create a new laser if the cooldown counter is equal to 0. Otherwise, it just won't do anything. That's fine. We can hit space as much as we want, but if we're on cooldown, it's not going to work. So what we now need to do is have a method that can move these lasers, because right now, if we do that, it's just going to make them and they're going to stand still. And in fact, right now, we won't even see them because we're not drawing them. So first, actually, I'll just draw the lasers. So inside this draw method, I'm going to say for laser in self.lasers, like that. And then we'll literally just do laser.draw window. So that will draw all of our lasers. We have a draw method on our lasers that just draws them here. So that's totally fine to call that, no issue there. Now we're going to define a new method. This will be called move lasers. So define move lasers, self, vel, and then objs. Now, the reason I have objs here, so vel makes sense because that's like how fast are we going to move the lasers, the velocity, but obj stands for objects. And the idea here is that when I move these lasers, I want to check for collision with all of these objects. So to do that, I need the objects that I want to check collision with, which are here. So we're going to move all of the lasers by this velocity. So we're going to say for laser in self.lasers. And before we do that, we're actually going to increment the cooldown counter by calling self.cooldown. So every time we move the lasers, we're going to call this once a frame, which means that we'll increment the cooldown counter when we move the lasers, right? So we can check if we can send another laser or not. And then we'll loop through all of the lasers. And what we'll do in here, I got to check here, is go laser.move the velocity. So we'll move it by the velocity. And we'll say if laser.offScreen, which we've made that method here, we'll delete the laser. So with laser.offScreen height, we'll say if that's off the screen, then we'll go self.lasers.remove laser, like that, and there shouldn't be a problem with that. Now, otherwise, if laser dot collision with an object, and we'll actually need to implement another for loop in here in a second. I'll tell you that. Okay, let's take a step back here. So I think I'm going to confuse myself a little bit. So I just want to step back and make sure everyone understands. So first of all, I've changed this parameter from objs with an S to obj. The idea being that actually what I'm going to do in this specific move lasers method is check if each laser has hit the player. So the idea behind this is that this is going to be used for the player and for the enemy. But inside the player, what I'll actually do, because this is the base class, right? We're inside a ship, is I will implement a new method called move lasers. But rather than checking if we hit the player, we'll check if we hit any enemies. So that's kind of the idea. We need two separate move laser methods. One for checking if all of the lasers shot by the enemies have hit the player, and one for checking if all the lasers hit by the player have hit the enemy. So that's the idea. Since there's only one player, we only need one object here, which means for each laser, we can do if laser.collision object, then we can reduce the health of that object, which will be our player. So we can say obj.health minus equals, let's say they lose 10 health. So we can change this value to be whatever we want, but I'm just going to keep it at 10 for now. And I think that that is pretty much good, except that we're going to need to delete this laser. So self.lasers.remove laser like that. So yes, so that's what this is doing. Call the cooldown, which goes through and says, okay, you know, we're going to increment this cooldown based on what we've defined here. So if we can shoot or not, then we're going to, for each laser that we've shot that exists currently in our list, we'll move it down the screen by the velocity. We'll check if it's off the screen. If it's off the screen, we'll remove it. If it's not off the screen, but it's collided with one of our objects, in this case, this object will be the player that we pass to it. We'll do object.health minus equals 10, which is the player, right? Minus equals 10. And then we'll say self.lasers.remove lasers. So remove that because when it hits them, we don't want it to keep going down afterwards and it potentially hit them a bunch of times if it keeps colliding with the player. So that's the move lasers here. I'm going to copy this and we're just going to change it a bit inside of player. So let's put this inside of player. This is going to override that parent class one and we'll do the same thing. So it'll call self.cooldown again. And we'll say for laser and self.lasers, laser.move. But now what I'll do is I'll say elif, laser.offscreen height. We'll change this to objs. Then we'll put an else. And inside of here, we're going to put another for loop. So we're going to say for, in this case, obj in objs. Then do this and say if laser.collision obj. And then we could do obj.health minus equals 10. But since what I'm going to pass in here is a list of all of the enemies, because we want to check if the player's lasers have hit any enemies, we're just going to remove that enemy from the obj's list. So we're going to say, we'll remove the laser, obviously. But we'll say objs.remove obj. Okay, so I think that makes sense. So we have the player. What this is doing is I'm going to pass to here, and this is going to make a lot more sense when I start actually passing from the main loop. It's just, I know it's confusing now because it's kind of an abstract concept, but for each laser that the player has, move the laser. If the laser's off the screen, remove it. If it's not off the screen, for each object in the object list, if the laser has collided with that object, remove it. So delete that object. Otherwise, remove the laser, or not otherwise, but remove the laser after that happens as well. So that's all we need for player and ship for moving the lasers. So now what we need to do is for each player, well, our player, and for each ship or each enemy ship, we need to move their lasers each loop. So for enemy and enemies, we also need to call enemy.moveLaser, right, with a velocity, which is going to be the, I guess, what was the velocity? The laser velocity? Do we have laser velocity as a variable? We do not. So I'm going to define that. I'm going to say laser underscore val equals 4. Then here we'll do move it by laser underscore val and check if it's hit the player. So we pass the player object there. That's the idea behind that. Then down here we're going to say player.moveLasers, pass in this case the laser val and the entire list of enemies. So self.enemies. So this will now check if the laser has collided with any of the enemies. So that's the idea behind this, is that what is the move lasers method is doing. There's easier ways to do this probably, but this is the way that I came up with it that seems to make the most amount of sense. So let's run this now and say self is not defined. So oops, so this shouldn't be self.enemies. My bad, this should be enemies. Long session of recording, starting to get tired here. So let's run this and check now. So if I press space, okay, so name X is not defined. Where is that? So I've made a mistake somewhere here. Let's have a look. So laser XY self.laser image. Okay, so that should be 83 and shoot. So I know what the issue is immediately, but I'll break it down for you. So I made a mistake here in the shoot method by calling XY when really this should be self.x, self.y. Won't be surprised if we get a few more errors like that. So let's run this and press space. When I press space, nothing's happening. Aha, so I've determined the issue. So you saw that none of the lasers were showing up. Now there's a few problems I'm going to go through. I want to summarize what we've done so far and then fix this issue. So what we just did was create these move lasers. Now I apologize in advance if this was really confusing, because I was kind of confusing myself while I was going through this. But the idea is, again, these are moving the lasers. So we call this every loop on all our enemies and on all our players, or our player, so that they can handle the movement of their own lasers. Notice that in the draw, we're drawing all the lasers, so they should show up on the screen. What we do is inside of cooldown, we're making sure that we're not shooting too fast and that we have at least a half a second delay before we can shoot. That's what this does here. We make sure that the cooldown counter is equal to 0. Then we make a laser and add it to the list if we press space, right? If we call this method, if we shoot. So then we set the cooldown counter to 1. The cooldown counter goes through, does its loop, and then it lets us shoot again once it resets to 0. So here, this is the move laser for the player. This is a little bit different. What this is doing is checking if the laser collides with every single enemy, which we pass in as OBJs, right? If it does, we remove that object, so we remove that enemy, and we remove the laser. Now, the issue I was having is this right here. If laser.offScreen height, then remove the laser. What I did in offscreen was a little bit of a mistake. So this actually needs to say not this. So what this is telling me here is if this is on the screen, that's what this value is. So I need to negate that to not, to make sure that I actually get what I'm looking for is if this is off the screen, I get true. And if it's not off the screen, I get false. Whereas before, if it was off the screen, I was getting false. And if it was on the screen, I was getting true. So it was just immediately being deleted. So let's go ahead and run this now and notice, and I'll show you this mistake as well. When I press, this bullet's going backwards. Now the issue with that, and let's just actually just test if this even works. So it does. If the laser hits them, it deletes them. The reason that's happening is because I haven't made the velocity negative to make it go upwards. So what I need to do is here in laser val for players, I need to make that negative. The reason for that is I want to make sure that I'm going up, not down. Because if I pass a positive velocity and I add a positive velocity to my bullet or my laser, it's going to go downwards, not upwards. So let's negate that or change that to negative. And now notice my bullets are going up. Now, if you don't like the speed of these bullets, you want to increase them. I would agree with you. I think they might need to be a little bit faster. Let's make them 5 like that. And we will notice a slightly substantial difference in terms of the speed of these bullets. But notice that that collision was working. And now all we need to do is make it so that the enemies start shooting at us. Once the enemies start shooting at us, we'll implement the health bar, and then we'll pretty much be done with this. Well, we obviously need to do we have the you lost screen actually, but we need to add like a little bit of a menu and stuff, but we're pretty much almost done once we do that. So let's do that now. Let's make the enemy start shooting at us. Okay, so what we need to do now to actually have the enemy shoot a bullet is pick some probability that they're going to shoot each frame. So ideally what we're going to do is something like if rand range between 0 and some number is equal to 1, then have the enemy shoot. So what number do we pick though is the question. So let's say you want every second your enemy to have a probability of 50% of shooting. So every second you want a 50% chance that your enemy is going to shoot. So in theory, every 2 seconds your enemy should shoot a bullet, and that's going to apply to every single enemy. Well, you need to take that probability, which is 1 over 2, right? Which would mean you just put 2 here and multiply it by 60 because you have 60 frames per second. So if you want the probability to be that they have a 50% chance of shooting every second, then you make this number 120 because 60 times 2 is equal to that. And in fact, if you want to keep this easier for yourself, you can do something like 4 multiplied by 60, even though we know that's 240. just so you can change this to have it equate to the amount of seconds before you want the enemy to shoot. Now you can hard code like every 2 seconds have the enemy shoot, but I just like to have some degree of randomness to make the game a bit more difficult. I don't know if this probability is going to be too low or too high. Let's leave it on 2 for now and just mess with this number and see if it's good or not for you, right? So now that we have that though, let's run this and hopefully our enemies should start shooting once they get onto the screen. So let's have a look at this, and they do. You can see that they're starting to shoot. Some of them are shooting more frequently than others. Of course, obviously this is random, right? Now notice that I can run through my enemies. So we're going to fix that so that we can actually, if we hit the enemies, we lose health. But also I can be hit by the bullets or disappearing. These things can hit me. And you might notice that the bullets are shooting slightly offset from the center of the enemies. It's quite easy to fix that. You can just subtract. Oh, actually, I'll fix it for you guys right now. You can just subtract the X value of where you're going to start shooting the bullet from. So in this case, if we go to enemy, where are we here? And shoot, where is shoot? Do we need to find the shoot method? If we override the shoot method in enemy, so we'll just take that and move that here. What we'll do is we'll just offset where this is being created. So I'm overriding this in the enemy. I'm going to say self.x minus like 10 pixels. So now if you look at this, they shouldn't be, or they should be shooting more from the middle because we just offsetted where the bullets start by 10 pixels. So that one clearly didn't do that much for us. Let's move it over even more. Let's move it over like 20 pixels and see if that makes a bigger difference. Let's have a look here. Waiting for some enemies to come on the screen. Let's wait for this guy to shoot his green bullet. So that's slightly to the left. That's okay with me. I'm fine if they're like that far to the left. I want to see these blue guys shooting now though. Give me the bullet. Okay, so that's fairly in the center. So for me, that's fine. I mean, if you wanted to be perfectly center, you'd have to use a little bit more math there. But this is the probability of them shooting. I think it might be a little bit too high right now. But again, we can mess with that number and change it around. But now let's do the collision between the spaceship and the other ships. And then a health bar, a main menu, and we're pretty much done. So to do the collision between the player and all the other ships, all we have to do inside of here is say, if collide enemy, and in this case, this is going to be player, then we'll just say player.health minus equals 10, and then remove the enemy. So enemies.remove enemy like that. Enemy, if we spell that correctly. Okay, so let's put that at the top though, because we want to make sure we don't remove the enemy before we check that. So we'll do that right after the enemy shoots like that. And then we'll put this as an elif actually, just to make sure that we're not going to check if, you know, the enemy's off the screen if it's already collided with the player. So that's the idea there. We have this random shot, we have this collision with the player, that'll remove the enemy and will reduce 10 health from our player. Now we need to add a health bar, which is pretty easy to do actually, and then the main menu, and we're pretty much done. So let's do the health bar. To do the health bar, what I'm going to do is just implement a function inside of player. So I'm going to say define health bar like that. Here I'm going to take self, and all I'm going to do in here is draw rectangles that are red and green based on the health of my player. So the first rectangle I'm going to draw is going to be red. It's going to be the length of my player. And then I'm going to draw a green rectangle that goes on top of that red rectangle, but will be only the length of the health, right? So if it's like, say we have 50% health, we have 50 out of 100 health, it'll be 50% of the length of the red rectangle, but on top of it, so that it shows like half green, half red. It's kind of a cool trick. I'll show you exactly how that works. Let me just get this because there is a little bit of an equation that goes into doing this that I had to come up with. So here, what we're going to do is we're going to say pygame.draw.rect. We're going to draw that. So we need to draw the health bar, I guess. So it's going to be a window. Let's take that on the window. Rectangle, we need a color. We're going to draw red first, so 25500. Then we need the rectangle, so self.x, self.y, if I could spell this, self.y, plus self.image, so self.shipImage dot get underscore height. Why is my typing so horrible today? Self.height plus 10. Let's finish off those brackets there. So the idea behind this is that we want to make sure the health bar is below our player. So we want to get the Y value of the player, add the height of the ship, add 10 pixels, and then start drawing that there. And the self.x can draw where we usually draw the x, and that's fine. Now for the width, what we'll do is self.shipImage, right? Dot get underscore width, so it's the same width as the ship. And for the height, I'll just make it 10 pixels. And you can make that as much as you want, but we'll just do 10. Now let's copy this, and we'll do the exact same thing now in green, except just a little bit different for the rectangle width. So it's gonna be the exact same stuff, except the only thing that's gonna change is the width and the color. So 0, so red, green, blue, so 0, 2, 3, 5, 0. And what we need to do now is essentially determine what percentage of the width we should draw. So if we want the width to be this, so self.ship underscore image.get width, we're gonna multiply this by some fraction that will essentially tell us how much width we want to put. So to do that, we're going to multiply that by 1 minus, in this case, max underscore health minus self.health. And I actually think that should be self.health. And then that's going to be divided by, here, self.maxHealth. Now I think I might have made this math equation way more difficult than it needs to be. But let's just think about this for 1 second. So I want to multiply the width by 1 minus, these don't need as many set. Oh yeah, I think these brackets are correct. 1 minus the maximum health minus the self.health, which will essentially tell us, okay, so how much difference is there between the maximum health and the health we have right now? And then divide that by the max health to get the percentage health that we're down. And we're going to subtract 1 from that, although I think an easier way to do this would just be to multiply by self.health. Yeah, this is going to be easier, by self.health over self.maxHealth. So I'm glad that I took the initiative to fix that there. Yeah, so this is the image width multiplied by the health over the maximum health, which is just telling us what percentage of health we're currently at. So since we know this is going to go in increments of -10, this is fine to do. Like, we won't get a decimal value here, but you know, sometimes we might. So just keep that in mind. But yeah, I think that's the equation. I think that makes sense. Hopefully that makes sense to you guys. I'm just trying to figure out what percentage of width that we should draw the green rectangle at, so that if we lose 10 health, that goes down a little bit, right? And we can do that variably using that kind of equation that I just drew. So we have health bars, so let's implement that now into the draw method of the player ship. So let's define the draw again. So define draw, we'll do self window. We're gonna call the super draw method, so super dot underscore, sorry, what am I saying, dot net, super dot draw. We'll pass that the window, and then we'll call self dot health bar. So self dot health bar with the window. So I've just overridden the method from the parent class, which is this one here, which has the draw. I called the parent's draw method with the super, and then I'm calling the health bar for the window, or with the window, which now should draw that health bar for me. So let's have a look. What's the issue here? Let's see. Has no attribute get. So I've added an extra dot accidentally here. This should be a get underscore height. Get underscore height. I'm sure most of you probably noticed that. So get underscore height. Let's run this now. What's the issue here? I made another mistake. Rect argument is invalid. I think I forgot to add the 10. Yes, I did. So multiply there. Let's see if this is the correct bracket. Yeah, so I think I'm just messing up a bracket here. I think that goes there, and I think now we should be good. No, we're not. Let's see what's going on with the brackets here. Give me 1 sec, guys. Okay, so I did fix it. The issue was I just had all these brackets messed up in here. I just needed to add 2 at the end there. The code will be in the description if you guys are getting confused with what I'm doing. So here, you can see when we load in, the health bar is off the screen. We can fix that if we want quite easily. In fact, let's actually do that now, just before we forget. Go down to where we're allowed to spawn, first of all, where we spawn the person in, and make it so he spawns at 630. And let's just add 10 pixels to where this guy can move. So if we go player get height plus 10. This is just to make sure that the health bar will be able to be shown. If we add 10 pixels there, we'll ensure the health bar will be showing up. So let's do that. Now we can see the health bar shows up. In fact, it cuts off a little bit, so let's make this 15 pixels. And now let's run this, and we can see that the health bar will stay perfectly on the screen. So there we go, the health bar is on the screen. Let's watch what happens if we hit one of these guys. You can see the health bar does decrement, it goes down. And that is a strategy, I guess, in this game. If you want to waste your health and hit one of the things to like sacrifice yourself for that, you can do that. So yeah, that's how the health bar works. So I guess now, all that's really left to do is the main menu. So let's go ahead and do that. Okay, so main menu. What we want to do essentially is just have it so it says like press any key to begin, and when you press that key, you can begin. And that way, if you die, it'll bring you back to the main menu, and you can choose when you want to start playing again. Other than that, though, the main functionality of this game is pretty much done. So let's implement a main menu. So let's define main underscore menu. This is going to be quite simple. I'll go fairly fast. We're going to say run equals true. While run, we're going to say for event in Pygame dot event dot get if event dot type equals Pygame dot quit, like that. Then what we'll say is run equals false. Okay, and then in here we're going to say, just draw this on the screen. And actually, sorry, I need to say if event dot type equals Pygame dot mouse button down colon main. So what this is saying is if we press any of the mouse buttons, enter this main loop and start playing the game. If we press the X button, set run equal false, we're going to quit here. So we'll say Pygame dot quit, like that. In fact, we can actually just use the quit method too. It's up to you, whatever method you'd like to use. But this is saying if we press any mouse button, call the main function. If we press quit, quit. But what I want to do is just draw like some text that says press any key to begin, or press the mouse button to start, something like that. So the first thing we'll do is we'll just say win.blit bg. Notice I'm just doing it in line here because it's just going to be short for the main menu. So we'll blit the background. We'll say Pygame dot display dot update, and then we'll create a font up here. So we'll say title underscore font equals Pygame dot font dot sys font Comic Sans. Let's do size 70, and then we'll render something onto the screen. So we'll say title label equals title font dot render. Press the mouse to begin, dot. Let's render that one. Let's render that white. So 2v5, 2v5, 2v5. And then let's say win.blit title label. Let's blit this in the middle of the screen. We remember that shortcut I showed us. So that's width over 2 minus title label dot get underscore width over 2. That'll put that in the middle. And then here for the Y, let's put that at 350, and then that should be good. So now that we have that, what this loop will do, so rather than calling main, we need to call main underscore menu. And let's have a look at how this works. So we're getting an error. It's funny enough. Plus 15S, so I've accidentally pressed S. That's what happens when I try to save too frequently, apparently. What's the issue now? Pygame.quit, main menu. Let's have a look here. Pygame.quit. Inconsistent use of tabs and spaces. Love when I get that issue. So for me to fix that, I usually just do this, converting indentation to spaces. So that should work now. And let's run this. Win is not defined, so win needs to be capital. That. So let's run this, and there we go. Okay, so I'll go through this in a second. I'll summarize. I just want to show you. Now it says press the mouse key to begin. If we exit out, so press the mouse button to begin. If I hit X, it brings me back here. I'll show you how to fix that if you don't want that to be the case. But when I press the mouse, the game begins. We can start playing. And, when we exit, it'll reset like it should normally do. So that's how that works. If we want to fix it so that when we press the X, it doesn't bring us back to the main menu, what we can do is just, instead of saying run equals false in here, we can do quit. What that's going to do is quit the entire Python program, which will just end this whole thing for us if we press the X. So that's the idea. Now, main menu, I'll summarize quickly what I did here. Literally just set up the exact same thing that we had before, except for a main menu. So I made a main loop with a run equals true variable. I defined a font. I said in here, we'll draw what's going to be on the screen for the main menu, which is just these two things, right? So the label and the background. Then I'll do an event loop. I'll say, okay, so for each event, notice I didn't put a clock in here because I don't care about the clock speed for the main menu. That's irrelevant. We're not moving anything around. That's fine. So I don't need a clock. So we just have an event loop. If you press quit, it ends the game. And if you press the mouse button down, it starts the game. And it will always bring you back to this main menu function, because since we call main here without setting run equal to false, when main exits, right? When main is done, we exit out of this while loop here. We go back into main menu and wait until we hit the X button to stop playing the game. So that's the idea behind this, and that is pretty much this game. Okay, so we ran into an issue here, list.remove X. X is not in the list. So let's just fix that here. So 111 in move lasers. So we ran into a quick bug. Let's try to find that. 111 in remove laser. If laser.collision object, objects.remove obj, self.lasers.remove laser. So I guess what we should do is make sure this laser is in the list before we remove it, because I guess it could have been removed in a different situation. So in that case, we'll just say if self.laser, I guess we'll say if laser in self.lasers, then we'll remove it. Otherwise, we won't. So this is the fix here, just to make sure that if this laser is in the list, we can remove it. Otherwise, we will not. So let's run this and see now, because I hit something and I ran into that bug. So I want to make sure that we don't get that again. Okay, so that seems to be working. You know, one thing to note is if you hit something and it has a laser shooting, that laser will disappear just because we delete the object itself. There's not really an easy way to fix that the way that we've implemented it. I don't think it's a huge deal. I think that's part of the strategy of the game, is like, if you want to remove someone's laser, go in and shoot them. Like, I think that is a decent strategy, or that's something that can be incorporated. And yeah, that is pretty much it for this tutorial. Hello everybody, and welcome to a brand new tutorial series on this channel, where I will be showing you how to make a car racing game in Python using Pygame. Now, Pygame is one of my favorite modules in Python. It's been a while since I've done a tutorial series using it, so I kind of came up with this game right here, which actually, fun fact, is one of the first games I ever created using a software called Game Maker. So I kind of recreated it in Python, and it turns out to actually be pretty complicated to implement and makes a really good tutorial. Anyways, let me explain who this tutorial is for, and then I will demo the game to you. So this tutorial is kind of designed for intermediate programmers. If you are a beginner, you can definitely follow along. I'll try my best to explain everything as always, but this is going to use quite a bit of kind of more advanced Python syntax, or more intermediate Python syntax. And so if you haven't seen object-oriented programming before, it might be a little bit difficult to follow along, but again, I will try my best to explain. With that said, this will probably be 5 videos, maybe 2.5 hours of content. Everything you need will be linked in the description in each video. All of the assets you see here, most of them I actually made myself, and of course they're free to download from the description. All of the code that I write in each video will be uploaded to GitHub, so you can look at the code per video, not just the finished code. And yeah, with that said, that's pretty much everything you need to know. So let me demo the game for you, and then we will start actually writing the code. So the idea behind this game is we have 2 cars. One car is kind of the player car, so the red car. The other one is the computer, right? So the green car. Now the objective is to simply beat the green car to the finish line at every single level. Now you can see right now that the green car is going quite slow, but as the levels increase, it increases in speed and it gets progressively more difficult. Now I always like to leave my games pretty basic and then allow you guys to kind of add on to them. So something you could do to make this more challenging is add obstacles. You could add, like, I don't know, oil or something on the track so that you would slip if you hit it. You can do all kinds of crazy stuff. What I'll be showing you in this tutorial will allow you to kind of add that stuff as you continue. Now you can see here we moved on to level 2. Notice the car will get progressively faster, and then this game goes up to 10 levels. The last level has the green car almost as fast as the red car, and so if you beat that last level there, then you win the game. Anyways, I won't keep playing through this, but this is a pretty complicated thing to actually make. I know it looks trivial, but to allow the car to move in this way, to have this car follow a path, to have a collision with a track that's kind of not square, right? Not rectangular collision, to have the finish line, to increment levels, to change speeds. There's a lot going on here, and this is a really good kind of learning experience from this tutorial. Anyways, enough of this long introduction. I apologize. let's go ahead and get into the code. Go ahead and get started. Now we have some setup steps that we need to walk through. And then once we do that in this first video, I'm going to show you how we can move a car around the screen. I know that seems trivial, but we're going to implement acceleration, velocity, braking, and slowing down, and a bunch of other stuff like actually changing the angle of the car and determining the horizontal and vertical displacement of the car based on its angle. So it's actually pretty complicated, and that's why this video will be, the length it is. It's probably pretty long, although I haven't filmed it yet, obviously. And anyways, before we can do all that, we need to set up our environment. So I'm here in Visual Studio Code. Feel free to use whatever editor you want. And the first thing we're going to want to do here is download all of the assets for the game. So I'll just walk through them kind of one by one because I actually made almost all these assets myself. So hopefully you guys are impressed by that. But we have a finish line. We have this grass, which is kind of the background. I didn't make this. I found this on Google Images. We have a green car. I made this. I was impressed that I made this with pixel art. Hopefully you guys like that too. We have a gray car. We have a bunch of other cars as well. I just made a bunch of different colors, so you guys could swap the colors if you want, but I'm using green and red. And then obviously we have the red car. And then we have our track border. I'll discuss why we need this in a second. And then we have our track. So notice this track kind of has some white outlines. The reason for that is I took this from Google Images and then removed the background from it in Photoshop. I'm not very good at doing that, so that's why it looks the way it does. Feel free to use any track that you want, but what you will need if you use a different track is you will need the border, or kind of like the, I guess you'd call it border. I guess you could call it the walls or the outline of the track as well. You'll see why we need this, but this is how we're going to handle collision by using kind of just the edges to determine if our car has actually gone off of the main track. And that's how we're going to bounce our car backwards. So again, you need the main track like this, and then you would need the track border. You could do it with just the border as well, and then you could have some background kind of beneath the border. You'll see what I mean in a minute, but I'm kind of just explaining why we have these two images here. Then, of course, we have the white car. Again, this is just so you guys can have some options when we're using the cars. Great, so download all of those. Again, link in the description. It should download a zip folder, and then you can extract the zip folder, by right-clicking on it and get all of the images. Now that we have that, what we need to do is install Pygame. So what you're going to do is go in your terminal or command prompt and type pip install Pygame like that. Now, if for some reason this doesn't work, I have 2 videos on this channel. I'll link them in the description as well. They'll walk through all of the possible ways that installing Pygame could go wrong and how to fix them. So I'll refer you to those 2 videos there if for some reason you cannot install Pygame. So watch those and then come back. Great. Obviously, I already have Pygame installed, so we are good to go. Now that we've done that, I'm going to make a Python file. In fact, I already have one called main.py outside of the images directory, but inside of the folder where my project is going to be. All right, so now that we've got all of that set up, I'm inside of the main.py file, and we're going to start writing some code. Now, the first thing I'm going to do is just import Pygame, because we're going to need that. A few other imports we'll need as well. It's going to be import time, and then I'm just looking at my cheat sheet here. In fact, if you notice me looking to the right, it's because I have all of the code already written, just so that I don't get lost as I'm going through this tutorial. We're also going to import math. We'll be using a lot of stuff from the math module. Now that we've done that, the first thing I actually want to do is just load in all of my images. The reason I'm doing that now is because we actually need some of the images to set up some other things you're going to see. So the first thing I'm going to do is load in my grass. So in all capitals, I'm going to say grass. The reason all capitals is because this is a constant. This is not going to change. So that's the convention. I'm going to say pygame.image.load, and then I'm going to put the path to my image, which is going to be images / and then grass.png like that. So now I have my grass. Next, I'm going to load my track. So I'm going to say track is equal to pygame.image.load. It's going to be images / track.png like that. After we do that, we will load in our track border. So I'm going to say track _ border like that is equal to pygame.image.load, and this will be track - border. Let's make sure that's the correct name. Looks like it is. Okay, great. And now that we have the track border, we can load in the finish line. So I'll just say finish is equal to that, and then this will be finish.png, and then we can load in our cars. So we will say red car is equal to, and then this will be red - car. And then we will have our green car. Let's make sure that's all capitals, and then green car like that. Now, of course, feel free to swap these cars if you want. I don't think I need to explain how to do that, but you would just change the name inside of here and then the corresponding variable name. Great, so now that we've done that, what I want to do is start displaying some of these images on the screen. But first I need to actually set up a screen or set up what's known as kind of the display surface. So what I'm going to do here is say that my window, or my win in all capitals, is going to be equal to pygame.display.set_mode, and then the mode that I need to set inside of here is a tuple containing the width and the height of my display. Now the width and the height of this display, I actually want to be equal to the size of my track. So whatever the track size is, that's how big I want my Pygame display to be. So what I'm going to do here is say width, comma height is equal to, and then track.get_width, and then track.get_height like this. So a little trick in Python, whenever you have a surface, which is what this does, it loads in an image and renders it as a surface or stores it as a Pygame surface, you can get the width and the height of that surface by using getWidth and getHeight. So we're going to get the width and the height of our track, and then I'm going to say that I want a display that is of size width height, and that is obviously corresponding to the size of the track. Now that I have set up the window, I'm just going to give my window a name. So I'm going to say win dot, and then this will be set underscore caption like that. And I'm just going to say racing game exclamation point like that. Okay, so now that we have our window set up, we should see if we run the code here. Let's see, no such file or directory, images grass.png. Okay, that's interesting. Let's see why that's happening. Oh, it's grass.jpg. Well, that makes sense. So let's fix that. Let's run this now, and then we should see a Pygame window pops up, and then it just immediately goes away because apparently it has no attribute set caption. Interesting. I believe that's because this is actually the correct one, pygame.display.set_caption. My apologies again. That's going to happen a lot. I'm going to make mistakes in this video. Let's run this code now, though, and see what we get. And there we go. Perfect. So everything is working as you would expect. The reason the window's not staying on the screen is because we haven't made it stay on the screen yet. Okay, so now we have loaded in some of our images. The next thing that I want to do is actually show some of them on the screen. So I'm going to set up my event loop. I'm going to say while run, and then I'm going to make a variable here that says run equals true. Now the event loop in Python is kind of a constant loop, or in Pygame, sorry, that is going to be handling all of your collision, all of your movement, all of your events, like the user pressing a key. And so the first thing you usually do is you set up this main event loop, and that's what keeps the window alive, right? Keeps it running on the screen. And then as soon as you quit the window or the game ends, then you would destroy the event loop and destroy the game, and then the window would disappear. Hopefully that makes a bit of sense, but we're going to say run equals true while run. Now inside of here, I'm going to say the following: for event in pygame.event.get. This is going to give us a list of all of the events, and then we can loop through them. And the first event that we want to check is if the user has closed the window. So if they press the X in the top right-hand corner. So the way we do that is we say if event.type is equal to pygame.quit, then we're going to say run is equal to false. We're going to break out of this for loop right here. And then underneath this while loop, I'm going to say pygame.quit. Now this will just close the window cleanly for us. So the idea is if we press the quit button, we make run equal false, we exit the while loop, and then, well, we would quit the game. Awesome. So now that we have that, if I run my code, we should see that it says racing game, window shows up, everything's fine. And then if I click X, it closes. There we go. And that is some good progress. Okay, so now that we have that, what I want to do is set up a clock. Now, what a clock does is make sure that our window is not going to run faster than a certain frame per second, or than a certain speed is probably what I should say. So right now, this while loop is going to run as quickly as our processor can handle it. So if you have a really quick processor, it's going to run faster than if you have a really slow processor. But the thing is, when I have this game, I want it to run at the same speed on every single person's computer, right? Or I want it to at least have a maximum speed so one person can't be going like super fast down the track. Meanwhile, on a slower computer, they're going really slow just because their processor can't handle it. So I'm going to set up a clock, and this clock will fix that for us. So I'm going to say clock is equal to pygame.time and then .clock with a capital C. Then up here, I'm going to say FPS, standing for frames per second, is equal to 60. right at the top of my while loop, I'm going to say clock like this, dot tick, and I'm going to tick by FPS. Now what this does is make sure that this while loop cannot run faster than 60 frames per second. Okay, so if you change this number, then that will change how quickly this while loop can run. Hopefully that makes sense, but if we run the code now, we should see that it's just working the exact same. We're not really going to see a difference because we're not drawing anything on the screen. Okay, so now that we've done that, I want to draw some of these images on the screen and just see the size of them, and then we're going to kind of position them and redraw them just to make sure they look good. So let's go inside of here, and let's start by doing this. Pygame.display, not clear, but .update. Now this is a method that you need to run every single time you want what you've drawn on the screen to actually be drawn. So what you can kind of do in Pygame is you can draw a bunch of stuff, and then as soon as you've drawn it onto the screen, you update the display, and then it will show all of the stuff that you've drawn. So in this case, I want to start by drawing this grass background and the track over top of it. So let's do that. We're going to say Pygame, actually not Pygame, we're going to say win, which is the name of our window, .blit. This is what you do when you want to draw an image onto the screen. We're going to put the image we want to draw. So I want to draw grass. And where do I want to draw this? At position 0, 0. Now the coordinate system for Pygame is 0, 0 is at the top left-hand corner. I guess top left would be there for you guys. And then as you go down, the Y increases. So the bottom of the screen would be the largest Y value. And as you go to the right, the X increases. So the furthest right would be the largest X value, sorry. So yeah, the X increases as you go right. Perfect. So let's run this now. Let's see if grass is showing up. And notice grass is showing up. Now it's not quite large enough. We'll make it larger in a minute, but for now we can see it on the screen. So now that we've done that, we want to draw the track. So I'm going to say win.blit and then track like that. And we'll draw the track at 0, 0. Now notice the order I've drawn this. I've done the grass first and then the track second. That's so the track will show up over top of the grass. If you did it in the other order, well, you would get it in the other way. Let's run it now. And notice now we have our track and that the size of the window is exactly kind of the size of the track here, right? So now what we need to do is draw the finish line, and we also need to increase the size of the grass. And I actually want to make the track a little bit smaller because it's taking up a bit too much room on the screen for my liking. So let's just draw the finish line now. We'll say win.blit like that, and then we'll say finish, and we'll just draw this at 0, 0 as well, just so we can see what it looks like. And then that's the finish line. That might actually be a good size, but we might need to make that a bit smaller as well when we change the size of this stuff. Okay, so now that we've done that, we need to change the size of some of these images. So to do that, I want to write a function. The reason I want to write a function is it's just going to make it a lot easier for us to scale our image rather than having to manually write the same thing a bunch of times. So I need to go look at my cheat sheet here, and we're going to write the following function: define scale underscore image. This is going to take in an image and a scale factor. Now the factor is like if I give 2, it's going to scale it by 2x. If I give 0.5, it's going to shrink it by a factor of 2, or shrink it, or I guess multiply it by a factor of 0.5, right? Whatever way you want to think of it, but that's kind of how it works. So now I'm going to say the size, this will be the new size, is going to be equal to round, and then this is going to be image.get underscore width multiplied by the factor. The reason we need to round this is because we need to have integers when we scale the image. We cannot have decimal values. So we'll do that. Now let's copy this. We're going to go comma, and instead of get width now, we're going to do get height. And again, we're going to multiply it by the factor. So this will give us a tuple that contains the new width and the new height of our image. Then what we're going to do is return like this, pygame.transform.scale, and then we're going to pass the image, and we're going to pass the new size that we want this image to be. Let me make sure that's right. Looks like it is. So that will allow us to scale our image. Now the thing is, I don't really want this function kind of cluttering up my main file. So what I'm going to do just to clean things up a little bit here is I'm going to make a new file called utils.py. And inside of utils.py, I'm going to put utility functions that are going to be used from inside of this main file. So inside of here, I'm just going to import this function. And at the top of the program, I'm going to say import Pygame like that, just because we need access to Pygame in here to use this Pygame function. Great, so now rather than having this function here, I'm just going to say from utils import, and we will import scale underscore image like that. Great, so now we can use scale image. So the first thing I want to do is I want to scale my grass. So I want to say scale image. I'm going to pass this image to scale. And then what do I want to scale it by? Let me check here and see. For now, we'll try with 2.5. We might want to change that, but that's what we'll go with right now. And then for my track, I don't really want to shrink this too much, but I want it to be a bit smaller. So I'm just going to scale it by 0.9. Okay, so now we've scaled the track and the grass. While we're at it, I'm just going to scale the track border to be the same size as my track. The reason for that is I need the border to be the same size. Otherwise, we're going to have some weird collision errors in the future. So let's make this 0.9. And then the finish line we'll leave like that for now. Okay, so let's run this. And notice that that looks a little bit better. The grass is taking up the full screen. Track is a bit smaller. Everything looks good. Now let's just draw a few cars and then let's scale those. So let's go down here and rather than blitting the finish line, let's blit a car. So let's just go with red underscore car. All the cars are the same size. So if you scale one, you can scale all of them. Notice the car is a little bit big. I'd like that to be a bit smaller because we want to be able to fit two cars on the track kind of parallel or beside each other. So let's make the car a bit smaller. Let's go to red car. Let's go scale image. And that should not be in all capitals. Let's go scale image like that. And we're going to scale this to 55%, so 0.55. And then we'll do the same thing here. Scale image and 0.55. Okay, now let's run it. And let's look at our car. And that is a much better size. Sweet. So now we have drawn pretty much what we need to onto the screen. However, what I would like to do is kind of clean this up a bit. And you're going to notice we're going to continually be cleaning and refactoring stuff as we go through this. I want to take all of the stuff related to drawing, and I want to put this in a separate function just to make sure that I know where all of my drawing's being done, and I'm not drawing, like 100 things inside of this wallet because that's going to get really messy really quickly. So I'm going to make a function up here called draw. Now, the reason I'm not going to put this inside of the utils function is because this is very heavy or very correlated to the game, whereas the stuff inside of utils.py, I could use this in any game, whereas this draw function is going to be used only in this game, right? So it kind of makes more sense to be in this file. Anyways, I'm going to take a window that I want to draw stuff on, and then I'm going to take images that I want to draw. And then inside of here, I'm going to say for, and we're going to go with img in images. I'm going to say win.blit, and then I'm going to blit the img, and we're actually going to say img comma pause, and you'll see why in a second, and I'm going to blit it at this position. Now what I'm going to do is I'm going to say my images are equal to, and I'm going to make a list containing images and their positions that I want to draw them on the screen. So I'm going to say grass, and I want to draw this at 0, 0, and then I'm going to say track, and I again want to draw this at 0, 0, and for now we won't draw the car, we're going to draw that a bit differently. So now inside of here, I need to call this draw function. I need to pass in my window, which is a capital win, and then my images like that. So now if we run the code, we should get the same thing we got before, and we do. All is working. Okay, so that is all good. Now we want to draw the car, and we want to move the car around the screen. And the thing with the car is that we need it to be able to change its position. We need to be able to rotate the car, right? So it can go left, it can go right, because that's how we're going to be able to turn. We have to be able to turn around the track, and well, we need to turn the heading of the car. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. They have over 160 coding interview questions on the platform, and I am one of the instructors on that platform, so you can be sure there are great explanations for each of those questions. Check them out from the link in the description and use the code TechWithTim for a discount on the platform. So what I'm going to do here is set up a class, and this class is going to handle all of that stuff for our car. So I'm just going to say class, and I'm actually going to make what's known as an abstract class. I'm going to say abstract car like this. Now, let's see why we need this in a minute, but the idea is we're going to have both a player car and a computer car, so there's going to be a lot of stuff that's common to both of these cars. So we're going to put all of the common stuff in an abstract class. This is a class that's not meant to be instantiated, but that's meant to act as the base class for the other two classes. If you're not familiar with inheritance, don't worry about it too much. Just understand that all of the stuff I put inside of here is going to be used by both my player car and my computer car, and that's the point of this. So inside of abstract car, I need to go and look at my code here to remember what I put. I am going to define and init. Now I'm going to say define init like this. And inside of here, we're going to take self. We're going to take a x and a y. Actually, no, we don't want an x or y. We're going to go with max velocity as our first parameter. And then as our second parameter, we're going to go with the rotation underscore velocity. So the reason I want both of these is because I want to know the maximum speed my car can go, so the maximum velocity. And I also want to know how quickly my car can rotate, so it's rotation velocity. And then inside of here, I'm going to say self.max underscore vel is equal to max underscore vel. I'm going to say self.vel equals 0. The reason why the starting velocity is 0 is because your car's not moving when it starts. It has a velocity of 0. And then I'm going to say self.rotation velocity is equal to rotation vel. I'm then going to say self.angle is equal to 0. And the point of this is that our car will start at an angle of 0. And then when we change the angle, that will change the way that the car is rotating. Okay. So now that we have that, the first thing I want to handle is just rotating the car. So I'm going to go inside of here and I'm going to say define rotate like that. I'm going to take a self, a left is equal to false, and a right is equal to false. Now you're going to pass left equals true if you want to rotate to the left, and right equals true if you want to rotate to the right. Now inside of here, all I need to do is say if left, I'm going to say self.angle, and then this is going to be plus equal, and then self.rotation velocity like that. And then if we are moving to the right, it's going to be the opposite. So we're going to say elif right, then self.angle minus equals self.rotation vel. And now that I'm thinking about it, when I'm going to the right, my angle is increasing. When I'm going to the left, my angle is decreasing. So I actually think it might need to be the other way around. Or maybe I'm crazy here. You know what? We'll leave it like this for now. And if for some reason we're rotating in the inverse direction, then we'll change this. I think this is right. I'm just confusing myself. Okay, so now we have rotate. I'm just looking at anything else we might need here. For now, that actually looks good. So what we can do is call the rotate method, and then depending on if we're going left or right, we'll rotate to the left or right. The way we rotate is by changing the angle. However, we need to actually rotate the car, right? We can change the angle in this class, but that's not going to change the position of the car image. So what we need to do is find a way to actually draw the car image rotated. So we need to know how to rotate the image in Pygame. Now this is a little bit complicated, but I'm going to go inside of utils.py and I'm going to write a function that can take an image and return to you a rotated image based on an angle. So let's do that. We're going to say define blit underscore rotate underscore center. And what this is going to take is a surface. This is where we want to draw the, actually let's call this win. This is where we want to draw the rotated image. Then we're going to say the image. We're going to say the top underscore left. And we're going to say the angle. Okay, so I'm just going to write this function, then I'll explain a little bit about what's going on after. But I will note that rotating an image in Pygame is not trivial. If you're going to be rotating an image, you can just normally rotate it. But if you do that, you're going to get all kinds of distortions. And the reason for that is the rectangle that contains the image. So I should say every single image in Pygame is really a rectangle, and then the actual image is inside of that rectangle. So even if it doesn't look like a rectangle, there is a rectangle that's containing the image. So when you rotate the image, you're also rotating the rectangle, and based on the position that you're rotating the rectangle around, you can get really kind of weird, like, you know, morphing and distortions occurring with the image. So that's why we need whatever we're doing here. So I'm going to say a rotated image is equal to Pygame. And I believe this is .transform. It is .transform.rotate. And we're going to pass the image and the angle that we want to rotate. Now, what this will do is rotate the image around the top left-hand corner. Now, that's no good. We don't want to rotate the image around the top left-hand corner because that's going to lead to us kind of having like a circle around that stationary point. Instead, we want to rotate around the center of the image. So the way we're going to do that is we're going to say new rectangle is equal to rotated image like this. And this is going to be .get underscore rect. And we're going to say that the center of this rect is equal to image dot and then get underscore rect like this. And we're going to say that the top left, so top left like that, is equal to the top underscore left. And then inside of here, we're going to say dot center. Okay, so what's happening here is pretty complicated, but I will try my best to briefly explain it. I have to admit, I did take this code from Stack Overflow. I didn't come up with this on my own. Anyways, point being, we rotate the original image. When we rotate this image, I'll show you in a second, we get all kinds of weird distortions, and the actual X and Y of the image is going to change based on how it's rotating around the top left-hand corner. So then we have our new rectangle. So we say the new rectangle is equal to the rotated image.getRectangle. The point of this is we want to remove the offset, so we want to make it so that we rotate the image without changing the X and Y position of the image on the screen. That's what this whole line is trying to do for us. So we're saying let's get a rectangle from the new rect, but let's make its center equal to the image, the original image, its rectangle at the top left-hand corner position, and then whatever the center of that is. So we're getting the original image. We're saying the top left-hand corner of that original image is equal to whatever its X and Y position is, because the image doesn't know its X and Y position. So we need to set the top left-hand corner explicitly to be equal to that. Then we're saying, let's get the center of that. And wherever that center is, the new image needs to still be on that center. So that way we're only rotating from the center of the image, not from the top left. But we had to originally rotate from the top left because that's the only way to rotate an image in Pygame. Hopefully that makes a little bit of sense. And then what we're going to do is say this. We are going to say win.blit, and we're going to blit the rotated image. And we're going to do this at the new rect.topLeft. So the whole idea of this new rectangle is to find the correct X and Y position of the new rectangle such that it's going to be in the same position as it was before, but now it's rotated. All right, a lot of complicated code there, but there you go. That will blit it and rotate it in the center for us. So let's go to main.py now, and let's define a method inside of abstract car that can draw the car for us. We're going to say define draw, and then we're going to take in self, and we're going to take in a window. All we're going to do is the following. We are going to say, first we need to import this. I believe this was blit underscore rotate center. Yes, it was. So we're just going to say inside of here, blit underscore rotate center, and then we're going to pass self.img. Actually, we're going to pass win, and self.img, which we've yet to define, which we'll do now. So we're going to go to abstract car. And we're going to say self.img. Actually, not up here. What am I doing? Sorry, we're going to do it inside of here. We're going to say self.img is equal to, and then here I'm going to say img is equal to, and we are just going to reference one of the images that we want for this car. So in this case, I want the red underscore car. I'm going to say self.img is equal to self.img. Understand this is a little bit weird. What we're doing here is saying the following. We're going to store inside of the class the image that should be used for this class. So in this case, I want it to be a red car. Then I say the self.image, so the image specific to this instance, is equal to self.img, so whatever the image is here. And then inside of here, we then reference that image so that we can rotate it and, well, blit it in the center. Okay, that's all great. However, I need to first make a way to actually rotate my car before we can see if this is working. So let's actually just draw the car first. Let's make a car. I'm going to say car is equal to, and first we should create a concrete instance of this class. So I'm going to say class. I'm going to go with player car like that. Now inside of here, all I'm going to do is just copy this. I'm going to remove it from abstract car because now we have this class. And that's actually all I need inside of player car, but I need to make sure I inherit from abstract car. So let me just explain this quickly in case this is a bit confusing. We have the abstract car class. This defines a bunch of functionality. When we put it inside of the brackets like this, we're saying we're going to use everything from inside of here. So imagine all of this is just copy and pasted right inside of player car. The only thing we're doing differently here is we're defining image inside of here, and then it will be used inside of the initialization when we instantiate this car class. Okay, that was a lot of big words, but let's continue. So I'm going to go here and say car. Actually, we'll go with player underscore car is equal to player car like that. Now we need to pass to this a maximum velocity and a rotation velocity. So for now, I'm going to go with 4, 4. Feel free to change that to make it slower or faster. Obviously, the higher number, the faster it will go. And now let's just draw the car. So inside of draw, I'm now going to pass my player car. So that means we need to now take player underscore car. And now we're going to say player underscore car dot draw. And then inside of here now, I'm going to take my pygame.display.update. I'm just going to put this right inside of the draw function so that everything related to drawing is contained in one place. Okay, so that should draw our car. Let's see if this is working. And missing one required positional argument win. Okay, player car.draw, that would be right here. So we just need to make sure we pass our window to the draw method. So let's run this now. And we got an error. Bullet rotate center, missing 2 required positional arguments, top left and angle. Of course, I forgot those. Let's fix that. So we need to pass the top left-hand position. Now the top left-hand position is actually going to be equal to the X and the Y of the car, which we haven't defined yet. So we're going to do that now. We're going to say self.x, self.y is equal to self.start underscore position. Pause like that, sorry. And then inside of here, we're going to say start underscore pause is equal to, and then we're going to define what the starting position should be. So I'm just going to say, actually, let me just go look at my other code and see where I started it before. I was starting it at 180. Was that right? Let's see, 180 and 200. Okay, so go 180 and 200. Okay, so now our self.x and self.y is equal to the starting position, which we've defined here. And inside of here, we now need to pass that. So we're going to say self.x, self.y, and then we want to pass the angle. And the angle is just going to be self.angle like that. Okay, let's run this now, and let's see what we get. Okay, so there we go. Our car is now drawn here. Now, let's just see if changing the angle actually does anything. So let's go and make the angle 90. Let's see where we go now. Notice we are facing left. Perfect. That's what we would expect, okay? Now let's make the angle 180. We should be upside down now. And there we go. So we are getting the car in the correct position. Sweet. So let's make that back to 0. And now let's make it so we can change the angle based on pressing a key. So we're going to go and I'm going to write the following inside of my main event loop. Remember, anything in the event loop is kind of handling events, handling collision, handling all of those types of things. So this is where we would put, key presses and moving the car. So I'm going to say keys is equal to pygame.key.get underscore pressed like that. And then what I want to do is check if we pressed a specific key. So I'm going to say if keys, and then I'm going to go pygame.k. Notice that's a capital underscore and then A. So I want to use WASD to move my car. So this would be left if I'm pressing on the A key. So if I'm doing that, then I want to say player underscore car dot rotate left is equal to true. Okay, let's copy this. And then let's go here and say if keys pygame k underscore d. So this would be right. Then I want to say right is equal to true. Okay, so that should now allow us to actually rotate our car left and right by clicking on A and D. If you're wondering how you find other keys, you can look them up. There's a bunch of, I guess these are called constants in Pygame, but you also can just do K underscore and then whatever the lowercase letter is of the key that you want. If you want like a space bar or something, then you would go all capitals and you would go space. Same thing with like shift or enter or any of those keys. If it's not just a standard character, then it's usually in all capitals. Okay, well, let's run this though, and let's see if it works. And now notice if I go left and right, I can rotate my car. And the speed at which I'm rotating my car is defined by that rotation velocity. So you guys can mess around with that, but if you change the rotation velocity, you'll notice you're rotating faster or slower. Okay, that's great. So we can now rotate the car off to a good start. That's actually a pretty difficult thing to do. So congratulate yourselves if you made it through that. Now let's see how we can move the car forward. So we have our self-velocity. We have the maximum velocity, we have the rotation velocity, we have the angle. The next thing we need is the acceleration because cars don't just instantly reach their top speed. They take a few seconds to get up to speed. When you slam on the gas, you are accelerating, you're adding more force to the tires, you're going faster, and then eventually you reach kind of like a terminal velocity, which is what we're going to get to here. So I'm going to say self.acceleration, did I spell that correctly? Looks like I did, is equal to 0.1. So this means every time that we are pressing down on, I guess it's going to be the W key to go forward, we're going to increase the velocity of our car by 0.1, let's call it pixels per second. That's maybe the unit that we're going at. If you want to accelerate slower, then make this 0.05, right? Or if you want to go faster, make it something like 0.2. Anyways, we have that. Now I want to define a method, and I want to call this move underscore forward, okay? So define move forward, and inside of here, I'm going to take self. Now, all this is going to do is it's going to increase the velocity of my car based on the acceleration. And if I'm already at the maximum velocity, it just won't do anything, but it will move me forward. So inside of here, I'm going to say self.vel is equal to, I guess this is going to be the minimum, the minimum of self.vel plus self.acceleration and self.max underscore velocity. So what this is doing is saying, okay, well, if self.vel is already at the maximum and we add self.acceleration, we don't want to go faster than the maximum. So we put self.maxvel here. So if this is greater than this, we just default to the maximum velocity. If it's not, though, then we will increase the speed of the car by the acceleration. Remember, the velocity starts at 0, okay? So that will increase our velocity. Now, that's great, but we actually want to move the car forward. So to do that, I'm going to make a new method called move. I'm going to say define move like this. And inside of here, after I increase the velocity, I'm going to say self.move. Now, the thing is, inside of move, I need to actually calculate what direction I'm going to move my car. Because if I'm angled to the right or I'm angled to the left, then I need to move in that appropriate direction. I can't just go up or go right or go left. So I'm going to start by just showing you how we move in one direction. So I guess one plane or one dimension. And then I will show you how we can move in multiple dimensions. So move X and Y based on the direction of our car. And that's going to involve a little bit of trigonometry. Anyways, inside of here, I am going to say self.x plus equals self.velocity. So we're just going to move to the right based on whatever our velocity is. That's all we're going to do to start right now. Then we'll get more complex. Okay, so now that we've done that, we want to implement another key press to move the car forward. So I'm going to go here and say if keys pygame.key underscore w, then player car dot move underscore forward like that. So now as we press down the W key, we should increase speed. As soon as we get to the top speed, we'll stay at that speed and we'll move forward. Now remember, we're not decreasing the velocity here. So as soon as we hit the maximum speed, we'll stay at that maximum speed. Even if we let go of the W key, we'll keep going at the same speed. I'll show you how we fix that in a second, but just wanted to note that as we got in here. Okay, so I've loaded. Now notice when I press W, I move over to the right like that. Now I'm going to stop as soon as I let go of the key, but when I press the key again, I'll be moving at the maximum speed. So that's it. That's how you move one direction, right? We just incremented the X of the car, and that moved our car over. Okay, that's great, but we ideally would like to be able to move in 2 dimensions. So this is where I need to pull out the Paint program and start showing you some trigonometry. Okay, so I'm here in Paint, and I'm going to start describing the trigonometry that we're going to use to actually move in the direction that we're facing. This is not trivial. This is why I'm in Paint. Now, please go easy on me. I am using my mouse, so this is going to be really rough, but it will give you kind of, you know, what you need. It would give you the basic visualization of this. So the idea is we have some car. Let's say this is our car. Now, if he's just moving this way, all we have to do is move the Y direction, right? If he's facing completely up, then we can just move that direction. If he's facing completely to the right or completely to the left, any of these kind of polar coordinates here, then we can just go in those directions, right? It's very easy. We can just decrement the X, increment the X, decrement the Y, increment the Y. However, what happens if we're moving on an angle like this? Well, it is not so simple now to actually figure out how much we need to move this guy by, because we can't just move by the X and we can't just move by the Y. We need to move by both of them. We need to go some amount up, right? And some amount to the right. Now, first of all, what are those amounts? Well, if you said the amount is equal to whatever the velocity of the car is, that's incorrect. The reason for that is if my car has the heading like this, like it's pointing this direction, then the velocity that we have is in that direction, right? So let's say my velocity is 4. Well, if that's the case, then this is 4. That does not mean that my X is 4 and my Y is 4. In fact, I need to use this total velocity to determine how much X and how much Y I need to go by so that my total velocity accumulates 4. Because when I'm moving in 2 directions, I'm moving, well, 2 ways. And so I need to sum the velocities, but it's not as easy as just adding them together to determine what the total velocity is going to be. Now, in this way, we're going to go in the opposite direction. We're going to say the following. We're going to say, okay, well, this is like a right triangle, right? We want to go some direction X, some direction Y. So let's say X and Y like that. And then this is our total velocity right here. Now it turns out that we know this angle. And if we know this angle, we can actually figure out what Y and what X are by using trigonometry. So there's a few very popular equations. The way I remember them is the following. We have SOH, which is SOH. And then we have K, CAH like this. So cat, and then we have TOA as well. TOA. Now, O stands for opposite. Now, this is relative to the angle that you're talking about. So if I'm talking about this angle right here, the opposite side is Y. So OHA, those are all sides, okay? That's side lengths is what I'm talking about. And S stands for sine, C stands for cosine, and T stands for tangent. Anyways, I have my angle. So the opposite side is this because that's kind of what the angle is like facing. It's what it's looking at. And the adjacent side is this. It's X because that's what's beside the angle. That's the way you can think of it. So if I want to solve for Y here, keep in mind I know my angle and I know my velocity. Then what I need to do is the following. I need to set up my equation. So I'm going to say that the sine of theta is equal to my opposite over my hypotenuse. Now, we know the angle and we know the hypotenuse. So H is really V, which is my velocity. Now, let's just plug in 4 because we know the velocity is going to be 4. We'll say the maximum velocity is 4, right? So now we're solving for O. And O is really equal to Y, right? Because that's the opposite side. And so what we do is we say that the sine of theta, which we can calculate, we can just take the sine of the angle, multiplied by 4, because we need to take the division and multiply it on this side, is equal to Y. So the sine of theta multiplied by our velocity gives us our displacement in Y. And then if we go to cosine here, it's just going to be the other way around. We're just going to take the cosine and we're going to multiply that by our velocity, and that is going to give us how much we have for displacement in X. So just basic trigonometry, but I wanted to walk you through that. All right, so hopefully that is a decent enough explanation. What we actually do in the code might differ a tiny bit just because of a few factors, but this is the general idea of how we can solve kind of two components based on one velocity and an angle. We're calculating the X and the Y component. That's what they're known as because this is, we can kind of call this a vector, right? Like this line right here. If you know anything about physics, you would call this a vector because we have a angle, so we have a direction and we have a velocity or a magnitude, and then we want to split it into its two components, X and Y. Okay, so let's get rid of that and let's implement this. So let's go to our move method, and now rather than moving just by the velocity, we're going to do that kind of fancy equation that we just did. So the first thing I need to do is I need to convert my angle into radians. This is because we use radians in most computer math. Radians is just kind of a special way of calculating angles. In case you're unfamiliar, 360 is equal to 2 pi in radians, and 180 is equal to pi. Okay, you don't really need to know that, but just figured I'd let you know. So we're just going to say math.radians and then self.angle like that. Notice our angle is in degrees because that's how we want to rotate it. But then when we actually are looking for the components, we need it in radians. Now let's calculate the vertical displacement or the vertical velocity. So we're going to say vertical is equal to, and then this is going to be math dot, and I actually think this is going to be cosine for this, math dot cosine of radians multiplied by self dot velocity. And then we are going to say that the horizontal is equal to math dot sine of radians multiplied by self dot vel. Then I'm going to say self dot y minus equals vertical and self dot x minus equals horizontal. Now you can switch this to the plus sign and watch what happens, but the reason we need minus is because these are actually going to return to us in a lot of instances negative values. And based on the way that we are angling our car and just kind of some other things we've done that I don't really want to get into too much, we need to subtract rather than adding. Now, if we're subtracting, that means if this value is positive, we're going to the left, right? And if we are, and we're going up. So we're going to the left and up, which is the way that our angle is directing. So that makes sense. And then if this value is negative, that means that we're going to be going to the right and we're going to be going down. I mean, respective to X and Y. Anyways, let's just run our code here and see if this works. And so let's do this. And now notice I can move in whatever direction my car is facing. There you go. So we are now moving our car, which I'm going to call a success. Now, the only thing we need to do here is we need to make it so our car slows down, because as you saw, let me actually run this again. My car just instantly stops, right? If I let go of the key, it just instantly stops. That's not realistic. Our car is going to have momentum. It's going to be moving, and it's going to take some friction to slow the car down. So we need some way to actually slow the car down when we're not pressing on the key, which is what we're going to do now. So we're going to implement a method here on our car, and we're going to call this reduce underscore speed, and we're just going to take in self. Now what we're going to do is reduce our speed by half of our acceleration. that is because we can accelerate faster than we can slow down. At least that's the logic that I'm going to use. I'm not sure if that actually applies in the real world, but that's kind of what we're going to do here. Also, just so that we don't slow down super, super quick, because we can accelerate really quick. Anyways, you'll see how this works as I get into this method. Now, I just need to look at where I have this in my other code so that I don't mess this up too bad. Okay, so we have reduce speed. What we're going to do inside of here is say self.vel is equal to the maximum of self.vel minus self.acceleration over 2. And then this is going to be 0. Now, the reason we have this is because if this value for some reason is negative, we don't want to be moving backwards. We just want to stop. And so that's why we have the 0 right here. So we change the velocity. And then since we have this move method already set up, we can just say self.move. So now when we reduce the speed, all that's happening is we're reducing the velocity by half of the acceleration, and then we're just going to move. And since this is set up, it'll just work. It's just going to move us slower in whatever direction we're facing. And while we're slowing down, if we're not on the gas, we can still turn, which is a very important thing to keep in mind. Okay, so now we have reduced speed. So what we're going to do is go inside of here, and we're just going to do something. I'm going to say moved is equal to false. And inside of here, I'm going to say moved is equal to true. Now, the point of this is that if we are pressing the W key, we don't want to reduce the speed. But if we let go of the the W key, we do want to reduce the speed. So now I'm going to say if not moved. So if I didn't press forward on the gas, reduce my speed. So I'm just going to say not self, but we'll go with player underscore car. And this will be dot reduce underscore speed. So now you should see that when I'm not pressing on the gas, I'm not pressing on the W key, we should reduce the speed. So let's run this code and let's see what we get. So now notice that we slow down, right? And it takes a second to slow down. I'm pressing the key, I let go of the key, and we continue going, and then we slow down until eventually we stop. All right. So with that said, this long video is now over. If you guys had the patience to sit through all of this, give yourself a pat on the back. I did not expect it to be this long, but there is a lot of stuff that goes into moving a car in this fashion. In the next video, we're going to set up the actual collision with the track. We're going to make it so you bounce off of the track. We'll then add a finish line, and we'll make it so that you can hit the finish line and collide with the finish line. So we'll just be doing collision pretty much in the next tutorial. Then after that, we will implement the computer car, so moving around a path, which is also not that easy to do. And then I guess we'll do 4 videos for this series. And in the last video, we'll implement all of the nice stuff like the text, showing the kind of the stats, the level system, all of that fun stuff. So I am back with video 2 in this series. In this video, we're going to be talking about collision and handling pixel perfect collision, actually. Anyways, first thing I want to do is actually make it so our car can move backwards because, well, we didn't do that in the last video and I meant to show that, so let's do that now. So to move backwards is very easy. In fact, it's the exact same as moving forwards, except we just need to modify the velocity and everything a little bit. So we're going to go and make another method here, and this is going to be called move backward. And inside of here, we're going to say self.vel is equal to the maximum of, and this is going to be self.velocity minus self.acceleration. When we move backwards, we need to subtract the acceleration because we're trying to go in the opposite direction. So we want a negative velocity to be moving backwards because it's like the reverse gear in your car. You don't turn around to go backwards. You can just rotate the wheels in the other direction, which is what we're going to do here. And then this needs to be self.maxvel over 2. I don't know why I deleted that. The idea of this is that we want this needs to be negative, is that we want the maximum possible negative velocity to be half of the velocity going forward. The reverse gear in your car, you cannot go up to 100 miles per hour, right? You can only go a certain speed. There's a top speed in that. So same thing here. We're going to make it so when you go in reverse, you are going slower than when you are going forward. I don't know why that's super important, but that's what we're doing. So self.velocity minus self.acceleration, and then negative self.max velocity over 2, just splitting that in half. I think that's pretty self-explanatory. Let's now make it so we have a key that does that. So we're just going to copy this, and I'm just going to change this now to key. This is going to be S. S will go backwards, and then we will change this to be backward like that. Notice I have moved equals true. We need that to make sure we don't reduce our speed as we are going backwards. Perfect. Now that we have that, let's run the code and let's check if the reverse gear works. So now I can move backwards, and notice I cannot go backwards at the same speed that I can go forwards, right? I can go at half the speed. Great, there you go, backwards is working. If you try to turn when you're going backwards, you'll notice that the turning works, and you actually should be turning in the inverse direction, which is correct. And that's why we set up all this stuff so that it just works when we add other things in the future. Great, so what I want to do is just clean up the code a little bit here. I want to take all of this stuff, so keys, moved, all of the stuff related to moving my player, and I want to make a function here, and I'm going to call this move_player. Now inside of here, we will just take the player car. So we'll say player_car like that. And then we can perform all of this stuff simply using player car. Okay, so again, just trying to clean this up. So now inside of here, I'm going to say move_player, and I'm going to pass my player car. And this will handle all of the movement. Let me just get rid of that. Let's run this, and let's make sure it's still working. And it is. We are all good. Okay, one more small refactor I want to do is I just want to go and grab this reduce speed method here and put this inside of my car class. Reason being that my computer, which is going to inherit from this abstract car class as well, does not need to be able to reduce its speed. It's going to be the same speed the whole time. And so it makes sense to have this in the class where it's actually going to be used, because it's not going to be used by anything else that implements the abstract car class. You could leave it in there. There's arguments for both, but I am just going to move it here. Great. So everything will continue to work. We don't need to test that. Moving forward, though, the next thing I want to do is collision. So this is where we need to talk about masks, and we need to talk about how you actually handle collision of different objects in Python. So what I'm going to do is open up Paint here, and we're going to start talking about masks. All right, so I'm inside of Paint here, and I'm going to explain to you masks and how we do pixel perfect collision. So let's start with traditional collision, and then we can explain pixel perfect collision. So let's say we have some object, and let's just make it a circle for simplicity. Now remember, I told you that every single surface in Pygame is really a rectangle. So even if this is all that we're showing, we actually have a rectangle around this circle here. So we might not see the rectangle, and the reason we wouldn't see it is because all of these pixels here would be transparent pixels, so they wouldn't show up on the screen, but they're still there. It's still a rectangle. So let's say we have another image, and let's just do it like this. And maybe inside of here, I don't know, we have some green, whatever. Okay, this is what this image looks like. Point being is that these two rectangles, the rectangles containing these two images, are overlapping. This is the overlapping area right here. However, if we're looking at these two images, remove the rectangles, they're not colliding with each other, right? The pixels that are present in both of these images are not touching each other. But if we were to use traditional collision, which is just rectangular collision, you just check if two rectangles are lying inside of each other, then it would say that these two objects are colliding. And this is the overlapping area, but again, the pixels in the images are not actually colliding. So how do we fix this? Because I don't want it to show me that two objects are colliding unless the pixels on the screen actually look like they are colliding. This is where we use something known as a mask. Now, what a mask is an array of values representing whether or not a pixel in an image is transparent or present, whether it just exists. It's not a transparent pixel. Now, the point of a mask is that rather than performing rectangular collision like this, we can simply check if pixels that are not transparent are overlapping into rectangular regions. So let's clear all of this, and now let's look at an example of a mask. Let's say we have a very simple image. Okay, I'm going to just go with a rectangle because it's easier here. And we have maybe something like this, okay? We have pixels all in here, pixels all in here, and then inside of the other two regions is transparent, okay? And now we have another image, and let's just do something like this, and maybe we only have pixels inside of this bottom left-hand corner. Well, the mask for these two images would look like this. It's just going to be an array, so we'd have a large array. It's going to be a two-dimensional array, and we would have 1, 0, okay? And again, excuse me, I'm using the mouse here, and then 0, 1, like that. Now for this image, it would be similar, but we're going to have nothing in the first row because we have no non-transparent pixels. And then we would go here and we would have 0, 1 like that. Okay. Now let's imagine these masks are directly on top of each other. The two objects are completely on top of each other. Then what we would do is we would just compare values in these arrays and see if two 1s are at the same position, right? So we check here. So, okay, there's no 1 here. So we're not colliding in this region. Okay, then we go here. So, okay, there's no 1s there, so we're not colliding there. We go here. Okay, no 1s, we're not colliding. And boom, we find two 1s, which means we're colliding in this region right here. And so we would say, okay, yes, we are colliding because two pixels that are not transparent are touching each other. There you go. Perfect. That's all you need to know. However, it gets a little bit more complicated because we need to know the location of both of these masks before we can do this comparison. In the example I just showed you, we just imagine they were on top of each other. So if I select this and I grab it, it's going to be a bit rough, but we imagine this mask was right on top of the other one. And in that case, it was really easy to check if they were colliding. But what if the mask is sitting somewhere like this, or sitting here, or sitting up here? Well, we need to know that, and that's known as the offset. So we have something, and actually let's make a new file here. We have something known as our calling mask, and then I guess the mask that it's being called on. So let's say that this here is our calling mask, and then this is the mask that this mask is being called on. Well, we need to determine the difference between the top left-hand coordinates so that we can overlap these masks in the appropriate region to determine if pixels are colliding. So I want to calculate the displacement in X and the displacement in Y, so then I know the total displacement, and then I can align these masks properly before I do the collision. So if this is my calling mask, and this is the mask that I want to find the offset on, well, I just need to find that. I'll show you how we do that in code, and then that's one of the values that we need to pass to kind of our mask collision function so that we can overlap these masks in the correct area. All right, that's my explanation of masks. Hopefully that was good enough for you. Now we are going to actually do this. First thing we need to do, though, is create masks. So to do this, we're going to say track underscore border underscore mask. Now, this is the whole point of having this track border, is that we're going to use this border, let's go to it quickly here, as our mask. This will be one mask, and then we will compare this to the car, our player car, and we will see if these two masks are colliding with each other. And this is actually really easy to use because its corner is 0, 0, right? Its top position is 0, 0, which actually just makes it way simpler for us to do the offset calculation. So I'm not going to do scale image. I'm going to do Pygame dot, and this is going to be mask dot from underscore surface. And we're just going to pass in here the surface we want the mask of, which is our track border. Easy enough. That's how you get a mask. Okay, so we have that mask. Now what I want to do is make a method inside of my abstract car class. It will go inside of abstract car because this is going to be for both the computer and my player. And I will call this collide. Now we're going to take in self mask x equals 0 and y equals 0. With the point being, we are going to pass some other mask here. We'll generate a mask for our own image. We will then have the x and the y of the other mask. We obviously already have the x and the y of the car. We will determine if two masks are colliding in here. So I'm going to start by saying car underscore mask is equal to pygame dot mask dot from underscore surface. And this will be self.img, so whatever image we're using for this car. Then we are going to calculate the offset. Now the offset needs to be integer values, so keep that in mind. So I'm just going to say int like this. And the reason we need that is because we could get some floating value when we do this subtraction. But we need to calculate the offset x and the offset y. Now the offset is relative to the calling mask. In this case, we're going to say, I guess, collision, or we'll actually go with POI, which stands for point of intersection, is equal to, and then this will be mask dot, and I believe this is called overlap of the car mask with the offset. So we're going to use the other mask as the calling mask, which is going to dictate how we calculate the overlap. If we did the other way, we need to flip the the offset, sorry. Okay, inside of int, I'm going to say, we're going to go with x minus self.x and y minus self.y. Or is the other way around? Let's see. Of course, I've done it incorrectly. It's going to be the other way around. It's going to be self.x minus x and self.y minus y. Okay, so the reason why we're using this as our offset, again, is because the calling mask is the other mask that we're passing. So we're going to take whatever our current x position is and whatever our current y position is, and we're going to subtract that from the x and the y of the other mask. Now that will give us the displacement between the two masks. If we did this the other way around, that'd be fine, but we would then have to swap this and say the car mask is calling the other mask, okay? So that's how that would work. Hopefully that makes a bit of sense. The reason we're converting this to int again is because we need integer values for the offset. We cannot have floating points, and our self.x and self.y can be floating point values. Okay, so now that we have that, this is going to return to us the point of intersection between these two masks if there is one. Now, we don't actually care what that point is, at least not right now. We're just going to return the POI. Now what we can do to determine if two objects have collided is we can see if the POI is equal to none or not. If there is no POI, the two objects didn't collide. If there was a POI, then they did collide. So now we have collide. So I'm going to go inside of here and I'm going to check for this collision. So I'm going to say if, and we're going to go car_player dot collide, and we're going to do this with what mask was it? This was going to be the track border mask. And notice that I don't actually need to pass an X and a Y here because the track border is positioned at 0, 0. Now, we actually haven't even drawn the track border, but that's fine because we don't need to. We don't need to draw the track border right now because we just know that it's going to be at the exact same position as where our current track is on the screen, because the track border and the track are the exact same size. They're pretty much the same image, except one is just the border, the other is not. So we don't need to draw it, but we can still use the mask, and we know its location is going to be 0, 0. Okay, so we have that if player_car.collide track border. We can say does not equal none there. Then what we can do right now is we can just print collide. And that way it's really easy for us to see if we actually have collided. We can just look in our console and see if, well, we had a collide. So let's run this, and Pygame.surfaceObject has no attribute overlap. Okay, let me go here. Okay, car mask, Pygame.mask surface, mask.overlap. I realized what I did here. I passed the track border when I meant to pass the track border mask. Okay, so make sure you've actually passed the mask. That was the point of creating it. Let's run this now. And okay, we're all good. So now watch what happens when I go into the wall. Notice I get a bunch of collisions. And then when I get off the wall, it stops for a second. And if I go back to the wall, it continues printing collide. Now you can't really see it because my whole console is filled with collide. But let's quit this and clear and run again. And I'll show you, let's turn and let's go here. And then we get a bunch of collides as soon as we hit the wall. Okay, so that is the idea behind the collision. That's really all you need to know for calculating collision. Now that we have done that, we need to do something when we hit the wall. We can't let our car drive through the wall. So what I'm going to implement now is a bounce. So if you hit the wall, you're going to bounce off the wall with the same velocity that you hit the wall with, right? I guess we could go into the laws of physics, laws of motion, maybe is what it's called. If you hit something with a certain velocity, then you're going to go back in that same direction, right? Just like when you throw a ball off of a wall, it comes back and you're going to lose a bit of velocity, but point being, you know, law of physics. I won't explain more than that. So inside of my player car, I'm going to implement a method which is going to be bounce. I'm going to say define bounce self. Now, all I need to do inside of bounce is I just need to reverse the velocity. So I'm going to say self.vel is equal to negative self.vel. Now, this will work if we're going backwards or forwards, because if we're going backwards, the velocity is already negative. So this will then make it positive. So we go forward. And if the velocity is positive, then it just makes it negative, right? And then, of course, we'll just say self.move so that we start moving as soon as we reverse the velocity. So now all we need to do is here say self.bounce. And now if we hit a wall, we just bounce. And sorry, this is not self, this is going to be player_car. So if we hit a wall, we collide, we just bounce backwards, and we'll go in the same, well, actually the complete opposite direction as the one that we hit the wall at. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is AlgoExpert. AlgoExpert is the best platform to use when preparing for your software engineering coding interviews. They have over 160 coding interview questions in many different categories. They have heaps, they have arrays, they have linked lists, everything that you could imagine and that you need to prepare for your software engineering interviews is available at AlgoExpert. Check them out from the link in the description and use the code TechWithTim for a discount on the platform. Okay, so now that we have that, let's run the code and see if this is working. And let's try it out. And notice that I am bouncing off the walls. There you go. That is what I would expect. Now, this is a little bit glitchy. I won't lie. This isn't always going to work perfectly every single time. And you'll notice that sometimes you will kind of hit a wall, even though you don't really see a wall. That's just because my image is kind of messed up a little bit, the way that I had it. And so you might be hitting some pixels that you can't actually really see. Anyways, this is working good enough for me. I'm happy with the bounce. And so we're going to move on to the next thing. Okay, so we have now handled the collision with our walls. And you'll actually notice now that you can't go outside of those bounds because, well, you just can't, right? If you hit any of the walls, then you're going to bounce back inside. So now we need to make it so that you can hit the finish line, right? So let's start drawing the finish line on the screen. Let's handle collision with the finish line. But you'll notice that this is a little bit trickier than it seems because we have to know what direction we cross the finish line from. Because if the finish line is where we start, right, kind of starting line, finish line, if we just drive directly backwards, we can't say that we've won the race. We have to hit it from the other direction. So we have to handle that. Okay, let's go here though. We have finish. Now, let me see if I need to scale this rather than just messing around with it. Let's see if I did scale it in my, my code previously. Looks like I did not scale it. So that's good. We can just leave it where it is. But I do need to determine the position of the finish line. So I'm going to say finish underscore position is equal to, and I've already figured this out for you, it's going to be 130 and 250. So now let's just draw this in that position and let's see what it looks like. So I'm going to go to my images here and I'm going to add that as one of the images. So I'm going to say finish. I'm going to draw this at the finish underscore position like that. So now let's run the code and let's see what we get. Notice the finish line is right here. All right, so there you go. The finish line is up. Now this looks fine. However, we can see it is kind of overlapping with our track. So what I'm going to do is just draw the track border over top of this. So that way we get rid of any of these edges that are being cut off. So this is kind of a neat solution that we can go with here. But what I'm going to do is just add inside of my images here. And make sure you do it after the finish line, by the way. Otherwise, it won't go over top of the finish line. I'm going to say track underscore border. And we'll just draw this at position 0, 0. Not 0M, 0, 0. Make sure we add our last bracket there. And let's run this now. And parentheses does not match. Did I mess something up? Okay, that looks good. All right, so now let's see this. And notice that now the finish line is no longer overlapping. The reason for that is it is actually overlapping, but we're just drawing over top of it just the track border. So that way, everything looks good. And then there you go. Our car is now moving around. Let's see if we bounce, and we do. Sweet. Okay, so that is good. Now that we have done that, we want to handle colliding with the finish line. So now we're going to do another thing down here. We're going to say if player underscore car dot collide, and now we need to get a a mask for the finish line. So let's generate a mask for the finish line. We'll do that from up here. Where is the finish line? Right here. Okay, we're going to say finish underscore mask is equal to Pygame dot mask dot from surface and then finish. Okay, we now have the finish mask. So now we're going to say player car dot collide. We're going to go with finish underscore mask. And then we need to pass the finish position, but with an asterisk. What this does is split the tuple that is storing this position, so X and Y, into two individual coordinates and passes this to the function as two arguments. So if you do asterisk finish position, this is the same as passing 130 and 250. Okay, they're identical, but I figured I would show this to you because it's interesting Python syntax. Anyways, we're going to say again, if that is not equal to none, then what we want to do now is just print finish, okay? So now let's see if we can check for collision with the finish line. So I'm just going to go backwards and notice we get a bunch of finishes. And then if I go up here, we get finishes again. So the thing is, as I was saying, we don't want to be able to just drive backwards and say, oh yeah, you finished. In fact, if we drive backwards, we don't want to be able to go past the finish line. We should only be able to go forward on the track. We shouldn't be able to go backwards and cross the finish line. So this is where I'm actually going to use the point of intersection to determine what direction I hit the finish line from. So rather than just printing finish here, I'm actually going to store this. And I'm going to say finish POI collide. Yeah, I guess that makes sense. Finish point of interest collide is equal to that. And then instead of all this, we'll just say finish POI collide, and we will print out the finish POI collide. Okay, so let's run this. And now let's go backwards. And notice that we get a bunch of zeros as we're going backwards, right? So if I keep going back here, let's go back, back, back. Let's just go slow here. Notice all of these are 0, 0, 0, 0, okay? And then as soon as, I guess, the top of my car kind of gets to the middle of the finish line here, we get some actual values for the y coordinate. So what we can do is we can just check if the y coordinate of the point of intersection is 0. And if it's 0, that means we hit it from the top, so coming down. If it's not, that means we hit it from the bottom and we actually finished, meaning we went all the way around the track. So let me show you what I mean. We're going to say if the finish POI collide at index 1 is equal to 0, then car.bounce. So just like when we hit the wall, this is actually going to be player car.bounce. We're just going to bounce, meaning we're going to bounce ourselves kind of up, I guess, if we're going backwards trying to hit the finish line. Let's run this. Notice when I go backwards now, I bounce forwards because I'm trying to cross the finish line from the wrong direction. Now let's go all the way around, and this will take a second here, but let's see if we bounce when we go from the other direction. Okay, we got to slowly make our way through the track. We can just test my driving skills here while I try to fill in the silence because there's nothing to talk about. Okay, looks good so far. Maybe we need to increase the speed of this car for debugging because this could take a long time if I leave it at the speed of 4. Okay, almost there. Last 2 bends here. All right, coming around, and notice we only bounce when we hit the top of the finish line, right? Like I can go onto the finish line like that. It's only when I get to the top that I'm actually bouncing. So that's exactly what we wanted. Now we can just implement what happens if we cross the finish line from the correct direction. So I'm just going to put in else here, because if we collided with the finish line, but our y coordinate was not 0, that means we actually finished. So in this case, we will just print finish, and I'll actually implement kind of the finish behavior in the next video. But for now, we can add a few more methods to our cars. So I'm going to go to my abstract car class here, and I'm just going to define another method. And I'm going to call this reset. Now, what this is going to do is reset our car position. So kind of preparing for the next level, right? So all we'll do is we'll say self.x, self.y is equal to self.start_position. We then need to reset the angle. So self.angle is equal to 0. We need to say self.velocity is equal to 0 as well. And then is there anything else that we need to reset? I don't think so. Let's see. Rotation velocity, max velocity. Nope, that looks good to me. We can just do that. Okay, so now how about we say that if we cross the finish, we'll reset the car. We'll say player underscore car dot reset. I'm just going to increase the speed of my car. So let's make this a speed of 8, and we'll go with rotational velocity of 8 as well, just so that we can turn at the same speed we can move forward. And let's run this, and let's see if we go any faster. Okay, so we can indeed go faster, but we do have to wait to accelerate. And oh gosh, that's a crazy bounce, okay? Maybe we should make the bounce a little less harsh. And maybe the lower speed was better. Oh my gosh, okay. All right, come on. Let's try to get around this bend here. Okay, yeah, so I think the speed of 8 maybe is too fast. We also could just try spawning the car right before the finish line. That would probably be easier too, but you guys can just watch me struggle here. Okay, let's go. And you're noticing that sometimes we're hitting like a wall that's not actually there. Again, kind of unavoidable, but as you saw there, as I hit the finish line, we spawned on top of the finish line. We reset the car and everything was good. Great. So with that, that pretty much covers everything I need to go through in this video. I'm trying to think if there's anything else I can show you, but I think for now that is fine. In the next video, we're going to implement the computer car, all right? So the computer car moving around. And as I said in the last video, we'll do all of the kind of logic of starting the different levels, moving the speed of the computer car faster, you know, that nice fancy text on the screen, and really making the game an actual playable game. Hello, everybody, and welcome to the third video in this Pygame car racing tutorial series. In this video, I'll be implementing the computer car. So we're going to set up a path for this car to follow along with, and then we're going to make it follow the path, which is much more complicated than it seems. Let's get started. So the first thing I want to do here is make a class for my computer car. So I'm going to say class computer car like that. It's going to inherit from abstract car. And then inside of here, I'm going to define the image for my car as well as the starting position. So I'm going to say image is equal to, and this will be the green car, and the starting position will be 150. Okay, that's pretty straightforward for the computer car. Next, I'm going to override the initialization. So I'm going to say define init self. This is going to be maxvel and rotation vel is giving me that. Very good. And then I'm also going to take in a path, which is going to be equal to an empty list by default. Then what I'm going to say is self dot, not self actually, super dot underscore underscore init underscore underscore, and I'm going to pass the max velocity and the rotation vel. What this is going to do is use this method right here to initialize all of the values that I need, and then I'm just going to initialize a few more under here. I'm going to say self.path is equal to path. Path is going to be a list of coordinates of points that I want my car to move to. And I'm going to say self.current underscore point is equal to 0 because I need to know what point in my path I'm currently at. Then I'm going to say self.vel is equal to the maximum velocity because my computer car, we don't need to worry about acceleration. It's just going to immediately start at the maximum velocity and will move at that speed the entire time. Okay, now we have the computer car. The next thing I want to do is just implement a method on this car that can draw all of the points in the path, just because this will be useful for us to visualize. So I'm going to say define draw points, and then I'm going to say self, and we'll take in a window, and I'm going to say for point in self dot path. I guess we could have called that points too, but that's fine. And then we'll say Pygame dot draw dot circle. And we'll draw this on our window. We need to pass the color of our circle, which is going to be red. So in Pygame, the colors are RGB, so red, green, blue. So 255 is full red, 0 green, 0 blue. Then I'm going to pass the point. This is going to be the center of the circle that I want to draw. And then the radius will go with 5. So that means we're going to have a diameter of 10 for our circle. So that should draw all of the points for us. That's pretty straightforward. Okay, now we have draw points. Next, I want to make some feature that allows us to actually kind of click on the screen and, I guess, draw, create, select all of the points for our path. So that way we don't have to manually add them inside of this path variable. So you see what I mean in a second, but first let's create a car. Let's go computer underscore car is equal to computer car. We need to pass a maximum velocity and a rotation velocity. So for now, let's just go with 4, we'll match our player, although we will reduce this later. And then for the path, we won't pass anything right now because we're gonna kind of dynamically create the path. Okay, so now we've made computer car, let's draw it. So let's pass computer car to our draw function, and then let's go to draw. Let's take in computer car, and let's do computer car dot draw. And inside of here, let's draw on the window. And then what we will do is we will override the draw method in here. So we'll say define draw self win. We'll then say super dot draw. So we'll call the draw method from the abstract class here. So we'll do this. But before we do that, we will draw all the points, or after, it doesn't really matter, but we'll draw all the points. So we'll say super dot draw. We need to pass the win, and then we'll say self dot draw points and the window. So now when we draw our computer, it will also draw all of the points in the path for this AI computer or whatever. Okay, there we go. Now that we have that, let's just run the code and see if the computer is being drawn, and then we will continue. Okay, great. So the computer car is there. That's all we were looking for. Okay, let me clear the console here. Now let's continue. So the next thing I want to do is make it so we can click with the mouse, and that adds a point to our computer's path, and then we can get all of those points at the end of the program so that we don't have to manually write them. This is pretty easy. I'm going to go inside of my event loop here. So for event in pygame.event.get, I'm going to say if event.type equals pygame dot, this is going to be mouse button down like that. Then what we're going to do is get the position of the mouse. We're going to say pause is equal to pygame.mouse.get underscore pause. And this will give us the XY coordinate of our mouse on the Pygame screen. Then we will say computer car dot path dot append position. So we'll add that position to the computer's path. Okay, that's really all we need to do, except at the end of our program, we're just going to print out the computer car dot path just so that we can copy it and then save it in our file and use it for future use. So let's run the code and let's see what we get here. Okay, we get our computer car. Now let's start adding some points. So I'm going to add one here. I'm going to add one here, and I will just add all of these. And then once I'm done, I will be right back. Okay, so I've added all of my points here. You can see this is kind of the path that I've defined. I've tried to spread them out as much as possible, but it doesn't really matter. I mean, just add the points and make them on the track, and you'll be good. You could put them off the track because we're not checking collision with the walls, but obviously the better you make your points, the better this is going to be. Now, I recommend you do spread them out a bit. If you make them too close, you're going to see it's going to look like all jittery when we're kind of turning and angling towards them. Anyways, that's fine. Okay, so let's close this, and notice when I close this, it prints out all the points. So what I'm going to do is copy all the points, and I'm just going to make a variable at the top of my program here called path, and I'm going to have it store all of these points, just so that I can use this with my computer, right? With my computer card. So now what I will do is I will actually go to where I initialized my computer, and I will pass that path. So now that will be set for my computer. And then I'm going to get rid of this mouse button down logic because I no longer need that because my path has been set. So now that I have the path, let's just run this. And notice the path is still printing out. It's, saved, right? Because I have it in a variable. Great. And then, of course, my red car can continue to move just like it did before. Awesome. So now that we have that, what I want to do is hop over to Paint. And I want to show you or discuss how we're actually going to kind of solve this problem of moving the computer car towards these points. And it's pretty complicated to do this, but I will try my best to explain. So let's say our target point is right here, and our computer is right here, okay? This is our computer car. So let's just go see, this is car. Now, the first thing that's kind of intuitive to do here is to draw a line between the top left-hand corner and the point that we want to get to. Now, we're going to be using the XY as the top left-hand corner of our car, so keep that in mind. That is pretty important for this. And anyways, there we go. So we have our target, and we have, our car. Now, how do we get to this point? Well, the first thing we can do is we can calculate the displacement in X and the displacement in Y, right? So we know the velocity, but we do not know the angle. And so what we're actually going to want to look for here is the angle between our computer and this point. If we know the angle, then we can tilt our car to that angle, and then we can move in that direction. Easier said than done, but that's the goal. We want to find the angle between our car and the point that we want to get to, and then we want to set the car so that it's facing that direction, and then just move the car in the same way that we moved our player car, because we already know how to move the player car, right? That part is done. We've implemented that logic. So anyways, we have X and we have Y. Now, we can easily calculate X and Y because we know the coordinates of this point and we know the coordinates of this point. We would just take this point's X, subtract by this point's X. That gives us the displacement in X. This point's Y, subtract by this point's Y. That gives us the displacement in Y. Now, it doesn't really matter if we get negative or positive values. We could take the absolute value if we want, but it doesn't matter if we get negative or positive, okay? Finding the angle is still going to be the same. And then we have our velocity. Now, the velocity we don't really need to use, but we know the velocity is going to be the hypotenuse of the triangle. Okay, that's fine. So what we're trying to do here is determine the angle. We know X, Y, and V, so there's multiple ways to do this. Now, remember our equations are this is going to be an H. Let me erase that. So, Ka, and then Toa. Now, in this case, it seems intuitive to me to use Toa because we know the opposite and we know the adjacent. So what we can do if we want to solve for theta, which is the angle that we're looking for, is we can write the equation tan, and then this is going to be of theta, is equal to O over A. Now we can do our substitutions, and when we do our substitutions, we see that O is Y and that A is X. So we know X and Y, those are two variables that we know. So now we want to solve for theta. So any of you that know trigonometry know that we have to take the inverse tangent of this, and then that will give us theta. So we can say theta is equal to, and then tan inverse of Y over X. And then that will give us the angle that we're looking for. And in fact, this is actually always going to give us what's known as an acute angle. Now, an acute angle is any angle that's less than 90 degrees. Now, it will give us either a positive or negative acute angle. So we could get a negative value here or a positive value here. If we get a negative value here, that's indicating to us that we are looking to the left. If we get a positive value, then to the right. Anyways, that's not super important right now, but just keep in mind that this is how you calculate theta, and that this is always going to give us an acute angle. That is important. It's always going to give us something based on the way we're doing this calculation that is less than 90 degrees. Okay, so now we have found the angle. So we found the angle between our car and our point. So it should be simple enough, right? Just set the car at that angle. Well, it's not quite that simple. The reason why it's not quite that simple is because if our car is like facing this direction and we want to go over here, if I just set its angle to that, it's going to look like it's just teleporting over. That would be the easy solution. Just set the angle and then that'd be fine. But if we do that, what happens is, first of all, we're going to have our car facing the wrong direction a lot of times. We're also going to have the car flipping instantly, which we don't want. We want it to kind of slowly transition to that angle by its rotational velocity. We don't want it to just teleport over and face that direction. So now comes the problem. Okay, we know that angle. We know the angle our car is currently facing. How do we determine what direction to turn the car to get to that angle? That's really the problem now. We know the angle of our car. Now we just need to actually make this car get to that angle. So there's a few problems here. Again, the first problem is that we need to make sure we aren't just teleporting. So we have to kind of decide, do we want to go to the left or do we want to go to the right? Now, this might seem easy when you're looking at an angle like this, but there's so many different angles we could possibly have. And sometimes we could take the unoptimal approach if we only ever went to the left or only ever went to the right when trying to get to these angles. So for example, let's say we have this. Okay, let's just move this over a bit. Let's say our target angle is here. Okay, and our car is facing this way. So car is black and the target angle is red. Now, what way should we turn to get to this target angle? Well, we should turn this way. However, we might end up turning this way. So this is kind of the problem. We need to figure out which way to turn. Now, another problem that we're going to run into potentially here is that we might have the angle be here. So let's imagine this guy is gone, okay? We might have it be here. Now, theoretically, me turning like this is actually going to make it look like we have the same angle. I know this seems really weird, but the way that this angle is calculated means that this could actually be this, or other way around. We could get this angle from this. So we need to kind of put in some checks here to ensure that if we're actually moving downwards, we're actually going to go in the downward direction. We're not going to mistakenly calculate this angle. The reason why this is a problem is because these two angles are the same, right? If you look at this angle and you look at this angle, they're the same. And so when I do the tangent based on the way that I'm doing it, I could get this when my point is down here. And so I need to make sure that I'm actually looking at what direction my point is in, if it's lower or higher than where I am. And based on that, I'm going to need to make an adjustment to the angle I get to ensure that I'm going the right direction. So I'm just trying to kind of point out some of the problems that you can run into doing this. And there's all kinds of other problems as well. For example, right, like I was saying, we might go and try to go like this when instead it would be more efficient to go like this. So if we ever have a very large angle, we'll actually want to reduce that angle to a smaller yet equivalent angle so that we end up moving in the, I guess, best direction, the quickest direction to get to it. I also realized that all of my lights turned off here. I'm just going to turn them back on. I'm sure you guys can still see my face fine, but I have like these background lights that for some reason went off. Okay, so that's a bit better. Okay, anyways, that was kind of the point of this. I'm sure this hasn't cleared everything up. I haven't necessarily stated the solution. I just wanted to show you problems that can happen. And really the main problem is, what direction do we go? Do we go left or right? That's the main idea. So let's now start trying to implement this. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. Not only do they have a ton of coding interview practice questions, they also have mock interviews, a data structures crash course, and a bunch of other awesome features to help you prepare to land your dream software engineering job. With that said, check out Algo Expert from the link in the description and use the code TechWithTim for a discount on the platform. I'm going to go into Computer Car, and I'm just going to define a move method. Now, this move method is special because when I'm moving, I need to move towards a point. So the first thing I need to do is angle the car in the correct direction. And if I am in the correct direction, then I can start moving towards that point. And we already know how to move. We can just use the move method that we have inside of here, right? If we're angled in the right direction and we're going by a static velocity, then that's fine. So I need to look at my other code here because it's very easy to mess this up. So inside of move, what I'm going to do is just make sure that we have a point to move to. I'm going to say if the self.current point is greater than or equal to the len of self.path, then I'm going to return. This is just going to ensure that we are not going to get an index error by trying to move to a point that doesn't exist. That's the point of this line. After that, I'm going to say self.calculate, and this is going to be angle. Now, we will write this method in a second, but this is going to calculate the angle and shift our car in that direction. The next thing we're going to do is say self.update underscore path underscore point. Now, what this is going to do is see if we need to move to the next point, because as soon as we hit a point, we collide with that point, we then move to the next one. That's it. And then here, we're going to say super.move. So we're going to actually call manually the move method that we're overriding inside of car. Okay, so let's start by implementing calculate area or calculate angle. I'm going to say define calculate angle self. The first thing I want to do is calculate the displacement in X and Y between the target point and my current position. Once I do that, then I can find the angle between my car and the point, and then I can adjust the position or angle of my car accordingly to move towards that target point. So I'm going to say target underscore X, target underscore Y is equal to, and then this is going to be self.path at the self.current point index. This is getting our target point. Then I'm going to calculate the difference in X. I'm going to say the X diff is equal to the target X underscore X minus the self.X. Then I'm going to say the Y diff is equal to the target underscore Y minus the self.y. Now, I don't care about the absolute value because my tangent function will actually handle any negative values here, and it can potentially give me a negative angle. We will handle the negative angles. The negative angle is just, going to, I guess, the right instead of the left, or the left instead of the right. Doesn't really matter. Okay, so now that I have both of these, I'm just going to say if y underscore diff is equal to 0, then the desired underscore radian underscore angle is equal to, and I want to say 180, but I want this to be in radians. Sorry, not 180. I want this to be 90. And so in radians, this is going to be math.pi divided by 2. Because math.pi is 180 degrees, 2 math.pi is 360. So the reason for this is that if the y difference is 0, I need to manually set the angle because my equation involves a division of the y difference, and I can't have a 0 division error. So you'll see what I mean here. I say else the desired radian angle is equal to, and this is going to be the math.arc tangent, so the inverse tangent of, and then this is going to be this is going to be x diff over y diff. Okay, so this is going to give me the angle that is between my car and between the point. And then same thing here, this will give me that angle. So if we have no difference in y, then that means that we're horizontal, right? We're either 90 degrees or we're either 270 degrees. Now in this case, we'll just make it at 90 degrees because 90 and 270 are equivalent angles, not in direction, but in like the magnitude of the angle if you divide them. Hopefully that's making sense, but we just need to avoid having an over 0. So that's why I'm writing this line here. Okay, now that we have that, what I want to do is I want to kind of implement a clause here that's going to fix this angle slightly if a certain thing occurs. I'm being very vague, but let's just write it. I'm going to say if the target underscore y is greater than, so is lower down on the screen than self.y, then what I want to do is say the desired radian angle plus equals, and this is going to be math.pi. So the reason I'm doing this is kind of what I discussed before. We can potentially have a problem where the angle that we calculate it's always going to be an acute angle, right? And so if the target that we're looking for is actually lower down on the screen than where our current car position is, the turn that we need to make is more extreme than what the angle is that we're getting. Maybe we're getting an angle of 25 degrees, right? And the reason we're getting 25 is because 25 kind of spans this whole horizontal line. And so we're looking at it like this, but what we really want is to add a whole math.pi, add 180 degrees to it so that we go in the complete opposite direction of what the angle is that we calculated because we're going down. Because remember, we're always going to get an acute angle, so we're always going to be going kind of this way or this way, so we need to figure out if we need to go the opposite direction down. Now, in that case, well, the case is this. If target y is greater than self.y, we're going down, so we have to add math.pi to the angle to ensure that we're going to go the correct direction. I'm sure this is confusing, but that's really the best way that I can explain it. I'm not a math professor, and I don't want to get too much into it because I'm sure I'll butcher the mathematical explanations of all the angles. Anyways, there we go. Okay, so that's kind of the first thing that we need to do. Now that we have that, though, we're going to say the difference in angles is, or just angle actually, is equal to self.angle minus, and then the desired radian angle. Now we need to first convert this to degrees. So we're going to say math.degrees like this. Okay, so remember, this is going to give us the angle in radians. So then we convert it to degrees, and then we take whatever our current angle is and subtract it by whatever the desired angle is to get to. And then based on if this number is positive or negative, we're going to know if we have to move left or right. Now, another problem happens here. What if the difference in these angles is really massive? What if it's 270 degrees? What if it's 290 degrees? In fact, what if it's anything larger than 180 degrees? Well, if the difference in the angle is larger than 180 degrees, we are going to be taking an inefficient route to get to the angle. So let me show you what I mean. If I go to Paint here and we zoom in, so let's go, come on, zoom in. Control plus, does that not zoom? Okay, let's just move this. Okay, so let's say we have this example here, right? Where we have some angle here, and actually let's just do one here. And then we have another angle here. Now, if we calculate the distance between this angle, or the difference between these angles, maybe we get something like 220 degrees, okay? That's fine. But if we were to go in this direction to get to this angle, we need to travel 220 degrees. Whereas if we go in this direction to get to this angle, then we have to only go 140 degrees. Is 140 degrees correct? Yeah, 360, yeah, 140. I think that's right. Okay, so we only have to go 140 degrees. So obviously we would prefer to go 140 degrees than to go 220. So what are we going to do if we have an angle that's greater than 180 degrees? Well, if we have an angle greater than 180, we know we're taking an inefficient route. So all we'll do is we'll take this angle and we'll subtract, so let's say it's 220, we'll subtract 360 from it. Now you might be saying, well, why don't you do the other way? The reason I'm not doing it the other way is because I want to actually get the negative angle by going backwards. So if I have 220 by minus 360, then what I'm going to get here is negative 140, which is what I want, because I don't want to go 140 degrees this way. I want to go the other direction 140 degrees. So that is how I'm going to kind of fix this problem of potentially turning the wrong direction, is I'm going to simplify this, or I'm going to do this check to make sure we're going in the right direction. Okay, so anyways, we have the difference in angle, and now we're going to say if the difference in angle is greater than or equal to 180 degrees, then we're just going to say the difference in angle minus equals 360. So now we'll turn the opposite direction. So now that we have calculated the difference in the angles, we don't even care what the difference is. Well, we actually will use it in a second, but we just want to move in the right direction now to get towards the angle that we want. So we're going to say if the difference in angle is greater than 0. So if the difference in angle is greater than 0, notice we're having our angle first and then the angle that we want to get to. We want to go the other way. We need to go to, I guess, the right as opposed to the left. And the reason for that is when we go to the left, we increase our angle. If our angle is already greater than the angle that we desire, we need to go the opposite direction to get to that angle. So we're going to say self dot and then angle is going to be minus equals, and this is going to be the, actually, let me check here, the minimum of self dot rotation velocity, and then the absolute value of the difference in the angle. Let me check that that's all good. Okay, yeah, that's what we want. So the reason for this is that I don't want to potentially pass the angle going the other direction. So let's say the difference in the angle is 3 degrees, and my rotational velocity is 4 degrees. If I just straight up go 4 degrees to the right, I'm going to pass by the angle that I want. And then what's going to happen is I'm going to pass by it, and now all of a sudden I'm going to be 1 degree less than the angle that I want. And so I'm going to have to move back the other way. But I can only move by my rotational velocity, so I'm going to move back by that. So what's going to happen is you're going to be like stuttering back and forth, like left, right, which you don't want. You want to just be, steadily on the angle. So the point of this kind of min right here is that if the difference in the angle is less than the rotational velocity, we'll move by that amount. So we snap precisely on the angle. We aren't going like above the angle, below the angle, above the angle, below the angle. That's the point. Okay, so now that we have this, we're just going to say else, because if it's not greater than 0, then it must be less than or equal to 0. And here, we're just going to swap this to a plus. Now, I think we can just leave the exact same thing in here. Yeah, we can. And that should actually be good. That will actually rotate our car so that it's going to move towards the point. So that is kind of the trickiest part right there. This very complicated method, I'm sure this doesn't make 100% sense. It doesn't have to. If I'm being honest with you, I don't understand it 100%. This was a lot of trial and error to get this to work. But hopefully what I explained gives you some sense of why we're doing the things that we're doing. Angles are difficult. That's the moral of the story and of this tutorial series. Okay, continuing. Now that we have that, what I would like to do is I would like to make sure that we move to the next point in our path when we are ready to do that. So I'm going to say define update underscore path point like that. And then inside of here, all I'm going to do is check for collision with the points that we have. So whatever point I'm currently on, I'm going to see if my car has collided with it. And if it has collided with it, then I've hit that point. We can go on to the next one. So let me just look at my cheat sheet right here. Okay, that looks good. I'm going to say the target is equal to, and this is going to be self.path at self.current point. I'm then going to create a rectangle from my car. Yeah, that's what we're going to do. We're going to say rect is equal to Pygame dot, and then this is going to be, I guess it's just rect. Yeah, I think it is just rect, pygame.rect. And then we're going to, instead of doing target, we're going to say self.x, self.y, and then we need to get the width and the height of our image. So I'm going to say self.img.get underscore width and self.img.get underscore height. So the point of creating this rectangle is that my image alone is a rectangle, but it doesn't know its location, right? Like the image doesn't know where it is. So I make a rectangle using the X and the Y of my car as the top left-hand corner, and then I get the width and the height of my image. So now what I can do is use a built-in method in Pygame, to determine if a point is colliding with my rectangle. Now this is pretty intuitive, but it is collide point like this. And all it does is take a point. So you have to call this on a rectangle, but it takes a point, which will be target, and tells you if you are colliding with it. Now, in fact, it actually takes a X and Y coordinate. So what I'm going to do is pass asterisk target, which will then pass the X coordinate and the Y coordinate as separate arguments to this function. If that's the case, if I am colliding with that point, I'm going to say self.current point plus equals 1. So if we've hit the current point that we're going to, then let's move to the next point. That's the idea behind update path point. Now let me just look and see if I've messed anything up. Everything looks good to me. What we can actually do now is we can start running the car, like moving the car around, and you will see that it will start moving on the path. So let's see how to do that. Again, I have to reference my code here. Okay, it was easier than I thought. We're just going to say computer underscore car dot move. Okay, so just like we have move player, now we have the move car. So let's do that. Let's run our code after we move our car. Let's cross our fingers and let's pray this works. And notice our car is zipping around the screen here and it's actually following these points. Okay. Now you will notice that sometimes it might kind of hit the edge, right? So you just saw right there, it almost hit the edge of the screen. Keep in mind that it is aiming to get its top left-hand corner on all of these points. So that's why it's taking these kind of wide turns. You'll notice that the top left-hand corner of the car is what's kind of aiming to intersect with some of these points. Okay, so we just ran into a problem there with this point right here. So that is most likely due to the fact that that point was too close to this one right here. And so we couldn't actually hit this point. We couldn't intersect this point from this one because we couldn't turn quickly enough. So what I'm going to do is kind of fix up some of these points and then I'll be right back. Notice we're getting another problem here. So in fact, let me just look at this and see maybe where I made a mistake and I'll be right back. So the problem is what I expected. The points that I have are just too close together so the car can't actually hit it. Now that will be fixed by lowering the velocity of the car because it can turn quicker than it can move. But to fix this, we just have to remake the path. So I'm just going to remake the path. I'll be right back. I'll show you the new path and then hopefully we should just be all good. All right, so I've just recreated the path here. Now I'm not going to lie, it's not perfect. It goes off the screen a few times, not very badly, but anyways, point being, I recreated the path. You guys know how to make the path. I showed you the code to do that. It's pretty straightforward, so you can mess with it and design as many times as you need to. Now, based on the way we have it right now, if you just clear the path at the start and then you add values to the path, the car will actually follow up until the last value in the path. That's the way that we've designed it. So every time I was clicking, it was actually going to that point, which was kind of cool. You could see how it kind of traced the path in real time. Now, one of the big reasons why it's hard for the car to actually hit some of the points is because of the turning radius, right? If you increase the rotational velocity, then you won't have the same problem that I'm having here. Just because it needs to take kind of a wide turn to be able to get to some of the points. Now, that's going to change with speed, so you have to be careful. If you have a lower speed than your rotational velocity, it's not necessarily higher, but you can just turn more because you're not moving as quickly to each point. Anyways, I just wanted to point that out. Okay, so now I have this new path. So I'm just going to copy that into this path variable here. So let's get rid of all that. Let's paste that. And now let's repass path. Where is it? Right here. So I'll just show you what I had was I just added this code back in, and that's how I was able to recreate the path. And then I had just cleared the path previously. Okay. All right. So now that we have all of that, our computer is going against the player. So what I want to do now is get rid of the drawing of the path. So I'm just going to go and comment out under draw this self.draw points because I don't want to do that anymore. And I want to implement some collision between the computer and the finish line, just so I know if the computer gets to the finish line first. And then in the next video, we'll implement all of the level stuff, but this will just be kind of a nice thing to finish off right now. Okay, so just like we have this, the finish POI collide, I want to go player underscore, and I just want to preface this all with player because I'm going to do the exact same thing now, except with the computer. Although with the computer, I know it's not going to hit the finish line in the wrong direction, so all I have to do is just see if it hit the finish line, and then I know it crossed in the right direction. So I'm going to copy this, and I'll put it actually above here, and we can go like this. And instead of player, we'll just say computer. And then we will just change the player to be computer car. And now this will tell us if the computer has hit the finish line. So I can just do an if statement here, and I can say if the computer car computer underscore finish underscore POI underscore collide does not equal none. And then I can print out computer wins, exclamation point, because in this case, the computer would have gotten there before the player. Now, we do need to reset both the player and the computer if the computer does win. So I'm going to say player car.reset and computer car.reset. And that reminds me, inside of here, I also need to say computer car.reset because now if the player gets to the finish line, we need to reset the computer as well. Okay, we can get rid of the print statement. I'm not going to test this because I'm just very confident this is going to work. But what I'm going to do now is take all of this collision code and I'm just going to put it in a function. Again, just to kind of clean things up. So I'm going to say define handle underscore collision. Now we want to take both the computer car and the player car. So I'm going to say player car and computer car like that. Now inside of here, we'll do all of this and then we can just call that function. So I'll say handle collision, and then we'll pass the player car and the computer car, and let's just run this here and let's test and see. Yep, okay, I can hit the walls just like I was before. Great, so there we go. That is all working. And with that, that's going to end this video. So we're getting very close to finished here. We just haven't implemented the logic for the game and the nice text. So in the next video, we'll do all of that. But this is the hard stuff. What we're doing going forward is very simple. We just need to keep track of what level we're on. We just need to reset the cars in, the correct way. And yeah, all that stuff's pretty easy. So we'll wrap that up in the next video. Hello, everybody, and welcome to video 4 in this Pygame tutorial series. In this video, I'm going to be adding the finishing touches to this game, making it a fully functioning game. We have now implemented all of the physics and the logic to allow the players to move, but we need something that tells us if we won, if we lost, what level we're on, all of that kind of stuff. So that is what we will do now. Before I go any further, though, if you have made it this far, give yourself a pat on the back and go leave a comment. Let me know what you've thought of the series so far. Any feedback, positive or negative, is more than appreciated. All right, let's continue and let's get into this. So we need to know levels. That is kind of the first thing we need here. The reason we need levels is because the computer is going to start off very slow and then it's going to get faster and faster, and it's going to determine its speed by the level. So what I'm going to do is make a class here, and we're going to call this class game info. Now, this is going to be responsible for exactly what it says, the information about the game. You're going to see why it's beneficial to do it in this way, but rather than creating like 20 variables to keep track of all of the stuff that we want, we'll just do it in this class, and then it makes our code very, very readable. So I'm just going to say levels is equal to 10. So it'll be a constant. We're going to have 10 levels in this game. If you wanted more, well, then you can increment this. Then I'm going to say define init underscore underscore, and I'm going to say self, and then level is equal to 1. This is just indicating that we're starting at level 1. Okay, then we're going to say self.level is equal to level. We're going to say self.started is equal to false, indicating whether or not the current level has started. And we're going to say self.level underscore start underscore time is equal to none. The reason that we're doing this is, actually we'll do it at 0, sorry, is because we want to know how much time has elapsed in the current level. That's something that we're going to do in here. Okay, so now we're going to say define, and we're going to implement some methods. We're going to say define next level. Now what this is going to do is say self.level, and then plus equals 1. And then it's going to say self.started is equal to false, because if we're going to the next level, then we don't want to start the next level yet. We need to wait for the user to do that. Then we're going to say define, and this is going to be reset. Now inside of reset, we're just going to reset everything. So we're going to say self.level is equal to 1. We're going to say self.started is equal to false, and then self.level start time is equal to 0 as well. I think that's all we need to do. Then we're going to say define game underscore finished. We have to spell finished correctly. This will take in self, and this will simply return self.level is greater than self.levels. So if the current level is greater than however many levels we have, then we have finished the game. And then we'll say define, and this is going to be start underscore level. Now all this is going to do is it's going to say self.started equals true, and it's going to say self.level start time is equal to time.time. So that's why we imported time previously here. I'll go back to this so that you can read it. But the idea is we want to keep track of when the level started, and then we can easily determine how much time has elapsed by checking the current time and subtracting it from this. Okay, and then lastly, we're going to say define get underscore level underscore time self. And here we're just going to say if not self.started, then return 0. So if you haven't started the level, then no time has elapsed. Otherwise, we will return self.level start time minus time.time. Okay, I went through that relatively quickly, but that is the game info class. You can almost see all of it right there. Pretty straightforward, pretty simple, but it's just going to make our life easier as we go through this. Okay, so now that we have that, what I want to do is kind of make something pop up on the screen when we first start the game that says like press any key to begin level, right? So every time a new level happens, I want to say like press any key on the keyboard to start the level. That's all I want to do. So the way I'm going to do that is I'm going to go right after my draw here. I'm actually going to put another while loop. Now this while loop is going to wait until the level starts. And once the level starts, it will get out of it and then allow all of this stuff to happen. So you won't be able to move the car. The computer won't move until we start the level. So let me just go down here so I have a reference on my other screen, and this is what we're going to do. While not, and then this is going to be game underscore info dot started. Now we need to define game info. So I'm going to say game underscore info is equal to game info like that. And while not game info dot started, so we've not started the current level, we are going to blitz some text onto the screen. So I'm going to say when. Actually, I'm going to do something else, which I'm going to describe now. So what I want to do is write a function that is capable of writing any text onto the screen directly in the center of the screen. This is a very useful function to have. So to do this, we first need to define what's known as a font. So if you want to write text onto the screen in Pygame, you need a font. So what you're going to do is at the top of your program, you need to make sure you do this at the very top. You're going to say pygame.font.init. You know, obviously after you import Pygame. Then what I'm going to do is I'm going to actually define a font object. This font object is what you can then use to render text with that font. So I'm going to say main underscore font is equal to pygame.font.sys font, not system font, just sys font. And then inside of here, there's a bunch of options, but you guys know that I always go with Comic Sans. And then you can put the size, and for now, I'm going to go with 44. Now, this is the text size. Change this, obviously, to whatever you want. 44 is a good size, though, for like some title text, which is what we're going to have. Okay, so now we have our font. This will only work if you initialize the font. So if you're having an issue, just make sure you init the font first. And now that we have the font, we can use that to render some text. So I'm going to go in utils.py. I'm going to make a new function. I'm going to say define, and then this is going to be blit underscore text underscore center. And this is going to take in a window. It's going to take in a font, and it's going to take in some text. All right, so inside of here, I'm going to say render is equal to font.render. And then we're going to put the text that we want to render, the anti-aliasing, which is 1. And then we're going to put the color, which is going to be white. So 255, 255, 255. And in fact, let's go with like 200, 200, 200, just so it's gray, because we have white on the screen already. Actually, is this going to give me white? I'm not sure what this color is going to be. You know what? We'll experiment with 200, 200, 200, and we'll see what that gives us. In case you're curious, you just put text you want to render. You put anti-aliasing. Just always put 1 for this. I won't really explain it. Just you always want 1 here. And then you're going to put the color. And then you can actually blit this text onto the screen just like an image. Say win.blit, render. And then we need to put the position we want to render this at. The top left-hand corner, by the way, that's where you're putting here. So what I want to do is I want to render this at the win.get underscore width. Why did it fill all of that in? Okay, that's fine. Divided by 2. And then this is going to be subtracted by, and this is going to be the render.get underscore width over 2. So what this is doing is, let's go to Paint, and I will show you. So let's say we have our window, okay? We obviously have some width, and we have some height. And then we have the text that we want to render. And I want my text to be here. Now, I need to calculate this position. Not this. This would be easy enough. I just take width over 2. I want this. So the way you do it is the following. This is width over 2, right? W over 2. So you subtract from this half of the text width. Pretty straightforward, but if you just subtract half of the text width from half of the screen width, you get the top left-hand corner position of where the text should be drawn from, so that it's going to fill the entire screen and be directly in the center like that. Now you can just do the exact same thing in the height, and well, that will give you the coordinate for Y that you want this to be at, right? So it would give you it, around here. Okay. Actually, it would be probably close to around where I have it right now. Hopefully that makes sense, but that's my quick Paint explanation. And let's go here, win.get underscore height over 2 minus render.get underscore height over 2. Okay, so it filled that in for me. That is great. So that's going to render my text on the screen in the middle. We're going to use that a few times. That's why I wrote that. Now we want to import that. So from utils, import blit text center. And then we're going to go down to our, where were we? Our while loop inside of here, and we are going to render this. So we are going to say blit text center like that. And we're going to make an F string, only available in Python version 3.6 and above, by the way. I'm going to say press any key to start level. And then inside of here, I'm going to say game info.level exclamation point. Okay. Now that's the text. That's actually the last thing that we're going to pass. The first thing is win. The second thing is our font, which is main font, and then our text. If you're unfamiliar with F strings, the way they work is you can embed expressions directly inside of curly braces. You just put a lowercase or uppercase F before the string. So now whatever the level is, we'll say press any key to start level 1, 2, 3, so on and so forth. Okay, now win needs to be capital. Forgot about that. And now that we have blit that text onto the screen, what I'm going to do is do an event loop. I'm going to say for event in pygame.event.get. I'm going to actually copy this. It seems inefficient to rewrite this, but it's simpler than trying to come up with a cleaner way, essentially. And I'm going to still have this kind of quit clause, except instead of run equals false, I'm just going to say pygame.quit. Okay. And then here, I'm going to say if event.type equals pygame.key down. This means you pressed any key down. Then what I'm going to do is say gameinfo.startLevel. So we're going to call that start level method that will start the current level, which means this while loop will now exit. And then we will go on and, well, we will have the level. Now, I'm wondering if I'm missing anything. I am. The one thing I'm missing is I need to manually update this display here. So pygame.display.update to ensure I actually show this, because we're going to be skipping this draw function. Hopefully that kind of makes sense, but we're drawing everything, right? And then we have this while loop, and this is only going to run if we haven't started the current level. So if we haven't started the current level, we put this text over top of everything in the middle of the screen, and then as soon as they press the key down, we're going to exit out of this while loop and then start the game, and the current level will start. And then if I go here, let's just make sure start level looks good inside of this class. Okay, all good. So let's run the code and see what we get. Okay, notice it says press any key to start level 1. Maybe we want to move it up a tiny bit because it's kind of hard to read when it's over top of the white, but for me, that's fine. Press any key, and then notice the car starts going and we can start moving. All right, there you go. So that is how we start the current level. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. They have over 160 coding interview practice questions, mock interviews, a data structures crash course, all kinds of other great features. Of course, I am an instructor on the platform, so you know there's going to be some quality content. And well, with that said, you can check them out from the link in the description and use the code TechWithTim for a discount on the platform. Now that we have that, I just want some text in the bottom left-hand corner displaying the current level, displaying your current velocity, and displaying the amount of time elapsed in the level, which is actually pretty easy to do. So inside of the draw function, now what I'm going to do is also take in my game info. So now I'm going to go inside of draw, and I'm going to start rendering some text and drawing some stats onto the screen. So let me go to my code here, just so that this will be a bit faster for me to code out. And I'm going to start by saying that my level text, let's go like this, level underscore text, is equal to, and then this is going to be main font dot render, and I want this to say level, and then game info dot level like that, and then I want the anti-aliasing 1 and the color of white, 255, 255, 255. Okay, now I'm going to render my level text, so I'm going to say, not render, sorry, I'm going to display it on the screen, win.blit level text. And then where do I want this? I'm just going to tell you the position, but you can feel free to mess with it all you want. I'm going to say 10, and then I'm going to say height minus, and this is going to be level text dot get underscore height minus 70. This is because we're going to put 2 other things below this. Now, the reason I'm doing this is so that it's dynamic. So if I ever decide to change the height of my screen, then I don't need to change this right here because it's based on the height of the screen, which is height, and the height of whatever this text is here. So again, if I change the height, or sorry, the size of the text, I won't need to modify anything. This will just automatically adjust itself and put itself in the bottom left-hand corner. Okay, so I'm just going to copy this now because we're going to do the same thing for velocity and time. So I'm going to say time text, and this will be time text like that. The minus here is going to be 40. Because we're going to have 30 pixels offset. That is something that we manually would have to update, but that's fine. And then here I'm going to say time colon, and this is going to be equal to game info dot get level time like that. Okay, that looks good to me. Now let's copy this, and we're going to do the same now with our player velocity, just so we can see how quick it's going. I just figured that would be a cool stat to add. So now we're going to say vel, and then this. Actually, let's add a second here too. Let's add an S just so it says seconds. But for velocity, I'm going to go with, this is going to be player car dot velocity. And then we'll go with px per second, standing for pixels per second, just so we have some unit there. We'll go with white again. Now, instead of time text, this is going to be called vel text. So we'll just change these all to be vel. So this is going to be vel. And then rather than minus 40, we're going to go minus 10. So 70, 40, 10. The pattern is 30 less every time. All right, there we go. That's it for drawing that text on the screen. Now let's run the code and let's see what we get. Draw takes 4 positional arguments, but 5 were given. Good call. I forgot to import my game info, or to add this as a parameter. So do that, and now we should be good. Remember, I passed game info into the draw function here. Okay, let's run the code. And notice that now we get level 1, time 0 seconds, velocity 0 pixels. And when I start this, now notice we have our time. Now, that's kind of ugly, and it's negative, which means I messed something up. So we're going to have to fix that in a second. But then you can see the velocity gets updated here as well. Great, so that's fine. But what I want to do is I want to round, first of all, the velocity. So let's do that. Let's go to my velocity, and let's just round this to 1 significant digit. So round and then comma 1. And then let's go to our game info class here, and let's see where I messed up. So I did self.level start time minus time.time. The reason this is incorrect is because time.time is going to be after the start time. So I need to flip this around and say time.time minus that. And then I will as well round this, but I'm just going to round this to 0 places. So just do a whole number, because this is going to give me the displacement in seconds, or the difference in seconds, okay? So let's run this now, and let's see what we get. And now notice that the velocity is all good, and so is the time. Perfect, there you go. Okay, so that's all we need for those stats. Okay, so now that we have that, we have the velocity, we have the time, we have the level showing up, what I need to do is make it so that my computer gets faster every time I beat a level. So what we need to do is go inside of our computer car here, and we need to write a method that is going to allow it to update its speed based on the current level. So I'm just going to say define next underscore level, and what we will do is say self. Now, when we go to the next level, what we need to do is reset this car. Now, we could manually call reset outside, but the first thing we'll do is say self.reset. Like that, so that this is going to go to its start position, its velocity is going to get updated, all of that. However, after we reset the car, we then need to change its velocity based on the level. So I'm just going to say level inside of here. So we're going to reset the car, and we're going to say self.vel is equal to, and then we'll go with whatever the self.maxvel is that was passed, plus, and then this is going to be level minus 1 multiplied by 0.2. Now 0.2 is how much I want to increase the speed of this car every level. We could put this in a variable. I'm just going to hard code it in for right now. You also could change this and make it something like 0.5. The one thing to keep in mind is you do not want this car to ever be faster than the player car. If it's faster than the player car, there's no way the player will win. It's just impossible, because this car will take, assuming you did a good path, the best possible line around the track. And so there's no way the human's going to be able to beat it, especially because it doesn't have to worry about acceleration. It just starts at the maximum speed. So you need to make sure that whatever your increment here is, that multiplied by the number of levels that you have plus the maximum velocity you start with is not greater than the player's speed. You could make it the same, but even if you make it the same, then the player still can't win. So this is fine. I'm saying level minus 1, which means on the very last level, I will have 9 multiplied by 0.2, so 1.8. So the speed will be 3.8, so it'll be 0.2 slower than the player. Hopefully that is good. Let me just make sure that that all makes sense. Yep. And then the last thing we need to do is say self.currentPoint is equal to 0, although that should really go inside of the reset method. So where is reset? Reset was in the abstract class. Okay, so we can leave self.currentPoint here. All right, that should be good. Now we just need to see where we should call next level. So what I'm going to do now is go to my handle collision. Handle collision now needs to take game info as well. And so when we call handle collision, we need to pass game info. And now we're going to start kind of working on what happens when the computer wins or when the player wins. So if the computer finishes, we are going to reset the player car, reset the computer car. That looks fine. Okay, and now we go here to when the player finishes. Well, if the player finishes, then rather than computer car.reset, we're just going to say computer car.nextLevel. and we're going to pass game info dot level. But first, we're going to say game info dot and then next level like that. So we're going to increment the next level for game info if the player has won. We're going to reset the player car, and then this will reset the computer car and change its speed for the next level. So that should be good. Now, by doing this, it means that this will automatically trigger for the next level because the game will now not have been started. We'll be waiting for the next level to be started. Okay, that's fine. The only thing we need to handle now is if the computer wins. So if the computer wins, we need to put some message on the screen saying, hey, you know, you lost, whatever, and then we need to reset the game. So we'll actually go game info dot reset. And before we do that, let's just put some text on the screen. So let's say blit text center. And then this is going to be, what do we want to say here? You lost, exclamation point. And we'll do this on the window and we'll pass the main font. Okay. Then we need to manually, this is going to be capital win like that. We need to manually delay the game. The reason we need to delay is so that we have time to see this text, because what's going to happen is we're going to show you lost. We're going to delay for however many seconds you want. I'm going to go with 5 seconds. And then as soon as that delay is done, it's going to automatically restart the game for us. So I'm going to say Pygame dot time and then dot wait. And you put milliseconds in here. So 5,000 milliseconds is 5 seconds. So we're going to do that. Okay. That should be good. The only other thing we need to handle is what happens if the player wins the game, but we're going to do that here. So after we move the player and after we move the computer and after we handle the collision, then we're going to say if the game info dot game finished, we want to do a very similar thing to what we just did here. We want to reset all of this stuff. So we'll do that. And we want to blit text, you won the game. Like that. Okay, so that's actually all we need. Now I'm going to get rid of this print statement, and I believe that we have just finished the game. Now, obviously, I'm not that confident because we have not tested it right now, but scrolling through, everything looks good, and I think we've just handled everything that we needed to. And I'm also realizing how much code we have here. So again, a massive props to you guys if you stuck around because this is a lot of code to digest over video. All right, let's run the file and let's see if we can win a level here. Okay, let's press any key to start. And never mind, I remember that the guy, my computer, did I start him at a speed of 2 or did I start him at a higher speed? Let's see what speed he's at. Yeah, it's at 4. Okay, so I need to put my computer car speed to 2. Otherwise, I'm going to have no chance here. Okay, so let's run the code. And let's see. That's better. Okay. So now let's try to get a win here. And we'll see if the levels are working. Okay, look at this driving skill. Nice, nice. All right, almost there. See if we can finish before the computer. I'm hoping so. And there we go. Okay, so level 2. And it says press any key to start level 2. Okay, so let's do level 2. Let's just make sure it goes to level 3. And then I will kind of fast forward as I get to the final level, and we'll make sure that this actually works if the computer wins and if I win. Okay, but let's just get through level 2 first, though, to ensure that we're going to get on to the next level. Okay, almost there. I forget what the time was on the last one. I should have kept track of that. Then I could have seen if we were going faster this time. Oops. Okay, looks like there's an invisible wall there. That's, I guess that's going to happen. And let's try to get up here. And okay, press any key to start. Level 3. We're on level 3. So now what I'm going to do is let the computer win. I'll fast forward through that. Assuming that works, then we'll see and make sure that the game actually ends when we hit level 10. All right, so here we go, home stretch of the computer. You can see I haven't really moved until now. Let's see what happens when the computer wins. And nothing. Okay, so that's actually a good thing to run into because, oh, it says press any key to start level 1. So I guess it lagged for a second. Okay, let's see what the problem was here. I'm guessing the problem has to, okay, this makes sense. So what happened was we delayed for 5,000 seconds, or 5,000 milliseconds, so 5 seconds, but we forgot to update the display to actually show this message. So I have to say pygame.display.update, and now this will work. I'm not going to test it. I know that this will work now, and everything will be good because it did actually reset back to level 1. So with that, I believe everything should be working. I'm not actually going to go through and test the fact that the player wins works properly. I have faith that I've coded this correctly, especially because I have the finished code on my other side, and these two pieces of code are identical. Although if for some reason it doesn't work, please do let me know. I'm sure the error is very easy to fix if there is one, although I doubt there is. All right, so with that said, I'm going to end the video here. I just quickly want to thank everyone who got through all of this. I hope that you learned something from this. I hope my explanations were decent enough for some of this complex code. It is difficult to do a video where, you have about 300 lines of code. That's kind of what we ended up having here, right? Tons of code, lots of code in different files as well, all kinds of classes, all kinds of functions. We used a lot of different Python features. So again, hopefully you learned a lot and you enjoyed this video. Hello everybody and welcome to a brand new tutorial series where we're going to be building the checkers game in Python with Pygame. Now if you don't know Pygame, that's totally fine. It's a module in Python that lets us build 2D games. What I'll be doing in this series is walking you through everything that we need to do to build a full-fledged checkers game. Now I'm actually quite excited about this because this is going to be leading me up to another series I'm going to be doing, which is talking about the mini-max algorithm to actually make an AI that we can play checkers against. So let me give you kind of a demo of what this should look like. I've already built the game out and I will be not necessarily copying from my other screen, but just having it up as a reference to make sure I don't get too lost. But you can see this is kind of the game of checkers. The human player is red and then the other player obviously is white. And you can see that we have an AI, so the AI will automatically move based on the move that you do. So let's see if I leave myself open here. The AI, decided actually not to capture me because I would capture it back. And if we play this for a few minutes, I won't go through all of it. You'll notice that the AI is actually pretty decent and it actually can play pretty well against us. So I'll be talking about how we can build this kind of AI, of course, after we've built the game in a separate series. So stay tuned for that. All right. So that being said, that's pretty much it. All I want to say quickly is this is not a beginner tutorial series. If you're an intermediate, you've worked in Python before, that's awesome. I'm going to try my best to teach you guys some new, more advanced stuff in this series. So yes, we will be going through and just building the game, but I'll be kind of throwing in some more advanced techniques and explaining how those work. So you're definitely going to learn something other than just how to build checkers if you want to follow along with this. All right, so let's go ahead and get started. The first thing we need to do is just install a package. This is called Pygame. So we need Pygame again, which is the module that we're going to use to do all of the graphics. So what you can do is open up a command prompt or open up a terminal. And what you need to do is type pip if you're on Windows or pip3 if you're on Linux or if you're on Mac. So pip or pip3, depending on your operating system, and then the word install, and then Pygame. So of course you need to already have Python installed on your system for this to work, but type pip or pip3 install Pygame. That should go through and install this. You can see for me, it was already installed. It says defaulting to user installation, blah, blah, blah. We already have it installed. Anyways, if this did not work for you for some reason, that probably means that pip is not in your system path. So I will link a video in the description, as well as I'll put a card in the corner here that will tell you how you can actually install and fix pip. So follow along with that. It won't be titled like how to fix pip, but just trust me, in that video, it goes through and it explains how to actually fix pip. Okay, so once we've done that and we've installed Pygame, the first thing we're going to do is make a new Python file. You can see I'm using VS Code for this tutorial series, which is just the editor that we're going to use. And let me just zoom in a bit so you guys can actually read what's going on. But what we're going to do is make a new Python file. I've named mine main.py, and I'm putting that inside of this checkers tutorial folder here. And I'm simply going to type import Pygame like that and just make sure that this works. So if you're working in VS Code, what you can do is install the Python extension. So if you go to this extension tab right here, it's on the left-hand menu bar, type Python, click here and install it. Then you'll be able to debug Python scripts, you'll be able to run Python scripts, and everything should work out well for you. So what I'm going to do here is just press this run button, and this will simply run the current script that I'm on. You can see that it says hello from Pygame, and that means that everything is working and Pygame has been installed properly and we're good to get started. So what we're going to do here is we're actually going to try to build kind of a module around the checkers game and then add kind of like an API. I don't want to use big words to confuse anyone, but an application programming interface on top of the game so that we can use it with an AI later on. So you'll see what I mean by that as we go through. But what I'm going to do right now is just make a new folder inside of my checkers folder, and I'm just going to call this one checkers like this. So inside of here, what we're going to do is actually make a new file. I'm going to call this __init___.py. So 2 underscores init 2 underscores.py. What this will do is initialize this folder here as a package or a module or whatever you want to call it. And that will allow us to actually import stuff directly from this package in kind of a special way, which we'll be doing later on. Now, what we're also going to do is do an __init__.py inside of our upper level directory. So I have main.py, init.py, and then checkers. Again, that's inside of a folder right here. So it's inside of this checkers tutorial folder that I have open. And once we've done that, we can go back to the main.py script, and now we can start actually writing a little bit of code. So the first thing that I'm going to do here is I'm actually going to set up a Pygame display. This is where we're actually going to be drawing everything onto. Then we're going to set up like a basic event loop. And what that's going to do is check if we press the mouse or if we press a certain key or whatever we're doing, it's going to check for that. And then once we've set up the main loop, we can set up some basic drawing. So essentially draw the board for the chessboard, draw all the pieces, all of that, and then start getting into the actual logic of the game. So the first thing I'm going to do is I'm going to say win in all capitals, because this is going to be a constant value, is win.display.set_mode. And inside of here, I'm going to type width and then comma height. Now, these are going to be two variables that we are going to define. And what I'm going to do now is go inside of this checkers folder that we've created. I'm going to make another Python file, and I'm going to call this, it's lowercase, constants.py. So what I'm going to do is I'm going to put all the constant values inside of this file here, so that if we ever want to change anything, we only need to go to one file and we can really quickly see all of the variables and we can change everything that we need to. So inside of constants.py, I'm going to import Pygame. We'll use that later on. And now what I'm going to do is say width, comma height equals 800, comma 800. If you haven't seen this type of way of defining variables, it just means width is equal to 800 and height is equal to 800. Now you can define this to be whatever you want, but just keep in mind if you change this value, you're going to have to change a few other ones accordingly. So just maybe leave it the same, but this is 800 pixels high by 800 pixels wide. Next thing I'm going to do is define the amount of rows and columns we're going to have in our chessboard. Or checkers board, sorry. So we're going to have 8 by 8. That is a standard checkers board. So I'm going to say 8 by 8 like that. And then what I'm going to do is I'm going to say square underscore size. So essentially how big is one square of our checkerboard? And I'm going to make that equal to the width integer divided by the rows. Now we could as well do the height divided by the columns. Or sorry, what am I doing? Width, sorry, this should be width divided by cols, not, it's not gonna make a difference, but it makes more sense to do the width divided by the amount of columns rather than the width divided by the amount of rows. So now we have a few constants here: width, height, row cols, square size. While we're in this, I'm just gonna define a few variables for some different colors we're gonna use. So in Pygame, when we use colors, they are red, green, and blue. So RGB color codes. So for red, obviously, we're going to do 255, 0, 0. This means we're going to fill the entire amount of red. We're going to have 0 green and 0 blue. And just so we know, red, green, blue goes up to 255 inclusively. So you can use any value for these between 0 and 255. Next, we're going to do white. White is simply 255, 255, 255. And then we're going to do black, which is equal to 0, 0, 0. And finally, we're going to do blue, which we're going to use to figure out what squares the person can move to. That was those little blue dots you were seeing before, if you remember when I ran the game. It's going to be 0, 0, 255. So pretty straightforward. I'll add a comment here to just say RGB, just so we understand that's what it's in. And now we've kind of filled in the constants. We'll do a few other things here later, but we can skip that for right now. So what I want to do is I actually want to import the constants that I defined here into this main.py file. So to do that is actually pretty simple. What I can do is I can say from checkers dot constants import, and then I can import the variables that I want, which are width and height. Now, the reason I can do this and I can reference checkers directly is because inside of checkers, we added this init.py file. This init.py file tells us that, hey, this folder is actually a Python package. And because of that, we can import specific things from it. So just to show you, if I went inside this init.py file and I said, from constants import star, so that means import everything from constants, what I would actually have to do now if I wanted to import width and height is simply say from checkers import width height. The reason for that is because inside of the init.py, I import everything from the constants file. So what happens is as soon as I import this folder, checkers, it automatically runs this, which means it will automatically import all the stuff inside of constants. Now, I'm not going to do that. I'm going to get rid of this just because I don't want to confuse anyone if that doesn't make sense. But that's kind of just the explanation there, and I figured I'd show that to you guys. So let's go back to from checkers.constants, import width height. Okay, so now that we have the window, we're going to set a caption for it. So I'm going to say pygame.display.set_caption. And inside of here, I'm just going to call this checkers. This is simply the name of our game, and it will pop up kind of in the top little bar. After that, what we're going to do is we're going to define a main function. This main function is going to be what we run to actually run the game. And in here, we're going to create what's known as an event loop that's going to run every, X times per second that will check if we've pressed on something. It will update the display. We'll do all that. So I'm going to say run equals false like that. Or sorry, what am I saying? Run equals true. My bad. I'm going to say while run. And then inside of here, I'm going to put the event loop. So the idea being that we're going to call the main function from outside. It's going to start running all of this. And then there's going to be a while loop inside of here, which will do all of the event handling and drawing everything. So while run, which is just the variable we defined up here, is true, we will do this loop. The next thing I'm going to do is I'm going to define a clock. So in Pygame, if we want our game to run at a constant frame rate, so like 60 FPS, for example, we can define a clock, and the clock will make sure that our main event loop doesn't run too fast or too slow. This is good because in a game, if you have like a really fast computer, it would run faster if you didn't have this, and a slow computer would run slower, obviously. So you want everything to be the same so it can at max run at what we're going to put it at. So we're going to say clock equals pygame.time.clock. And then inside of the while loop, we're going to say clock.tick, and I'm going to put all capitals FPS like that. And actually up here right above win, I'm going to say FPS equals 60. Now, some of you may ask, why don't you put this in the constants folder? The constants folder is going to be specific to the checkers game, whereas this is specific to us actually rendering and drawing the game, which will make more sense later, but that's kind of the idea of why I'm putting it in here rather than in the constants file from checkers. Okay, so now we have while run clock.tick FPS. Okay, great. And what we're going to do is set up our basic event loop for Pygame. So for event in Pygame, if I could type this out, event.get. What this will do is essentially check to see if any events have happened at the current time. If they have, they'll be in this list of the events.get. And then what we can do is look at the event and see if it is a specific type. If it is, say, us hitting the quit button, we'll quit. If it's like pressing a certain key, we can do something else. So we say if event.type equals pygame dot and in all capitals quit. This just means we hit that red button at the top of the screen, which we'll see in a second. Then what we're going to do is say run equals false. So that will end this loop right here. And then at the very end of our loop, we're going to say pygame dot quit. So essentially, if we make it to this line of code, so this while loop ends, we will quit the game, which just means get rid of the window that we're going to be popping up. Okay, so now that we have that, I'm going to say if event.type equals pygame.mouse button down. So this just means we pressed any mouse on our mouse down. If we did that, or any mouse, what am I saying? Any button on our mouse down, excuse me. If we do that, then we will check to see, hey, did we press on a red piece? Are we moving? Whose turn is it? All of that kind of stuff we'll do inside of here. But for now, I'm just going to simply type pass. All right, so now that we have that, we have a window set up. We have the event loop. And let's actually go ahead and run this and see what we're getting. So when I run this, you can see we get just a black box and it says checkers at the top. All right, so I'm going to quit that, and that means that we're doing things properly so far. And now what we're going to work on is actually making it so we can draw that checkerboard on the display, and we set up a few classes that are going to represent, all of the stuff that we need to draw on the screen, essentially. So I'm going to go inside to this checkers folder here, and I'm going to create a new file, and I'm going to call this board.py. Now this, if you haven't guessed, is where we're going to put a class named board, and this board class is going to represent a checkers board. So what it will do for us is it will handle, say, all of the different pieces moving. Whose turn is it? Or actually, it won't handle that, but it will handle moving specific pieces, deleting specific pieces, drawing itself onto the screen. That's what this class is going to do. So we're going to say import Pygame like this, and we're going to say class board like that, and define an init method that we will define in just a second. Okay, so let me just go over to my file here. So inside of the init, we'll actually just leave it with self, and we're just going to define a few attributes of this board class. So the first thing that we're going to have is an internal representation of the board. So what I'm going to do is I'm going to make a bunch of objects, which are just like, you can think of them as just pieces, right? Like red pieces or white pieces. And we're going to store them in a two-dimensional list inside of this class. So it would look, if I can get this working properly, something like this, right? We might have like white, 0, meaning there's no piece there. White, 0, meaning there's no piece there, right? White, and then maybe there's a red one here and there's nothing, and there's a red one here and there's nothing, and there's a white one here. That's kind of what this is going to look like. We're not going to use white and red, but just to give you an idea, we're going to have a two-dimensional list because we have 8 rows and 8 columns. So we'll have 8 interior lists, and inside of each of those lists, we will have 8 different elements, and those elements will be pieces, which will tell us if they're red, if they're white, if they're a king piece, all the other stuff that we need for, for checkers. All right, so now we have the board. The next thing that we'll do is we'll say self.turn equals 0. What I'm going to say here is 0 will mean that, actually, I don't think I even need to define a turn in here. Sorry, I'm gonna not define that. We'll do that in another class, but we just need to keep track of, is it red's turn? Is it white's turn? So we know who can move, right? Next, I'm gonna say self.selected underscore piece equals none. So this is telling us, hey, have we selected a piece yet? Have we not selected a piece? Let's define that. And then I'm gonna say self.red underscore left equals self.white underscore left equals 12. So the point of this is saying, okay, we want to keep track of how many red and how many white pieces we have. In checkers, we have 12 of each. So we'll set a constant value up here, or not a constant, but we'll just set this equal to 12. And then as soon as we remove a white or red piece, we can subtract from that. Next, we're going to say self.red underscore kings equals self.white underscore kings equals 0. If you're unfamiliar with the syntax, this just means these are both equal to 0. Like if red kings is equal to white kings and white kings is equal to 0, then red kings is equal to 0, right? So that's what this means, and that's all we need for the init. The next thing we're going to do is we're going to define a draw underscore cubes. Now, we could call this something more meaningful maybe, but we're going to say self win. And what this is going to do is say, okay, give me some surface, which is going to be our window, that's what win stands for, to draw the red and black cubes on in a checkerboard pattern. So let me just run the other one and we'll have a look at it here to see what we actually need to do. Okay, so we need to draw red first, then black, then red, then black, then red, then black, and so on in a checkerboard pattern. So we're going to need to write some code that can do that. I will show you how we do that right now. Okay, so what we're going to do to start is we're going to fill the entire window, so win.fill, with black. Now I need to import black, remember from my constants file. So what I'm going to say is from.constants import black. Now I'm using dot because when we are in the same package as something else, we need to specify, hey, this is what's known as a relative import. We're going to import from dot constants, which just means from something in the same directory as us, named constants. So we're going to fill the window with black, and we're going to say for row in range. And in this case, we're going to just put up here rows, so we know how many rows we have. So for row in range rows, and then we're going to say for call in range row mod 2 8 2. and not 8, sorry, this will be rows. Now, what am I doing here? Why have I done mod 2? Well, we want to draw a checkerboard pattern, right? So when we start the column here, we either need to start in column 0 or column 1. So let me just bring this checkerboard pattern back up again so I can explain this. Essentially what I'm saying is, okay, if the row is 0, then what we'll do is we'll say row mod 2, which obviously 0 mod 2 is just 0. So we will start by drawing a red square in column 0. Then we will step by 2, we'll draw a red square in column 2, and then in column 4, and then in column 6. Now, when row goes to 1, we're going to start drawing the red cube in column 1, because row mod 1, or sorry, 1 mod 2 is 1, so we're going to start in column 1. And then we will skip over columns again, and we will go 1, 3, 5, 7. Next, what are we going to start at? Because it's going to be 2, we're going to go again, and we're going to say 0, 2, 4, 6, right? That's kind of the idea behind doing this, and this is probably the simplest way we can actually write this code. So what we'll do is we need to figure out where we're drawing this. So we're going to say Pygame .draw .rectangle. We're going to draw it on the window. We're going to draw it with color red, which we'll import from up here. And while we're up here, we'll actually import the square size as well, because we're going to need to use that. So what this is saying is, okay, draw a rectangle, draw it on the window, draw it with some color, in this case, which is red. And then we need to give what's known as a rect argument. So a X, Y, width, and height. Let me bring back up the Pygame window so I can explain this a bit. Whenever we start drawing something in Pygame, we draw it from its top left coordinate. So top left in Pygame right here is 0, 0. So if you can see where my mouse is kind of right beside this icon, this is 0, 0. As I go far to the right, I increase in the X. As I go down, I increase in the Y. So technically at the bottom here, we'd be at 800, whereas at the top we're at 0. So when I start drawing, I need to pick where is the top left of the shape I'm about to draw. So if I said 0, 0, it would be here, and then I would draw 100 wide and 100 tall to draw a square that is that dimension at that place. So that's how that works. So for our X and for our Y, what we're going to say, we're going to say row multiplied by square size, and then col multiplied by square size. And then for the width and height, we're simply going to say square size, square size. Now I know this is cutting off a bit. Let me zoom out so you can see the whole thing. Okay, so for row and range rows, for col and range rows, pygame.draw.rect on the window, red, and then of course this is going to calculate where the top left and right should be, and then the width and height. Okay, let's zoom back in. All right, so there we go. That should be it. I'm just going to check and make sure that's all we need to do. And I think that should be fine for drawing the cubes. So now let's test this out and make sure that this is working. So what I'm going to do is I'm going to say from checkers dot, in this case, board, import board. So what we'll need to do is create a new board object. So we'll have to say board equals board like that inside of here. And then at the end of every loop, and what is this telling me? This error is here. Pygame has no mouse button down. Yes, it does. What I'm going to do at the end of each loop is I'm going to say, okay, board dot draw cubes. And then we'll just pass it the window that we want to draw it on. And then hopefully this will draw it. And we'll say Pygame dot display dot update. So whenever we want to update the display in Pygame, we have to call this method. The way the drawing works is we'll draw on top of each other. So say I draw like a cube, and then I draw a square after that. So I have like one line that draws a cube, and then another one that does well, cube and square, I guess could be the same thing. What am I saying? Draw cubes. Maybe we should call this draw squares. Yeah, let's call this draw squares. I realize my geometry is a bit off. So if we draw 2 squares, the one that we draw second is the one that we will see. That's what I'm trying to say, essentially, if they were on top of each other. But anyways, we update the display after we draw the cubes. So let's press the run button. And what is it saying? Has no attribute draw squares. Did I change this? Squares, board object, save, draw squares. Am I spelling something wrong? It's no attribute draw squares. Okay, let me look at this. Maybe I'm spelling something wrong. I must be. Let's see. Define, draw squares. Save. really telling me it has no attribute. Let's see again. And there we go. Okay. So I don't know what was going on there, but now it seems to be working. And we have red, black, so on and so forth, and a perfect checkerboard pattern. Okay. So there we go. That is a good start. Next, what we need to do is draw all of the pieces. So let's go ahead and do that. So we have board.py, and now what I'm going to do inside of here is I'm going to say define create underscore board. Now this is going to say self, and we'll take a pass. And what we'll do inside of here is, well, we will create the actual internal representation of the board, and we will add a bunch of pieces to the list. Now, of course, if we're going to add pieces, we need pieces. So let's make a new class in another file here called piece.py, and let's spell it properly like that. So piece.py, I'm going to say class piece like that, and then we're going to say define underscore underscore init underscore underscore. We're going to say self row call and color. So when we make a new piece, we need to pass it what row it's in, what column it's in, and what color it is. So we'll say self.row equals row, self.call equals call, self.color equals color, and that should be it. We'll add a few more. Self.king equals false. So this is going to tell us, are we a king piece? If we're a king piece, that means we can jump backwards, right? If you're familiar with checkers. So we'll get to that part later, but we'll just add that in now. And let me just check my file and see what else we needed. We'll have self.selected. That can be equal to false. Actually, I don't think we need this either. I have some code that I have written, but we don't really need, so I'm just filtering it out as we go. And what else? We need self.direction. That is important. So self.direction equals, we'll have to define this here. Okay, so the dilemma I'm having right now is I need to pick the direction for each piece, right? Are we going positive? Are we going negative? What way are we going essentially? So what I can do is I can say, okay, well, if we are, and let me just run this to look at the checkerboard pattern. If we are the white pieces, so we're at the top, because I believe white is at the top, we're gonna move down, which means the direction we're gonna go is positive if we're thinking about the coordinate system of Pygame, where if we're red, we're gonna move up, so the direction we're going is negative. So let's do that inside of piece. Will say if self.color equals, and now we have to import red and white from the constant. So from .constant import red, white. So if self.color equals red, then the direction is actually going to be -1, meaning we're going up. Otherwise, self.direction equals 1. Okay, so that handles that. And then next we're gonna say self.x equals 0 and self.y equals 0. And then what I'm gonna actually do is I'm gonna make another method that says calculate pause. Now what this is gonna do is calculate our x and y position based on the row and column that we're in. So in this case, we're gonna need to know the square size so that we can simply multiply whatever row and column we're in to figure out what our starting x and y position should be when we draw this piece. So that's what I'm gonna call calculate position. I'm gonna say self.x equals square size multiplied by self dot, in this case is gonna be call, because we're doing x, which is the horizontal axis, plus square size over 2. Now, the reason I'm doing this is because I want to be right in the middle of the square when I talk about my x and y position. So we're going to have circular pieces, right? And circular pieces, we draw them from their center. So we have a radius around a circle, and that's how we draw a circle. So our x and y position should be in the middle of the square. So we'll just divide the size of the square by 2. That will give us 50, right? So in this case, we could literally just put this as 50 if we wanted to, and then we would be in the middle of the square. All right, so self.y equals the same thing, square size multiplied by self.row, that's the only difference, plus square size over 2. Okay, so what we'll do is simply call self.calculate position after this. The reason I'm not just writing this code inside of here is because we're gonna need to do this a few different times if we change our row and column, so it just makes more sense to have a method that can do it for us. Next, I'm gonna make another method. I'm gonna say define make underscore king. What this is gonna do is simply change the king variable, so self.king equals true, and that just means we'll literally just make this piece a king if we can. Next, we're gonna draw, so we're gonna say define draw what this will do is pretty straightforward. We will draw the actual piece itself. This is actually pretty easy to do, but let's go ahead and do it. So self win, we're going to start by drawing a circle, and then we'll draw an outline for that circle so that we can actually see it well enough. So we're going to say Pygame dot draw dot circle win self.color, which is what we have to put here, I believe, self.color. And then we need to pick our XY position for the center of the circle. Actually, I think this is the right way. Yeah, I think it is. So we're going to say self.x, self.y. And then finally, we're going to pick a radius. So for the radius, we need to determine what we want that to be. And that is going to be based on how much padding, essentially, do we want. Let me just bring this up. Between the edge of the square and the circle. So if you look here, we have like maybe 10 pixels of padding on each side. So we need to define that, and then we can derive what the radius should be based on that. So I'm going to define as a class variable here, padding equals, let's make it say 10 or something like that. I'm going to see if that's what I use for the other one. Yeah, we'll make it padding is equal to 10, and we'll define a border, which is essentially what do we want the outline to be. So we can actually call this outline. So outline equals 2. All right, so now when we draw, what we're gonna do is figure out, okay, the radius of our circle should be equal to, first of all, the square size over 2, right? Because the radius is not the diameter, so we have to divide the square size, minus the self.padding over 2. So sorry, I've made a bunch of mistakes here. This should just say self.padding, not divided by 2, not multiplied by 2, whatever I said. This is the correct math is minus self.padding. Okay, so if that, assuming is that that's the padding we want on each side. So then I'll just put radius here, and yeah, I guess that's lowercase variable, and then that should draw the circle for us. Now the next thing we'll do after that is we will draw an outline. So we'll simply say Pygame dot draw dot circle, and we can literally copy the exact same thing. We're just going to change the color and the radius. So for the radius, we're going to say radius plus self dot outline. The reason for this is whatever the actual radius of our button is, we'll just go 2 pixels outside of that. And actually we'll have to reverse how we draw this, but we'll go 2 pixels outside of that. So we draw a slightly larger circle. And then on top of that circle, we're going to draw the interior one. So it will look like it's a border, but really what we've done is we've drawn a big circle and then a smaller circle inside of that circle that's covering what that interior circle's color actually is, if that makes any sense. So I'm going to start by drawing the larger circle, which will be radius plus outline. And then on top of that, I draw the smaller circle. So you only see, you know, the 2 pixel difference in the radius between these as the outline. Now for the color, we need to pick a color that is not the piece color and is not one of the square colors so we can actually see it. So I believe that we can pick something. I'm trying to think of like a decent, maybe we'll go with a gray or something. So let's just define gray inside of our constants, and we'll use that. So inside of constants, we'll say gray equals, and we'll go 128, 128, 128. That's just a common color code for gray. And then instead of color here, we will simply do gray, and then we'll import that from constants. Okay, great. So now we have radius, we have the actual circle being drawn for the piece, and I think for right now, that's all we need to do. I'm gonna add one more method just to make it easier for us if we need to debug this later, and it's just gonna be repr. What this means is, what is the internal representation of this object? You may have seen before, if you print out like an actual object that you've created, you get some weird like object at X blah, blah, blah location. To avoid that, we can simply make our own representation of the object. And that's, again, just if we print this out or if we look at it, it will show us this. So I'm simply just going to say that we will use the color. So return the string of self.color. So repr has to be a string. So we'll just take whatever our color is and just turn it into a string. So we'll see like 0, 0, 255, 0, 255, 0. Whatever the color of our object is. So now we have piece, and if we want to see them, well, we need to start creating some pieces. So inside of my board class, under create board, I'm going to create a bunch of pieces. We're going to start obviously by making the white pieces will be at the top, and then the red pieces at the bottom. So this is not too complicated, but it is a little bit of a for loop kind of indentation thing that you'll see here, because we need to obviously have them be spread out. We're only going to have, I believe, 4 in each row, and then they need to be staggering, and then the white needs to go up there. There needs to be a space, and then it needs to be the black, or the red, sorry, the white, and then the red, my bad. All right, so 4 row in range rows, 4 call in range calls. We can import calls up here. Technically, again, I mean, I can change this here to be calls. Doesn't matter because they are the same value, but say we had a checkerboard that wasn't exactly square, then these would matter. So 4 row in range rows, 4 call in range calls. What we're gonna do is we're gonna start by saying self dot board dot append an empty list. The reason for this is because we want to have interior lists for each row, right? So we want to have a list that represents what each row is going to have inside of it. And we'll just do that by appending one for each row that we have. Next, what we're going to say is if call mod2 equals a little bit of fancy math here, row plus 1 mod2. What this is saying essentially is if the current column that we are on modulus 2, so if it's divisible by 2, if that equals whatever the row plus 1, so say we're on row 0, technically we're on row 1 mod 2, then what we can actually do is we can draw the red or white cube. Now, if we look at the checkerboard, I'll kind of explain to you how this works by going through a few examples. So when row is, I'm trying to be able to view the code at the same time. So bring it back my Pygame. We've got 2 of them open. Let's close one. Okay, there we go. So let's say row is 0. We're on the first row. Then the row plus 1 mod 2 is going to be equal to 1, right? So that here that I can't highlight unless it will put away this is equal to 1. And then call, so if we're on column 0 in this case, call mod 2 will not be equal to that. So that'll be this first square here, this red one, so we won't draw the checker. I think that's what you call it, like a checker piece, I guess. And then the next cube over, right? So the row stays the same, but the column now is column 1 mod 2. So that's equal to it, so we draw white. All right, move next. Now it's column 2, so we're not drawing that. Next, we go column 3, we will be drawing that, so on and so forth. Now you increment the row. When you increment the row, what happens is row plus 1, so 1 plus 1 is 2, mod 2 is equal to 0, which means we'll only draw on the even columns, right? And then the next one will draw on the odd columns. So that's kind of how this is going to work. And that's like the basis behind this math that I'm explaining. Okay. So in this case, we can draw. So if this happens, we can draw something, but we only want to draw when we're in a certain row. So we have to say if row is less than 3, because 0, 1, 2 are the first 3 rows that we want to draw the white pieces in, then what we will do is we'll say, and we're not actually drawing here, we're just creating the pieces, but same premise. We'll say self.board row.append, and we'll create a piece. And what will we do here? We'll say row, column, and then the color we're gonna put here is gonna be white. So I think I imported white, I did not. So first of all, let's import calls properly, and now let's import white. Okay, so black, row, red, square size, calls white, great, and then we can append white in there. Elif row is, I guess we'll say less than, should be 5, 6, 7 is where, so if we say if row is less than 4, then we'll simply continue. Actually, let's just do this. If row is greater than 4, so if row is 5, 6, or 7, then we can say self.board row.append piece row call red. So hopefully this makes sense, and we need to import piece, which we'll do in a second. But the idea being that we're just creating this board. We're going to do it with the checkerboard pattern, and then obviously we're not going to do anything in the rows that are 3 or 4. What am I saying? 3 or 4. Yeah, in rows 3 or 4, we are not going to add any pieces. Now, when we don't add a piece though, what I want to do is I actually want to add a 0 instead. So I'm going to say else, and in this case, we're going to say self.board row.append 0. The reason for this is that's just going to be like our blank piece. Like we'll have 0 white, 0 white, 0 white, so we can keep track of by looking at the board what row and column each piece is in by having these kind of blank separators. Next, we're going to say else self dot board row dot append 0. So essentially, if we don't add a piece, we are going to add a 0 so that we can separate the pieces and be able to look at this list and figure out where the pieces are. Now we need to import piece. So we'll say from dot piece, import piece like that. Okay, so that should be good. That should create the board for us. Now what I want to do, just to make sure this is working, is actually draw the board. So I'm going to make a new method here called draw. And what this is going to do is say self win, and this will draw all of the pieces and the squares. So this is going to say self.draw squares. So we'll draw the squares on the window, and then we'll loop through all the pieces and draw those. So let's say for row in, range, if we can do this here, for row in range, all capital rows, and then we'll say for call in range, all capital calls. What we'll do is loop through the board. So we'll say piece equals self dot board row column like that. And we'll say if piece does not equal 0, because if the piece is 0, obviously we're not going to draw anything, right? So if the piece does not equal 0, then piece dot draw on the window. So I think that should be good. Let's test this. So I'm going to go to main now, and rather than board dot draw squares, I'm just going to call board dot draw. And let's just make a quick test here and see if we crash. Invalid syntax. Where is the invalid syntax? Okay, so I don't know what error I was having, but I managed to fix it. I think it was because I was actually in the Python console accidentally. But anyways, when I'm running this, I'm getting an error now that says list index out of range. Now, the reason for that is that we have this create board method, but we haven't called it. So I haven't actually created a board. So we have this draw that's trying to loop through all these rows and columns, yet they don't exist in the board. So let's actually fix that by saying self.createBoard inside of our init, so that right when this object gets created, we automatically create the board. Let's try this now. And Pygame is not defined. Okay, so I guess I didn't import Pygame inside of some place here. That would be inside of piece. So let's say import Pygame like that inside of our piece module, file, whatever you want to call it. Okay, now we can run it, and there we go. We can see our red and white pieces, and they look to be working fine. Now, I'm not a fan of how big these are, so I'm going to make them a little bit smaller. We can do that really easily by just changing our padding, right? So if I change the padding to 15 and run this file, now we can see they move down a little bit, and you guys can experiment with those, make those bigger, smaller, whatever you like. Okay, so I think that is good for right now. Next, what we're going to do is we are going to actually work, I guess, on a bit of the logic of the game. So we have now the ability to draw these things. We can see everything. Now we need to actually move them, figure out the valid moves for each piece, as well as we need to figure out what happens if one of these pieces is a king. So first thing I'm going to do actually is start working on how we can draw the crown for a king piece. We'll test that out, and then we'll get into the logic. So to make a king, first what we're going to need to do is we're actually going to need to download an asset for a little crown that we will draw on our piece if it is a king piece. So let me see if I can bring this up for you. I have an image of it. I'm going to pop it over here. You can see this is what the crown looks like. It's a transparent background. So go to the link in the description. It will say like download asset here or something. You're going to download a compressed zip folder. What you need to do is right click on that compressed zip folder, press uncompress or unzip here. So just make it so that you don't have that like zipped up folder anymore. It's an unzipped folder. And then take that unzipped folder, it should be called assets, and just put it inside of this directory right here. So inside of this checkers directory. So it's going to go inside of the checkers directory, not like inside of the root directory. Although you could put it inside the root directory, but we're just going to put it inside of this checkers directory. So let me actually do that. I need to grab that folder. So I'm just going to look for it on my system. So I have assets right here. I'm going to copy that and I'll put that into my checkers folder like that. So now we have the assets, and is this inside of the right one? Yes, it is. Now we should be able to load it. So what I'm going to do is inside of constants.py, I'm actually going to load that image. So I'm simply going to say crown equals pygame.image.load, and I'm going to load assets slash crown dot, and in this case, I think it is PNG. Okay, so we'll go crown.png. Now what I need to do actually is I need to resize this. So it's actually too big by default. We need to make it small enough that it will fit on the actual checkers pieces. So to do that, we're just going to use a method from Pygame. I just have to find it because I forget exactly what it is. We're going to say pygame.transform, I think. Is it pygame.transform or pygame.image? No, I think it's pygame.transform.scale. And what we do is we put the image first, and then we put the resolution that we want to scale it to. So I've just kind of hard coded these numbers in. You could do this mathematically, I guess, but I'm going to go with 45 and 25. This relatively keeps the aspect ratio of this image, and it makes it small enough that we can actually put it on the direct center of all of our pieces, and we can tell them, hey, you know, this is a king piece. So I'm going to make this, sorry, capital again. Don't know why I made that lowercase. And now let's go to piece, and from constants, import red, white, square size, gray, and crown. Inside of the draw, we're going to add a really basic if the piece is king. So if self.king, then what we will do is we'll say win.blit the crown. Blit simply means put some image onto the screen or put some surface onto the screen. That's what it's saying. These are just special Pygame methods to draw directly onto the display, whereas this one, we're, you know, just blitting the image. And then we need to pick our XY position that we want to put this on. Now I want this to be perfectly centered, so I'm going to use a little bit of math here to do this. What we're going to say is self.x minus crown.get_width. Get_width is going to get the width of the image. Now we already know what the width of the image is, but what I'm trying to say here is that, let me actually just go to a kind of drawing whiteboard so I can show you what I mean. If we have a square, okay, got it. Come on, let me draw. Why can't I draw? Okay, so apparently Windows or Microsoft Ink just doesn't work, so I can't draw the thing for you right now. I don't know the solution to that. What I'm trying to say is imagine that the X and Y position, or you don't have to imagine, the X and Y position we have is in the middle of the square. So let me just load the other game, and at least I can maybe show this to you. So the XY position is right in the middle, so where my mouse is. Now we want to draw the crown right in the middle, so it's perfectly centered. But if I just draw at the XY, it's going to move the crown, and it'll be kind of to the right, because the XY is the top left of an image when we're drawing it, other than a circle, right, where we have the radius. So I can't just draw it at the XY. I need to draw it someplace to the left and up a bit, such that it will be perfectly equal distance from this left side and the right side of the circle. So all I have to do is get the width of the image and subtract half of that to figure out where the starting X position should be. Because that will say, okay, from this point, if this is the center, we just move half of the image's width to the left, and that will mean that it's being drawn perfectly center in the cube or on the circle. Same thing with the Y position, we can do that as well to make sure it happens perfectly in the center. So that's what we'll do. We'll say self.x minus crown.get_width integer division 2, just so we don't have any rounding errors. And then we'll say self.y minus crown.get_height over 2. Great. So that should draw the crown for us in the middle. So what I'll do is just set all of these crowns to be true, just so that we can make sure that this is working and test it out. Pygame.transform has no attribute scale. Well, it would help if I spelt scale correctly. So scale, there we go. All right, let's check this now. Cannot load assets / crown.png. Okay, so let's try to fix this. I believe the issue we're having is something to do with kind of the path system in Python. So what I'm going to do is just take this folder and put it outside. So put it in the main root directory rather than inside of the checkers directly. directory, and now it should probably load. So let's try this now, and there we go, that is working. Just to reemphasize what was happening there, this, I had assets/crown.png. I had that folder inside of this checkers folder. I specifically told you to put it there, but I was wrong. So what we need to do is take it out and just put it alongside the checkers directory, so it's in that root directory, because when we run this main.py file that's not inside of the checkers folder, the path that Python will look at to load images will be in this directory where we loaded main.py. So I would have to say checkers/assets/ if I wanted to load the image the way that we were doing it before without moving this folder. Anyways, not a huge deal, but hopefully that's loading for us. And I think that this is working fine. We can see the crown on all of the pieces, again, perfectly in the center. All right, so let's go back and remove that now. So piece, we no longer want to draw the crown. So we will say false. And now I got to figure out what we are going to do next. So I'm thinking probably what we should do next is actually set up a way to move pieces around and delete pieces. So from board, what I'm going to do is I'm going to make a move method. So I'm going to say define move. I'm going to say self, and I'm going to say piece. So you tell me the piece you want to move and what row and column you want to move it to. Now, what we'll have to do to move the piece is we'll have to delete the piece from where it is, and we'll have to change its position. So that reminds me that we actually need to go to piece, and we need to add a move method as well. So define move like this, self row call. So what will happen when we move a piece? Well, we're going to have to say self.row equals the new row, right? Because this needs to stay updated. Self.call equals the new call, and then self.calc position. So remember, calc position, which is right here, simply tells us what the XY position of our piece should be. So we have to recalculate that when we change our row and column. So we have move now on piece. So board, what we'll need to do is we'll actually need to, first of all, move the piece within the list, right? Because we have this list that represents all our pieces. And then we'll have to also actually change the piece itself. So piece.move to wherever it's going to go to update on the pieces side. All right, so what we'll do is we will say self.board, and we're going to say piece.row, piece.call, comma, self.board, row, call, equals, and then we're going to say self.board, and we're literally going to copy these just in reverse. So I'll talk about how this works, but this is an easy way to swap things in Python, or swap positions in a list. So what I'm saying with this line here, and I'll zoom out so you guys can read it, is essentially that the piece that's in the position, piece.row, piece.call, so the one we want to move, and I need to spell piece correctly, and then the piece that's in the position that we want to move to, we're going to swap their values by simply reversing it like this. So this piece here will move to this one here, so row call, and then the other one will move to this one. So they'll essentially swap. That's just how this works. And this means we don't need to make like a temp variable, delete something, re-add it in, all that we would usually have to do. All right, so now that we have that, what we'll actually do is we'll say self dot, actually we don't need self, we'll just say piece dot move row column. There we go. So if, or not if, but when we move this actual piece, we'll just move it row column. Now I just want to look and make sure I've done this correctly. I think we have, but there might be some other things that we want to consider here. All right, so now we've moved the piece. This should actually work. We'll test this out after, but what we need to do is make sure that we haven't moved. Well, we don't need to check that. We need to make sure if we've moved into a position where we'll become a king, we become a king, right? So if we move and we hit the last row or the first row, then whatever our piece is should become a king. So what we can simply do is just check if the row column that we moved to is actually a position that should make us a king. And if it is, then we will make that piece a king. And we will also update the variables we have here for the amount of kings that we have. So what I'm going to say is if piece.row, or I guess we could actually just say row, if row equals rows or row equals 0, what we can do is we can say self, or not self, piece dot make, not make move, make king. So this will make that piece a king, and then we'll need to update the red or black. Is it red or white kings? So the reason this works is because if we move into a position that is 0 or 7 for the row, that means that we are at the end or the beginning of the board. Now, some of you might be asking, well, won't this break because we already have pieces in those positions that are the same color, right? So like the white piece is already in row 0 and the red pieces are already in row 7 or row 8, whatever you want to call it. So won't those just become kings? Well, no, they won't, because they have to move into that position. So we're not going to let them move backwards unless they're a king, which means that they won't become a king unless they actually move to the other side of the board from where they start at. Now, there will be a situation where a king will move into not its own side and become a king again, but that's fine. If it's already a king, there's no difference in making it a king again, right? It's not double kinging or anything like that. All right, so if row equals rows or row equals 0, piece.make king, we need to update the red and white king. So if piece.color equals white, then self.white kings plus equals 1, else, so if it's not white, it must be red, self.red kings plus equals 1. Okay, so that should be it for move. What we can do now is check to make sure this is working. So what we will do is just simply put inside of this, actually, we'll just do it right here. Say board.move. And now we run to our first problem. We need a piece, right? We actually need to pass a piece object like this to this move function or move method so that it can move it. So how am I actually going to get a piece? Well, we'll write a method here that says define get underscore piece, and we'll say self row call. So essentially, you give this board object a row and a column, and it will give you a piece back. So this will simply return self.board row call. All right, so now let's just say piece equals board.get piece. And let's pass a row and column we know there's going to be a piece in. So in this case, I believe there's one in 0, 1, because I don't think it starts in the top left corner. So we'll get a piece at 0, 1, and then we'll say board.move that piece right here. And let's move this to, I don't know, where do we want to move this? Somewhere where there's not already a piece. Let's go row 4, column 3. All right, so that should move it into the center of the board, or relatively into the center of board. And what is it saying? Oh, missing one required positional argument column. So oops, I shouldn't have put these in a tuple. I should just have them separated out like this. So 4, 3. Let's run this now. And what is the other one? Piece is not defined. Well, it would help if I spelt piece correctly. Where is it telling me this is undefined? It is undefined here. Looks like, yeah, piece is spelled wrong. Okay, so let's go back to board. Let's go to move and let's fix that. There we go. Okay, run, work. And there we go. We can see that now that piece here is moved over here. So this move method does work. Now we want to figure out a way that we can do it using our mouse, right? So this will be a bit more complicated, but very doable. And the next part of this series here, or this video. So what I'm going to do is I'm going to make a method that says define get row underscore call from mouse. So this will simply take the position of our mouse, and it will tell us based on the position of our mouse what row and column we're in. So we're going to say xy equals position, because this is going to be a tuple that will have the x position of our mouse and the y position of our mouse. And then based on the square size, we can calculate really easily what row and column we're in. So we can simply say, well, we'll make it a bit easier. We'll say row equals y integer divided by square size. So this is really easy, right? And we need to import square size. But if the square size is 100 and we're trying to figure out what row we're in, if our y is at 650, then we know we must be in row 6, right? And if our y is 700, we must be in row 7, right? It's pretty straightforward. So that is how this works. That's how we get the row and the column, just a little bit of division. So we say call xx, or divided by square size. Now we'll need to import square size like that, and we can return the row column. Great. So get row column from mouse position. Now what we'll do is when we press the mouse down, we will get what row and column we're in. We will select that piece, and then we will move that piece to wherever we want to move. So we'll be able to select the piece, and then we can select where we want to move it to. So if pygame.mouse button down, then we will say row call equals, and first we'll say position equals pygame.mouse get underscore pause. This will get the mouse position. Say row call equals get row call from mouse position. Then we can get the piece associated with this. So we can say piece equals, and we can say board dot get piece row column, and we can move it. Now, what I'll do right now is just because I don't want to code everything, is I will simply just move whatever piece we select to the same position. So we'll just move it to 4, 3, just so you can see that this does work when we press on the piece. But we will obviously make it so that you're moving it where you want to move it afterwards. Okay, so let's just test this out and make sure this works. So if I select this piece, you can see that all these pieces, obviously they're going to be hidden by that white piece because that's there, but they get moved to that position. So when I press them, they move there. Again, obviously all of them are moving to the same one, so you can't really see, but that is okay. So now that we have this, what we need to do is actually allow us to select the piece, have it selected, and move to a valid square. Now, that also involves having to figure out where can we move to, like what is a valid square, right? And if we move and we say jump over a piece, how do we remove that piece? How do we get rid of it? You know, can we jump and double jump? Like those are the things we have to figure out now, which are kind of difficult, but obviously if we're going to do them, they won't be that hard. Okay, so I'm going to make another file inside of checkers, and I'm going to call this game.py. Now, what this is going to be responsible for is handling actually the game. So figuring out like whose turn is it? Did we select a piece? Is this piece good? Like, can we move here? Can we move there? That's what game is going to do. And it's going to use board and a bunch of other stuff to do that for us. It's also going to handle like drawing everything and a bunch of other stuff. All right, so now we're going to code out the game class. Now, the whole point of the game class is going to be to let us actually interface with the board and the pieces and everything else with a few really simple methods. So essentially, I don't want this main kind of loop that's actually running and checking for us pressing buttons and stuff to be associated at all with how this game operates. I want this game to be able to be operated by, in theory, 2 computers, right? I don't want it to be linked in directly to us pressing buttons and all of that, because later on, what we'll do is implement an AI so we can play against it, right? So we need to make sure that it's very clear that game just exposes some methods that we can use, but it's not dependent on the fact that we're pressing certain things or that 2 human players are playing. That's kind of what I'm trying to get at here with the point with this. So let's define the class. Let's import Pygame like that. Let's say divine underscore init self. And do we need anything else for game? We're actually going to take the window that we want to draw this game on. So we could put the window in here if we want, like we could define it in this game class. I'm not going to, just for the purpose that, say we actually want to draw or play maybe like 4 or 5 chess games at the same time. Well, we could in theory pass a window that is big enough that we could draw 4 chess games, and then we could just pass subsets of that window to different games and play multiple games at the same time. So I'm just trying to keep things flexible. We could define win here. I'm not going to, but just figured I'd tell you why. So first I'm going to say self.selected equals none. This actually reminds me that I want to go back to board and remove the selected piece, because we're not going to use that inside of board. We're going to use this inside of game to figure out what piece is selected by someone that's playing, if they are. And then next I'm going to say self.board equals board. So that means from main here, we're actually not going to make a board. We're actually just going to make a game, and the game will control the board for us. So rather than having to get the piece, move the piece, all of that, all we'll do is use the game to say, okay, we selected this row and column, move it to this row and column, and that will figure all of that out for us. So self.board equals board. Next, we're going to say self.turn equals red. which means we need to import constants. So from dot constants import red, white. What else will we need? Probably a few other things, but we'll just leave red and white for now. So self.turn equals red. And after that, we need self.valid underscore moves equals a dictionary. We'll talk about this after, but this is going to pretty much tell us what the current valid moves are for whatever player is playing so that we can draw those or we can move those or whatever it may be. Next, we're going to say self.win equals win. So just store that window in here so we don't need to pass it every time. And then what we're going to do is define an update method. So update will just be like, say we're updating the Pygame display. Instead, we'll just simply call this update method. So we'll say inside of update, self.board.draw, and then anything else that we want to do to actually kind of update the game. And then next, we'll say pygame.display.update. So now, right, if we go back to main, all we have to do actually is, instead of saying board.draw and pygame.display.update, we'll say game.update like that. Instead of making a board, we'll say game equals game. So now in theory, we've just kind of wrapped some of this functionality in. So I'm going to get rid of those two lines. We're not going to use those for right now. And we need to import game. But once we import game, all we'll have to do is just use the update method, the move method. It's a lot simpler on this end when we do that. So let's say from checkers.game import game. And let's run this and see if this works. Okay, so I'm getting an issue, missing a positional argument win. So I forgot I have to pass the window to my game. So let's do that. And what is this now? Board is not defined. So we need to actually import board into game. So let's do that. And now let's try it. And what's the error this time? Missing one required positional argument win. Okay, so let's go back to game. Sorry guys, and let's say self.win inside of the call to self.board.draw. Okay, and there we go. Now it's working. So we can see that it all works the same. We've just kind of wrapped it up and are using it a little bit differently. All right, so now let's go back to game and let's start defining a few other methods that we want. So first I'm going to define a reset method. This is pretty straightforward. Just say we want to reset the game. Then what we'll need to do is say self.selected equals none, self.board equals board, self.turn equals red, and self.valid moves equals blank. And in fact, that looks really similar to what all of this stuff is, right? So let's wrap this in a new method. And let's just say define, and let's actually just call this a knit. So inside of the reset method, we can just call a knit like that. And I'm going to make this private, just putting an underscore beside it so that no one else can call this. They have to call the reset method. And then here, what we'll do is we'll just call underscore a knit. So the logic behind this is that since we're doing the same thing twice, but there's a little bit difference in the init method here, let's just put it in a method that does it. And rather than having the user just call a init, right, what I will do is have them call reset. The reason for that is that init technically is initializing the game, but we don't want the user to have to call an init method when they want to reset the game, right? So just so it's more clear for them, we make this private so they don't see it. They only see the reset, and really all it's doing is just calling init, which is also used by the initialization of the game. So it's just about what we're exposing and showing to whoever's using this class. Yes, we ourselves are using this class, but you have to imagine that maybe someone else is using it, or maybe we're going to use it in a different capacity. So it makes more sense to have methods that are named the right thing. And then inside of a init, we're going to have self like that. Okay, and this will be self.init and self.init, my bad. Okay, so now that we've done that, I'm going to add a method for select. So this will say select a row and column, so self row call. And we will have move. So define move self row call. All right, great. So this is pretty much saying, all right, when you select something, you will call this select method. You will tell us the row and column that you selected. And then based on that, whatever information we're currently storing in the state of this game will do something, right? So if you already selected a piece, then maybe we'll move it. Or if you selected a different piece, we'll change that selection, right? That's what we're going to do. So I'm going to say if self.selected, so if we have something selected, because note right now selected is equal to none, then what we'll do is we'll say result equals self.move of row call. Now, this won't make too much sense right now because we haven't defined this move method. But what I'm saying is, okay, if we already selected something, then let's try to move what we've selected to the row and column that you put in here. The point of this being that I'm actually going to make move private. We only ever select something from the game. So when we are like moving stuff around or when we're giving any input to the game, we just call this select method. We say, okay, I selected this, I selected this, I selected this, blah, blah, blah. And this will handle what happens based on that selection. So we don't need to call move and select. We just call select, and select will determine whether or not we should move something based on what you've already selected. That's what I'm doing at least. Might not make perfect sense, but anyways, I'm going to say if not result, then self.selected equals none, and self.select row call. So essentially what's going to happen from this move method is if we were able to successfully move something, so if the row column that we selected was valid because we already had something selected, so we selected, say, a diagonal square that we could move to, then we will actually move it. But otherwise, what we will do is select a different piece, or at least try to select a different piece. So we'll say, sorry, let me re-clarify this. So what this is doing essentially is saying, okay, if we have something selected already, that means we already pressed on some piece. So we're trying to move the piece that was selected to whatever row and column we just passed here. Now, let's say that doesn't make sense. Like maybe we pressed a red square and then we pressed a white square. Well, that's going to mean that result is going to be false. It's going to tell us, hey, no, that wasn't valid. Like you couldn't move there. So what we do is we reset the selection and then we reselect a row and column. So this is going to call this method again, except now we're going to get into the else statement that I'll put here, or not the else statement, but we'll get into the rest of the code that I'm going to put here, which will essentially say, okay, let's select this piece. Let's do that. Let's whatever, right? That's what it's going to do. So we're going to say piece equals, and in this case, we'll say self.board.getPiece row column. So we've used this before, but we're going to use it in here. We'll say if piece does not equal 0. So if we're not selecting an empty piece, we're actually selecting something that's red or black and not black, sorry, red or white, and self.piece.color, and actually it's not self, it's just if piece.color. If piece.color equals self.turn, so whatever turn it currently is, then what we can do is actually select that piece. So let's say self.selected equals that piece, and we'll say self.validMoves are equal to self.board.getValidMoves, which is a method we're going to define in a second, and we'll simply pass in that piece. And then we will return true to tell us, hey, this was right. We selected something, that's good. Otherwise, we'll return false. So this is just to tell the user, hey, this selection was valid, so we're returning true to you. If it's not valid, we're returning false. And that's the basis of how this works. So again, we'll go through it. If we selected something, then try to move it to whatever else we just pressed here. If that doesn't work, so we get a false back, then say, okay, get rid of our current selection, reselect something else, which means call this method again. And that means we'll do whatever happens here. Now we could put an else statement just to make sure, in this case, return false is fine, just to make sure that we're not going to accidentally run this code after the self.select happens and we return back here, if that's making sense, because this is technically recursive, but anyways, that's what I'm getting at. So we can go over this again later, but I think that's enough of an explanation. Okay, so now we're going to do move. So move is called here, and now we need to actually move something if this is called. So we're going to say piece equals self.board.getPiece row, comma, column. Next, if self.selected, so if we have actually selected something and the piece is equal to 0 and the row call is in valid moves, which is going to be self.valid valid underscore moves. So hopefully this is reading clean enough that it makes sense. But essentially, if we selected something and the piece that we selected is 0, this is important because we can't move into a position that has another piece. So only if we selected something and what we selected is actually not another piece, because at this point we've, okay, so we've already selected something. And then what the row and column that we pass here that we're trying to move to is not another piece, if that's the case. So actually I don't think I can say, yeah, if piece is equal to 0 from row and column that we just pressed on, and the row and column that we want to move to, right, is in the valid moves, then we can actually move it. So we can say self.board.move, and we can move the piece, which we would have had as selected. So self.selected, we can move the selected piece to the row and to the column. Okay, so I double checked that. I'm pretty certain this is right. I've been confusing myself because there's a lot of rows and columns and the same words everywhere. But we'll move the currently selected piece to the row and column that was passed to us here. And this will work. We've already set up how the board moves the pieces. And then what I'm going to say is, this will be weird because we haven't seen this yet, but skipped is going to be equal to self.validMoves. You know what? Actually, let's skip this because I don't want to confuse anyone if we haven't yet wrote the code that we're about to try to like work with, if that makes any sense. But otherwise, if this is not true, we're going to return false and then return true if this actually works. Now, the other thing we need to do is actually change the turn. So I'm going to say define change turn self, and we're going to say if self.turn equals red, self.turn equals white, and otherwise self.turn equals red. So change turn, just to make this a bit cleaner to see, and then we'll call self.change turn. All right, so valid moves, we haven't looked at this yet, but this is going to be a dictionary of the valid moves that we can take from any possible position. And then we have change turn, which is going to say, okay, if it's red, we'll go to white. If it's white, we'll go to red. So pretty straightforward. I want to see now if I can get select to work, or if this is working. The only problem is we're not drawing anything, right? So I won't really be able to see if what piece I've selected is working or not. So we're actually going to have to keep writing code until we can really test this and make sure that we haven't messed anything up. Okay, so now it's actually time for, in my opinion, what the fun part is, which is trying to figure out an algorithm that can essentially be given any piece and determine all of the valid moves for that piece. Now, unfortunately, my like drawing software isn't working. I'm going to try to get it working. If it doesn't, then you'll be seeing me hand drawing something in just a second. All right, so now I got the drawing stuff to work, fortunately, so I don't have to actually go and get a piece of paper and film myself doing that. But what I'm going to show you is essentially how we figure out what pieces or what moves pieces can go to based on where they are. That's a mouthful and I still didn't say it correctly. But let's say we're considering this red piece right here that I'm filling in, so this red checker. Essentially, what are the valid moves for this piece? I'm going to draw them in green. So one of the valid moves would be this. Another one would be this, right? To hop over this piece. But if I move this piece, so I remove this blue one, then no longer is that a valid move. The valid move is, if I can go back to green, this one right here. So this is actually kind of tricky because it looks simple. It looks like just expand on the diagonals and figure out where you need to move to. Just say, okay, is there empty space on the diagonals? If there is, you can move there, right? But then again, what happens if I add a checker right here? So I add a blue one right here. I can no longer move here. I can only jump over top. And if I add another blue one right here at the end, now I can't even move on this diagonal at all. So hopefully you can understand kind of the complexity in this and why the algorithm we're about to write is actually kind of complicated to figure out where a chess piece is, or a checkers piece is able to move. Essentially, we need to look at all of the checker pieces on the diagonals of where that checker piece is. And now imagine the situation in which this is a king. So if we give him like a little crown or something, that's sure, this will be our king. It's not really a crown, but if it's a king, it can move backwards, right? And it has the same rules applying to it, except it can move backwards as well. And then what happens when we can double jump, right? So if we have a situation, I don't think I can even set one up where we can double jump. Let me see if I can. Okay, let's see if we can get a double jump set up somewhere just to show you an example. If I have a piece here and I have a piece here, and then imagine that this expanded on, technically a valid move is right here in this square for this piece. It can jump here and then it can jump over there and capture both of these pieces. And we need to keep track of what pieces we jumped over so that we know if we remove them. So it seems pretty simplistic, but actually moving these pieces is pretty complicated. So let's consider the algorithm that I'm actually going to run through. I have it up beside me. I'm gonna bring it up beside me at least, and I'll show you what I'm gonna do. So the first thing that we're gonna do is check the color of the piece. So is it red, or in this case, is it blue? But this would be white, obviously. I'm just doing it in blue because you cannot see white on this background. Okay, so the color, is it red or is it blue? That determines the direction that we're going to move in. And in fact, I think we already have the direction set on the piece as either -1 or +1. So let's say that we're considering something that's red. We can only move down in that direction. So what we're going to do is look on this left diagonal and this right diagonal for any valid moves for this piece. We can only move diagonally again, right? So what are we going to do? The first thing we're going to do is we're going to move down one row. So whatever row this is on, we're going to start from this row right here. And we're going to, if we're checking the left diagonal and the right diagonal, we're going to check one at a time. So I'll start by checking the left diagonal here. I'm going to look to the square that is one left and one down, so on the diagonal right here, and say, okay, does this have a piece in it or does it not have a piece in it? So the two things here are, okay, if it has a piece in it, is the piece blue or is the piece red? So is the piece the same color as our piece? If it is, we can't move on that diagonal. So if this piece right here is actually red, then we can't move here, right? Because we cannot have a red move into a piece where another red is. Now, if the piece is empty, so if there's nothing there, we can move there. That's a valid square. So if it's empty, then we say check, okay, boom, we can go there, that's fine. If it has the opposite color piece in it, then we have to keep moving on the diagonal and see if we can jump over this piece. So if there is a piece on this diagonal, we need to check the next piece here and see if we can move into that square. So if there is not another piece in this next square over, doesn't matter what color it is, then this becomes a valid move and we can move into this square. Now this applies the exact same way on the right side of the diagonal as well. We'll move over one and to the right, and we'll say, okay, is there anything here? In this case, there's not, so we can move there. But if there was, we need to check the color of it. If it's the opposite color, we need to check continuing on the diagonal and see if we can move over top of that color to jump it, right? And if we do jump that, we need to keep track that this move would jump a piece so that we can remove that piece if we decide to take that move. Now, where it gets a little bit more complicated is if you're double jumping or doing something else. So actually, let me just erase all of this and draw a fresh grid because it's getting kind of messy here. And I'll talk about how we handle the situation in which we're double jumping. So let's just say this is our grid. It doesn't have to be even or neat. It's just for the purpose of showing you here. And let's say we have, maybe we can change the colors again. We have our red checker here. Then we have a blue one and a blue one. And we'll expand this out like that. Okay, so technically, we should be able to move here to this square to double jump. So what I'm doing, at least in my algorithm to check this, is saying, okay, if we jump over a piece and we land in a square that doesn't have another piece in it, from this square, check if we can jump any other piece on the diagonals. So we already know how to check if we can jump a piece, but imagine that there's a piece here and here. Technically, this is a valid move, because if we move here, we can actually jump over to the other side and jump the other piece. So that's something to be aware of as well. So as soon as we go here, I'm actually going to run the exact same algorithm I ran before, right? Except this time, I'm only going to consider a move valid if it jumps over another piece for the double jump or triple jump or so on and so forth. So as soon as we jump a piece, we immediately consider if from the current position that we jump to, we can jump any other piece. And if we can, we add those moves to the valid move set. So that is how we're going to do this. I'll write the code for it, which is more complicated than this. And then that will be probably the hardest part of this video, is writing this little bit of algorithm here. All right, so let's get into it now. Bring the keyboard back, get rid of all the wires for my drawing tablet, and there we go. Okay, so what I'm gonna do is I'm gonna say, define inside of board.py get underscore valid underscore moves. And this is going to take self. And do we want to take a piece, or do we want to take, yeah, or we'll take a piece instead of row and call. All right, so first I'm going to say moves equals an empty dictionary. What I'm going to do in this dictionary is store the move as the key. So what place we could potentially move to as a row call. So like 4 or 5 might be a available space that we can move to. And I'm going to have this as the key being equal to any pieces that we jump to that move. So say that we jump over the piece in 3-4 to get to 4-5. Then that would be stored in a list that is associated with this key in the dictionary. So, you know, more accurately be it like that, so that we know if we move to this move, we have to remove that piece because we jumped it. All right, so moves equals empty dictionary. I'm going to say left equals piece dot call -1. Oops. Because we're moving left 1, and then right, oops, equals piece dot call +1. So essentially just getting the, you know, what's left and what's right, because that's the diagonals we're going to start considering. And then row equals piece dot row, like that. All right. So now what I'm going to say is actually, I need to check something here. Yeah, the direction that we have on this piece is actually, if I can find it, do I have direction? Not going to be relevant, so we can actually just get rid of it because we're not going to use that. We have to do it another way that I forgot. So inside of here, what I'm going to say is if piece.color equals red or piece.king, we'll do something. If piece.color equals white or piece.king, do something. The reason I'm doing this is because we need to check whether we can move up or whether we can move down based on the color and based on if this piece is a king. That's what we need to do. Now, what I'm going to do is I'm going to define 2 more methods. I'm going to say define underscore traverse underscore left, which is going to look on the left diagonal for us because we're going to have to do this multiple times. I'm going to say self pass, and I'll fill in the rest of the parameters after. And then next, we're going to say define underscore traverse underscore right, which is going to move to the right. So we have 2 methods here that we're going to call from inside of here to kind of split up this algorithm and just make it a little bit more digestible and easier to see. But for our traverse left, I'm going to say, where do we start? Where do we stop? How much should we step by? And what is the color left? And I think one more thing, skip only equals that, or skipped equals that. Now I'm going to copy these and I'm going to put them inside of traverse right. Now let me just explain why I've added all these. So start, stop, step is going to be for the for loops we're going to put inside of here. The step is the most important because essentially it's telling us, okay, do I go up or do I go down when I'm traversing through the rows for the diagonals? Am I going on the top left diagonal or the top or the bottom left diagonal, right? Am I going on the top right diagonal or the bottom right diagonal? Skipped will tell us, okay, because we're going to call this method recursively, which you'll see in a second. Have we skipped any pieces yet? If we have, we can only move to squares where we skip another piece, right? That's what this is telling us. And left, sorry, this should say right in traverse right is telling us, okay, where are we starting in terms of the column when we're traversing to the left? Okay, so that's what this is telling us. So inside, we're going to fill in traverse left and traverse right, and then we'll use them inside of get valid moves. So if traverse left, I have to look at my other screen here because there's no way I'm going to be able to do this just off the fly. I have to say moves equals a empty dictionary. Last equals an empty list. We're going to say for R in range. R is going to stand for row, start, stop, step. So again, the point of this is that I'm giving the parameters for my for loop in the, or I'm giving the arguments for my for loop in the parameters so that I can simply just put them here. And this will tell me, okay, what row am I starting at? What row am I stopping at? And what am I stepping by? Awesome. Okay, so start, stop, step. Next, we're going to say if left is less than 0, break. So if we get to a situation where we're now looking outside of the board, so our left is no longer in the range of columns that we have, because we're going to subtract from left every time in this loop. In fact, we can just do that like this at the end. Then we need to break. All right, so we're looping through all of the rows, and we're going to have a variable that keeps track of left for us that we just increment as we move through the rows. This, again, will move us kind of on a diagonal pattern, which is what we're trying to look for. We're going to say current equals self.board.get_piece, and we're going to put r left like that. So row, and then left, which is the variable keeping track of, again, the column that we're on. I'm going to say if current equals 0, and now we need a more advanced thing inside of here. And by the way, we're going to copy almost all of this for traverse right. So once we do this, there's just a few minor changes. So if current equals 0, meaning the current thing we're looking at, if it is 0, then we need to check if skip underscore only and not last, then what we'll say is break. Okay, so to explain this is kind of complicated, but what we're gonna do, and maybe it actually would be easier if we call traverse left first, just so that I can kind of illustrate this better. In fact, that's what I'm gonna do. I'm simply gonna say here, moves.update self._traverse left. And then what I'm going to pass is row -1. I'm going to pass the max of row -3 and -1. And I'll talk about this in a second. -1 piece.call. Wait, is this correct? Sorry, piece.color. We need the color and left. Okay, so what I'm saying is I want to update the moves with whatever is returned from here, which is going to be another dictionary. I'm traversing left. I'm passing row -1, which means, okay, if we're red, we are moving up, right? So we need to move, we need to check upwards to see if there's anything valid there. So we're going to start, remember this is the first parameter here, start at the row above the current row that we're at. We're going to say, okay, how far up are we going to look? How many rows up am I looking? Well, I'm going to look at row -3 or -1, so the maximum of that. Now, -1 pretty much says stop at -1, which means look up to row 0, right, which is a valid row. And the reason I put row -3 is because I don't want to look further than 2 pieces away from where I currently am. And if I start at row -1 and I move to maximum of row -3, right? Then what that means is I'm only looking 2 above the current row that I'm at most. So that's why I'm putting row -3. -1 is saying move up when we increment this for loop or decrement this for loop in this case. The color obviously is the piece color, and left is where we're going to start for our column and what we're going to subtract as we move upwards. That's what this moves.update is doing. Now I'm going to do the same thing for moves.update with right, except it's going to be changed a little bit. So move.update traverse right. The start, stop, step is going to be the same. Piece.color will be the same, except instead of left, we're obviously going to pass right. Now let's do the same for white, just to show you what I mean. Hopefully this will make it more clear in this order of explaining. And instead of, traverse left is right, except now instead of row -1, it's going to be row +1, because we're moving down this time, right? And now instead of the max, it's going to be the min of row +3 or rows. Right? Hopefully this is making sense. And then instead of -1, it's going to be 1. And left and right is the same. So I think that's right. Let me make sure I did that correctly. Yes, it is. And then outside of here, we'll return moves. So this method right here, traverse left and traverse right, will return us a dictionary. Essentially what moves.update is doing is merging this dictionary with the one we currently have, so that we can have as many things as we want in that dictionary. We don't have to say moves equals this and then go through and add them automatically. This method does it. Okay, so hopefully that's making sense on how we're going up and how we're going down. But what I'm saying is if current is equal to 0 and we skipped a piece and we have not seen a piece yet, so we'll define last in a second, but if we've skipped a piece and last, which is a piece that we would skip to move to where we're going to go, is not defined, then break. The reason for that is if the next square we look at when we jump over a piece is a blank square, we can't move there because we need to jump to another piece, jump over another piece to be able to actually make that a valid move. Now, this will make more sense as I complete the algorithm. I like to explain things as I go, but sometimes you just have to walk through all of it and then kind of go through parts after. So elif skip only, we'll do something in a second, and else we're going to say moves. And this will be our left is equal to last. All right, and then finally, what I'm gonna do, not finally, there's actually more to this. I'm gonna say if and last, why is that an error? I don't know, we'll see in a second. Say if last, then what we're gonna say is if step equals -1, row equals the max of r minus 3, 0, else row equals the min of r plus 3 rows. So this is now doing the same thing that we did before, because what I'm preparing to do essentially is saying, okay, if we found an empty square and last had a value in it, so there was like, we found something when we were looping, which, you know what, I'm just going to keep going and then I'll explain this. So if current does not equal 0, what I'm going to say is elif current.color equals color, break else last equals current. We're going to put this inside of a list. Okay, now I'm actually almost done with this, but I just need to code out a good amount to be able to start explaining this. So if current is equal to 0, that means we found an empty square. Otherwise, if it's not, so if it has a color, it wasn't equal to 0, and it's equal to our current color, so the piece we're trying to move is equal to our piece, then we can't move there. Obviously, we're blocked, we can't jump over it, so we break, and we won't be adding any moves if that's the case. Otherwise, we say, okay, if it wasn't our color, it means it was the other color, which means we could potentially move over top of it, assuming that it's an empty square next. So we say last equals current. So then what happens in this instance, we're seeing if we can jump, right, which is the complex aspect. Last gets equal to current, we loop again and we look at the next row and we move left and we look at the other diagonal piece. Say, okay, if current now, so if this next piece is 0, and if we skipped and not last break, I'll talk about that after. If skip only, we'll do that. But in the situation where it's 0 and none of this was true, we add this as a possible move. So we say, okay, if it's 0 and last existed, right, then that means we can jump over it. So we say moves r comma left equals last. Now, in the situation where we find this first and we don't just find a piece that is the other color in between, we will add the move, but we just won't skip anything because last will be equal to an empty list. All right, now we're saying if last, so essentially if current was equal to 0 and last, which means that we had something that we skipped over, now we can actually skip it. We're preparing to see if we can double jump or triple jump, right? So that's what we're trying to do. So what we do now is we say, okay, what direction were we going? Were we going up or were we going down? Because we need to recalculate, and this shouldn't say r plus r, this should say r plus 3. We need to recalculate where we're going to stop because now we're at a new position when we recall these two functions. So what we're going to say now is moves.update, and we're going to say self._traverse left, which is the same one that we're doing here. We're going to say r plus step. So either we're going up or down based on what the step is. If step is -1, r will subtract 1. If it's 1, we'll add 1. Say r plus step. We'll say row. And actually, is it row? Sorry, this should be r plus step. Yeah, row. And then in this case, step, because we already passed the step, so we know what direction we're going in. Then what do we need to pass after that? We need the color. Okay, we're going to pass left -1. And finally, we're going to pass skipped equals last. Okay, so that's what we pass for that. And then we'll copy the exact same thing, move down a line, and do this now except traverse right. And instead of left -1, it's going to be left +1. All right, so let me make sure I did this correctly. I think I did. But the whole point of this is like, once we get to a point where we've skipped over something. So in this case, we found a valid square, we skipped over something, we figured out, okay, now where are we gonna go to figure out if we can double jump or triple jump? What row do we stop at? We call this again recursively, which means just do it again and see if we can double jump or triple jump from this position. And then we actually can just break here. It won't matter if we put a break or not, because based on the way that this for loop is set up, it won't run anymore. But I'm just going to break just so we're clear that after we do this, there's no more valid moves in this current iteration. And now I need to fill in this pass here for skip only, but it should actually just say skipped. Okay, so let's go to skip now. If skipped, we're going to say moves r comma left. And yeah, r comma left equals last plus skipped. So essentially, if we're in the situation where we found a valid move, we skipped over something, right? Now what we can do is we can actually, sorry, this is the situation where we're double jumping something. We will combine the last checker that we jumped with the checker we jumped on this move into this move's skip so that we know whether we can jump one or whether we can jump two and which ones we need to remove. This is all going to make more sense as we continue doing it, but just it's hard to explain this because it is a really kind of abstract, complicated algorithm without really a visualization. Now, the reason we have this break here again is essentially we're saying if we've skipped over something, we found a blank square, and we don't have anything that we can skip again, we can't move there. That's what this is saying. So that means all we have to do here is check if we've skipped, because if we skipped and we did find another thing that we can skip over, then we can update the move or add another move that has the last plus this one. If none of this is true, if we didn't skip anything, so we're on the first one, as soon as we find an empty square, this is valid, moves are left equals last, right? And there we go. And then we check and do this recursive call to see if we can skip any more from that blank space. That is kind of how this works. Again, hard to explain, but that's what we have to do to get this to work. And now I'm going to go traverse right. I'm going to copy all of this, and we're just going to update a few of the variables. So instead of left, we're going to say right. And instead of right being less than 0, it's going to be right greater than or equal to rows. And actually not rows, is going to say calls. Now, current, that's fine. Instead of left, again, this says right. So pretty much anywhere it says left, just substitute it with right. And some of the minuses and pluses we'll have to substitute as well. Yep, and this will say right. Instead of right minus equals 1, this is going to be right plus equals 1. Instead of left, this is going to be right. That can stay the same with plus 1 and minus 1. And let's see if there's anywhere else. I think that should be good. And finally, let's return moves from this and from this. Okay, so this is the algorithm to determine the valid moves based on a piece, right? So given a piece, tell us all the valid moves. This will do it. I don't think I messed it up at all. And now what I want to do is just add something that can draw these valid moves so we can actually make sure that this is working. So next, what I'm going to say is define draw underscore valid underscore moves. And why is this break giving me an error? Let's see what it says. Instance of list has no get piece method. Current equals self.board. Oh, oops, sorry. So this should say self.board. My apologies, guys. We're going to have to make a quick fix here. Line 78, self.board r left, because we're inside board, not game. I forgot, so the internal representation is different. And then here, same thing, self.board r right. Okay, so that should be good. Now let's go to draw valid moves. Let's say self. We can say, should I say moves? I'm just gonna look at where I've done this before. So actually what I'm gonna do is I'm gonna take this method, and I'm gonna put this inside of game, just because game handles most of the drawing. So inside of here, we'll say define draw valid moves, self moves. And then what we will do is we'll say, okay, we need to just draw squares for all of these valid moves. So we'll figure out their row and their column, and then just draw a circle there for each move. So we'll say for move in moves. And then we will get the row and column. So we'll say row call equals move. Remember, all the moves are going to be a dictionary. Okay, so we say row call equals move. This loops through all the keys of the dictionary, which coincidentally is the rows and columns that are a tuple for us there. So row call equals move, and then pygame.draw.circle. We'll draw it on the surface, which is self.win. And then what we will do is we'll draw it. What color do we want? We want blue, which I'm going to import from here. So blue like that. We'll say self.x. Oops, not self.x. We have to actually calculate self.x. So I'm going to say row multiplied by square size. Row multiplied by square size minus square size over 2. That should give us the middle. And then same thing with call. So call times square size minus square size over 2. We've already talked about how that works, so I'm not going to go over it again. And then we need the radius, which in this case, let's just hard code at 15. Okay, so square size, we also need to import. So let's import that like that. And I think that's all I need to do for draw valid moves. Now inside of draw, or inside of update, sorry, where is that? I've got to find where the update method is. We'll say, oops, self.draw valid moves. And we'll pass the self.valid underscore moves, or self.board.valid moves. Okay, so I think that is, or no, we have it stored inside of here. What am I saying? Sorry, guys. After an hour and almost 2 hours of recording, the brain starts to go when I'm talking and doing all of this. But anyways, self.valid moves, which is stored in here, which should be updated when we select a piece. And now I apologize, it's been like 40 minutes since we've tested this, but I'm going to run this and see what is happening. Oops, what is this going on here? Let's go back here. Okay, so now when I select something, nothing is showing up, which is great. And let's just check this. Okay, so I realized why nothing is showing up, because I just looked at this here. We have not called the select method of our game at all. So we need to actually call the select method. So what we're going to do that is we're simply going to say game.select row call whenever we press on something. And that should be good. Let's check that out. And actually what I'll do here is say if game.turn equals red. So pretty much just let us select the red ones is what I'm saying here, because later we'll make we need to import red. Later we'll make the white ones the AI, but let's run this and see now if we get anything. Okay, so I've select, and okay, so it's giving us some moves, but clearly these are not valid. So I'm just gonna have a quick look at the bug that I made, and then I will be back and we can discuss what is going wrong. So I've made a stupid mistake here by mixing up inside of the draw move, the draw valid moves, the row and the column. So I was like looking through all my code, like what the heck did I do wrong? Like where did I break something? When in reality, this just needs to be changed from call and row, because I'm drawing the row I'm drawing like the X and Y reversed. So I was like, this looks like it's like getting it right, just drawing it opposite. And that's exactly what it was doing. So I did some debugging and figured that out. I'm trying to figure out where else. I think I printed some stuff out that I want to remove. Maybe not. Anyways. Okay, but that was the major issue. Also, there was a small mistake. I had a break statement. I think I went over this, but on line 92, the break statement was indented. Just needs to indent, is that what you want to call it, out here, so it's in line with the if statement. Same thing here in traverse right. So let's look at this now. All right, so one more error here in this draw method. I just looked at it, I'm like, what the heck, what have I done wrong? These negative signs need to be positive signs. So what I was doing is saying, okay, we're gonna go to the edge of the square, so the top left edge, and then subtract from the top left edge, which meant we were going up into the other square, which is why it was going off. So that was the issue, but now change those negative signs to positive signs inside of here between the square size and square size over 2, and hopefully, fingers crossed, let's click something. Everything looks to be working. Okay, great, so that's awesome. So that is pretty much how this works to get the valid move. So I apologize to everyone for butchering that horribly. And I'm trying to make sure that the white and red, I think the checkerboard pattern is good. Now we need to worry about actually jumping over pieces, updating the valid moves. You can see that worked to actually move where I moved it, but there's a few glitches, so let's fix that now. All right, so let's go back into game. Let's go into the select method that I don't think I actually ended up finishing. And let's just check and make sure this is all good. So first of all, I need to get rid of this else statement, which I realize is a mistake, and put it like that. I'm not going to explain exactly why, but just don't add that else statement. That messes it all up. You can read through this and go back. I think I explained kind of how this works. Okay, so after that, what we'll do is go back into move, and now we'll make it so that if we skip over a piece, we actually capture that piece. So we're going to move the position is what we've done. We'll change turns, but what I want to do is check if the position we moved to had a piece skipped. So I'm going to say skipped equals self.validMoves, and not piece. We're going to say valid moves, and inside of here, I'm going to say row column. Now we say if skipped, and then what we need to do is say self.board.remove skipped, like that. And then actually we can just put change turn at the end, because I think it makes more sense to go afterwards rather than before. And looking at that, I think that's all we need inside of here. Just double checking, looks good. Now we need to add this remove method inside of the board class here. So what I'm going to do is say define remove self pieces, and what we'll do is loop through all the pieces and just remove the ones we need to. So we'll say for piece in pieces, and then simply say self.board, and we'll say piece.row piece.call equals 0. So that should be as easy as it is to remove all of these, loop through all the keys that are in this, because it's going to be a dictionary, or not dictionary. It'll just be actually a bunch of pieces, and we will simply just remove those pieces. So we'll just set them equal to 0, which, at the same time, we'll remove them. Okay, so now that should work. Let's see how this works now if we run. Okay, so let me go here. Now let's see if I can move white. Oh, I can. Great. And what's something that's happening here? So I noticed that when I'm moving, it doesn't, at the end of the move, remove these valid moves. So we have to do that. So let's actually do that now. Let's go to move. And yes, at the end of valid move here, where it says self.changeTurn, let's go inside of change turn, and let's say self.validMoves equals a blank list. Okay, so that should hopefully fix that. Let me close this and restart it. And now let's test some stuff out. So first of all, I can't move to any places that aren't valid moves, right? So click on a piece and try to move it somewhere else. You can't. You can only move it to a place that is valid. So I can move it there. Now I can't move these pieces or even select them because it's not my turn, but I can select the white. So if I select this one here, now let's go with the red, and let's see if we can jump over, and it looks like it's working. When we jump, it actually captures it. So really, with that, this is the finished checkers game. What we have to add as well now would be checking if someone has won. So I'll show you how we do that quickly. And actually, let's just make sure that the king pieces work properly before I say that we finish the tutorial. All right, so we capture there, capture there. I'd like to set up some kind of double jump and make sure that that's going to work at some point too. So let's do that as well, actually. Not doing a great job at setting it up though. Okay, let's move this here. Whose turn is it now? My turn. Okay, let's go here. We can go there. I'm trying to move this. I guess I can't move it down. I wanted to move this one so we could double jump, but anyways, let's see if we can just get a king piece first as well. Okay, so let's move that there. This can go here. That can go there. All right, move you here, here, go there, and king. Okay, that looks like it's working. And now it's white, and when I press the king, I can jump backwards over the other pieces. Okay, so that's great to see. That looks like that is somewhat working. Now, let's move this guy here. And it's hard to play the same game against yourself. I'm just trying to get a double jump setup. So let's move that here and let's see. Okay, so it looks like I can double jump and that this is indeed valid. Now it'd be cool if I could have done a triple jump. In fact, maybe let's see if we can get a triple jump and just really test ourselves out here and see if that's working. So to get a triple jump, I'm gonna make this guy a king. And it looks like something went wrong. So good job, we were testing that. List index out of range, board R right. So actually when I moved to the last square, we had an issue. So let me just look at the code and see what's going on there. So first, the mistake is here. I had row equals rows. Obviously that's never gonna be true because we can't move into rows, which is 8. We can only move into potentially row 7, but based on the way it's indexing. So I'm saying if row now equals row -1, then in that case, we can make this a king. So that should fix the fact that that guy didn't go to a king, but now I'm trying to figure out what the issue was with that index out of range, and let's have a look at that. Aha, so I've found the culprit here again. This max on line 69 should say min. So what happened was we were maxing row +3 or rows, which meant we were going to use whatever the larger one was. So we'd use row +3 when we were traversing, which meant we would try to go down from when we moved into that position. And obviously that wouldn't work because there was no more rows to look at. So let's just kind of run through and test one more time. I'll add one thing to check if someone's a winner, and then we'll pretty much be done. Okay, so let's do that. Let's do that. Let's see, you go there, you can jump. I just want to move a white to the other end to make sure that all of that is working. Okay, let's just keep going. And white. Okay, so now he's king, and now it's the red's turn, and there we go, he can move here. Okay, so that seems to generally be working. I'm gonna test just one more time and see if this double jump works. So this is crazy. Look, he can go boom, boom, and if I go there, it actually captures both of those pieces. So this is working properly. Great, so I am satisfied that this is functioning, that the game is working, we can move around. Of course, you can add some music, sound effects, make it look better. I'm not focused on that, I always focus on the function first. And now let's add one thing to check if someone has won, and let's go actually back to board, let's go to remove and let's update that method because I remember that I forgot to do something. So now when we remove a piece, I want to actually check if that piece does not equal 0, first of all. And so if piece does not equal 0, if piece.color equals red, then remember we have this count up here for the red and white left that we need to update. So now what we'll say is, okay, if piece.color equals red, then self dot, I believe it's red left minus equals 1, else self dot white left minus equals 1. Now we can even add a winner onto here. So we can say define winner, and this will return to us the color that won if they won. So we'll say if self.red left is less than or equal to 0, return red. Elif self.white left is less than or equal to 0, return, oops, sorry, this should be the other way around, return white and return red. And then finally, return none in the situation where no one won. So return none like that. Now I'm not gonna actually like program anything related to that, but what I'll do is simply just say if game.winner does not equal none, then print game.winner. Could simplify that, but this is fine for now. And this is pretty much, I'm just trying to show you, if you want to check if they win, just do this. And then inside of here, you can do something specific. In my case, I'm literally just going to print out the color of the winner because I can't be bothered to add any more to this now. So with that being said, this has been Checkers. All right, so I am back and it is the next day and I just read through this code and tested it and I realized that I made a kind of small mistake at the end, so I just wanted to hop in here quickly and fix it for you guys in case any of you were running into problems. So essentially, some of you probably noticed this, but when I said if game.winner, I didn't actually add this winner method to the game class, I added it to the board class. So that's fine, we can just add another one to the game class that simply uses the one from the board class. Really easy fix, but I just wanted to hop in here and show you how to do that. So we're just gonna have to define winner inside of our game class. we'll take self here, and we'll simply just return self.board.winner. So that's it. Let me just run this and make sure that everything's working now, and we can see that it is, and we're good to go. So let's get back to the original video. If you guys made it to the end of this video, give yourself a pat on the back because I hardly did. It is much more difficult than you would imagine to go through and explain about 400, 500 lines of code, especially because I'm doing this pretty much in one take, only cutting out like any major mistakes I make. So if you guys appreciate this, please do leave a like, subscribe to the channel. All the code will be available in the description in case your game isn't working or something is messed up. And yeah, let me know what you thought of this series, and hopefully you're looking forward to adding to the AI to this, which we'll be doing shortly. Hello everybody, and welcome to a brand new tutorial series on creating an AI for the game Checkers using what's known as the Minimax algorithm. Now in these next few videos, I'm not sure how many there will be, I will not only explain to you how the Minimax algorithm works, but I will then go ahead and show you how we can implement it specifically on our own game that we've already created, which in this case is Checkers. Now, don't worry, if you want to use this Minimax algorithm on something else, you totally will be able to. In fact, there's only a few minor changes you'll have to make. But since we've already made a tutorial series, or I've already made a tutorial series on how to make the Checkers game, I figured it would make sense to implement the AI on this game as we've created it ourselves. So let me just first show you the game. I will note that you can download all of this code, which you will need if you want to follow along exactly with this tutorial series, from the link in the description. There'll be a GitHub link as well as a download link. You can check out either one of them, but the idea is that this is the game of Checkers. We can move pieces around, right, like this. We can capture pieces, and we want to make an AI that can play as the white pieces and can essentially beat us, right? Can be better than we are. And in fact, the AI we make will actually be quite good. It might not be able to win in every single scenario, but it will be at least competent, and it will make moves that make sense. Now, to give you a quick demo of what that might look like, I have kind of a half implemented version here. This is another Checkers version I have, and you can see that when I move, give it a second, and the AI will make its move. Now, let's say I leave myself vulnerable like that. Maybe if I move over here, he'll decide to capture me. I guess he decides not to because he'll see that I'll capture him right back if he decides to capture me. All right, so let me move over here. Let's see if this AI decides to grab me. No, it doesn't. It moves over there. And I'm just going to keep kind of moving around and just we can see what movements we're getting. Okay, so the AI decides to make a capture there. I'm going to capture back here. Let's see what he does. He captures me there, and we can keep moving forward. But it is competent. It's making moves that make sense. And I've played against this quite a few times, and it seems to do a decent job. Anyways, let's get started. This first video, what I'm going to do is simply explain how the Minimax algorithm works. And then in the next ones, we'll actually start coding and going through the implementation. All right, so let's start explaining the Minimax algorithm. Now, I've just drawn a really rough checkers board here just so we can do some kind of illustrations and examine some situations and demonstrate to you the complexity of actually creating AIs that can play games. So checkers is actually a game that has a lot of different potential moves. Not as many as chess or Go or some other games like that, and that's kind of why we're actually going to be doing this. It's a little bit easier than something like chess. But there is still a high degree of complexity. In fact, let's just consider the amount of possible moves that this AI can make in its current position. So let's assume the green is our AI. So, green like that, and it is its turn to move. So where can we actually go? I'm just going to put blue dots where valid moves are, and you can kind of infer where which pieces would go there. So obviously this piece could go here, that piece could go there, so we get a blue dot. One could go here, here, and here. This guy could jump over here, he could jump here, this guy could move here, and he could move here. So these are all the potential moves in this position. We have 1, 2, 3, 4, and 1, 2, 3, 4, 8 potential moves. So just thinking about that, that's actually not that many moves, right? We could potentially just run through and look at all of the different moves and see which one would be the best. And if we did that, we would probably consider that the best move to make would be to actually just capture this piece here with either this one or with this one. In fact, these moves might be rated the same. They might get the highest score per se if we were going to score the moves. And that would be what we would do if we were just going to look one move ahead, right? So if our AI was just really basic, we didn't implement any crazy algorithm, and all we did is say, okay, look for a move where we can capture a piece. If we can't do that, maybe make ourselves a king piece if that's possible. And if we can't do that, well, then we'll just pick some other random move. We could implement that as an AI, and that would be a somewhat competent AI, but it would make a lot of captures that don't really make sense. So now what we have to consider is, okay, how do we make this AI more complex? Rather than considering just all of the moves it could make, we actually have to consider what the outcome of its move might be. So essentially, what will this red player do when we make the move that we just make? We have to consider what the other player may do to make sure that, for example, say if I capture over here, that I don't just get captured back by this red piece and, well, we cancel out, or maybe I set myself up to be double jumped or something crazy like that, right? And in fact, if I actually were to capture right here, this piece will be able to double jump me like that, right? It could go here and then it could go over top. So that obviously would be a bad move. And well, we wouldn't see that if we weren't considering other moves from the other player. So the way the minimax algorithm works is it assumes that our player, the person we're playing against, is going to make the best possible move that it can. So actually what we're going to do is consider every single possible move that we can potentially make. And then for each one of those moves, we're going to consider every single move that the other player could potentially make against us. Essentially what we'll say is, okay, we want to either maximize a score or minimize a score, and the other player wants to maximize or minimize, be the reverse of what we're doing. So now we have to talk about what a score is. In every single position, so every single possible position of this board, we can give it a score. Now the score will be defined by something that we come up with, but a really easy way to determine it is just to simply count the number of green pieces and the number of red pieces. So we can say that the score is going to be equal to the number of green minus the number of red. So if that's the score of our board, then obviously green wants to make this as big as possible. It wants to maximize its score and have the most amount of pieces, and red wants to minimize that score. So that is where we get this minimax name from. So we have to assume that when we make our move, we are going to pick the move that has the best potential score, and red will pick its move that has the minimum potential score. So what we have to do in the algorithm is consider the fact that we want to maximize our score and red wants to minimize its score. And what we can actually do is draw out a tree, and I'll show you that in a second and kind of illustrate how we actually derive what the best possible move is, because that's going to come from a combination of what's the best move for us and what's the best move, or actually the worst move for us, based on what red is going to do. So hopefully that is kind of making sense. That's just like the basis for the explanation. And now I'm going to get into actually talking about kind of how this algorithm works, and I'll draw out some more stuff. So to start explaining the minimax algorithm, the first thing I need to talk to us about is the decision tree. Now, we're not actually going to make a data structure that holds this tree, so don't worry about that. But this is kind of the way to visualize how the algorithm actually works and how it searches through the potential options for the moves that it should make. So we're going to start by drawing a node here, and this is going to be known as our root node. And what this will represent is the current position that we're in. So say red moves. Now it's green's turn. Remember, green is our AI. And right now, this represents the position that green is in. So technically, we would have a score for this position, but we're not going to really worry about that, because what we want to do is look forward and say, okay, what is the best score that I can get based on the move I make from here? So what we do now is we say, okay, we need to make a move. What are the potential moves that we can make from this position? Well, we could go here, we could go there, we could go whatever, right? We have a certain amount of moves that we can make. And we're going to draw out all of those moves onto their own separate branch. So imagine that this green that I'm drawing here is all the moves that our AI could potentially make from this position. These moves will be different, they'll all be unique, but these are some of the moves that they could make. All right, so this is green's move. Now, after green moves, well, red has the potential to move from each position that we potentially move to, right? So each of these moves are going to now have a new position where the piece that we move will be changed. And from there, this board will be given some kind of score, right? And then red will get a chance to actually move as well. So what we'll say is, okay, in this position, maybe red has, say, 2 moves like this, right? Or maybe it has 3 moves, we can draw it like that. From this position, maybe red has 2 moves, and from this position, maybe red has, say, 4 moves that it could potentially make. All right, so these are the moves that it makes. And you can imagine that we can continue this tree on to whatever depth we desire in terms of how many moves forward we want to look. So maybe we continue on again and we say, okay, after red moves from this position, we can potentially move to here, 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 or here. To keep this simple, I'm just going to keep this at a depth of 2 to explain it to start, but we can, of course, put this to a higher depth if we want. So just imagine this is kind of how we're looking forward. It goes red move, or it goes green move, red move, green move, red move, and that's how we consider, based on every single move we make, where the other person might go. Now remember that when we talk about minimax, red is trying to minimize its score and green is trying to maximize its score. So let's say we reach the depth that we're satisfied with. We're only going to go depth 2 or depth 3, whatever you want to consider this depth being. Now what we start doing is evaluating all of the positions. So here, when it's red's move at depth 3 or depth 2 or whatever this is, we'll just, put a line here. At this position here, red is going to get some kind of score for whatever move it decides to make. So let's say that one of the moves score is maybe like -3, maybe another move score is like -1, and another move score is 4. So we're going to assume that red is going to take the minimum of these potential scores, right? So it's going to take whatever is going to favor it the most, so it will move into the position that has a -3 score. So what we do now is we draw a -3 here, which tells us, okay, if we make this move, whatever it ends up being, red is going to take this -3 score because that is the minimum score that it can get based on the move that we just made, right? If we move into this red position, or green position, now red has 3 potential moves it can make. It's going to take -3. All right, so now we'll do the same thing over here. So we'll say, okay, -3 is scored there. Now red has 2 moves based on what move we make here. And maybe those moves are like 2 and 3. Those are the scores that red can get for moving into those positions. Again, red is trying to minimize its score, so we know that red is going to take the score that has the lowest value, which in this case is 2. So we draw 2 here. And now, same thing, we move over here. Maybe we have a -1, -1, maybe we have a 3, and maybe we have a 4. Well, we know red is going to take one of the -1 scores. It doesn't really matter to us which one they take, so we write -1 here. Now we're looking at this level because we've evaluated all of the positions that red could do based on the moves that we can make. And hopefully this is kind of making sense, or it's starting to click. Now it's green's turn, right? So based on any of these moves that we make, these are the score that's going to happen based on what red will take after. So what we want to do is obviously pick the move that's going to give us the maximum possible score. So we would pick 2, and we would put 2 right here, which would mean we would decide to move here. And we could assume that after that, red would decide to move here. Then we start this process all over again. Red's made its move. It may or may not have decided to go where we thought it goes. So now we consider again at our current position, all of the moves we could make, all of the moves red could make based on all of those moves, and pick the best possible move for us based on what red decides to do. Hopefully that makes sense, but that is the basic explanation of the minimax algorithm. Red tries to minimize its score and green tries to maximize its score. And we make the assumption in this that red is going to take the best possible move that it can make from any position. Now, it may not do that, but we're going to assume that it does just to make sure that we're set up for the best possible position that we can be. Now, it's actually a really powerful algorithm, and you can potentially say if we extended this depth even further, right? And we had, okay, now green can go here, green can go here. You can do this to an infinite depth. But that also means this gets exponentially larger, right? We don't know how many potential branches we're going to have, and we're branching off, potentially 10 or 20 times off every single move. So as soon as we add another depth, we're increasing this exponentially, which means that this is going to be a lot of computations as if we go to a depth that's too high. So for us, considering about 3 moves ahead is totally fine. That's probably what we'll do, which will mean our tree will look something like this. So we'll consider what red will do after our move, and then what we'll do after red's move. And that will tell us what the best potential move should be. So hopefully that explanation makes sense. There is a way to optimize this. It's called alpha beta pruning. I'm not going to talk about that in this video just because we don't need to do it. And it's something that I kind of want to leave for homework for you guys if you care to add it. I'd rather add the kind of default algorithm first and then discuss how we would go about what's known as pruning the tree. So removing potential paths that we know wouldn't be any good. Essentially, that's what alpha beta pruning is. Okay, anyways, that's the explanation for Minimax algorithm. Hoping it makes sense, and in the next video, we'll actually go ahead and implement this and get into the code. Hello everybody, and welcome to part 2 of the Checkers AI tutorial. So in this video, we're actually gonna be implementing the Minimax algorithm. Now, the first thing I wanna do though is make sure you guys are set up with the code. So please go to the description and download all of the code. So this is what it's gonna look like here. I'm gonna walk through it quickly just to make sure everyone's clear on how all of this stuff works. But if you wanna see how you actually build all of this code, again, I already made a series on just walking through and building this checkers game. Of course, if you're interested in the AI, then just download the code and we'll go from there. But anyways, when you download the code, you'll see that there is a main.py file, there's a checkers folder, an assets folder, and some init.pys. Main.py is actually how the game is played in terms of the UI side. So this allows us to select certain pieces, move, so on and so forth. Now we're going to be modifying a few bits of this code. So the first thing I want to do is just kind of explain to you how this works. So in main.py, it's pretty simple. This is really just what is actually getting the user's input. So you can see we kind of have a main game loop here. It's checking if someone has won. If it does, you know, it's printing the winner. And actually what we should do in here is say run equals false, which means we're going to quit the game. So this is the first addition we can make on line 27 if someone has won the game. Now, what else we see is we have game.select, game.update. Game is a class, and that represents the state of the game. So game is actually kind of like, I don't want to call it an API, but it kind of is just an API that we can use to play a game of checkers. If you go ahead and look in this class, you can see we have an update method. This simply updates the display and draws it. We have winner, we have reset, we have select, which will allow us to actually select a piece or potentially move a piece. We have the move method, we have draw valid moves, and then we have change turn. So we can use all of these things within this class, like any ones that don't have an underscore before them, we can use them. And essentially that is just kind of how we actually play checkers. So within this class, we actually create a board from this init method. A board is another class that we've set up. The board handles the state of the board, so holding all of the pieces, allowing us to check what the valid moves are. It's the actual checkers board. Whereas the game is more handling like, okay, can you move there? Can we allow the board to move over here? Whose turn is it? That's kind of what the game is handling, whereas the board is handling more of the state of the actual game, and it's less concerned with what the user's actually doing. So if we have a look here inside of board, we can see we have some stats related to how many kings are left, how many pieces are left as well, so red left and white left. We have some methods to draw the squares, so the actual checkerboard squares. We have this move method, which will actually move a piece to a certain row and column. We have get piece, which given a row and column will give us the piece that is at that row and column. We have create board, obviously this is setting up the board. We have draw, which is drawing everything, and then remove, that's obviously going to remove a piece or pieces. We have get valid moves, which given a piece will tell us all of the valid moves that this piece could move to. We have traverse left and we have traverse right, which is handling how we actually determine where we can move to. And that's it for board. Finally, we have piece. This represents one singular piece. It stores simple things like the color. If this piece is a king, its XY position. It allows us to draw it and to move it. And that is kind of the basic setup. Now we're going to concern ourselves mostly with this game and board class. We'll just need to use them because as the AI, right, we're trying to build this AI. We need to know, first of all, well, where can the AI actually move from this position? Okay, we need to have a board that we can use to score, right? So we're going to need some way to evaluate the positions. We need to figure out all of the pieces that could potentially move. So we need to actually add a few things to this code to allow that to work. We'll do that. Actually, maybe we'll do that now. Maybe we'll do that after. In fact, let's do it now. So the first thing that I want to do is I'm going to go inside of this board class. Again, go inside of here if you just downloaded the code. And what we're going to do is simply add an evaluate method. Now, the evaluate will tell us, given the state of this board, what is its score. Now, we'll use a really simple evaluation method, which is going to take into account how many kings we have and how many pieces we have. So define evaluate self. Now this means if we have a board object, we can just call .evaluate on it. It will return to us some number, positive or negative, telling us the score of this board. Now in the last video, I told us that to score a board, we would simply subtract the amount of white versus the amount of red. Now we can do that if we want. So we can return self.whiteleft minus self.red, red left, like that. And that will give us a positive, negative score. White's going to be our AI. So if white has more pieces left, obviously this is going to be positive. Now that's fine, but I would like to incentivize our AI to actually try to become a king if it can. If I don't do this, it means that it's not going to prioritize moving to the end of the board. It's just going to kind of slowly move its pieces upwards. So if we actually prioritize it becoming a king, then it's more likely that we'll see a forward progression and that it actually will try to become a king, which obviously is an advantageous piece to be. So what I'm going to do is simply subtract this, and then I'm going to multiply the red kings and the white kings by a negative and positive number and add them together. So what I'm going to do is I'm going to say plus, in this case, the self.white kings left multiplied by 0.5. So that means if we have, or sorry, not white, we'll say white kings, my bad. So self.white kings multiplied by 0.5. And then we'll subtract here the self.red kings multiplied by 0.5. So what this will do is essentially just give us another value, right? So if there's more red kings than there is white kings, then obviously this will be 0 minus, this means we'll actually be subtracting whatever the amount of red kings times 0.5 is from this evaluate. Or from this score, sorry. So hopefully that makes sense, but this is what we're gonna use. Feel free to tweak this, mess around with it, make it more complex if you want. The better we make this function at evaluating the board, the better our AI is going to be. All right, now that we have that, the next thing that I need to do is actually make a method that can return to us all of the pieces of a certain color. The reason I need this is that we can simply use the board. If we have a look here, it says get valid moves to get all of the valid moves for a specific piece. But if we want to check all the moves that a possible color could make, what we need to do is determine, okay, what are all of the pieces on the board that are this color, and then check all of the valid moves for all of those pieces, right? If we have 10 pieces, all of those 10 pieces could potentially move, so we need to actually get all of those pieces. So again, don't be too concerned about this because this is code that you guys haven't written yet. I wouldn't expect you to understand it, but just a few things that we need to add. So define get underscore all underscore pieces, like that. We'll put self in here and we'll say color. Now what's going to happen is we're going to pass a color in here, an RGB color, so either red, green, blue, whatever the piece color is, and we will loop through all of the pieces that we're storing in this board and return the ones that are that color. So I'm going to say pieces equals a blank list, and just try to follow along here. Although this code will be in the description as well. So not only the old code, but the final new code. And I'm going to say for, in this case, row in self.board. So if we have a look here, this board has an internal representation of all of its pieces. It's actually a two-dimensional array. It looks something, say like this, where, you know, let's just imagine it was like a 3x3 checkerboard. It would have like a piece object. It would have a 0 if there wasn't anything there. It would have a piece object. It might have 0, piece, 0. So essentially, if there is a piece in that square, it stores a piece object. Otherwise, it stores a 0. We can figure out where a piece is by looking at its position in the list. In this case, this piece would be at 0, 0 because it's in the 0th row and the 0th column. This would be at 0, 1 because it is in the 0th row. This would be 1, 0 if we're going to go row columns. This would be in the first row and the 0th column. All right, so that is kind of how that works. Hopefully that makes sense, but we'll say for row in self.board, and we'll say for piece in not self in row, and we'll say if piece does not equal 0 and piece.color equals color, then pieces dot append piece return pieces. All right, so make sure I spell piece correctly, or pieces correctly. Hopefully this is pretty straightforward. Again, just looping through all of the rows. For each row, we're gonna loop through all of the pieces. If the piece is not 0, we will check and see what color it is. If it is the color that we requested, we will add it to the list and we will return it. Okay, so that is, I believe, all we need for the board. We now need to go to game, and I'm just gonna add one method here because we'll need to do this. I'm gonna say define get underscore board. And all we're gonna do here is say self and then return self.board. Now, actually, I'll add one more thing as well. So get board is just saying, okay, we have this board object, right, that's stored here. We were gonna wanna get that when we actually start using the algorithm. So we'll just add a method to return that. Next, what I'm gonna do is say define AI underscore move. Now, this is a bit preemptive. You're not really gonna understand why we're doing this right now. But essentially, when our AI makes a move, what it's gonna do is just return to us the new board after its move. So rather than saying like, oh, I'm gonna move this piece here, which we could do, but that will be kind of complicated, what I'm gonna do is just make it so that we can just pass a new board object to the game and it will simply update the game with that new board object. So all we're gonna say is self.board equals board, and then we're gonna say self.change turn. So we'll simply change turns right here after we get this board, or after we update the board, because obviously if it's white's turn, well, we need to change it to red, and you can see that that is what this does. Okay, so now that we've done that, we're looking good. What I'm gonna do is add a new folder inside of this directory, not inside of the checkers directory, sorry, but inside of the like upper level directory that I'm in, and I'm gonna call this mini-max. Now inside of mini-max, I'm gonna add a file. This is underscore init.py. What this is gonna do is make Minimax a package, which means I can import stuff directly from this Minimax folder. Inside of here now, what I'm gonna do is make a new file. I'm gonna call this algorithm.py, and you can assume what's gonna go in here, obviously the algorithm that we're about to write. Now I will be referencing my other screen just because this is a complicated algorithm somewhat, and I just don't wanna mess it up for you guys. So I will be looking over there if you see me kind of peering to the left. Anyways, what I'm gonna do is start by importing a few things. I'm gonna say from copy, import deep copy. We're gonna use this in a second, but what we're essentially going to do is copy the board a bunch of times. What deep copy does is we'll make a actual, it's kind of hard to say this, but you can make what's known as I think it's called a shallow copy or a deep copy. A shallow copy will simply copy the reference to a object, whereas a deep copy will copy not only the reference, but the object itself. So essentially said I did something like this, right? X equals list, Y equals X. If I modify X or Y, it will modify both of the variables. Like if I say X0 equals 1, then that means Y0 will equal 1 as well. Obviously, we don't want that when we're going to be doing this algorithm. So if we said something like Y equals deep copy of X, then what would actually happen is if I modified X or Y now, they won't modify each other. That's the basis behind deep copy, but we'll talk about that after. I'm going to import Pygame, and I think that's all I need for right now. I'm also going to define the two colors we're going to be using. So I'm going to say red equals 255.0.0. By the way, if you don't have Pygame installed on your system, you will need to install that to get this to work. I'll quickly show you how to do that. What you can do is open up your command prompt or your terminal if you're on Mac or Windows. And what you need to do is simply type pip install Pygame. If you're on Windows, this will be the command you need to run. Press enter. Obviously, you need to have Python on your system for this to work. And if you're on Mac or Linux, type pip3 install Pygame. For some reason, this doesn't work for you. I will leave videos in the description that say how to install Pygame on Mac and how to install Pygame on Windows. And I will also leave cards to them in the corner. It should be the top left or right-hand corner where you guys can have a look at those and follow along with that. Then come back, install Pygame, and be good to go. All right, so we have red. Now I'm going to say white. Now in Pygame, when we define colors, we define them with RGB. Obviously, all red, 0 green, 0 blue is going to be red, and all of the colors is white. So 255, 255, 255. Now what I'm going to do is I'm going to say define mini max, and inside of here, I'm going to say position, depth, max underscore player, and game. Now, position is going to stand for the current position that we are in. So what position will actually be is a board object. So we have boards like this, right? And what we will do is we'll pass different boards to the Minimax algorithm and say, okay, based on this board, give me the best possible board after this that I should move into as the white player or as the red player. So we have position, which stands for really the board. It's telling us, okay, this is where we are, what current position we're in. Depth is telling us, okay, how far am I making this tree? How far am I extending this tree? We're going to decrement this, and this is going to be a recursive call, which means every time we call this, the depth will decrease by 1. Next, we're going to have max player. This is going to be a Boolean value that tells us, okay, are we minimizing the value or are we maximizing the value? So if max player is true, then that means we are trying to maximize. If min player is max player's fault, we are trying to minimize. Again, that means we technically could use this AI to have the AI play against each other, white and red, which maybe we'll show later. Next, we have game. Game is the actual game object that we're going to get right from here in this main.py file. We're going to pass that to the algorithm. And what that will do is then strip out anything it needs from that and potentially draw some stuff on the screen if we want to do some visualization. All right, so the first thing to do inside of the Minimax algorithm is to determine what our depth is. Now, remember that we only evaluate a position when we reach the end of the tree. So in our previous example, we had the root node, and then we had 2 side nodes, right? And then, or 2 or 3 nodes after that. And then after all those nodes, we had other nodes, right? So it went like the red move, or it went the white move, and then the red move, and we evaluated at the red move and bubbled up those evaluations upwards. So we're only going to actually make an evaluation if the depth of our tree is at 0. So if we're looking at the last node essentially in the branch that we're on. So I'm going to say if depth equals 0 or position.winner. Now remember that if we look at board, we have this winner method that I put somewhere, maybe at the top. I think I had winner. Yeah, winner is right here. So we can check if someone has won the game. So essentially, if position.winner, we can just say it does not equal none. Then what we're going to do is return position.evaluate and position. Now I'll talk about why we're also going to return position afterwards. But the point of this is essentially to say, okay, if the depth is 0, so we're at the last node in the tree, meaning we're not going any further than this. Let's get the actual evaluation of that position. And then let's return this current position alongside of its evaluation. So we know what evaluation goes with what position. Now, when I say or position.winner does not equal none, what I'm trying to say is, well, if we've won the game, then the game is over. There's no need to continue evaluating, right? So that's what this is saying. All right, so now I'm going to say if max underscore player and else. So the reason for this, you can kind of guess, is because, well, if it is the max player, then we're going to do something different, maximize the score. Whereas if it's the min player, we're going to minimize. So these two blocks here, the if and else, will be similar. We can actually copy and paste them and change some things, but it's just because max and min. So the first thing I'm going to say is the max evaluation that I've seen so far is negative infinity. Reason for this is because whenever we check a new position, we're going to determine which one is the best. And well, if we haven't checked anything yet, then currently the best that we've seen is negative infinity, right? Meaning if we see anything else that has a score higher than negative infinity, which they all will, we'll consider that the current best until something else comes along and beats it. Next, I'm going to say best underscore path equals none. You can guess what, or actually instead of best path, let's say best move equals none. You can guess what that means. That's going to store the best move that we could make. And then we're going to say for move in get all moves, which I'm going to write in a second. This is going to be a function. What this function will do is get all of the possible moves for our current position. So we'll pass it the position. We'll pass it actually the color that we want to consider, which in this case is going to be white because the maximizing player is going to be the white player. We're just going to hard code that in there. And we will pass it the game in case, again, we want to draw anything for visualization purposes. So actually, rather than waiting before we write this, I'm going to write this now just so that the get all moves function, just so that it's clear and that we don't get too confused and then go back to it. So I'm going to say define get underscore all underscore moves. What this is going to take is a position, it's going to take a color, and it's going to take the game. Now, the point of this function is to get all of the possible moves that we could make from the current position. So that is why, again, within this board class, we just wrote that method that got all moves. I forget where I put it, but I think it was like, yeah, get all pieces. So that inside of here, we can get all of the pieces, and then we can check all of the moves for those pieces and add those into a moves list. So I'm going to say moves equals a blank list. Moves, what this list is going to store is it's going to store the new board. So it's going to look like this: board and piece. Essentially, it's going to say, okay, if we move this piece, this is what the new board will look like if we move it to a certain position. So this is the piece and this is the new board. And then we'll have a bunch of these that'll say, okay, this is, another new board. So new board, and this is a piece that we move to get that new board. So moves equals a blank list. And I'm going to say for piece in board dot get all moves, or not get all moves, sorry, get all pieces. And we just need to pass it the color. So we'll simply pass it color like that. And what this will do is get all of the pieces of that certain color. Now I'm going to say valid underscore moves equals board dot get all valid moves, or get valid underscore moves. And we'll just pass it the piece. So hopefully this is making sense. Loop through all the pieces in the board. They're the certain color, get all of the valid moves for that piece on the board, and then say for move comma skip, which I'll explain in a second, in valid moves dot items, like that. Now we're going to do something. So valid moves dot items is saying, okay, I want to loop through, since this is a dictionary, all of the items. Now the items is a key value pair, right? And the key value pair is going to say row column colon, and then it's going to have a list of all of the of all of the pieces that we would skip if we move to this row column. So the way that I've kind of done this is that the keys are going to say, okay, if we move this piece to this position, to this row column position, we will skip over and need to remove these pieces. That's, say, if I jumped over another piece, then there would be pieces or a piece in this list to tell me which one I need to remove if I take this move. Most of these won't have anything because most of the moves we make won't be jumping over someone else, but they potentially could be, right? So that's what we need to consider. All right, so for move skip in valid move.items. Move, again, is that row column tuple. Skip is a list of the pieces we would skip. What I'm going to say is temporary board equals deep copy board. So I need to do this, and sorry, instead of position, I'm going to call this board. It's really the same thing, but board I think is just more clear here. So we'll say board, but I'm going to deep copy the board because I'm going to be modifying this board in order to determine when I move to this position, what the new board will look like. So I don't want to modify the same board. I want to make a copy of it every single time so that the next piece that I consider has a fresh board that it could potentially move to. Hopefully that makes sense, but we just can't have it be the same board. Otherwise, every time we move a piece, it will move on the same board, which means when we're running this algorithm, the board will permanently move to all of the things that we're just trying out, right? Which obviously we don't want. So now I'm going to say new board equals, and this is going to be a new method, which we'll write in a second, simulate underscore move of piece, move, and then 1 second here, we need to pass the temp board, game, and skip. Now, I'll write this method in just a second, but imagine that what this is going to do is, or we haven't written this yet, but this function, sorry, imagine what this is going to do is take the piece, take the move that we want to make, take the temporary board, and then make that move on it and return to us the new board. That's what it's doing. It's telling us, okay, if you make this move, the new board will look like this. And then we're going to store that, and we're going to put that in our moves list. So we're going to say, all right, moves.append the new board, like that, and then comma, the piece. So we're going to say, all right, if this piece moves to whatever move it is, then the new board will look like this. And then we'll score that board from inside of here, and we'll see which board is the best, and we'll return that, and that will be the board that we then set in, like, technically the move that we make. So I hope that makes sense. But in here, I'm going to say return moves, and now I'm going to write the function for simulate move. So define simulate underscore move like that. This is going to take a piece. It's going to take a move. It's going to take a board. It's going to take game, and it's going to take skip. All right. So what we're going to do in here is simply just say, if I can look at it here, board dot move. So what I'm going to do in here is now move the piece. Now, if I go to the board method here and I have a look at move, it takes a piece and a row and column we want to move it to. So what I'm going to say is board dot move piece, and we're going to move that to the move 0, move 1. Now, the reason I have to do this is just because this is a tuple, so I just need to split it up and make it 0 and 1. So this means we'll get the row and then we'll get the column. So we'll move this piece to that row and column. And then I'll say if skip, which means, okay, if we skipped over a piece or we jumped over a piece, then board.remove skip like that, and then return this board. So return board like that. Now, technically, we don't really need to return the board. I'm just going to do it because it makes sense. We could just actually not have new board equal to this and just use the temp board inside of here, but it doesn't make a big difference, so we'll leave it like this. Okay, but that is the basics for simulate, move, and get all moves. So now we can move back into our minimax algorithm. We're actually almost done, but I have to write this core algorithm part now. So inside of here, what I'm going to do is I'm going to say move, child, comma, underscore. And in fact, now that I'm thinking about it, let me just say, let me just leave move where it is actually. And let me go here and just not add piece and actually just add new board, because I'm thinking about it now and I don't really care about the piece that moved, because at least for right now, I'm not drawing it anywhere. If we do decide to draw the piece that's moving and draw a circle around it and all that, which we might do, then I will add this back. But anyways, what I'm going to do is just say new board like that. So I'm going to get rid of the list that I had and just go back to new board. All right, so new board is there. Now we're back here. I'm going to say for move in get all moves. Now what I'm going to say is evaluation. So I would write eval, but evaluation is what I have to write, is equal to mini max of the move, the depth -1. I'm actually going to write false here. And then for the game, I'm just going to pass game again. All right, so before anyone gets confused with this, essentially what I'm saying is, okay, for every single move that I could potentially make, I want to evaluate that move. Now, how I evaluate that is I call minimax. Minimax will, if this is the last branch in the tree, so if depth is equal to 0, it will give me that position's evaluation. If it's not, it will go through and it will do what's about to be programmed here again. So it's a recursive call. We start at the root node and then we say, okay, well, I want to consider the 2 moves I could do from here. All right, so I can go left or I can go right. Imagine those are the 2 possible moves. So from there, we branch down to those, and now it says, okay, well, we want to evaluate these. So what can I do from these? Well, I can go here, and then it says, okay, well, I want to evaluate these. What can I do from here? And then it keeps going until we reach the depth that's desired, where it starts evaluating those positions, and then they bubble up. So it says, okay, well, this is -5, this is -4, so we're going to pick -4, and then that goes back and back and back, and that's kind of how it works. I hope that makes sense. This is just kind of recursion. It's hard to explain this with this example because it's kind of complicated, but this is essentially getting an evaluation for each of the nodes that we're considering. All right, so max evaluation is going to be equal to the max of max eval and evaluation. So this is saying, all right, well, now we got our evaluation. Maybe it had to go all the way down to the left and had to check a bunch of different things, but we know how good this move is. So we're going to see, is it better than what we already have in here? If it is, we'll change that. Otherwise, it will stay the same. Then what we say is if max eval equals evaluation, we'll say the best path or the best move is equal to the current move. And what this is going to do is keep track of, okay, so if the move that we just looked at is the best one that we've seen so far, then let's set that in this variable so that we know that this is, the best board that we possibly have, or the best move that we can make. And then what I'm going to say is return the max evaluation and the best underscore path. So what this will do, imagine if I call this one time, right? I call this minimax algorithm the first time. If it's the max player, it will go through all of this. It will determine the maximum possible move we could make and the best path and return that to me. Now, of course, that's not going to happen until we do all of these recursive calls. But after all of this stuff has finished, it's been evaluated, we will know what the best path is and we'll be able to return that from here. Now, we don't care about what the best path is when we actually are inside of here. So what I need to do is where it says minimax is I'm just going to take minimax of 0. The reason for this is that minimax returns to us a position or some board as well as the value for that position or board, right? It tells us the best or the worst one depending on how we're calling it. So I'm just going to strip off the fact that it's giving me the path and just take the number. Only when I'm returning back to the caller, do I care about actually keeping the best path. So I know this is confusing. This is an advanced thing, but let's just keep going and hopefully it's somewhat making sense. So actually I'm going to copy all this now and I'm going to put it in here. And we're just going to change some of these things to say instead of max eval, this is going to say min eval. This is going to be positive infinity because the worst that we've seen so far is positive infinity. We're going to say for move and get all moves. Instead of white, we're going to say red. And then we're going to say evaluation equals minimax of move, depth -1. Instead of false, we're going to say true. Again, the reason for this is that after we look inside of here, right, we're evaluating for the best player here. So if we're going down another depth, then we need to consider what it's going to be for the worst player. So it's like flip-flopping. So what will happen is it will start by going into this if statement. Then this will be called with false, which means we'll then go into this statement. Then say we branch even more, then this one will be called with true, which will go into this statement. So it's going back and forth between red, white, red, white, red, white to figure out the mini max, right, of whatever nodes we're considering. Okay, so, and sorry, not best path, this should say best move. And instead of best path, again, this will say best move. And now let's just change a few things. So instead of max eval, it's going to say min eval. Was the min eval of min eval and evaluation. And we'll say if the min eval equals evaluation, then the best move equals move, and we can return the best move. So, and instead of max eval, return min eval, best move. So believe it or not, this algorithm is actually finished. Now I'll show you it functioning in a second. We do actually have to still call this, but let me just run through one more high level time how all of this works. So minimax, it takes some board, which is telling us the details about all of the pieces on there, some depth, which is telling us, okay, how many positions do I want to consider? Tells us, are we looking to maximize this score or minimize this score? And then the game. Game is relevant right now. We might use that later, which is why I kept it in, but you can remove it if you want. And then I'm going to say if depth equals 0. So if we're at the furthest down that we can go when we're considering, then what we'll do is say position.evaluate and return the position. Or, of course, in the situation where someone has won, there's no more further to go down. We've won the game, so we just return this position and the evaluation. Now, the reason I'm returning both is, again, because just the way this works, we need to return two things so that we can get not only the best possible number, right? So we get, the highest number, the lowest number, but we also get what position corresponds with that so we know where to move to. Anyways, it gives us that. And then in the situation where the depth is not 0 or someone is not 1, we say, okay, are we maximizing or minimizing? For maximizing, we run this. This says, all right, the max eval starts at negative infinity. The best move yet, we don't know. And we say for move and get all moves. First, we get all of the moves related to the current position for the color white, which is the maximizing player. Then what we do is we loop through all of these moves and we evaluate these moves with the minimax algorithm. So we say, okay, well, if we're only at depth, say 2, and we need to go to depth 0, then let's check what the minimax of this move is, right? It's recursive. So then we call this minimax, and we would go and we would repeat this process, and we would then, in this case, go to the minimizing player if the depth was not 0. Then the minimizing player would do its thing. It would return to us what the min evaluation is. It might potentially have to call minimax again. And then all of a sudden we have an evaluation for whatever move we could potentially make. Now we check, okay, is this evaluation better than what we currently have? If it is, we set it and we set the best move. If it's not, we keep going until we've considered all of the possible moves. Works the exact same thing for min evaluation, and hopefully that makes sense. I think simulate move and get all moves are good enough. And let's just make sure valid moves is spelt correctly. Okay, a lot of talking. Sorry, I know this is complex. I'm trying my best to explain. Now let's go into the main loop and I'm going to show you how we can do this. So right now, the game currently works like we can select a piece, we can move a piece, blah, blah, blah. Now, if we just run this right now, none of our algorithm, oh, it's telling me invalid syntax, 1 second. Our algorithm obviously isn't going to run because we haven't called it. And right now you just play 2 players. So what I'm going to do is simply add a thing inside of here that says if game dot, I think, do I have get turn? No, I don't. I can just say if game dot turn equals white, which means the computer, then let's call the minimax algorithm on the current board. So let me start by importing it. I'm going to say from, and remember minimax is in its own folder. So I say from minimax dot algorithm. Did I call it algorithms? No, it should just be algorithm. Import minimax. All right, so now we have that. So inside of here, I'm going to say minimax, and I'll actually say the new underscore board. I'll say value comma new underscore board equals the minimax of the game dot get board, because we want to get the board from this game, the color, which is white, and then we'll just pass the game object. All right, so value new board. What is it saying here? Undefined variable white. Okay, let me just import white from constants. You guys can just add this right here, comma white, and then that should fix it for you. All right, so value comma new board equals minimax of game.getBoard white game. Now what we're going to do is say, okay, game.ai move new board. What that's going to do, right, is it's going to say, okay, well, the AI has moved, so let's update the new board to be whatever board this is. And then that will actually change the turn for us, and then it will allow the red player to move again. Okay, I know this is a lot, but let me just test this and see if I messed anything up. And what did we get? Minimax missing 1 required positional argument game. Interesting. So let me go back to minimax and see what we've done. I forgot to add the depth. Sorry guys. So what we need to do is say game.getBoard, and we need to pass a depth. I'm going to pass a depth of 3. You're going to notice if you're on a slow machine, this will take a while. Go up as high as you want with the depth, but that means the higher the depth you go, technically the better the AI will be, but the longer it will take to run. So, you know, you can kind of pick your poison on what you want there. But let me go and move. And whoa, okay, we got some crazy thing happening here. So let me just quickly check what's going wrong. Notice that a bunch of stuff just moved when really only one thing should move. All right, so I've realized the error. It's kind of a weird one. It's also just based on how I program this game. So my apologies to you guys that we're going to have to make this strange fix. But essentially the problem that was happening is that these pieces are not copied, but the board is copied. So what's happening is when I pass piece in here to simulate move and we move this piece, it's changing the actual piece on the board. So the board itself isn't changing, but it's changing the piece that's associated with the board. So what I need to do is get the new piece that's copied inside of this board and use that instead to pass here. So I'm going to say temp underscore piece equals, I'm not going to deep copy that piece, but what I'm actually going to do is say temp underscore board dot get piece, because this will copy all of the pieces that are stored within the board automatically. And what I'll do is I'll say piece.row piece.call, and then I'll pass a new piece here, and now it'll work. But or sorry, not new piece, temp piece. But what this is saying essentially is, okay, from this new board, get the piece that is in the same position as where this piece would be, and that should work. I don't think we'll have any errors with that, but let me run this and just make sure. Okay, so I've just been playing against this for a minute to make sure everything's working. I think it's all working properly. The white piece has actually managed to get a king piece. I'm not really playing, you know, the most properly ever, but now we're running into an issue where it just keeps going in between king, not king, king, not king. Maybe it just doesn't want to actually move. So let me see what happens if I open myself up to be jumped. I mean, it's still moving like that. Oh, and now it decides to move there. So maybe the AI is just way smarter than I think, and he actually is moving in some of an accurate place. All right, so I've been messing around with it. It seems to work fine. I mean, you guys can play with it yourself and see if there's any bugs. But what I'm going to do now is just show you how we can draw what's being considered by the AI. And I'll actually make the depth 4 and just show you the difference in speed. So now if I run this and I move, we can see that it takes significantly longer to actually make the move. Before, it was happening pretty much instantly. At least, I'm not sure what you guys saw in the video, but it was going pretty quickly. Now it's actually taking more time before it's moving. And if I change this to 5, I almost guarantee it's going to take a really long time to move. So let's see. I move it there, and look at this. It's just thinking. I can't even move it. It's just frozen, right? Because adding that one extra layer makes it take so much longer. So it eventually moved, and that was the move it decided on, but it had to consider so much more. So it will be a better AI, but you'll have to tell your players, hey, you know, you're going to have to wait for it because, well, it's going to have to take some time to think. Now, we could add that optimization technique. As I mentioned, I'm not going to do that, but just wanted to be clear. All right, so now let's go to algorithm. And since we have game inside of here, what we can do is actually start drawing some stuff related to the moves that the AI is considering. And I'll add some like time.sleeps in this so that we can see kind of what it's actually looking at. So I'm just going to make a function here. I'm going to say define draw underscore moves. I'm going to take a game, a board, BOARD, and a piece. Now what I'm going to do is I'm going to say valid underscore moves equals board.get underscore valid moves for the piece. This is kind of redundant. We've done this before, but anyways, it's fine. It's just for the drawing purposes. I'm going to say board.draw, and I'm going to simply pass the game.window to it. I'm just going to go through all this and then I'll talk about what it's doing. I'm going to say pygame.draw.circle, and I'm going to say game.win. I'm going to say 0, 255, 0. I'm going to say piece.x, piece.y, and then I'm going to say 50, 5. Now, what I just did is draw a green circle around the piece. So we're going to pass to this draw moves a piece, a board, and the game, and it's going to draw all the valid moves for that piece just so that we can see it and make sure we're not running into any like critical errors, and you can kind of visualize how this is working. Next, I'm going to say game.draw underscore valid underscore moves. I think that's what I called it. And I'm going to say valid underscore moves dot keys. And then finally, I'm going to say pygame dot display dot update, and then pygame dot time dot sleep. And I think I passed milliseconds into this, so I'm going to pass 100, which means we'll sleep for 100 milliseconds. Now, I know I just like rushed through that. Valid moves, gets all the valid moves for a piece. Board.draw, redraws the board on the game window. So game.win is just the window that we can draw on. Pygame.draw.circle, draw it on the game window. Color green, that's what 0, 2, 55, 0 is. Piece.x, piece.y, this is the middle of the circle. 50, this is the radius. 5, this is the thickness of the outline of the circle. Then game.draw valid moves. This will draw all of the valid moves. The reason I got keys is again because our valid moves look something like this. We have like 4, 5, comma, some piece object in here. So we need to make sure that we just pass the actual row call. We're not passing that piece object to confuse this method. Next, pygame.display.update, that will update the display. Pygame.time.sleep, this will sleep it for 0.1 seconds so that we can actually see it being drawn. Let's run this and see what's happening. All right, so when I do that, nothing happens because I didn't call that method or that function. So we need to call that. I need to remember where I actually end up calling this from because I can't remember, but I think I do it inside of the get all moves. That would seem to make sense. Simulate move, get all move. Yes, let's do it inside of here. All right, so I'm going to say draw underscore moves. And I'm going to draw that with the game, the board, and the piece. Not important that I pass that temporary board or that other piece. We're not going to see them actually moving. We're just going to see them considering these specific moves. All right, so let's now do this. All right, main.py, run, and let's go ahead and move. And what is happening? Pygame has no attribute sleep. Maybe I messed something up. Pygame.time.sleep, is that not an attribute? Okay, you know what, guys? I don't know why that one's not working. Usually that's something... sorry, it's not sleep, it's delay. Pygame.time.delay. All right, that's what it should be. Okay, let's look at this now. And we can see that it's going quite quickly, but it's showing us pretty much what it's considering. And you can kind of see the pieces moving as it's simulating everything as we go through. So this is really what's happening kind of in the back end, is it's moving all these pieces. It's checking, okay, if I move in this position, what's the score? Is this the best position? Should I move here? Should I move there? And notice that it's not only considering the white, it's considering the red, because it has to consider all of our moves based on all of its potential moves. So this is obviously going to take a long time to run through and draw everything. What I'm going to do is just quit out of this game. So close the program. It's not responding just because it's not threaded, so I can't do that. And what I'm gonna do is remove this delay, and you're just gonna watch it literally like zip through, which I think is kind of funny to see. So now what I'll do is go like that, and it just literally spams the screen showing us, okay, we're thinking about where we're going. And there you go. The decided move was to go from here to here. Now, of course, you guys can add stuff to this, play around with it, but that is all I'm going to do for this tutorial. If you guys have any questions, as always, please leave them down below, but that is how you make a checkers AI using the minimax algorithm. I apologize if any of this went over your head. It is difficult to explain this stuff because it is, somewhat complicated stuff, right? This is not the easiest thing in the world. Hello, everybody, and welcome to another YouTube video. In today's video, I'm going to be showing you how to make the famous game Pong in Python. Now, this is a great project for beginner or intermediate programmers. We are going to be using a module called Pygame to accomplish this. However, you do not need to know Pygame, and the features we're going to use from it are very limited. A lot of what we need to code out is the logic related to moving the ball around the screen, having it bounce off the different paddles, implementing score, all of that type of stuff. And you're going to learn a lot in this project if you are not, say, an expert Python programmer already. With that said, let me give you a quick demo, and then we'll actually start writing some code. So in front of me, I actually have the finished code for this project. Whenever I do a tutorial, I code it out first, and then I reference that code while I'm teaching it to you guys, and all of the code that we write in this video will be available in the description. Anyways, let me just run this here, and then we can have a look at the finished product. Okay, here we are. So this is Pong. We have two paddles. You can move one paddle with W and S, and the other paddle you can move with the arrow keys. And you also would be able to implement this as a single player game if you wanted to code like an AI for one of the paddles, which would be pretty easy to do. You can see this is kind of the basics. We have an implementation of Pong, and then of course there's scoring at the top, and I've just made it so that when you get to 10, then the game is over. Now, I'm not going to play through the entire thing, but there you go. That is the project, and I'm going to show you how to make it. So with that said, let's get into the code. So let's go ahead and get started. The first thing we need to do is just set up our environment and install the Pygame package. Now, again, I want to reiterate here that you do not need to know Pygame for this tutorial. I will show you the limited features from it that we are going to use. Now, if you want to learn more about Pygame and make some more advanced games, I have tons of tutorials on my channel, so feel free to check those out. You can probably just go on YouTube and search Pygame Tech with Tim, and you'll see like 10, 20, 30 different videos all going through different Pygame projects. All right, with that said, let's get this set up. So right now I'm in Visual Studio Code. This is the editor I'm going to use for this video. Feel free to use whatever you want. You can use the default idle from Python. You can use Sublime Text. Really doesn't matter. I'm just going to use VS Code. Now I'm using Python version 3.9. You can use pretty much any version as long as it's above 3.6. Other than that, what we need to do here is open up a terminal or a command prompt and install Pygame. Now to do that, we're going to type in the command pip install Pygame like that. Now I already have this installed, so I'm not going to run it, but for you guys, run this command. It should install Pygame. Now this command does not work sometimes. If it doesn't work, try the following: Python, and then you're going to do -m and then pip install Pygame. If that doesn't work, try Python 3 -m pip install Pygame. And finally, if that doesn't work, try pip3 install Pygame. Now, if none of those commands work for you, I have two videos, one for Mac and one for Windows. I will put them up on the screen, and they show you how to install Pygame for the respective operating systems. Okay, so we now have Pygame installed, and we can actually start writing some code. Now, we want to create Pong, so the first thing we're going to do here is just import Pygame. We're going to set up what's known as a display. So in Pygame, we have a main kind of window or display, and that's where we draw everything to. Once we have the display, then we'll implement things like the paddle, the ball, the scoring, handling collision, all of that type of stuff. So I'm going to import Pygame at the top of my program, and now I'm going to set the width and the height for my window. Now you're going to notice here when I'm coding everything out that I'm putting everything in variables. This way our game will be dynamic and you can simply change the value of a variable and everything will just work and adjust according to that. So rather than using kind of hard-coded values, we're going to put everything inside of variables, use the variables for everything, which will make it a little bit more complicated to code out. However, it's going to be really nice because if you want a bigger window or a smaller window or a larger paddle or whatever, you just change the variable. So for the width and the height, I'm going to go with 700 and 500 for right now. By the way, this is a way that you can declare kind of two variables on the same line in Python. Okay, so now that I have that, I'm going to set up my window. So I'm going to put this in a variable called win in all capitals. Whenever I do something in all capitals, I'm making a constant, meaning that this variable is not going to change. So to do this, I'm going to say pygame.display.set_mode. And then inside of here, I'm going to put a tuple and I'm going to pass the width and the height. And I guess at this point in time, it's a good idea to mention that you should have some familiarity with Python. Of course, you don't need to be an expert. You can be a beginner, but you should know things like if statements, while loops, for loops, because I'm not going to explain all of the very basics. Anyways, to set up a window, this is all we do, pygame.display.set_mode, and then we pass a tuple, so just the brackets like this with width and height. Great. Now that we have our window, we can make a caption for it. So the caption is just going to be the title of the window. And to do that, we do pygame.display.set_caption. And for the caption, I am just going to call this Pong. Okay, so this will just be the title at the top of the window when it's actually loaded up. So now that we have this, what I want to do is implement what's known as the main loop of my program, or the event loop of my program, which is actually going to display the window and then draw something onto it. So I'm going to define a function here. I'm going to call this main. And inside of this function, I'm going to declare a few variables that we're going to use to actually kind of show the display and handle all of the events that are occurring. So I'm going to make a variable here called run. I'm going to make this equal to true. And I'm going to do a while loop here and say while run. Now, whenever we have a Pygame Pygame program, we need a main loop. And the main loop is just a loop that's constantly going to be running, that's handling everything related to our game. So it's handling collision, it's moving the ball, it's allowing us to move the paddle. So that's what this is right here. So inside of this main loop, I'm going to write the following. For event in pygame.event.get. Now this will get all of the events like clicking your mouse, clicking the keyboard, closing the window. That's what this loop is doing here, looping through all of the different events that have occurred. We're going to handle those events and then do something. So in here, the first event that I want to check is if we are actually quitting the window. So I'm going to say if event.type is equal to pygame.quit with all capitals for quit here, then I'm going to say run is equal to false, and I'm going to break out of this for loop. Now, what this is going to do is check if we hit the red button in the top right-hand corner of our window, so the close button. If we hit that, we want to stop the main loop, so we actually end up closing the program, and then we want to break. Now, outside of my while loop here, I'm going to say pygame.quit, and quitting is just going to quit Pygame and close the program for us. Okay, awesome. Now, one thing I need to do here is right after I import Pygame, I need to initialize it. So I'm going to say pygame.init. You should run this whenever you import Pygame, just directly below it. It just initializes a few things that you need, and we'll use this later, or this will allow us to do some things later. Okay, so here we go. We have a basic program. We have main, we have run equals true. We have our while loop here, which is going to be the main event loop. Inside of this, we're checking all of the different events. And then what I'm going to do here is call the main function. So I'm going to say if name is equal to main, then call main. Now, what this does is ensure that we are running this module to call this function. So essentially, if we were to import this module, so the solution.py file, then what would happen is this would not run because the name of this would not be main. Now, I'm not going to explain exactly how this works, but it really just makes sure that you're only going to run this main function if you directly run this Python file, not if this Python file was imported from another project or from another file. Okay. Hopefully that makes sense, but when we do this, we should see a Pygame window pop up. There won't be anything on the window, it'll just be a black screen, but that's the thing we need to start out with. Okay, so there we go. We can see it says Pong. We have our Pygame window, and when we click the X, it should quit. Great, there we go, it quits. Okay, so that's our starting thing. Now, the next thing I'm going to do is implement something known as a clock. Now, a clock is going to regulate the frame rate of our game so that it's going to run at the same pace on every single computer. So I'm going to say clock is equal to pygame.time.clock. And then inside of here, I'm going to say clock.tick. And I'm going to pass this an all capital FPS variable, which I'm going to define up here as 60. Now the FPS is the frames per second. And when you put this inside of a while loop, it makes sure that you cannot run faster than 60 frames per second or 60 ticks per second, which means that this while loop here is going to run a maximum of 60 times per second, so that if you're on a really fast computer, it's not going to be running quicker than if you were on a slow computer. Hopefully that makes sense, but that's why we want the clock. It just regulates the speed of this while loop. Now, it's worth noting that if you're on a very, very slow computer, this while loop may run slower than the FPS that you're putting here. This is simply limiting the amount of times it can run. It's not making it run 60 times per second. So on almost all modern computers, it will run at least 60 frames per second, or I guess exactly 60 frames per second. But on a very slow computer, you may run under this, and so you may see some lag in your game if it's a really slow computer. Just wanted to note that because some people have mentioned that in my previous Pygame tutorials. Okay, so now we have our clock, and the next thing I want to do is implement something to actually draw some stuff onto the screen. So I like to handle all of my drawing in a separate function so it's really easy to see where I'm drawing everything. So I'm going to make a new function here, and I'm just going to call this draw. And this is going to take in one variable, which is going to be the window that we want to draw on. Now inside of here, all I'm going to do for now is fill the window with a specific color just to show you how that works. So I'm going to say win.fill, and then here I have to pass an RGB value. Now RGB is red, green, blue. Now I could just pass the RGB value directly in here, but I like to define all of my colors or RGB values as variables. So I'm going to make one called white, and this is going to be equal to 255, 255, 255. And then I'm going to make one called black, and this will be equal to 0, 0, 0. Okay, so those are my two colors up here. And what do I want to fill the window with? Well, we are going to fill it with black, but for now I'll just put white so we can actually see what's showing up. Now, whenever we do some type of drawing operation in Pygame, we need to update the display manually, and then it will actually do all of the drawing. So when I do something like a win.fill, this is filling the entire window with white, so it'll change the background color essentially to white. But for this to actually happen, I need to say Pygame.display, not clear, but .update. Now this will update the display and perform any of the drawing operations that we've done. So maybe I've done a few other drawing operations, so I'm going to do all of those and then update the display. And updating the display is kind of the most intensive part. So doing the actual drawing does not take very long, but updating the display where it applies all of the drawing, that's going to take the longest. So you only want to do this after you've done all of your drawing. Okay, I'll continue to explain that in a second, but for now, inside of my while loop, I want to call this draw function, so every single frame we're continually redrawing the window. So let's call draw here, and let's pass to it the all capital win, which is going to be the window here that we want to draw on. Okay, hopefully that makes sense. Let's run the program now and see if we're getting a white screen. Okay, so notice we're getting a white background. Perfect, that is what we wanted because we are filling the window with white. Now I'm just going to change this to black because we actually want a black background. I just wanted to show you how win.fill works. So now that we've done that, what I'd like to do is implement the paddles. So I want to add a paddle on the left side and a paddle on the right side, and then I want to see the paddles actually be able to move when we hit the different keys on the keyboard. So I'm going to make a class here, and I'm going to call this paddle. And the reason why we're going to do this is because we're going to have multiple paddles, and we want their movement and different properties to be stored as an object so that we don't have to kind of repetitively code this up. Now, if you're unfamiliar with object-oriented programming, I'll explain kind of the basics of what I'm doing here, but I do have a ton of videos on my channel explaining object-oriented programming in Python. Okay, so for the paddle, I'm going to say define init. Now, this is essentially what's going to be called when we initialize a paddle or create a new paddle. And what I want to take in for the paddle is an x, y, width, and height. Now, our paddle is just going to be a rectangle. One will be on the left-hand side, one will be on the right-hand side, and they're going to have different x and y coordinates on the screen. And we're going to change the y coordinate based on where we're moving, right? So if the user presses the up arrow key, we want to move it up. If they press the down arrow key, we want to move it down. So I'm going to say self.x is equal to x, self.y is equal to y, self.width is equal to width, and self.height is equal to height. Now, these are the attributes or properties of this paddle, which means that each paddle I create will have different x and y and different width and height corresponding to what we passed here when we created the paddle. So there we go. We have our initialization for the paddles. Now, I want to write a method on the paddles, which is essentially a function you can call on them called draw. Now, draw is going to do exactly what it says. It's just going to draw the paddle. Now, our paddle is going to be a rectangle. It's going to have the color of white. So let's define a class attribute here called color, and let's just make this equal to white because this will be a constant. It's not going to change. So inside of draw, I want to use the window to actually draw my paddle on the screen. So I'm going to say, actually, Pygame. Let's make sure the indentation is correct. Pygame.draw, and then not dot circle. We want dot rectangle like that. And I keep messing up my indentation, so let's fix that. And when I'm drawing a rectangle with Python, well, this is how you do it. Pygame.draw.rectangle, and I need to pass to it where I want to draw it, which is going to be the window, right? And then I need to pass a color. Well, the color is going to be self.color. That's going to reference this right here, which is equal to white. And then I'm going to pass a rectangle. Now, a rectangle is an X, Y, width, and height. So in Pygame, when we draw something, we draw from the top left-hand corner. So in Pygame, 0, 0 is the top left-hand corner, okay, of the screen. So if I draw it something like 10, 10, that's going to be 10 pixels, right, and then 10 pixels down. And then if we're drawing something like a rectangle, for example, the X, Y that we're drawing the rectangle at is the top left-hand corner of the rectangle. And then the width and height is, well, the width and height of the rectangle based on the top left-hand corner. So you'll see what I mean here when I draw this, but I'm going to do self.x, self.y, self.width, and self.height. And that's all I need to draw the rectangle. Okay, so now we have our paddle. So let's create two paddles and let's draw them. So I'm going to go here and I'm going to say my left paddle is equal to a paddle, and I need to pass this an X, Y, width, and height. So for the X, I'm just going to make this 10, so it'll be 10 pixels off the left-hand side border of the screen. Then we're going to pass a Y. The Y I want to be directly in the middle of the screen. So we're going to say height, which is the height of our window. We're going to integer divide this by 2 just to get a whole number. And then we're going to subtract this by whatever the height of our rectangle is going to be, or the height of our paddle. So I'm going to make a variable up here, and I'm going to say paddle, paddle underscore height and paddle underscore width. And this is going to be equal to, just let me look at my screen here, 120. And I realize here that I probably want to go width first and then height second, just to stay consistent with width and height up there. So I'm going to say paddle width, paddle height, and we're going to make this 20 and 100. So that's the values for our width and our height. Okay, so we're going to use that now here. And we're going to say paddle height divided by 2. Now, to explain to you why we want this, let's just quickly open up Paint, and I can show you. So let's zoom in a bit. Let's say this is our window, okay? Now, as I said, here is going to be 0, 0. Now, I'm drawing with my mouse, so just excuse me, but let's write this 0, 0. Now, our height is going to be all the way down here. So height is H. This will be H, okay? So if our height is something like, I guess we have 500, then this coordinate right here would be 0, 500. So the middle of this is going to be height over 2, right? So we have H over 2. But the issue is if I start drawing my rectangle here, I'm going to draw it like this because the top left-hand corner is where I start drawing it from. So what I need to do is draw the top left-hand corner so that my rectangle will be perfectly center. So this will be the center of the rectangle. Hopefully that makes a bit of sense, but to find this position here where we want to start drawing the rectangle from, we need to know the height of the rectangle. Because if the height of the rectangle is, say, 100, then what I'm going to do is take whatever the height of my window is divided by 2, and I'm going to subtract half of this height, which is going to be 50. And that will tell me where I need to start drawing my rectangle so that it's perfectly center in the screen. Okay, that hopefully, again, that makes a bit of sense. We're going to take the height over 2. We're going to subtract the height of our rectangle over 2, and then that tells us the correct height to draw a rectangle at such that it's perfectly in the middle of the screen. Okay, so let's close this here, and let's now implement that. So this is going to be height over 2 minus paddle height over 2. Okay, I guess we already have that. And then what we want for the width and the height is just going to be the paddle width and the paddle height. Now let's copy this because it's going to be very similar for our right paddle. So here I'm going to say right paddle. Except all I'm going to change is where I want the X to be because this is going to be different. And I'm going to say this is going to be the width. And then this is going to be subtracted by 10. Subtracted by, and then this is going to be the paddle width like that. Now, again, the reason for this is that I actually have to go in Paint to explain this. If we want our paddle to be, say, 10 pixels off the right border, okay, then what I need to do is make the X coordinate be here, right? So let's say we want this to be 10, kind of the gap between the right border. Then I need to account for the width of this rectangle as well as kind of the padding I want between the right border. So what I'm doing is I'm taking whatever the width of the screen is, which is going to be right here, okay? So this would be width and then 0, this position. So I'm taking the width, I'm subtracting from the width this 10, which is the padding that I want, and then I'm subtracting the width of the rectangle, and that's telling me the exact x coordinate that I want to put this paddle at. And then the height is going to be the same thing, that's why I've left it the same. Okay, hopefully that makes sense. That is what we have for the right paddle. And now what I want to do is draw the two paddles on the screen. So to do this, I'm going to pass to my draw function a list that contains both my paddles. So I'm going to say left paddle and right paddle. Now I'm going to go to draw. I'm going to take in paddles like that, and I'm going to use a for loop to draw both of the paddles. So I'm just going to say for paddle and paddles, paddle.draw, and then we'll pass to this the window. Now, why am I getting an error here? Indentation. Okay, let's move that over by 1, and now we're good. All right, so the reason I'm doing a list is just because I'm going to do the same thing to draw both paddles, so we can just do a for loop and draw both of them, and maybe sometime down the future we add a third paddle, a fourth paddle. Now we just pass it in the list, and it will draw all of them for us. Okay, so let's now see if our paddles are showing up. Let's draw this, and we got an issue. Pygame.draw has no attribute rectangle. Am I spelling rectangle incorrectly? Let's see, pygame.draw.rectangle. My apologies, guys. This needs to be rect, not rectangle. That's actually how you draw the rectangle, is with rect, not rectangle. Okay, let's try this. Let's run. And there we go. Now we have our two paddles. They are perfectly center in the screen, and they're at the correct x coordinates. Now we want to move the paddles, so let's figure out how we can do that. Okay, so to move the paddles, we need to change their y coordinate, right? Move it up and move it down. Now we need a velocity to move the paddles at. So essentially, how much do we go up or down when the user hits a specific key? So I'm going to add a velocity here on my paddle and make this equal to 4. Now notice anything that's going to apply to all of my paddles, I'm putting as a class attribute, meaning I'm defining it here rather than inside of the initialization or inside of a method. So I'm doing val equals 4. Now I'm going to implement a method on my paddle, and I'm going to say define move self, and I'm going to say up is equal to true. Now what we're going to do here is call this method on the paddle, and if I pass up equals true, we're going to move the paddle up. If I pass up equals false, we're going to move the paddle down by the velocity. So all I'm going to do here is say self.y, and then this is going to be plus equals, and then the self.velocity. But that's only going to be the case if up is equal to false. So I'm going to say if up, then we'll do something. Otherwise, do this. Let me just copy this, and then I will explain what's going on here. Okay, so if self.y, then minus equals self.val. So if we are going up, then we want to move the paddle up. Now to move the paddle up, we need to subtract from the y coordinate whatever the velocity is, right? So we'll do that here. Otherwise, though, we need to move the paddle down. So we'll say self.y plus equals whatever the velocity is. So as the y value increases, we're going down. As the y value decreases, we're going up. So this should now move the paddle up and down. Okay, so now that we have this, we need to actually call this, but we're only going to call this when we are pressing the up or down arrow key. Now, to do this, we're going to have to get the keys that the user is pressing and then allow the paddle to move when they press a specific key. Now, for this game, I'm making it 2-player, so we're going to have W and S allowing the left paddle to move, and then we're going to have the arrow keys allowing the right paddle to move. Now, again, you could implement an AI for Pong. Maybe we'll do a video where we'll implement AI for Pong. Let me know if you want a specific video on that, but for now, we're just going to do it with 2 players. So I'm going to say that keys is equal to pygame.key.get_pressed, and this is going to give us a list containing all of the different keys that have been pressed. Specifically, it's actually going to give us, I believe, a map. It's either a map or a list. Either way, I'll show you how we can access and check if a key was pressed. So I'm saying keys equals pygame.key.get_pressed. Now what I want to do is make a separate function that will handle moving the paddles for me because it's going to be a good amount of logic and I don't want it to kind of clog up my main loop here. So I'm going to call a function, and this will be handle underscore paddle underscore movement like that. We're going to need to pass to this the keys, and we're also going to pass to it the left paddle and the right paddle so that we're able to move them. Okay, so let's make a function now. Let's say define handle paddle movement. Let's take in our keys, and let's take in our left paddle and our right paddle. Okay, So inside of here, we're going to check if the user is pressing the W or S key and move the left paddle, and then the arrow keys and the right paddle. So I'm going to say if keys, and then this is going to be Pygame dot, and this is a capital K underscore W. Notice this is a lowercase w. So if we are pressing the W key, then we want to move the left paddle up. So we're going to say left paddle dot move up is equal to true. Okay, and then we'll say if keys, and this will be Pygame.k underscore s. Then we want to do the same thing, but we want to move it down. So left paddle dot move, and then not down equals true, but this is going to be up is equal to false. Okay, this is now handling the movement of our left paddle. Now let's copy this and do the same for the right paddle, except we're going to do this with the arrow keys. So just a note here, when you want to check a specific key, if it's a letter key or a letter key, then you're just going to do a lowercase of whatever the letter is. So A, Q, W, whatever. If it's something like the shift key or the enter key, it's usually in all uppercases. So for the arrow keys, we're going to say key underscore up or K underscore up. And for the down arrow key, it's going to be K underscore down in all capitals. Now, all we have to do here is change this to be the right paddle and this one to be the right paddle as well. Okay, so now this should actually be working, handling our paddle movement. So let's see if this is working by running our code. Okay, so when I run my code now, I can move my paddles, but notice that my paddles actually go off the screen. So now we need to implement something so we're not going to be able to move the paddle off the screen. So to do that, I just need to check to see that if when we move the paddle, it's going to go off the screen or not. If it's going to go off the screen when we move it, then we're not going to let the user move it, right? So what I'm going to do here is say, we will allow us to move the paddle if we are going up. So if we're hitting the W key and the left paddle dot Y, and this is going to be minus the left paddle dot velocity is greater than or equal to 0. Okay, so if left paddle dot Y minus the velocity, because that's how much we're going to subtract from it when we move it, is greater than or equal to 0, which is the top of the screen, then we'll let it move. However, if it's not going to be greater than or equal to 0, so it's going to go off the screen even by a slight amount, then we're not going to let you move it, okay? Now let's do the same thing down here, except we're going to have to check if you're going to hit the bottom of the screen. So we're going to say, and the left paddle dot Y. This time we're going to add the velocity, right? So plus the left paddle dot vel. We also need to add, though, the paddle height. So I'm going to say plus left paddle dot, and this is going to be height like this. And we're going to check if this is going to be less than or equal to the height of the screen. So the reason we need this is because the Y that we're referencing is the top left-hand corner of our paddle. So when we're moving up, it's fine to check that because that's the top of the paddle, but the bottom of the paddle is the left paddle dot Y plus whatever the height of the paddle is, right? Because that's going to give us where the bottom of the paddle actually is on the screen. If we didn't have this, then what would happen is we'd be able to move it all the way down until it was just barely off the screen, because that's when the Y coordinate is at the very bottom. So we need to add the height to make sure that we're not going to look like we're moving off the screen, right? And now we're checking if it's less than or equal to the height, not greater than, right? Because if it is less than the height, then that's fine. We can continue to move. Otherwise, it's off the screen. Okay, so that's what we're doing. Now we're just going to check the exact same thing here, except for the right paddle for these ones. So I'm just going to change this to be the right paddle and the right paddle. And then same thing with moving down. So let's copy this and put it here. And now let's go right paddle, and right paddle. Okay, perfect. So now this should make it so we cannot move off the screen, because we're only going to move if we are not going to move off the screen. Okay, so let's run this and see what we get. And notice now that it stops at the very bottom of the screen and stops at the top of the screen. Let's just check the opposite, and it is all good. Our paddles now do not move off the screen. Nice. Now that we've done that, what I would like to do is draw a line in the middle of the screen, just because I think that looks nice. I want to draw a dashed line or a dotted line, and I will show you how we do that. So let's go inside of our draw function. Just need to reference my cheat sheet here, because this is a little bit complicated to do. So I'm going to say for I in range, we're going to start at 10 pixels. We're going to draw up to the height, and the increment for our for loop is going to be height over 20. Now, the idea here is that I want to draw a bunch of rectangles to represent kind of a dashed or dotted line. Now, I want the space between the different rectangles to be the same, and I want the rectangle, height to be identical for every single rectangle. So what I want to do is draw one rectangle, not draw a rectangle, draw another rectangle, not draw a rectangle, and kind of have a gap between each of them. So that's what this for loop is going to do, and you'll see how I implement that. So I'm going to say if I mod 2 is equal to 1, then continue. Now, essentially what this means is that if I is an even number, then I'm going to continue. So I'm going to skip this iteration and I'm not going to draw a rectangle. Otherwise, though, I will draw a rectangle. And the way I'm going to draw it is the following. I'm going to say pygame.draw.rect. I'm going to draw this on my window. The color is just going to be white. So we'll draw it white. And then the X is going to be in the middle of the screen. So to do this in the middle of the screen, we're going to say width over 2. But we need to subtract half of the width of the rectangle for the same reason we did that with the height when we were initializing the Y of the paddle. So now if we're looking at it horizontally, right, if we want to draw it right in the middle of the screen, then the X coordinate can't be directly in the middle. It needs to be whatever half the width of the rectangle is to the left of the middle so that it looks like it's directly in the middle. So I'm going to say width over 2 minus 5 because the width of my rectangle here, I'm going to make 10. Actually, let's see if that's what we're doing. I think, yeah, that's fine. Okay. Now for the Y coordinate, I'm going to make this I. Now the reason I'm making it I is because I'm saying I want to have 20 rectangles on the screen, right? So when I say height over 20, that means that we're going to do this for loop 20 times because we're going up to height and we're starting at 10. So we'll do it either 20 or 19 times. Either way though, the reason I'm doing I is because we're going to be essentially picking what Y value to draw at based on whatever the for loop is currently at. So we're going to start at 10, then we're going to skip 1, then we're going to be at whatever height over 20 times 2 plus 10 is, because that's how much we're incrementing the for loop by every single time. And so this will make it so our rectangles are evenly spaced out because that's how much we're incrementing the I by every single time. So I'm using I for my height. So width over 2 minus 5, I. Then the width of my rectangle is going to be 10. Notice this value here is half of the width, right? And then the height of my rectangle is going to be height over 20 because that's how much I'm incrementing the for loop by. So I need to make sure that's my height so that we're getting kind of the correct spacing for our rectangles. I understand this is a bit complicated, but this is how you do a dashed line. There is some other ways to do it, but they take up a lot more code, so I'm going to do it in this way. Okay, so let's just see if this is going to work now before we go any further. Let's draw this. And notice now we get a nice dashed line or dotted line through the middle of the screen. The top and bottom spacing might be slightly off, but for me, this looks fine. Now you could make this a solid line if you want. That would be a lot easier, but we're going to go with dashed for now. Okay, so I think that is all good. Now what I want to do is implement the ball. So we want a ball that's going to be moving on the screen. Now let's just go into Paint here and quickly discuss kind of some theory behind this because this is not trivial to do. So we want a ball. And this ball needs to move in 2 directions, right? It's going to be moving in the Y direction and in the X direction. Now, it's also going to collide with paddles. We'll talk about the collision in a second. But for now, we want the ball to move around the screen and to be able to collide with something like the ceiling. Now, to move it, as I was saying, we need a velocity in the Y direction and a velocity in the X direction. Now, we'll start by moving the ball just in the X direction. And based on where it hits the paddle, we'll change its Y velocity. But just understand that we have kind of 2 components of movement in the X direction and in the Y direction. And we're going to have to calculate what those velocities are and then move the ball by that velocity every single frame. So hopefully that makes a little bit of sense, but that's kind of the idea here behind the ball. And I just wanted to explain that because that's what I'm about to start coding out. So just like we had a class for our paddle, I'm going to do one for the ball. We don't necessarily need one, but it's just going to make things a little bit simpler. So I'm going to say class ball. I'm going to say define underscore underscore init. We're going to take in a self, X, Y, and a radius. Okay, we're going to do a circular ball. I know some Pong games do a rectangular, I guess you can't really call it ball, but rectangular object moving around. We're going to go with the circular one. So over here, I'm going to say self.x equals x, self.y equals y. Self.radius is going to be equal to radius, and then self.x underscore vel is going to be equal to vel. It's actually going to be equal to something called max vel, which I will implement in a second. And we're going to say self.y underscore vel is equal to 0. I'm going to implement my max velocity. So I'm going to say max velocity is equal to, and we'll go with 5. Now, the idea here is that I want to initialize the x velocity as whatever the maximum velocity is in the positive direction. For our velocity, we can have positive or negative, and that will change the direction that we're moving, right? But I'm going to make this positive, meaning it's going to be going actually to the right first, I believe. Yeah, it should be going to the right. Anyways, I'm initializing the X velocity as the maximum velocity, meaning that we're going to be moving to the right at the maximum velocity when the program starts. Then once it hits the paddle, we will simply reverse the X velocity and calculate the Y velocity based on where it hit the paddle at. But the maximum velocity is telling us what the maximum possible velocity is in either direction. So we'll always be moving at the max velocity in the X direction, but the Y direction velocity is going to change depending on where we hit the paddle, because we're going to have to change the angle at which we want to move the ball. Okay, again, I know it's getting a little bit confusing, but hopefully that makes a tiny bit of sense. Now we're going to implement a method called draw, so very similar to our paddles. We're just going to say self-win, and we're going to go in here and say this will be Pygame dot draw dot and then circle. We're going to pass our window. We're going to have a color, which we'll define up here as just white. Again, just doing this so we can very easily change the color. And then we want a radius. So we're going to pass the window to draw on, the color, the radius, and the X and Y position. Now, I'm actually not sure if this is correct. I think we have to do the X and Y before we do the radius. So I'm going to do self.x, self.y, make sure that's in a tuple, and then the radius comes after, and I think that is correct. Perfect. Okay, so now we have draw, we have initialization, and let's implement move while we're at it because this is pretty straightforward. So we're going to say define move, and all we do to move is we move the X by the X velocity. So self.x underscore vel, sorry. And then self.y plus equals the self.y underscore velocity. Okay, so that's how we move the ball. This is our draw. I think that is all good for now. And the reason we can do plus equals is because if the velocity is negative, then that will be equal to minus equals, right? It'll just move it in the other direction. Okay, so now we have our ball. We need to initialize our ball. So let's go in where we have our left and right paddle, and let's make the ball and say the ball is equal to ball. Now, what's nice about the ball is that the X and Y position for it is the center of the ball, meaning that if we want to put it in the center of the screen, we can just actually calculate the direct middle and then place it there rather than having to do kind of the calculations here we did by subtracting, half the width and that type of stuff. So for the X and Y position of my ball, I'm going to put it directly in the middle of the screen. So I'm going to say width over 2, and then I'm going to say height over 2. Now, the reason I'm doing 2 division signs here is because this is integer division. It's just going to give me the rounded division because I can't draw at a floating point position. All right, so we're going to go height over 2. And then lastly here for the radius, we're going to make a variable. We're going to call this ball underscore radius. And for now, we'll go with a radius of something like 7. And we can, of course, change that later on if we want. So let's now pass the ball underscore radius. Now we want to draw the ball. So we're going to have to pass that to our draw function. So we'll pass the ball. We're going to take in the ball here in draw. And it's very easy to draw this because of the method we have. We're just going to say ball.draw and draw it on our window. Great. So now we have our ball. This is the class. And I think that's actually all we need for right now. So let's run the program and see what we're getting. And we got an issue. Let's see what the error is. It says maxVel is not defined. My apologies. We need to add a self.maxVel here rather than just maxVel because I have to reference it from the class. Okay, let's try this now. And we got another issue. It says ball object has no attribute maxVel. We need an actual L here, or an uppercase L rather than a lowercase one. Let's see if we get any other errors. Okay, there we go. So the ball is in the middle of the screen. It's not moving right now because we're not calling the move function, or the move method, sorry. But once we call that, we'll see that the ball actually starts moving on the screen. Then we need to handle collision. So let's move the ball. To do that, we're going to go to under, actually, where do I want to move the ball? Yeah, it's going to do it right here. I'm just going to call ball.move inside of my main loop here. And now we're going to be moving the ball every frame by whatever its velocity is. Okay, so let's run this now. And let's see. And notice the ball is moving to the right. Of course, it's going to go off the screen because we're not handling any collision. Let's run it one more time in case you missed it. You can see the ball starts moving to the right. Now, if we change the Y velocity, it would move on an angle, but for now, we're just moving it in the X direction, so that's what's happening. Okay, so now that we've done that, we need to start handling collision. Now, I will admit, this is not the easiest thing in the world to do, but of course, I'm going to try my best to explain it to you, and you will have, collision handled by the time that this is done. So let's go into Paint again, and let's just talk about how we're going to handle collision. First of all, with like the ceiling, and then we'll talk about the panels. So we have this right here, okay? Now, let's say we have a ball, and let's say its trajectory is here, okay? So it's kind of moving up in this direction, and the average of the components makes it so the angle it's moving at is here. So if the ball hits here, and it's going in this direction with the Y, all we actually need to do to make it bounce off of the wall is we need to kind of bounce it off on the exact same angle that it hit the wall at, right? So if you have like a wall like this and you hit like this, you go here, right? Pretty straightforward. If you hit coming pretty straight on, you're going to come out going pretty straight on as well. If you hit at a huge angle, you're going to come off at a huge angle. So that's how the collision is going to work. Works either in the X or Y direction. Now, when we're talking about the ceiling, all we actually need to do to implement this is we just need to change the direction of the Y velocity. So here, this Y velocity would actually be negative because we're going upwards. So to make it bounce off, all we do is swap whatever the current Y velocity is to the positive direction, and then that moves us down. Hopefully that makes sense. That's all you need to do to actually handle collision with the ceiling, which we'll do shortly. Now, that's the easy part. Collision with the paddle is a little bit more difficult because we're not going to do this in kind of a physics real way. So let's say we have our two paddles here. Now, in Pong, the way that the collision works, at least my understanding of the way that the collision works, is you're going to bounce the ball off of the paddle based on where the ball hits the paddle, not based on the angle that it's coming in at. Now, if the ball was coming at an angle like this, if we're talking about real physics, we should just bounce it off at the exact same angle. Now, the reason why we don't want to implement it like that is because that means our games are always going to be the exact same, assuming you can line up the paddle. You never can change the direction of the ball. Whatever direction it hits the paddle at is the direction it's going to come off at. So we need a way to actually manipulate that so we can have a game that's playable. So the way that I'm going to do this is I'm going to figure out how to move the paddle based on its direction from the center of the paddle. Or sorry, not move the paddle, how to move the ball based on its kind of displacement or distance from the center of the paddle. So if the ball hits here, then I want to bounce it off on an angle like this, okay? If the ball hits here, then I want to bounce it off on an angle like this. If the ball hits in the direct center of the paddle, then I want to bounce it like that. So the further away from the center it is, the higher the angle is I'm going to bounce it off on. So we're going to, have something along the lines of this. And we'll calculate this using a custom function that I'll show you how to write. But that's the idea here with the ball. So that's going to be more complicated to do. But when the ball hits like here, we're going to bounce it off pretty much in the center because this is almost directly in the middle, right? So we'll bounce it a tiny bit higher than that, but that's kind of how we're going to do the collision with the paddles. So let's say we have a paddle here. Okay, this is the middle of our paddle. This is going to be the XY coordinate. And then we have a ball, and this is the center of the ball. So let's just go through some of the math here. So we first need to figure out where the middle of this paddle is so we can calculate the displacement between this and this. Okay, so to do that, we're going to take the Y coordinate, which is right here. So let's just call this Y1. Let's put a Y1 here. And we're going to add to this half of the height of the paddle. So H over 2. Okay, so we're going to add H over 2. Again, I'm using my mouse here. This is pretty hard, but this is what's going to give us the middle. So we can say this here is equal to M. Okay, so this is M, the middle. Now, once we have M, all we're going to do is subtract M from the Y coordinate of our ball. So we can call this Y2. Okay, so we're going to take M and we're going to subtract Y2. Now, if this gives us a negative value, that means we are above M. If it gives us a positive value, that means we are below M. So once we have the displacement, so we can call this D, we need to figure out what the velocity should be in the Y direction based on this displacement. That's where it gets a little bit more challenging, and I'm going to dive into that math in a second. But for now, we understand how to calculate the displacement. Once we know the displacement, we just need to make it so that when you're at the maximum possible displacement in the up direction or the down direction, you're going to move at the maximum possible velocity. Whereas when you're at, say, a 0 displacement, you move at a 0 velocity in the Y direction. Okay, hopefully I'm not confusing you guys too much. I just wanted to give a quick rundown because now we're going to implement the collision, which, as I've said, is fairly complicated. So let's do a function here, and we're going to say handle underscore collision. Now, to handle the collision, we need the ball, the left paddle, and the right paddle. Okay. Now, what's nice is that we only need to adjust the Y velocity of the ball, really. That's the only thing we're going to do here, but we need to handle it on the left paddle, right paddle, and the ceiling. So let's start with the ceiling because that's the easiest. So we're going to say if the ball dot x, or actually not ball.x. We only care about the y because we're going up and down, right? We don't care about the left-right collision right now. So we're going to say if the ball.y plus the ball.radius is greater than or equal to the height of the window, then we're just going to say ball.y underscore vel multiplied equal by -1. So simply going to reverse the direction. Now we're going to say elif the ball.y plus, and there's actually minus the ball.radius is less than or equal to 0, then ball.y underscore vel. And this is going to be multiplied equal by -1. Now that's actually all we need to handle the collision with the ceiling. So let's just look at this one here. This is saying if we're going to hit the bottom of the ceiling, right? So the height, we're checking the ball.y, which is the center of the ball, plus the ball.radius. It's important you add the radius. If you don't do that, it's only going to check for collision with the center of the ball. We don't want that. We want it with like the edge of the ball, which is the radius, right? So if that's the case, then we just, change the direction, reverse the direction. Now we do the exact same thing in the other direction, except this time we need to subtract the ball.radius, not add it, because we're checking up, not down, okay? There you go. We're now handling collision with the ceilings. Now, after we check that, we need to check if you're hitting the left panel or the right panel. Let's start with the left panel. So we're going to first check the direction of the ball because we're only going to see if we're hitting the left panel if we're moving left, right? So if the x velocity is negative, that means we're moving left. Then we'll check if we're colliding with the left paddle. Otherwise, there's really no point in doing that. So I'm going to say if the ball dot, and it's going to be x underscore velocity, is less than 0, then I'm going to check if we're colliding with the left paddle. Otherwise, I'm going to check the right paddle. So I'm just going to add a comment here. So to check if the ball is colliding with the paddle, we need to check both the x and y coordinate and check if the y coordinate is within the range of where the paddle is on the screen. So essentially, if the y value of the ball is greater than the y value of the paddle, but less than the y value of the paddle plus the height of the paddle. That's going to tell us if it's where the paddle is on the screen, essentially. Then once we check that, so if the y coordinates are correct, if it's in the right range, we need to check if the x coordinate is the same as the edge of the paddle. That's essentially what we want to look at. So I'm going to say if the ball.y, and we're going to say is greater than or equal to the paddle.y, because remember, this is the top left-hand corner of the paddle, and the ball.y is, this is going to be less than or equal to the paddle.y plus the paddle.height. So that's the first thing that we want to check. Now, after we check that, we want to check if the x coordinates are correct. Now, I could do this on the same line, but just so it doesn't get too messy, I'm going to do another if statement. And I'm going to say if the ball.x, and this is going to be, I need to think about this for a second, minus the ball.radius. And we're going to check if this is less than or equal to the paddle.x plus the paddle.width. Okay, let me check my cheat sheet to make sure I did this correct. I think I did. Looks good to me. Okay, so the reason we're doing this, let's go to paint quickly, is because we're checking the left paddle. So if this is the paddle right here, we know the top left-hand corner, xy is here, and we know the edge of the paddle in terms of the x coordinate is going to be the x plus whatever the width is. So that's what we want to check. Now we have our ball. This is the center of the ball, so we need to account for the radius, which is what we're doing. So we're taking the ball.x, we're subtracting the radius, which gives us the edge of the ball, and we're checking if that edge is less than or equal to this edge right here. If it is, we're just going to change the direction of the x, and that will then change how we move the ball off of the paddle, okay? So let's try this out. Let's go here, and for now, all we're going to do is change the x velocity. We'll deal with the y velocity later. So I'm going to say ball.x underscore vel multiplied equal by -1. Okay, it's just going to change the direction. So now we move from the left to the right. Okay, so that is handling the collision for the left paddle. Now, handling for the right paddle is a little bit different. So we're going to say if the ball.y, we actually can copy this for the y. So we'll do this, except we're going to check paddle. I keep saying paddle. Sorry, this needs to be the left underscore paddle. This needs to be the left underscore paddle. This needs to be the left underscore paddle. My apologies, guys. Fix that. So this will be left underscore paddle. And then for here, this makes it actually easier. We just make this right paddle. Okay, so right paddle and right paddle. Okay, so now we've checked the y for the right paddle. Now we need to check the x. The x is a little bit different. We're going to say ball.x plus ball.radius, and we're going to check if this is greater than or equal to the right paddle dot x. Okay, and if it is, we're going to say ball.x underscore vel multiplied equal by -1. Okay, so the reason why this is a little bit different for the right paddle is because when we're moving to the right, we're going to be checking the left edge of the right paddle, and that is represented simply by the x coordinate of the right paddle because that's the top left-hand corner. Whereas when we're moving to the left, we're checking the right edge of the left paddle, which means we had to add the width. Now, the reason we're adding the radius is because we're moving to the right, so the radius is going to be to the right side that we're checking rather than the left, whereas here we were subtracting the radius. Hopefully that makes a little bit of sense, but I think this is going to be good to allow us to move the ball left and right on the paddles. Let's check this out, and then we'll deal with the Y, which is a bit harder. Okay, so let's see this now. It should bounce off the paddles. Okay, so it didn't bounce off the paddle, which means I made a mistake here. Let me check the mistake, and I'll be right back. All right, so I found the error. This is kind of a silly one. I'm not calling this function. So I wrote this function, but I didn't actually call it. So of course the collision is not going to be handled. So we need to call this now. So after we move the ball, then we'll handle the collision. So we'll say handle, and then this will be collision like that. And we're going to pass ball, left paddle, and right paddle. Okay, fingers crossed. Hopefully this should work now. Let's run this, and let's see if it bounces off. There we go. So it bounces off. And notice that it doesn't really matter where I have the paddle. It's just going to bounce off at the same direction because that's all we're doing right now. Now, if I move the paddle, it should just go off the screen, and it does because, well, it's not going to collide with the wall. We haven't implemented that. Great. So there we go. That is now dealing with the collision. Now we want to deal with the collision in the Y direction. Again, a little bit more complicated, but we need to calculate the displacement between the ball and the center of the paddle, and then determine the angle that we want to bounce it off on. Now, we don't actually need to use trigonometry because of the way that I've implemented this, but you're going to see the math is not super straightforward. So the first thing we need to do is calculate the middle Y of the paddle. So we're going to say middle underscore Y is equal to, and then this is going to be in this case, it's the left paddle. So the left paddle dot Y, and then this will be plus the left paddle dot height divided by 2. Okay, that's fine. Now the next thing we want to do is calculate the difference in Y between the ball and the middle of the Y paddle, or the middle of the left paddle, sorry. So I'm going to say difference in Y is equal to, and this will be the middle Y subtracted by the ball dot Y. Now that we've done that, we need to figure out essentially how much we need to divide this value by to determine what the velocity should be. So let's go back to Paint here, and let's deal with some more math. So we have a max velocity. So let's call this V, okay? The max velocity is equal to, I believe we had 5. Okay, that was a rough 5. That's a better 5. So let's just call this mx for max velocity is equal to 5. Now, what we need to do is make it so when we're at the maximum possible displacement, that's when we get this maximum velocity, right? So if we're hitting the very, very edge of the paddle, so we hit right here, that's when we get a maximum velocity of 5. Now, when we don't hit this, we want it to be a little bit less, right? So I want the velocity to maybe only be 4 when we hit here. So essentially, how do we figure this out? Well, what we need to do is figure out what value we need to divide whatever the distance is to make it so the maximum possible value we can get is 5, and then any other value we get will be smaller than 5. I understand this is a bit weird, but we want it so that the distance or the displacement divided by some value gives us 5 when we're at the maximum possible displacement value, and then when we're not at the maximum, it gives us something a little bit less than 5. And as we get closer to the middle, it gives us a smaller value that should reach 0. So our range is 0 to 5. We need to take our displacement and then squeeze it in the values 0 to 5. Hopefully this is following a little bit. Again, not the easiest math in the world, but we're going to have a maximum velocity of 5. Okay, that's our MV. And our maximum displacement, okay, is going to be equal to half of the paddle. So if we're taking the displacement from right here, then the maximum possible displacement we can have is if the center of the ball is right here at the very edge of the paddle, which is just going to be half the height of the paddle, okay? So our maximum displacement is height of the paddle divided by 2. So we have these two values, and now we need to figure out what I'm going to call a reduction factor. And the reduction factor is how much we take the displacement between the paddle and the, and the ball, and divide it by. Okay, so now we also have D, so let's write a variable D. Let's go back to this. No, I don't want a pencil, I want brush. Okay, D. So we have D, this is equal to the distance between the middle of the paddle and the ball. So the way that we figure this out is we say that our reduction factor, which I'm going to call R, so we want to have D over R is equal to mv when specifically D is equal to md. So when the displacement is equal to the maximum possible displacement that we can have, and we divide it by R, we want to get the maximum velocity. That's what I'm saying here. Now, it doesn't matter if it's positive or negative because we'll get either the maximum positive or maximum negative velocity. Anyways, that's kind of the equation that we have. Now, fortunately, we can solve for R because we have a value for D and mv. Now, once we solve for R, we just use R as the reduction factor, and then that's going to give us what we need for the velocity for our ball. So if we plug in D, which is going to be md, which is just h over 2, then we have h over 2 over R is equal to mv, and we know mv, which is 5. Now, h over 2 is going to be variable based on the height of the paddle, but I think we actually know that this value is 50. Anyways, I'll show you how we solve just using the variables. So if we have h over 2 over R is equal to 5 and we're looking for R, then what we need to do to actually solve this is we need to do the following. We're going to have to flip R and h over 2. So we're going to say R over h over 2 is equal to 1 over 5, okay? Because what we do to one side, we need to do the other side. Then we're going to take h over 2 and we're going to multiply it by the 1 right here. So we're going to have h over 2 over 5 is equal to R. Okay, so it's going to be whatever the distance is, the maximum distance over 5. In this case, it would just be our max velocity, so that could potentially change, is equal to R. And then we take, in the future, whatever the displacement is, divided by R, and that gives us the value. I know that was a lot. I'm sure it's not 100% clear. Once I write this, maybe it'll make a bit more sense, but I just wanted to go in and try to explain how that works. Okay, so now I'm going to calculate the reduction factor. So I'm going to say reduction factor is equal to, this is going to be left paddle dot height divided by 2. Okay, divided by 2. And then we're going to take all of this and we're going to divide this by the maximum velocity of the ball. So I'm going to say ball dot max underscore vel like that. Okay, now we have the reduction factor. Now that we have this, we need to use this to calculate the y velocity. So I'm going to say the y velocity is equal to the difference in y divided by the reduction factor. Okay, so now this is going to squeeze our difference in y within the range of -5 to 5, which is now going to allow us to update the y velocity. So now I can say ball dot y vel is equal to the y vel, okay? Now it turns out that we do the exact same thing here with a few minor changes inside of this function. We just need to change left paddle to be right paddle, and it will give us the exact same result. Now, there's a lot of repetitive code here. Theoretically, we could maybe write a function to calculate this for us, but for now, I'm just going to put it inside of here because I think this is fine. So let's run this now and see if it's working. So if I look at this paddle here, it's actually bouncing in the incorrect direction. Okay, I need to fix that. Yeah, same with the other paddle. So it's giving us the reverse of what it should be. So I'll show you how we can fix that. But it is bouncing on an angle, which is what we want. So the reason it's giving us the reverse of what we want is essentially because we just need to multiply the y velocity by -1. I'm going to say -1 by y velocity and -1 multiplied by y velocity. How did I mess that up twice? Okay, let's rewrite this. -1 multiplied by y velocity. Now it should give us in the other direction. You can look at the math and you'll probably figure out pretty quickly why it's giving it to us, but it's because we're taking the middle y and subtracting from ball y. If we do ball y and subtract by middle y, then we don't need to do this. But I think this makes more sense, so that's why I'm doing it this way. Anyways, let's try this. Let's see what we get. Okay, now it's bouncing in the correct direction. Nice, that's what we wanted. Notice when it hits the edge of the paddle, it's going to bounce more down. Okay, there we go. We got it to bounce down. Nice. Awesome. And it bounced off the ceiling completely fine. So this is working as I anticipated. Now what I want to do is I want to make it so when it goes off the screen, we actually increment some type of score and display that. Okay, so let's get started on that. Our collision is working properly. As you notice, the closer we got to the center, the more the ball bounced off straight, and the further away from the center, the more we had an angle. That's why I was doing all this math. That's kind of how that works. Okay, so now we want to implement some type of score. So to do that, we need two variables. We're going to say left score and right score. So the left score will be equal to 0, and the right score will be equal to 0 as well. Now, to check the score, we just need to see if the ball moves off the left or the right-hand side of the screen. So I'm going to say if the ball.x is less than 0, then this means that the right player scored because it came off the left-hand side of the screen. So we're going to say right underscore score plus equals 1. Elif the ball.x is greater than, and this will be the width of the screen. Then we are going to say left score plus equals 1. Now that we have both the scores, we can pass those to the draw function. So I can say left score like this and right score. And then if I go to my draw function, I can now take in the scores. So we'll say left score, right score, and we want to draw them on the screen. Now to draw them on the screen, I need something like a font, right? I need to actually draw text on the screen. So to do that, I need to write a font. So to make a font, you can do the following. Score underscore font is equal to pygame.font.sys font like that. Now this takes in the type of font, which I always just use as Comic Sans, and then the size of the font, which I'm going to go with as 50. Feel free to modify these values, but this is the font you want, and this is the size of the font. And now you use this font object to actually render text that you put onto the screen. So inside of my draw function here, I'm going to use score font, and I'm going to draw this at the top, just so that the ball can be drawn over top of the score. So whatever I draw first will be drawn first, meaning that whatever I draw last is going to be on the very top. So I want to draw the ball last so that it will be over top of my score, okay? So the way that I do this is I say the left score text is equal to the score font, and then I call dot render, and I pass to this the text that I want to render, which is going to be an F string containing the left score, okay? And then I'm going to pass 1, and I'm going to pass the color, which is just going to be white. Now 1 stands for anti-aliasing. Just always make this 1, okay? So you do the text, anti-aliasing, the color, and that's what we have. Now F strings allow you to just embed expressions directly inside of a string. So I'm just doing the score here directly inside of the string to avoid having to convert it to a string using the string function. Now for the right score, it's going to be the exact same thing except right score. Okay, so now this actually gives me a drawable object. Now that I have a drawable object, I want to draw it on the screen. So I'm going to say win.blit, and I'm going to blit the left score text, and then I need to pass an X and Y location for it. Now I want the left score text to be exactly in the middle of the screen on the left half of the screen. So this is actually fairly easy to do, but I'm going to say width divided by 4, not divided by 2, because I'm trying to put this on kind of the first quarter of the screen or the first half of the screen in the center. So I'm going to say width over 4. And I'm going to subtract this from the left score text dot get underscore width over 2, okay? And then for the height, I'll just pick a height of like 20 pixels. Now we'll do the exact same thing for the right text, and then I'll explain why I'm doing this calculation. So this is going to be right score, but for the right score, I want this to be in the middle of the right-hand side of the screen. So I actually want it to be 3/4 of the width of the screen, right? That's the middle of the right-hand side of the screen. And then I'm going to subtract that from the right score text dot get width over 2. So for this, I'm going to do width, and I'm going to multiply this by 3 over 4, okay? So hopefully that makes sense. I think I can actually just do it like this and say width multiplied by 3 over 4, and then minus the right square dot get underscore width over 2. That should work properly. So to go to Paint to quickly explain this again, if we want this to be in, like, let's do this. We have half the screen. The middle of this half is right here. Okay, so this is width over 4. That gives me this X position. Then I have my text. Now, if I draw my text here, it's going to go like that. I don't want it to be like that. I want it to be directly in the middle. So I need to draw it like this. So I'm going to take half the width of the text and subtract that from this position. That gives me the top left-hand corner for where I need to draw. Now, exact same thing over here. This is 3 over 4 width, right? So I take that, subtract it from half of the width of the text I'm drawing, and I get it directly in the center of the screen, okay? And of course, this is how you get the width of the text object. You just use get width. Perfect. So that should now draw my score. So let's see if this is going to work. Okay, wait. I think I'm in the Python terminal here. Let's just quit that. Yes, okay. Let's rerun. And notice now that if we score, this goes up, and it's going to continue going up because I don't reset the ball. So I need to reset the ball, but you can see that it is indeed drawing in the middle of the screen, and it's changing based on what the number is, right? Okay, so how do we do this now? So once the ball goes off the screen, we need to reset the ball. So I'm going to put a method on my ball just called reset. So I'm going to say define reset, And what I need to do in here is I need to reset the y velocity as well as the x velocity, and then change the x and y position to be originally what it was set. So I'm going to add some new values here. I'm going to say this is equal to self dot original underscore x, and this is equal to self dot original underscore y. Now let's make those lower cases. So the idea here is when I initialize my ball, I'm going to store what the original x and original y value was in a separate variable. So that's how you do this here. And then I'll change the x and y as I go through the program, but I'm storing the original x and the original y so I can reset the x and y to be equal to the original x and original y when I reset. So I'm going to say self.x is equal to self.original x. Okay, and then we're going to say self.y is equal to self.original y. Then I'm going to reset the y velocity to be 0. Okay, and I'm going to say the self.x velocity multiplied equal by -1. Now, the reason I'm doing this for the x velocity is if I go off the screen going left, then I want the velocity of the ball to be hitting my opponent when the ball resets, okay? Now, same the other way around. If I go off the screen going right, then I want the ball to go left and hit my opponent's paddle first. You could change this if you want by just making it equal to the max vel, or not even changing the x vel. You could do that, that'd be fine. But I'm just going to reverse the direction. So if it just went off your screen, then it will go to the other person. Hopefully that makes a little bit of sense. That's what I'm doing with the x velocity here, okay? So that's reset for the ball. So now, if they score, we want to reset. So I'm going to say ball.reset and ball.reset. Okay, easy enough. Let's try this and see what happens. Okay, so let's score. And now notice it comes off and hits my opponent's paddle. So that's what I'm trying to do, just to give my other player some time to recover. So if we score, now it comes off on that side. Okay, let's score on the other side and see if our score goes up. Okay, score goes up, and then it comes back to me. All right. Now, again, you can change that if you want, but that was kind of my idea here. Now, one thing we could do is also reset the paddles when we score. That might not be a bad idea. For now, I'm not going to do that, but I think I've showed you how you would go about doing that. Just implement the same logic on the paddles and then call reset on left paddle and right paddle. Okay, nice. Now that we have that, the last thing I need to do is handle winning the game. So if the left player wins, I want to say, left player wins. If the right player wins, I want to say right player wins. So I need to first come up with a score that I want to end the game at. So I'm going to say the winning underscore score is equal to 10. And now we want to check if either player has a score of 10 after we increment the score. So I'm going to go here and I'm going to say if the left score is greater than or equal to the winning score, then we want to do something. And I'll say if the right score is greater than or equal to the winning score, then we want to do something. Now, the first thing that we want to do is we want to say ball.reset, okay? And we want to say ball.reset here as well. Now, I actually want to reset the paddles if someone wins because we're just going to play a new game. So let's actually implement the reset method on the paddles because I guess we're going to need that anyways. So let's go to our paddles. And in the same way that we did this for our ball, we're going to say self.originalx and self.originalY. And then we'll just implement reset. So define reset self.x is equal to self.originalx, and self.y is equal to self.originalY. Okay, paddle reset done. Very easy. So if one player wins, I want to say left underscore paddle dot reset, right underscore paddle dot reset, and same thing. Okay, nice. Left paddle reset, right paddle reset. Now, the thing is, this is pretty repetitive, so we could try to wrap this in a way where we're only going to write this code once. In fact, let's actually do something. I'm going to say reset. Actually, I'm going to say 1 is equal to false. And then inside of here, I'm going to say 1 equals true. Okay, and 1 equals true. And then I'm going to say if 1, do this. So this is just handling all our resets in one place now. So we just have a Boolean telling us, okay, did we win or did we not? Well, if someone won, then we'll do the reset. And then inside of the left score and right score if statement, we'll handle specifically what to do if the left player won and specifically what to do if the right player won. Now, actually, what I want to do is just put some text on the screen, show it for 5 seconds saying, hey, left player won, right player won, and then just immediately reset the game. So to do that, I'm just going to render some font. So I'm going to say win text is equal to, and actually, yeah, we could just do win text. We could say left player won, exclamation point. And we can say win underscore text is equal to right player won. So now that we have this in a variable, what I can do inside of 1 is I can use that variable to render text depending on who actually won. So I can say my win underscore, I'll say win, actually, let's just say text is equal to, and then this is going to be the score font. We could make a new font. I'm just going to use the score font. Dot render. We're going to render the win text 1, and then we're going to render this in white, and we're going to blit this to the middle of the screen. So I'm going to say win in all capitals, dot blit, and I'm going to blit the text, and then I'm going to blit this at win, or I'm going to blit this at height, at width over 2, minus the text, dot get underscore width over 2, and then it's going to be at height over 2, minus, and then this is going to be the text dot get height over 2. Okay, so we're centering in the X position and the Y position. Then I need to update the display. I'm going to say pygame.display.update, and I'm going to say pygame.time.delay 5,000, and 5,000 is going to be 5 seconds. This is the number of milliseconds that I want to display the program by. Let me run through this because I know I went quickly. We're saying the text is equal to score font.render, so we're just rendering a drawable object. The text we're rendering is whatever we put here, just so we're not repeating a bunch of code and doing this in both places, right? I'm rendering this with anti-aliasing 1, the color white. I'm then blitting this directly in the middle of the screen. I've talked about how we do the middle calculation many times, so I won't go through this again. We're going to update the display so that it instantly shows. Then we're going to delay by 5 seconds. We delay by 5 seconds, then we reset everything. Now, when we reset, we also need to reset the score, right? So we're going to say left score equals 0 and right score equals 0. And I think that's actually all we need to do for reset. Then the game will restart and everything will just work as expected. And then when you hit X, of course, the game's going to end. All right, so I think that's actually all good. That should really wrap up the program. Let's run this, though, and give it a test and see if it's working. So let's just see if we can score 10. So I'll just kind of let this run. And then once it's done, I'll be right back and confirm that it's working. Okay, so we're at a score of 9. Let's see now if this is going to work. Okay, it says right player 1. Perfect. And then it should restart the program. Let's see. Perfect. Restarts. Awesome. Okay, so that is Pong. We have finished the game now. As I promised, hopefully you learned a lot in this video. I just covered collision. We covered some more advanced math, drawing, kind of separating the program out and how we have different functions handling different stuff. Yeah, I think this is a fun program. Again, great one for beginner or intermediate programmers. And I am going to end the video here. Hello everybody and welcome to another Python tutorial where I'll be showing you how to build the game of 2048 in Python. Now this game was one of my favorite games as a kid and it's actually very interesting to code out. I won't lie to you, it is a little bit complex, but I think that's what will actually make a great video. I'll teach you some more advanced Python techniques and how you can actually structure a game like this. So we'll go through all of the steps, coding out the grid, combining the tiles, etc. And by the end of this video, you'll have a fully finished game and you will have learned quite a few Python features. Last thing to mention, this video is not designed for complete beginners. You should have some knowledge of Python already, but don't worry if you don't know Pygame, which is the graphics library we'll be using here. Anyways, with that said, let's dive into the video and learn how to build 2048 in Python. All right, so let's begin here by just walking through at a high level exactly what it is that we need to do and kind of come up with a bit of a plan before we just jump into the tutorial. So as you can see here, we have a grid, right? We actually have a 4x4 grid, so we have at most 16 tiles that can be inside of the grid. Now these tiles can either be 2s or 4s. We always start out with 2 2s on the screen, and then anytime we make a move, we will add 1 tile to the screen that will randomly be a 2 or a 4. When the tiles have the same values and they hit each other, so in this case if I go down, they'll merge, so you can see that we had those 4s turn into 8s. Pretty simple in terms of the rules here, and eventually you will lose the game if there's no more room on the screen to add more tiles and you can't merge any of them together. Now this might seem like a simple game, but it's actually a bit complicated because of the movement of these tiles and making it look smooth and animated. So what we'll begin by doing is setting up the general grid. We'll draw all of the lines, we'll pick the different colors, we'll start being able to generate some different tiles, and then where it will get a little bit more difficult is when we need to move and merge the tiles together. So for now, let's start by setting up the screen. We want to work on actually creating this grid system that you see here, and then having some representation for our different tiles. So we'll pick the different tile colors, etc., kind of get the drawing and hook up some of the different functions. Once we've done that, then we'll actually go over to the whiteboard and I'll explain to you exactly how we do the movement of the tiles and some of the more complex logic, which I think is really interesting and you guys will get some value from. So let's hop in to our code editor here. I am using Visual Studio Code. Feel free to use whatever you would like. Now the first thing we need to do here is install the Pygame module, which is what we're going to be using for all of our graphics. So we're going to go into our terminal, and in this case I'm on Mac, so I'm going to type pip3 install Pygame. Obviously this assumes you already have Python installed. Now that should install the Pygame library. I already have it installed, so I'm not going to run this command. If you're on Windows, you can try pip install Pygame. If you're on Linux, it'll be pip3 install Pygame. And if none of those work, you can try python-m pip install Pygame or python3-m pip install Pygame. I also have 2 videos that I'll leave on the screen that will show you how to fix this pip import. So for some reason it says pip is not a valid command. Follow those videos and they should show you how to install Pygame. Okay, now that we have Pygame installed, we just want to test this. So I've opened up a new file here in VS Code, and we're going to start by just importing Pygame. So we'll import Pygame and then we'll simply run our file, and we'll just make sure that we don't get any errors. Here it says hello from the Pygame community, which tells me that we are good to go. Okay, so now that we've imported Pygame, we'll import a few other modules that we're going to need to use. So we're going to say import random and import math, because we're going to need those. And then we are going to say pygame.init. This will just initialize all of the different features that we need. Now that we have this, what I like to begin by doing is defining some different constants on my screen. Let me just make this a little bit bigger so we can read it easier. And these constants are values that are not going to change, but that we'll need throughout the rest of the program. So we'll begin by writing those variables, and we do these in capitals to represent that they're constant. So first we're going to set the FPS. Now the FPS is the frames per second, and this will allow us to dictate how quickly the game is running and to regulate the speed on different devices. So we're going to type FPS equals 60. We then need to specify the width and the height. So I'm going to say width comma height equals 800, 800, because I just want this to be a square. We then are going to determine the row size. So we're going to say rows is equal to 4. And columns are equal to 4. And what's nice about this approach here is later on we can very easily change the width and the height, and we can adjust the number of rows and columns we want if we want to make the game more complex or a little bit different. Now, the next thing we need to do is determine how large a tile is going to be, or one of the rectangles is going to be, that's inside of our grid. So the way we do that is we'll say the, with all capitals, rectangular height is equal to the height of our screen divided by the number of rows that we have, right? In this case, we have a height of 800, 4 rows, meaning each tile will be 200 pixels tall. We're then going to say our rectangular width is equal to the width integer divided by the columns. The reason we're doing integer division is so that we get an integer rather than a floating point value. Now there's a few colors that we're going to define that we'll need for right now. So we're going to say our outline color is going to be equal to kind of a nice gray. Now I've already found these RGB colors, so I'll just type them out and you can copy them with me. So this is 187, 173, 160. Whenever you're defining colors in Pygame, you have the option to use RGB, which stands for red, green, blue. First value is the amount of red, second is the amount of green, last is the amount of blue. These values can be in the range of 0 to 255. If we had 0, 0, 0, that would be black. If we had 255, 255, 255, that would be white. Next, we're going to say, in all capitals again, the outline thickness is equal to, and then this will be 10. We can adjust this later. This is how thick the lines will be on the screen. And then we're going to have the background color, and this will be equal to a different shade of gray, which will be 205, 192, 180. Don't worry too much about the colors. Again, I already just found these. Next, we're going to say a font color. This will be the color of the text on the tiles. I'm going to go 119, 110, and 101 for kind of a blackish, grayish shade there. Okay, so now that we've defined some of our constants, we're going to create a Pygame window. So whenever we're coding in Pygame, we have a window. The window is where we can draw objects, and it's really representing the canvas of our screen. So we're going to say, in all capitals, if I could toggle the caps lock button, which for some reason is not working. Okay, window is equal to Pygame dot display dot set underscore mode, And inside of here, we're going to pass a tuple that contains the width and the height, okay? So this will actually create a Pygame window for us. So again, pygame.display.set_mode, then pass a tuple. Make sure you don't forget the enclosing parentheses there. And by the way, all of this code will be available from the link in the description in case you are getting confused or you want to copy a specific area. Next, we're going to say pygame.display.set_caption. This will be the title of the window, and I'm just going to call this 2048, which is the name of the game. Okay, last, we have two more constants that we need. We're going to have a font. Now, a font is something that we can use to render text onto the screen. So we're going to say font is equal to pygame.font. With a capital SYS font like that. Then we can put the name of the font. I always use Comic Sans. We're going to put the size of the font, which we'll go with as 60 for now. And then we'll say bold equals true because we want the bold version of the font. Lastly, we're going to define a variable here we'll use later called move velocity. This is the speed at which the tiles will move, and I'm going to go with 20 pixels per second. Okay, so that is most of the constants that we need. We define our FPS, width, height, rows, calls, rectangular height and width, and then the different colors we need, as well as set up the Pygame window. Just to make this a bit cleaner, I'll move this down here so it's the last line. We have our font and we have our move velocity, and now we are ready to start coding out some more components of our game. So the first thing we usually do when we're working with Pygame is we create something known as the main loop. Now the main loop is an event loop that's going to run constantly and check for things like button presses, exiting the screen. It's essentially what will just run the game, okay? It's the main loop that's handling all of the different events. So we usually put that inside of a function. So we'll simply say define main, and then what we need to do is obviously call this function. So we're going to go down to the bottom of the screen and we're going to say if __name is equal to __main__, then call main. And what we're going to do is actually call this with the window object, and we're going to take in window as a parameter here inside of the main function. So we're just specifying, okay, where do we want to run the game? Well, we want to run it on the window that we just defined as a variable here. And if you're wondering what this does, this simply means we are only going to execute this function if we are running this file directly. I'm not sure if that makes a ton of sense, but essentially if another file were to import this file, this would not run. Whereas if we actually run this file directly, which is what we'll be doing, then this will be true and we'll run this window. That's all this name equals main does. Just protects you in case you're reusing some functions in here and you don't want to actually run what's known as the main line. Okay, so there we go. We have main. Now inside of main, we need to create a loop that's going to continue to run. So the first thing we're going to do is set up a clock object. This will allow us to regulate the speed of the loop. So we're going to say pygame.time with a capital .clock. We're then going to have a variable called run equals true, which we'll set to false when we want to exit the loop. We'll then say while run, and we'll say clock.tick, and then we're going to tick based on the frames per second, which is this. Now this tick will just make it so this while loop is only going to run at most one time every 60 seconds. It could run less than that, but the reason we put this here is so that people that are running on different speed of computers don't have the game running at a different speed. If you didn't have this clock here, what will happen is you'll simply run the loop at whatever the fastest speed is you can run it at, which means someone on a really powerful computer is going to see the game a lot faster than someone on a slow computer. So always good idea to have this clock. Now that we have the clock, what we're going to do is create a simple event loop that's just going to listen for all of the different key presses and events that could occur. So to do that, we're going to say for event in pygame.event.get. This will loop through all of the events that have occurred, and we can then check the event and handle it. So we're going to say if the event.type is equal to pygame. With all capitals quit, then we will say run in lower cases is equal to false, and we'll break out of this loop. Now what that's going to do is simply say, okay, if we press the exit button, that's what this quit event is, we're going to set run equal to false, so this loop will stop running. We're going to break immediately out of this event loop so we don't handle it, and then what will happen is we'll come outside of the loop and we'll run the command pygame.quit, which will simply quit the Pygame window for us. So that is now the main loop, and what should happen is if we run this code, we should actually see a window appearing, and if we press the X button, we should be able to cleanly exit. So let's go ahead and try that, and you can see we get 2048, we get the window of our size 800, and I can click exit, and I cleanly exit the code. All right, so now that we have that, let's move on to doing some drawing operations so that we can actually see some stuff appearing on the screen. Now, I typically like to separate the drawing from the event handling just so it's a little bit cleaner. So the way I'll do that is I'll define a function here called draw. You'll notice that in my code, I'll write a lot of functions just to make sure everything is clean, readable, and easy to debug, and we can quickly figure out where something's going wrong by just isolating it to a specific function. This is good practice and something you can kind of take note of while I'm coding. So in the draw function, I'm going to take a window, and what I'll do for now is simply set the background color and then update the screen. So I'm going to say window.fill, and this allows you to fill the window completely with a background color. So we're going to say window.fill and then background color. If we look at background color here, this is what it is. So we're essentially just kind of painting the entire window this color. Then what we can do is say pygame.display.update. Now the way that Pygame works is we do all of these drawing or paint events, and then as soon as an update is called, we'll actually apply all of those onto the screen in the order in which we wrote them. So what that means is that we're always going to fill the screen first, because what that will typically do is it will actually override whatever was on the screen before by painting over top of it. Then we'll do any other operations to draw the updated screen, and then we'll update, and then when we do the update, we'll actually see that being performed on the screen. I know it's a little bit abstract right now, but it's just like we do all of these paint operations, then we update, then they're all applied at once rather than happening one at a time. So now we just need to call that function. So inside of this loop, make sure you're inside of the while loop here. At the bottom, we're going to say draw, and we're going to pass that window object. And now we should be getting the background color on our screen. So let's try this out. And you can see that now it fills with the background color. Okay, great. So now that we've done that, we want to start drawing the grid. So to draw the grid, we're going to write a different function. And we're just going to say draw underscore grid like that. Okay. And inside of here, we'll take the window object again. Okay, so for drawing the grid, what we'll need to do is we'll need to draw horizontal and vertical lines to represent the separation between tiles, and then we want to draw kind of a border around the entire screen so that we get that nice border effect. So let's begin with the border. To draw the border, we can simply draw a rectangle that's positioned at the edge of the screen. So to draw a rectangle, we'll say pygame.draw.rectangle like that with RECT. For this, we need to pass where we want to draw it. So we want to draw it on the window. We need to pass the color we'd like to draw it. You can see I'm getting the autocomplete here, so we want the outline color. And then we need to pass a rectangle that represents where we should draw the rectangle. So the way that we pass a rectangle is we give the x coordinate, y coordinate, and then the width and the height of the rectangle. Now the x and the y represent the top left-hand corner where we want to start drawing the rectangle from. Now this will get into the Pygame coordinate system, which I'll discuss in a second, but let's go 0, 0, and then width and height. Now, as well as that, we have the option to either have the rectangle be filled completely in or to be an outline. So in our case, we want it to just be an outline. We don't want it to fill in entirely. We don't want to draw a solid rectangle, We want one that's hollow. So what we'll do is pass what's known as the width or the thickness. So I'm going to say width, and then this is going to be the outline thickness, which in our case, I believe is 10 pixels. So before we go any further, let's draw this on the screen just so that we can see what it looks like. So let's go here, and in our draw, after we draw the background, we're going to say draw grid, and we're going to pass the window. So let's run this now, and you should see that we're getting kind of this outline. It's a little bit faint on my screen, but I think you can probably see it. Maybe not with OBS recording, but I can see it at least here, and we do have an outline filling the screen. Okay. So that's how that works. Now, actually, let's run this again. One thing to note here, when we're talking about coordinates and XY values in Pygame, we always start at 0, 0, which is the top left-hand corner of the screen. So rather than starting at the middle, which is typically 0, 0, it's the top left, meaning as you go to the right, your X value increases, and as you go down, your Y value increases. So if we look at the bottom right-hand corner, that would be 800, 800 in terms of the coordinate grid in Pygame. So just keep that in mind. You'll see as we go through here how we kind of do the positioning. Okay, so we've drawn that. Now we actually want to draw the outlines. So like the grid lines, right? So we can start by drawing the horizontal lines. So we can say for row in range, and then in all capitals rows. So we're going to draw a line for every single row that we have. And what we need to do here is simply calculate the y coordinate of the row or of the line, that we want to draw. So we're going to say y is equal to row multiplied by the rectangular height. Now the way this will work is we'll start with row being equal to 0, and then it will become 1, 2, 3, and then it will not be equal to whatever the last row is, which is fine. And in fact, we can actually do 1 comma rows because we don't need to draw the very top line because that will already have been drawn by the rectangular outline that we drew. Anyways, what we're going to do here is draw a line. The line will go from the x coordinate 0 to the width of the screen. And then what we'll do is adjust the y coordinates so that we're moving the line down every time the loop happens. So we take whatever the height of one tile is and we multiply that by the current row, and that tells us the y coordinate for this line. So we're going to say pygame.draw.line. Similarly here to the rectangle, we're going to pass a window. We're going to pass the outline color, and then we're going to pass 0. And then y. Y is our dynamic value, and when we draw a line, we pass the starting position and the ending position, so the 2 points essentially for the line to be drawn between. So next we're going to say width and then y, so we're constantly always going to have the line starting at 0x and width x, so that way we're filling the entire screen horizontally, and we're just adjusting the y coordinate, so vertically where that line is going to be drawn. Now again, we need to specify the thickness. We're going to put the outline thickness here, also known as the width of that line. So now if we actually go here and refresh, you'll see that we get our vertical lines appearing, or sorry, horizontal lines. So now we can copy this exact same thing and paste it here and just adjust it for the vertical lines. So we're going to say for column in range 1, comma, cols. Now this is going to be column times the rectangular width, and we're going to change this to be x. So now we're going to keep the y values constant and adjust the x. So this is going to become x and then 0, and this is going to become x and height. So you can see that we always have 2 fixed values, right, where we want to draw between, and then what we're adjusting is the x position, whereas here we were adjusting the y position, and where we make that change is with col and the rectangular width versus row and the rectangular height. Now in this case, the rectangular height and width are the same. However, they could be different, which is why I'm doing this in 2 loops, because if we wanted to have actual rectangles, not squares, then this code would adjust to that appropriately. Okay, so let's run this, and you'll see here that now we get our grid. Okay, so now that we have our 4x4 grid, what we want to start doing is actually representing tiles in those grids and then drawing the tiles on the screen. Once we're able to draw the tiles on the screen, then we can start moving them on the screen. Again, as I said, this is a bit more complicated. So we're going to create a class here called tile. Now I want to use a class just because there's some methods related to each tile which will fit nicely inside of this object or inside of the class, so it just makes it a little bit cleaner. So as a class variable, I'm going to specify colors. Now what I'm going to do is paste a bunch of colors in here. I don't want to write all of them out because it's a little bit tedious, and these are the exact same colors that are used in the real 2048 game. Now, these colors represent from like 2, 4, 8, 16, 32, 64, etc. So as we go up, it's just multiples of 2 or whatever double the last value is, okay? So that's kind of how I'm doing it. I'll show you how we index the colors in a second. And if you want this list of colors, obviously you can pause it and type it out, or you can just view the code that's linked in the description, and rather than looking at everything, you can just copy this colors variable, okay? So again, in the description, you can find all of the code. There should be a GitHub link, and just go ahead and find the colors and paste them into your code if you're following along with me step by step. So next, we're going to define the initialization for our tiles. So we're going to say define underscore underscore init underscore underscore. We're going to say self value row and column. Now for each tile, we need to know what the value of the tile is. So is it a 2, is it a 4, is it an 8, etc. We also need to know its positioning in the grid. So what row is it at, what column is it at, and that will allow us to determine the X and Y position of where we want to draw the tile. It also allows us to know what tiles we can merge with, so that's why we're storing that value. So we're going to say self.value equals value and create that attribute, and we're going to say self.row is equal to row, self.column is equal to column, and then at the same time we're actually going to set what the X and Y coordinates are for drawing this specific tile. So we're going to say column times the rectangular width, and self.y is equal to the row multiplied by the rectangular height. Now, how does this work? Well, if we were in row 0, column 0, then we would simply start drawing this tile at the position 0, 0. right? That's the very top left-hand corner of the screen. If we were in row 0, column 1, then we would want to start drawing this from, if I can calculate this correctly, a y value of 0, but an x value of 200, because that's where we want to draw the tile that's in that first column. When I say first column, I really mean the second column. It's because in programming, we're starting indexing or starting counting at 0. You'll see what I mean, and actually, I can just run this to explain it to you. Like if we want to draw a tile that's where my mouse is here, I hope you can see it in the position 1, 1. So 1, 1 is row 1, column 1, as opposed to 0, 0 here. Then what we're going to do is start drawing it at the top left-hand corner position of this, which is what we're calculating when we're doing the x and y. So we multiply the column by the rectangular width, which brings us over here. We multiply the row by the rectangular height, which brings us here, and then we would draw the rectangle in this square. You'll see what I mean as we go through the code, but hopefully that's an okay explanation. Okay, so now that we have the initialization and we have some values that we need, we want to start writing some other methods related to this object. So before I write all of them, we'll specify what they are. So we're going to say, well, we want to be able to get the color that we're going to draw this tile in, and that's going to be based on its value. We also want to be able to draw this. So we're going to say self and window, because that's what we need to draw. And what else do we need to do? Well, we need to be able to move this. So we're going to take in self and some delta, which is how much we would want to move this by. And I don't know what just happened there on the screen. And then lastly, we'll have another method called set position, which will allow us to actually determine, let me just pass this here, what position this tile is currently in while we're moving the tile. We'll use some of these methods later on, but I just like to stub them out so we know what we're about to write. So let's begin by writing the get color and the draw methods, which are the ones we'll use for now. So again, we need to be able to determine what color out of this list of colors we're going to use for the tile, and that's going to be based on what the value of the tile is. So we need to have some kind of function that can essentially give us the following values. So when we have a value of 2, we want to get the 0th index, which is the first color, which is what the color of the value 2 should be. When we have the value of 4, we want to get index 1. When we have the value of 8, we want to get index 2. And when we have the value of 16, we want to get index 3. So you can follow this pattern here, and you can actually come up with an equation which will allow you to get this specific mapping of value. So anytime the value of x or the input doubles, we want to then get the next value in our sequence. Hopefully that makes a bit of sense. I'm sure this is bringing you back to math class. Well, how do we do that? Well, we have this wonderful thing called a logarithm, which will actually allow us to figure out what the power is that's required passed on some value to get some other value, right? I'm sure you guys are familiar with logarithms. I'm not going to explain how the logarithm works, and that was a pretty poor explanation. But we're going to say the color index is equal to the math of log base 2 of our current value. Now, if we look at the logarithm function, we can see that if we pass f of 2, that actually gives us 1. However, we want this instead to be 0, so what we'll need to do is simply subtract 1 from whatever the value of the logarithm was that's returned. Now, just to ensure we're always getting an integer value and not a floating point value, we'll first convert the result of the logarithm to an integer. It will always be a whole number anyways, but this will just strip off any decimal point that might be there, and then we'll subtract 1. So now we have a function that takes in whatever our values are and maps it to the correct index in our colors list. So now that we have the index, we want to access the color. So we'll say color equals self.colors at the color index. Okay, and then we will return the color like that. So this now will give us the correct color based on the value of this tile. Okay, now we want to draw the tile on the screen. Now when we're drawing the tile on the screen, what we need to do is draw a rectangle for that tile. We also need to then draw on top of the rectangle the value of the tile. So what we'll begin by doing is drawing the rectangle, and then we will draw the text on top of it. So we're going to say that the color we want is equal to self.getColor, and this is going to tell us the color that the rectangle should be. We're then going to draw the rectangle, so we're going to say pygame.draw.rectangle, and we're going to draw it on the window. What color do we want to draw it? Well, the color that we just got. And then we want to draw this at the self.x position, the self.y position, and with the rectangular width and the rectangular height. And that's it. We want this to actually be a solid rectangle, so this time we won't provide a width, which means it will fill in the entire rect that we provided here. Now that we've done that, we want to generate some text that we're going to draw in the middle of the rectangle. So to do that, we're going to use our font object. So we're going to say text is equal to font.render. So the process whenever you want to draw text is you use this font object and you render some string into a surface, is what it's called, that you can then put onto the screen. So we're going to say font.render. And what we pass for this is the value. So we're going to put an f string here, or actually we can just do string of self.value. So we convert our numeric value into a string so that we can actually draw that. We're going to pass 1 for something known as anti-aliasing. Don't worry too much about that. And then we need to specify the color. Now the color is going to be the font color that we specified earlier. Now that we have the text object, what this has actually done is created a surface that contains the text, and now we need to specify where on the screen we want to put the text. So to do that, we say window.blit. Blit is how you put a surface onto the screen. So it's a bit different than drawing the rectangles. Now what we pass is what surface we want to put on the screen. In this case, I want to put the text surface. And now we need to place this in the middle of the rectangle. Now to place this in the middle of the rectangle, we need to determine the top left-hand corner position of where we should start drawing the, what do you call this here? The text. So in order to do this, there's a little bit of math that we need to perform. I don't know if I have a drawing tablet or maybe an ink thing that I can use here on Mac. Let's see if there's like a drawing surface or something. Okay, I just found like an online drawing program that we'll quickly have a look at here, just so that you can kind of see what I mean. So let's say we have our rectangle, right? Kind of a sketchy rectangle. Now we want to draw our number in the middle of the rectangle. What we need to do is figure out the location that we want to draw it in. Now, naively, you might think, okay, well, if I want to figure out the XY position, let me just figure out whatever the XY position is of this, and then we'll just take whatever the width of the rectangle is, and we'll start drawing it directly in the middle, right? So you'll just take, okay, we have W, and we'll just take W over 2, and that's where we'll start drawing it. The issue is if we do that, then we're going to start drawing here, and the number is going to go to the right because it's the top left-hand corner that we're drawing from. So what we actually need to do is offset this by half the width of the object that we're drawing. So what I mean by that is we want to draw like this, right? So let's say the number is kind of in this box, like in this bounding box. We want to find this location. That's where we want to start drawing the number from. So the way we actually do that is, let me just clean this up a little bit. I know it's very messy here. We have some W, right? This is the width of the rectangle. So we start by taking W over 2, which is going to give us this position. So W over 2. We then want to make sure that the number is perfectly centered. So we say, okay, well, we have the bounding box of the number, and this has some width as well. We can just call this, I don't know, A, okay? So what we actually do now is we take A over 2, and we subtract that from W over 2, and that gives us this position here, which is the top left-hand corner position of where we want to start drawing this object from. So, quick clarification, right? We go to the middle of the screen, we then subtract from half the width of the object we're going to be drawing, and that means when we draw the object out, it will be perfectly centered in the middle of the screen. The same thing applies in the Y direction, so that's exactly what we're going to do here. Now, I know that was really sketchy, but hopefully that's an okay explanation. All right. So now that we have that, let's start doing our little bit of calculations here. So we're going to say, okay, well, we'll start drawing this at the self.x position of this current rectangle. And then we're going to add to that what we just specified. So we're going to take whatever the rectangular width is, okay, because that's the width of the rectangle that we're drawing inside of. And we're going to divide that by 2. That gives us the middle of the rectangle, but now we need that top left-hand corner position. So we're going to say text dot get underscore width. This gives us the width of the text object, and then we're going to divide that by 2. This now specifies that this is the x position that we want to draw. Now next we're going to do the y position, so we're going to say self.y plus, and this is going to be the rectangular height. If we can get our cap locks to work, for some reason my caps lock button doesn't want to work very well. So this is going to be the rectangular height over 2 minus the text dot get underscore height over 2. Okay, and that's all. That will actually blit this on to the screen for us. Okay, so now we have the ability to draw our tiles. Now also notice the order in which we did this. We first drew the rectangle and then we drew the text on top of the rectangle. It's important you do it in this order, otherwise the text will be hidden because you'll be drawing the rectangle after. So now what we'll do is call that function. So inside of our draw function, we're now going to take in all of our tiles. Now we don't yet have any of those tiles, but we will create them in a second. And what we'll do is before we draw the grid, we'll draw all of our tiles. And that way the grid lines will go on top of the tiles and it will separate them and make it pretty easy to see. So we're just going to say for tile in tiles, and then we'll just say tile.draw, and tiles is actually going to be a dictionary, so I'm just going to say tiles.values. I know it seems a bit weird because we haven't yet created the tiles, but we'll just do a quick test and I'll show you kind of how it works. All right, so now we have that for drawing. Now we just need to make some tiles and then pass those to our draw function. So we're going to say tiles is equal to a dictionary. The reason we're going to use a dictionary is that we want to be able to index or locate all of the tiles very quickly by their row and their column. So there's multiple ways that we can go about indexing our tiles or storing them, but what we want to come up with is a key that kind of represents the tile, and then the value will be that tile class itself that we can index in here. So to do that, we'll simply say the following. For now, we're going to say 0, 0, which is representing the row and the column. So like you could have 0, -0, but in our case, we know we're always going to have less than 10 or 1-digit rows and columns. So we just go 0, 0. So we'll say 0, 0, colon, and then we'll create a tile. Now for a tile, we need a value, a row, and a column. So let's go with a value of 4. And then let's go with a 0, 0 for the row and for the column. Okay, so now let me just change this to give you another example. Let's say we have the tile 128. Now we want this to be at row 2, column 0. So that would change this to be 2, 0. Okay, the way this works again is that we have a 2-digit string. The first digit represents the row, the second digit represents the column, and then that's associated with the tile object itself that we actually want to be representing and drawing. This way we can always index a tile given its row and column, and we can find it instantly inside of the tiles dictionary. This is opposed to as if we made a list. If we made a list and we wanted to locate a specific tile, we need to potentially iterate through all of the tiles in the list and check their rows and columns to find the one that we want. Whereas here, we can always have instant access to a tile. So kind of an efficiency thing. That's why we've written it this way. Okay, now we're going to pass tiles to the draw function and just make sure they draw correctly on the screen. So let's run this. And we got an error. It says draw is missing one required positional argument window. Okay, so we're going to go here to tile.draw and pass window. All right, let's rerun this. And now we should get our tiles on the screen, and we get them at the positions we specified, right? So this was, what, 2, 0, and 0, 0. We can do one more tile just as a test. So let's go here, and we'll say maybe 0, 2. And this will be with a tile. And this will be, let's go 64. And then 0, 2. Okay, let's run. And you see now we get the 64 tile appearing in the correct position. Okay. So that's great. However, we don't want to actually start our tiles with some fixed ones on the screen. We want to randomly generate 2 tiles that have the value 2 that will begin as our tiles, right? So let's write a function that can do that. Let's say generate tiles. Now for this, all we're going to do is just randomly pick 2 positions that we can put the tiles in, okay? And we'll just make sure they're not the same. So we're going to say tiles is equal to an empty dictionary. We're then going to say for underscore in range 2. If you're unfamiliar with the underscore, this is a placeholder value that we can use when we don't actually care about the variable we put here. Normally you do something like for I in range 2, but in my case, I don't actually want to use I just want to do something 2 times. So I'll just say for underscore in range 2. We're now going to say row column is equal to, and we're going to call a function which is get random position. And we're going to pass our tiles. And then we're going to say tiles, and we're going to do an F string, and this is going to be at row column, if we can do this, is equal to a tile, and then this is going to be to row col. We're then going to return our tiles. Okay, let me slow down a little bit to explain what we just did. So we have an empty dictionary where we're going to store our tiles. We're doing something 2 times. And what we want to do is generate a random row and a random column to place our tiles inside of. Now we want to make sure that we're only doing this for a tile that does not yet exist, right? We don't want to create a tile that's in the place of another tile. So that's where this function will come in, which we'll write in a second. It will make sure when we are randomly picking the row and column, we don't pick one that already exists. Then what we're doing is saying, okay, tiles, well, this is a dictionary, so we need to set the key. The key is going to be equal to first, whatever the row is, and second, whatever the column is. So we use an f string available in Python 3.6 and above, which allows us to embed inside of curly braces here any values that we want to be converted to a string. So we're saying, okay, well, we just want the row and the column, which are numbers. They're going to convert it to a string. That's going to give us the correct key. And then we're going to make that equal to a tile object, which has the value of 2, because we always want to start with 2s in the row and the column. Okay, now let's write our get random position. So we're going to say get underscore random underscore pause. This needs to take in the tiles so that we make sure that we are not placing this in a position that already exists. So we're going to start by saying row equals none, column equals none, because we don't yet know what we want. And now we're going to say while true, and we're going to continue to randomly generate rows and columns or a position for this tile as long as this position already exists. So what I mean by that is as soon as we find a position that does not yet already exist inside of our tiles, then we will use that one. Otherwise, we're just going to keep randomly generating positions. So we're going to say row is equal to random range, and this is going to be in the range 0 to rows. When we use rand range, it means we'll generate up to, but not including whatever the value is here, which is 4. So we'll generate a random value between 0 and 3 inclusively. We're then going to say column is equal to random rand range, and then 0 columns. Okay, so we're just picking what the random position is, or what it should be, what we're going to attempt. And then we're going to say if, and same thing, we're going to do an f string here, row column is not in, and then we can just say tiles like that. Then we're going to break. Now, this is another advantage of using the dictionary. We can instantly check whether or not this key exists inside of the dictionary because of that property of the dictionary. We have instant access to see, okay, does this key, so does this position row column already exist? If it does not, which is what we're checking here, then we're going to break, right? So then if we break, we're going to return the row and the column from the function that we generated. Otherwise, we're going to continue to do this until this condition is true, allowing us to break out, meaning we found a random position. Great. Okay, so now that we've done that, we will go over to our main, and we'll say tiles is equal to generate tiles, and that should generate 2 random tiles on the screen for us. So let's try this now, and you see that we get a randomly generated tiles. Let's run it again. We get more randomly generated tiles, etc. Okay, so there you go. We've now generated the tiles and placed them on the screen. Okay, so at this point we've written quite a bit of code, and we have the main structure of the application set up. Now what we want to start doing is moving the tiles around. So let me hop over to the drawing tablet and explain to you that process. It is a little bit complicated, then we'll begin implementing it. Alright, so I'm on the drawing tablet now, and I'm going to explain at a high level what it is that we're about to do. Now, I can't cover everything conceptually here, but I'll give you a sense of how to think about this problem. Now, if you are someone who likes these problems, feel free to try to solve it on your own, first of all, but you will see that it's a little bit complicated because of the fact that we actually want to animate the tiles, and we want to move them on the screen. So moving them is actually the difficult part. Doing the merges is not so hard to figure out what the new position should be. It's more about getting to that new position and how we iterate and move so that it looks smooth. Anyways, let's have a look here. So we have a few different edge cases that we need to handle, and we can go through them one by one. So let's say we have the number 2. This is our tile, and we decide to make a movement to the left. Keep in mind, all the movements effectively are going to be handled the exact same, so we can just look at a case in which we're moving to the left, but the exact same thing would apply if we're moving to the right. There's just a few variables that change. So we're moving to the left, and we have this tile. Now, there's a few things that can happen. The first thing that can happen is there can be nothing to the left, and we can simply shift the tile. That's the easiest case, right? There's nothing to the left of us, so we just move the tile until we hit the border. Pretty straightforward. We take the X position and we just shift it over, and then once it gets inside of this square here, we just change the tile's position. So then rather than being at 1, 1, it's now at 1, 0. Okay, so that's the important thing to also keep in mind here. We have an X and a Y, which is the location in which we're drawing the tile, and we also have a row and a col, which we'll represent with R and C, which tells us the current location of the tile in the grid. So these values are linked together. However, while we are moving the tile, the R and the column is kind of in between, right? For example, at one point in time, my tile might be in between two rows and columns. In that case, we don't know its exact location, and we need to wait until it reaches some kind of boundary point to then reset the row and column to be the correct position based on the X and Y value. So I just want to say that one more time because I understand it's a little bit confusing. We're going to have a tile that's going to be moving. Could be up, right, whatever. While it's moving, this row and column, we don't necessarily know what the correct value is. So at some point, we need to adjust this so that it represents where its location actually is on the screen. And that's typically when the tile is no longer moving. Okay, so anyways, that's kind of the basics there. So this is the first case. We just simply move the tile over to the left. Now the second case is when we have a blocking tile that is in the direction in which we're moving. So again, we're moving to the left, that's where we've shifted, and now we see that when we move to the left, well, this tile exists and it doesn't allow us to move. So if that's the case, we just simply stay put, right? There's no movement that occurs for either of these tiles. Now it gets a bit more complicated, right? Where we have this tile here. So now in this case, we move until we reach a tile that is blocking us, okay? So obviously I think that makes a bit of sense. Now the next instance is when we are moving in a direction and we have a tile that contains the same value as us. If that's the case, we actually want to take this tile, we want to move it so it kind of merges with this tile, and then we need to update the value of the tile to the left, so this becomes 4, and remove this tile, so let's kind of do an X here so that we no longer see it on the screen. So this is the merge instance. Now the thing with this is that there's kind of two stages to this merge. The first stage is while the tile is actually moving into the position of this tile. So to keep things looking smooth, we don't just want to instantly merge the two tiles as soon as we see that they are going to merge. What we want to do instead is we want to take this tile and we want to kind of move it inside of the other tile, and then as soon as it's fully emerged in that tile is when we remove it from the screen, and then we simply update this one so it now becomes the new tile value. So those are those two situations, right? The first situation, okay, we know we're going to merge, we need to keep moving it so it looks smooth. Then the second situation is, okay, we've already moved it inside of the other tile, so now we'll merge it together. So those are pretty much all of the edge cases. Again, we have a situation in which there's no tile to our left or in the direction in which we're moving. We just move the tile. We have a situation where there's a blocking tile where there's no movement that occurs. And we have a situation in which there's a merging tile where there's two phases. The first phase is to move into the square where the merging tile is, and then to merge the two tiles and remove the other tile. So that's what we need to handle. However, doing this is a little bit easier said than done because of all the things that can happen. For example, let's say we have something that looks like this, right? We have like 2, 2, 2, 2. Well, what we need to do is actually make sure that we move the tiles in the correct order such that the merges happen appropriately. So in this situation where we have 4 2s, we want to ensure that we don't accidentally merge the two middle tiles, because if we were to do that, we would be left with a result of 2, 4, 2, which is incorrect. What we want instead, although I guess you could define this behavior however you want, is that after we do this movement, we end up with 2 4s, right? So delete, delete, and we have 4, 4. So what that means is that we need to make sure that we're going to start moving the tiles from the direction in which we're moving. So if I'm moving left, we're going to check the first tile, then the second tile, then the third tile, then the fourth tile, and at one step at a time, move them to the left rather than moving the tiles from the right first. Because if we move the ones on the right, then we're going to merge in the wrong order. So the merging order is important. There's a lot of other factors we need to consider there, but I think that's enough in terms of the high-level explanation. So let us now get into the code, and I'll start explaining it. And again, feel free to pause it, go reference some of the other code if anything's going wrong, and ask any questions you have in the comments down below. All right, so we're back now, and we're going to start handling the movement. So what we'll do is we'll define a function, move tiles, which is going to allow us to move them. So we're going to say window, tiles, clock, and direction, and this will be one function that will actually handle the movement of the tiles in all of the directions. Now we'll start by just doing one direction so you get the gist of it, and then we'll handle the other directions, which are just slight variants of one of them, right? So what we're going to do is create a variable called updated equals true, and we're going to create something called blocks, which I'll define in a second. Pretty much this blocks set is going to tell us which tiles have already merged in a movement, because we don't want to be merging multiple sets of tiles. I can show you an example of what I mean in a second when we actually run the code, but we create this set here so that we know which tiles already had a merge operation occur, so we don't allow them to merge again, which means we don't get this like huge chain of tiles merging in a row, which is not how the original game behaves. You can obviously change the behavior if you want, but that's not what I want to do here. Okay, so now what we want to do is just handle what direction it is that we're moving. So we'll just stub a little if statement here, and we'll say if direction is equal to left, we'll say elif the direction is equal to right, and let's just do a pass here. We'll say elif the direction is equal to up, and we'll say elif after we pass, just so that we have a stub there, the direction is equal to down. Okay, so now we're handling all of the directions. The first direction we'll go into is left. So what we need to do is define a few functions and variables that we'll use in the main kind of block of our code. So this is going to seem very abstract right now when I write this out, but just bear with me and I promise you it will start to make more sense. So we're going to say our sort function, and we're going to use something called a lambda, if I could type this. So we're going to say lambda x and then x dot column. Now remember that we want to move the tiles when we're going left, for example, from left to right. So the first tile we move is the one that's furthest on the left, and then we go to the right and then move the tiles in that order. That way we merge in the correct order, so we need to start actually moving from that left side. So that means that we need to actually sort the tiles so that we know which tile we should move first, because right now our tiles are stored in a dictionary and we're not going to necessarily have them in a sorted order. So we're going to take the tiles and we're going to sort them into a list, and then we're going to move all of the tiles. So that's why I'm setting the key here equal to the column. So I'm saying, okay, we're moving to the left, which means we're going to sort the tiles by their column. Now, if you're unfamiliar with this lambda, this is a one-line anonymous function, and it works the exact same as any other function. So this that I just wrote right here is the exact same code as this. Oops, not func. Define func x, and then return x dot column. Okay, it's the exact same thing. It's just so you can write it in one line, and you don't need to define a name for it when you don't need that name. Okay, so that's kind of all that does. This is like, okay, we're making a function, this is our parameter, and this is what we want to return from the function. It only allows us one line, but that's fine, that's all we need. Okay, then we're going to have reverse equals, and this is going to be false. Now this is going to tell us whether or not we want to sort in ascending or descending order. So we could actually change this to just be ASC like that, standing for ascending. Or no, that's going to look a little bit weird. We'll do reverse instead, sorry. This is just, again, telling us, okay, do you want to sort in reverse order or correct order? Because when we're going to go in the right, we want to sort again, but we want to sort in reverse order, so we start with the largest column elements, which are on the furthest to the right. Okay, next we're going to have a delta. Now the delta is going to specify how much we want to move each tile by each frame in this movement function. So the delta is going to be negative move velocity and then 0. So we're specifying how much in the x direction and how much in the y direction we're going to move. In this case, I want to move negative in the x direction, which will move us to the left, okay? So reducing x moves to the left. Next, we're going to have a boundary check. Now this is going to be a function again, and this is going to be lambda. We're going to take in a tile, and we're going to check if the tile.column is equal to 0. Now, if the column of the tile is equal to 0, that means it's already as far left as it can possibly go, so we're not going to move it any further to the left because it's hit the bounds of the screen. So again, same thing, anonymous function just tells us, okay, have we hit the boundary or not? Next thing we need is a function that can get us the next tile, so this is the tile to the left of the current tile. We need to check that tile because based on its value, we're either going to be blocked by it or we are going to merge into it. So we're going to say get next tile is equal to a lambda function, and this is going to take in a tile, and it's going to say tiles.get, and we're going to say f, and then row, and then column -1. So what we're looking for and sorry, this needs to be the tile.row and the tile.column. So what we're looking for is the tile to our left. The tile to our left is the tile that has a column that's one less than us. Now we do .get because we don't know if this tile exists, so we don't know if there's actually one to our left or not. If there is one, this will return that tile for us, which allows us to use this indexing scheme. Otherwise, it just returns none, okay? Next, we're gonna have our merge check. Now this is a lambda function again, and we're gonna take in our tile and our next tile. Now what this is essentially telling us is whether or not we should merge the tile based on the current movement of this tile, because you'll see what we're doing is moving the x coordinate of our tiles until we reach a certain position, in which case we then do the merge. So we're going to say that the tile.x is greater than the next tile.x, and then this is going to be plus the move velocity. So what we're checking is, okay, the tile that we currently have, so the one that we're moving to the left, we're going to check if its x position is greater than the next tile's x position plus the velocity that we're about to be subtracting as we move. What this is telling us essentially is, okay, have we moved far enough left that it now looks like we're inside of that other tile? If we have, then we can go ahead and merge. If we haven't, which is actually what this is checking, sorry, then we'll keep moving the tile. You'll see how we use it in a second, but this is checking, okay, are we in the position to merge or not? That's pretty much what it's telling us. Okay, next we're going to have a move check. Now this is going to be for when we're moving and there is a tile to the left of us. However, that tile is not the same value as the tile that, that we're moving. So this is going to be lambda, tile, next tile, and this is going to be tile.x is greater than the next tile.x plus this time the rectangular width plus the move velocity. Okay, so why are we doing it like this now? So in this instance, if we're moving to the left and we have a next tile, we want to stop moving as soon as we reach the border of that tile. Now the border of that tile is on the right side of the tile that's to the left of us. So to get that position, we take the next tile.x, we add the width of that tile, and then we add the velocity which we would be moving if we were to continue the move. Again, you'll see how this works in a second. I know it's fairly abstract. Okay, lastly, we're going to have ceil is equal to true. Now this essentially tells us whether or not we should round up or round down when we're determining the location of the tile after a move. I know, a lot of code, very abstract, but these are the different things that will be adjusted based on the direction that we're moving. So you can imagine when we're moving to the right, some of these things are going to change, right? Like the move check, the merge check, the sort function is going to be a little bit different, the reverse function. Okay, so that's kind of what we're doing here in terms of this. And then we have some general code, which we're about to write, which will perform the move based on these functions. So this is kind of the cleanest way to write this. So what we're going to do is say while updated. Now the idea is, while we've performed some kind of move update, we need to kind of update the screen and redraw it so it looks like we're moving. As soon as we're in a position where nothing has moved, we're going to stop this while loop. So when no update has occurred, which is what's going to be indicated by this variable here, then we'll break out of the loop. So now we're going to say clock.tick, and then we're going to tick by FPS, and we're going to say updated equals false. So it's our responsibility as we go through this loop to update this variable and make it equal to true if an update operation has occurred. So now what we're going to do is we're going to sort the tiles. So remember I said we need to get the tiles in a sorted order such that we're moving them in the correct order so that we get the correct moves. So we're going to say sorted tiles is equal to a sorted function of the tiles.values. We don't care about the keys, we just want the values. And the key is going to be equal to a sort function, okay, like that. And then reverse is equal to reverse. So the sort function we defined here, reverse we defined here. We're now using these to sort the tiles in the correct order. We're then going to say for I, comma tile in enumerate, and we're going to enumerate over the sorted tiles. This simply means get the index of the tile as well as the tile object itself. First thing we're going to check here is, okay, we want to be moving these tiles. So we're doing this for every tile, right? we're going to check if the tile is at the boundary. So if the boundary check of tile, then simply continue, because if we're at the boundary, there's no movement that needs to occur for this specific tile, so we can move forward. Next thing we need to do is get the next tile. So we're going to say the next tile is equal to get next tile, and we pass the current tile. Now that's going to give us the tile that is in the way of which we want to move. So we're now going to say, okay, well, if we don't have a next tile, so if there's no tile in our way, then we can continue to move, because we're not at the boundary and there's no tile next to us. So let's just move our tile. So we're going to say tile.move by our delta. And before I forget, let's go and code out this function. So move is right up here. And the way we move is the following. We say self.x plus equals delta 0 and self.y plus equals delta 1. And that's it. Very straightforward. Again, if we go look at our deltas here, you can see that we just have the components of how much we want to move. In this case, we're just going to move backwards in the x direction, because if we add 0 to the existing value here in y, it doesn't do anything. Okay, so that is move. Now we get into the more complicated cases. So we say, all right, well, if there is a tile beside us, we need to check something. We need to check, first of all, is this tile the same value as us? So we're going to say elif the tile.value is equal to the next tile.value. If it is, now we go into those two cases. So I don't know what I just did there, where we need to determine, okay, well, if it's the same value, we're going to be merging with it, right? So we're either in the process of merging with it, or we've just merged, like we've moved the tile enough. So we're going to say if merge check, and then tile, if we can type this correctly, and next tile, then we're going to say tile.move, and then delta. So this is checking, okay, are we in the process of merging? If we are, we can continue to move the tile. Now, if we are not, then what we need to do is actually perform the merge operation. So the merge operation looks like this. We're going to take the next tile, we're going to get its value, and we're going to multiply it by 2. We're then going to remove the tile that merged with it, which is the one that we're moving. So we're going to say sorted tiles dot pop at index I, which is the index of this tile in the sorted tiles list. We're then going to say blocks dot add, and we're going to add the tile, and we are going to also add the next tile. Or sorry, we don't need to add the tile because we just removed it. We're just going to add the next tile. Now what this is doing here is saying, okay, well, we've already, okay, so what this is doing here is simply saying, all right, well, this tile just got merged with another tile, so we want to make sure it doesn't merge again. So we're just adding it into the blocks so that we can then use that set to ensure we don't do a kind of double merge operation. Now where we'll actually use that is right here. We're going to say and tile not in blocks and the next underscore tile not in blocks. When I save that, we'll get the auto formatting, but what we're doing here is making sure, okay, well, if the tile.value is equal to the next tile.value, so if it's the same, and that tile and the current tile that we have has not merged with another tile, go ahead and we can perform this operation. Now, if it has merged with another tile, we don't want to do this. We don't want to merge with it, so we're not going to initiate that operation. Okay. Next thing we're going to do is we're going to say elif the move check, and this is going to be tile next tile. Then we're going to say tile.move by the delta. Otherwise, we're going to say continue. All right, so let me just quickly break this down here. What we're doing is we're getting the next tile. If we don't have a next tile, we simply move. Now, if we do have a next tile and that tile value is the same as this value, we're going to go ahead and initiate the merge operation, which we discussed. Now, once we reach this elif, we know, okay, we do have a next tile. The next tile's value is not the same as ours. So what that means is that we should move this tile until we reach the border of that next tile, which is what's checked by this function. So we move until this is false, right? Until it says that you can no longer move, we're going to continue to move. Otherwise, if none of that is true, then we just say continue. And what that means is we're not going to do anything. And when we don't do anything, no update occurred. So now we're going to go down here and we're going to say updated equaled true. So unless we were in this case, or we were on the boundary, we're going to reach this variable and we're going to say update equals true, and that's going to tell us to initiate another loop here and continue the movement process because something did actually move. As soon as this variable never becomes equal to true, we stop the while loop and we exit. Now there's a few other things that we need to do, but that's a good start to our function. All right, so let's continue here. As I was discussing, while we move these tiles, their row and column are going to be adjusted based on their X and Y position. So based on where they're actually moving in the grid, because as they move enough, then they're going to be in a different row and a different column. So we need to actually adjust that. So to adjust that, we're going to use this, if we can write here, set position function. Now the set position function or method, whatever you'd prefer to call it, is simply going to look at the current X and Y position of this, tile, and then adjust the row and col based on that X and Y position. So we're going to say ceil is equal to false. And this is a variable that's going to tell us whether or not we should round up or we should round down, which is going to be important based on the direction in which we're moving. So we're going to say if ceiling, so simply if we're rounding up, then we're going to say self.row is equal to the math.ceiling, which is always rounds a value up. And then we're going to take the self.y, and we're going to divide that by the rectangular height. So let's say the y position is 600, right? We're going to take 6. So let's say the y position is 599. We're going to take 599 divided by the rectangular height, which is 200. That's going to give us like 2.9 something. We're then going to round that up to 3, telling us that we are currently still in the third row. Okay, we're now going to say self.column is equal to math.ceiling self.x divided by the rectangular width. And then for the else, so if we're not rounding up, we're going to round down. So we're going to say self.row is equal to math.floor. And then the exact same thing here, right? So this is going to be the y value, and then self.column is equal to math.floor self.x divided by the rectangular width. Okay, so that is just going to adjust the row and column as we move. And what we're doing is we're essentially, with this, determining at what point when we move to the left or to the right that we want to set that row column value. So when I go with ceiling, that means as soon as I move fully past the bounding line, or I'm right at it, then I'm going to adjust this as I'm moving to the left. Whereas when I'm moving to the right, it's actually going to be the opposite, because of the kind of directions in which we're moving. It's difficult to explain this, but you'll be able to see in the code here how we change this based on if we're moving to the left or to the right, so that we know what row and column we're actually in to check for the next tile. Okay, so now what we'll do is we'll go over here to updated, and either before or after updated doesn't actually matter the order in which we do it. We're just going to set the tile position. So we're going to say tile dot set position, and we're going to pass that ceiling value which we defined here. So when we're moving to the left, ceiling is true. When we're moving to the right, it's going to be false. Okay, now this is all good. However, you'll notice that we removed some tiles, but we only removed them from this sorted tiles list. Now this is not actually where all of the tiles are stored, it's just where they're temporarily stored while we're in this updated loop. So what we actually need to do now is adjust the tiles object itself, which was passed in here, to remove any tiles that were then removed from the sorted tiles, and to kind of adjust them. So what we're going to do is, inside of the while loop here, but outside of the for loop, so make sure you have that indentation correct, we're going to say update tiles, and we're going to take the window, the tiles, and the sorted tiles. Now all this is going to do is essentially loop through our tiles, and it's just going to remove any of the sorted tiles that no longer exist from tiles. So we're going to say define update underscore tiles, and we'll take in the window, the tiles, and the sorted tiles like that. And we will go ahead and write that function. So the way we can do this is we can just start by clearing all of the tiles. So we're going to say tiles.clear, just removes everything from the dictionary. And then we'll just say for tile in the sorted tiles. And then we're going to say tiles, and we'll create an F string again. Okay, and this is going to be tile.row, tile.column is equal to the tile. That's it. And then we'll just do a draw operation here so we can actually see what's going on. And we're going to draw the window and the tiles. So update tiles is going to, as I said, update this tiles dictionary so it only contains the ones that are actually still there, and it's going to draw all of the tiles on the screen as they move so we can actually see that movement operation occurring. So I think that's okay. Last thing we'll do here is we're just going to call something known as end tiles. Now notice that this is happening outside of the while loop, so as soon as we're no longer updating any tiles, we're going to call this function. So we're going to say define end tiles like this. This is going to take in the tiles. And what this is going to do here is just check whether or not the game is over and kind of do that last cleanup operation. So what do we want to do here? Actually, let's call this end move because that makes a bit more sense. Okay. And then inside of here, we're going to say if the len of tiles is equal to 16, then we're going to return lost. So if after we did a move, we have 16 tiles, that means that we can't move anymore because the entire board is, well, full of tiles, and that way we lost. So we'll just say we lost, and then we can handle that later on if we want. And then what we also want to do is we want to add a new tile to the screen, right? So every time we make a move, a new tile gets added. So we're going to say row column is equal to get random position, and this is going to be tiles, and then we're just going to say tiles at the f string of row column is equal to tile, and then what we need to do is randomly select whether or not we want the tile to be a 2 or a 4. So we're going to say random.choice, and then in an array 2, 4, just randomly pick between 2 and 4. And then the position is going to be at row column, and we'll just return continue so we know that we can continue the game. Now from here we'll also return end move, and then what we'll do is we'll just go to main here, and we'll actually start calling these functions that we wrote, and then if we get a end game returned, then we'll simply end the game, right? We can send a message to the user, we can do whatever we want. In fact, I'll actually let you guys handle that, but we'll talk about that in a second. Okay, so we've now handled moving left. The other movements will be fairly straightforward. I know that was kind of complicated. Let's actually test this though. So what we want to do is we want to check for the different key presses, right? So if you're pressing left, right, etc. So we need to first check, okay, did we press a key? So to do that, we're going to say if event.type is equal to pygame.keyDown. So did we press a key down? If we did, we're going to say if event.key is equal to pygame.k underscore, and we'll start with left. So if we press the left key, then we're going to say move tiles, and we're going to pass window, tiles, clock, and the direction, which is left. Okay, so we're checking. All right, did we press key down? If we did, let's check the key that we pressed. If it's equal to K left, which is the left arrow key, you can also do like K A if you wanted to do the A key, so K underscore A. But in our case, we want the left arrow key, which is denoted by this. Then we're going to call the move tiles function, pass the window, pass the tiles, pass the clock, pass the direction of left. Let's copy this 4 times and handle the other directions. Okay, so if the key is right, then we just change this to be right in lower cases. Otherwise, we'll do up and down, and then adjust this so that's up and that's down. Okay, so now we have all of the directions. However, only left is going to work right now. So let's go here and let's move left, and you'll notice that they merge together, and then we saw a new 4 got added to the screen. Now when I press left, you'll see that even though there's no movements happening, a new thing will add onto the screen, and you can see that as we move them, they will move and they will merge accordingly. Okay, so we can only currently move left, and you'll see that now at this point the game's over because we can no longer move or merge any more tiles, although I guess we could go up or down or whatever, but in this case that's fine. Okay, so that's it for left. Now we just need to handle the movement in the other directions, and then we're done. So to move in the other directions, we pretty much just need to copy all of this and then adjust it for the different directions. So let's go with right now. So we're going to copy all that and paste this inside of here. So to move right is going to be very similar. We're going to keep the column key the same. We're going to change this to be true because now we want to sort in reverse order. The delta now is going to be positive, so moving in the right direction. And the boundary check is going to be if the columns is equal to column -1, because that is going to be the kind of right boundary, right? If we're equal to whatever the number of columns is, -1, well then we're in the last column. Now getting the next tile, we're just going to add 1. not subtract 1. And now the merge check will look a little bit different. So here we're going to change the sign to be less than, and we're going to subtract the move velocity because now we're moving right. And now for the move check, again, we're going to need to adjust that as well. So this is going to be tile.x plus the rectangular width plus the move velocity is less than the next tile.x. Okay, so we kind of just flip this around again because we're moving right. That should now handle right. And then we're going to say ceiling is equal to false because we actually want to round down when we're moving to the right side. Okay, let's run this. And let's check left and right. So we can now move to the right and we can merge as well as moving to the left. Okay, looks pretty good. Obviously we could, make the movement more fluid, but I think this is actually pretty good so far. Okay, let's see what happens if we go and merge, and you see now that game is done. All right, so let us now do the up and the down. Okay, so how do we do this? Well, for up, we're gonna copy the exact same thing. And actually, we'll copy it from left because it's going to be a little bit more similar to that one, and paste that here. Now for the sort function, we're now moving up and down, which means rather than using the column, we're going to use the row. Now for reverse, this is going to be false as well. And for the delta, we're going to change this now, so it's going to be 0, and it's going to be negative move velocity because we're moving up in the y direction. For the boundary check, this now will be row, not column. So if we're at the 0th row, that means we're at the top of the screen. And when we get the next tile, we're looking above. So it's going to be row -1, and then the call will stay constant. For the merge check now, it's going to be similar, but this time we're moving up, right? So rather than using x, we're going to have to use y. So we're going to say tile.y is greater than next tile.y, and then this will be plus the move velocity. For the move check, similarly, again, we need this to be y, so we're just going to adjust this so that rather than x, it's y, and we're just going to change from rect width to rect height. Okay, for ceiling, that's going to be true as well. And now we're going to copy this, and we're going to do the same thing for down. Okay, so down, this time reverse is going to be true because we're moving downwards. The move velocity is going to be positive. The boundary is going to be rows -1. When we look at the next tile, we're looking down a row, so we're going to add 1. And for the merge check, again, slightly more adjustments here. So we're going to say tile.y, we're going to change the sign, and this is going to be less than the next tile.y minus the move velocity. And for the move check, same thing, it's going to be next tile.y, we're going to change the sign, and we're actually going to take this, and we're going to put this on the other side. Okay, so we're going to go like that, plus the rect height, plus the move velocity less than the next tile.y, and the ceiling is going to be false. Okay, now if we run this, we should have a finished game. So let's go ahead and do this, and you can see that we can move up, we can move down, we can move to the right, and we can merge our tiles, and we can play the famous game of 2048. I don't know if I quite know the strategy, maybe as well as some of you guys, but there you go. Functioning game. Now, as I kind of play through this, I will mention that there are a few like kind of tiny little bugs or things that you could adjust here. For example, it doesn't handle when the game is finished. That's actually something I intentionally wanted to leave for you as homework. We already kind of set it up, so it should be fairly straightforward to add it. And there's a few other like kind of small movement things that you might notice if you play this a long time. But overall, I think it's pretty good, and it's not really worth it to fix them right now because it will add a significant amount of time to the video, and I think most of you are going to be pretty happy with this implementation that we currently have. Now, another thing to note is that if you get too high up, you're going to run out of colors. So if we look at this here, I only added, my quick math is what, like 10 colors, 9 colors? So that means we're only going to be able to go up to 2 to the exponent 9. Or actually, I think 2 to the exponent, 2 to the exponent 9. So you're going to need to add some more colors if you want to handle larger values than whatever 2 to the exponent 9 is. I don't actually remember what that value is. So you can add more colors. You'll see that you'll get an index error if you go above that value, but that's a pretty easy thing to fix. Okay, a reminder, all of the code will be available from the link in the description. I hope you guys enjoyed this video. If you did, make sure to leave a like, subscribe to the channel, and I will see you in the next one. In this video, I will be sharing with you how to build a platformer game in Python. This game will have pixel perfect collision, it will have an animated character as you can see here, it will have single and double jumping, it will have all kinds of different animations for falling, jumping, colliding with obstacles. For example, you can see here when I hit the fire, I kind of go into this hit state. I will show you how to generate different objects, how to scroll the background, and really at the end of this video, you will have a solid fundamental understanding of how to build a platformer game in Python, and you can go and extend this and build really anything that you can think of. I will even include a ton of free assets for you that allow you to change your character, change the terrain, change the background, and do all of that extremely easily. In fact, in this tutorial alone, I will show you how to use 4 different characters. Let me show you those characters before we continue. So this is the second character here. This is being referred to as Mask Dude. This is the third character. I'm calling this guy the Ninja Frog, as you can see. And finally, we have this character here, which is called Pinkman. Now in this tutorial, you will learn how to use all of these characters and you can swap them out with a single line of code. With that said, I hope you're excited. This video has taken a very long time to prepare, so please click the like button. All right, so let's go ahead and get into it. Now, since this is a long video, I do want to spend a minute here just talking about who this video is designed for, exactly what you're going to learn and what you can expect, just so you don't waste your time if you don't want to go through it. So this video is really designed for people that have a bit of experience with Python. Ideally, you are an intermediate Python programmer. You understand the syntax, you know for loops, you know functions, you know all of that. If you don't, feel free to follow along, but I'm not going to be explaining those basic concepts. Now, this video will teach you how to build exactly what you see here. So by the end of the video, you will have exactly this. And if you're not interested in waiting until the end of the video, then you can download the code from the GitHub repository that I will leave in the description. That's also where all of the assets are going to be. So regardless, you're going to have to download the code from GitHub. Again, I will leave that in the description. Download that, open up the folder, and kind of we can start working from there. Now, really what I'm going to be showing you here mostly is sprite sheet animation, pixel perfect collision using what's called masks, and then how you can do the scrolling background, generating objects, all of that kind of stuff. That is really the hard part when it comes to generating a platformer game. Once you have all of that down, it's very easy to extend this, to add levels, to add like, a finishing flag, to add coins, to add, lives. You can turn this game into anything you want. And that's how I've designed this so that you have the base and then you can go and make it kind of a full-fledged game and work off of that. So with that said, I will stop talking now. I think this game looks really good. I'm excited to share this with you guys. So let's get into actually building it. So right now I have Visual Studio Code open. Obviously we're doing this in Python and I already have Pygame installed. Now the first thing we're going to have to do is install Pygame, which is the module we're going to be using. So to do that, go to your terminal and type pip install Pygame. If that doesn't work for you, you're going to try pip3 install Pygame. If that doesn't work, try Python -m pip install Pygame. If that doesn't work, try Python 3-m pip install Pygame. If none of those work, I will leave 2 videos on the screen that show you how to install that module. Now, once you have Pygame installed, I'm going to assume that you've downloaded the GitHub repository. Go to GitHub, there's a little button that says click to download. Download the folder, extract it to your desktop, and then open it in VS Code or whatever editor you want so you have something that looks like this. You should have an assets directory. Inside of assets, you should have a bunch of different folders, and then you should have a main Python file that contains all of the finished code. Now, obviously, we're going to write the code from scratch, but you can either work off that existing code or you can kind of clear the file and type along with me, whatever you want to do. I quickly want to run you through the assets folder, and then we'll get into the code. So in assets, we have a ton of stuff. We're not going to use most of this, but I wanted to include all of it so that you could kind of continue the game later if you want. So we have, for example, backgrounds. These are a bunch of background tiles, so you can change kind of the theme or color of the background very easily. I'll show you how to do that. We have items like boxes, checkpoints, fruits, etc. We're not going to use any of those. Then we have main characters. For main characters, we have a bunch of sprite sheets inside of here, and I'll show you how we can split these sprite sheets apart and use all of the different kind of animations inside of here, right? So we have that for Mask Dude, Ninja Frog, Pinkman, and Virtual Guy. All of the file names are the exact same. Okay, then we have menu. We're not going to be using anything from there. We have other. We have terrain. We are actually going to be using terrain. Specifically, we're going to pull out this kind of block here, but you could change the block again if you want to do that. And then we have traps, and we are going to be using the fire trap, wherever that is right here, that has kind of an animation, right, where the fire is going. But again, you can add all of this stuff later on. I will show you kind of the base on how to do it, and then you'll be able to extend from there. Okay, now that we understand the assets, I apologize for such a long introduction. Let's get into writing the code. I also need to plug that I do have a course, programmingexpert.io. If you guys want to get better at Python, check that out from the link in the description. Okay, so let's start at the top of our program here by importing everything we need. We're going to import OS. We're going to import random. We're going to import math. We're going to import Pygame. We're going to say from OS, import list directory. And we're going to say from os.path, import isFile and join. Now, the reason I'm doing all this OS stuff is because we are going to be dynamically loading all of the sprite sheets and the images so that we don't have to manually like type out the file names that we want. I'll show you how we write a function that just loads these folders here, kind of splits the sprite sheets automatically and gives us all of the images that we're interested in. Okay. After we do that, we're going to say pygame.init. We need to initialize the Pygame module. Then we're going to go down here. We're going to set a caption for our display. I'm going to say pygame.display.set_caption. If you're unfamiliar with what this is doing, this is setting the caption at the top of the window. I'll try to explain most of the Pygame stuff as we go through the video. I also have a ton of videos on Pygame on my channel if you want to check out something a little bit more basic. Okay, now what I'm going to do is define a few global variables that we're going to be using here. The first one is going to be the background color. Now, we'll use this for now until we implement our own background. And for the background color, I'm going to make this white, which is going to be 255, 255, 255. All of our colors in Pygame are going to be in RGB. Okay, so red, green, blue. That's what we have for our background color. We're then going to define the width and the height of our screen. For some of you, you're going to have to make this smaller if you're on a smaller display. For me, I'm on a 2K monitor, so I'm going to go with 1000 by 800. But if you're on, again, a smaller screen, you might want to make this just a bit smaller so that it works for you. Although it doesn't really matter, make it whatever size you want. Next, I'm going to say my FPS, which is my frames per second, is going to be equal to 60. And I'm going to define my player velocity equal to 5. And this is going to be the speed at which my player moves around the screen. Okay, now that we've done that, we need to set up a Pygame window. So I'm going to say pygame.display.set_mode. And then I'm going to pass the width and the height to this window argument here, this mode argument. And this is going to kind of create the Pygame window for us. I'm going to store that in the window variable. And there we go. We have kind of our global variables created. Now I'm going to make a main function. I'm going to say define main. This main function is going to be what we run to kind of start the game. So inside of here, I'm going to take a window, and at the bottom of my program, I'm going to say if __name __ is equal to __ main __, then call the main function and pass the window argument. Okay, so hopefully you can see kind of the structure of our program already. The reason I have this line right here is so that we only call the main function if we run this file directly. If we don't run this file directly, say we imported something from it, then we won't run the game code, okay? So that's why I have this. Inside of main is where we're going to write kind of our event loop. The event loop will be what's handling, say, the collision, moving our character, redrawing the window, all of that kind of stuff. This kind of good practice to have your event loop in one place. So inside of the main function, we need to set up a few things. The first thing we need is a clock. So we're going to say clock is equal to pygame.time.clock. We also need to define, a while loop that's going to continually loop and act as our event loop. So I'm going to say run is equal to true. I'm going to say while true, or while run, sorry. And then the first thing I'm going to do is say clock.tick FPS. Now FPS, remember, is our variable right here. What this line does is ensures that our while loop is going to run 60 frames per second. Okay, so no more than 60 times per second. That's what this ensures. If you're on a really slow computer, chances are you could be running less than 60 frames per second. But in my case, I'm on quite a fast computer. And if I didn't put this here, then you'd see that my game would be like way faster than yours. So we need to do this to regulate the frame rate across different devices. Okay, now that we have that, we're going to say for event in pygame.event.get. And the first event that we're going to check for is if the user quits the game. If they quit, by quitting, I mean they hit the red X in the top right hand corner, then we need to stop the event loop and exit our program. So I'm going to say if event.type is equal to pygame.quit, then we're going to say run is equal to false, and we can break out of this loop. Then we can go down here and we can say pygame.quit. Notice this is outside of the while loop. And then we can put quit, which will actually quit the Python program. Okay, so now we have our basic event loop. And what should happen if I run the code now is a Pygame window should pop up. Nothing should be on the screen. And if I hit the red arrow, it should close. So let's try this and see what we get. Okay, notice it says platformer, and then I hit X and it closes. Perfect. We're well on our way to creating the platformer game. All right, so now that we've done that, I actually think that the first thing we can do is generate our background. Then once we have the background, we can create a basic player that we can move around the screen. And once we have that, we'll start doing all of the animations. And then later in the video, once we've got kind of the bulk of the stuff done, we'll handle the collision and all of the movements, right? Okay, so I need to make a function here, and I'm going to call this get_background. Now, before I dive into this, let's have a look at our assets folder again. Now, what I want to do is use these tiles, right? They're just tiles. I believe their size is 64 by 64 or 32 by 32, something along those lines. Anyways, we'll want to use these tiles and tile the whole background. So what I need to do is essentially create a whole grid of these tiles based on the size of my screen. So the way I'm going to do that is by using a folder here. This folder is going to return to me, sorry, not this folder, my bad, this function. This function is going to return to me a list that contains all of the background tiles that we need to draw. So that's what we're going to do here with get background. Now, what we want to take is the name. Sorry, as I was saying, the name is going to be the color of our background, and that's going to allow us to change what background that we're using. So the first thing we need to do here is load this background image. Now, it's very important that when you run this file, you run it from the directory that the file exists in. Now, the reason I'm saying that right now is because the way I'm going to load this image relies on the fact that you're running this code from the directory that it exists in. So see here that I'm in desktop Python platformer, and then notice tutorial is inside of that directory. That's why this is going to work. If you try to run this code from a different directory, say I cd to desktop, and then I tried to run this, then I'm going to get an issue. So just make sure you're in the correct directory. I just want to say that before we even get into this. Okay, so I'm going to load my image. I'm going to say image is equal to pygame.image.load. And then what I'm going to do is join the assets path, which is directly in the directory this file is in, with the backgrounds path here, if I spell background correctly, and then with the name, which is going to be the file name that I want to load, which is really just the color of the background. Okay, now that I have that, I want to get the width and the height of this image, so I'm not guessing what it is. So I'm going to say __ width height is equal to image.get_rect. Now, when you do this, it will give you the X, Y, width, height. I don't care about the X, Y, so I've just put 2 underscores here denoting that I don't care about these values. And then I'm able to grab the width and the height. So now that I have the width and the height, I'm going to say tiles is equal to an empty list. And then I'm going to loop through essentially how many tiles I need to create in the X and the Y direction. So I'm going to say for I in range, and then I'm going to take my width. I'm going to integer divide this by the width of my tile, and I'm going to add 1. And then I'm going to do the same thing for my height here. So I'm going to say for j in range height over the height of my image plus 1. Okay, so notice width here is the width of the screen. Height is the height of the screen. I'm integer dividing this by the width of my tile, and that tells me approximately how many tiles I need kind of in the X direction to fill the whole screen. Then, just to make sure that I don't have any gaps, I add 1, and I do the exact same thing for height in the Y direction. Then what I'm going to do is say, actually, yeah, I'm going to say rect. Is this rect? No, we're going to say pause is equal to I multiplied by the width, and J multiplied by the height. And this is going to denote the position of the top left-hand corner of the current tile that I'm adding to this tiles list. In Pygame, when you draw something on the screen, you draw it from the top left-hand corner. So what I'll be doing is continually moving the positions based on how this for loop is going, right? So for every I, for every j, I'm multiplying it by the width and multiplying it by the height, and that gives me the accurate positions that I need to place every single tile in on the screen. Hopefully that makes a bit of sense, but that's how this is working. And then I'm going to say tiles.append my position, and then I'm going to return my tiles. I'm also going to return the image so that I can know what image I need to use when I'm drawing all of these tiles. Okay, now that I have my background, I'm going to go into main, and I'm going to say my background is equal to get background. And for the name, I'm going to reference here in the background folder any of these images. So we can use any one we want. It doesn't really matter. I kind of like the blue one, so I'll go with blue. Feel free to change this though on your end. And there we go, if I can type this correctly. Okay, so I'm going to say background, comma, BG image like that. And now I want to set up something that's going to draw my background. So I'm going to make a function here, and I'm going to say draw. This is going to take in a window. And for now, it's going to take in a background, and later it'll take in everything else you want to draw. Inside of here, I'm going to say Pygame.display.update. And before I do that, I'm going to draw my background. So I'm going to say for, and this is going to be tile in background like that. And then I'm going to say window.blit. And actually, I need to take my BG image as well. So let's take that. And I'm going to draw the background image. And then what I need to pass here is the position I want to draw it at, which is going to be tile. So what I can actually do is just convert this to a tuple. Notice the tile is going to be a list, right? Tile is going to contain kind of my XY position. You can see that here, right? We're appending pause, which is a list of XY. And now that I think of it, to make it easier, let's just make this a tuple directly. And now we don't need to convert it. Okay. So in case anyone's confused, what we're doing here is looping through every single tile that we have, and then we're going to draw our background image at that position, which will fill the entire screen with background images. Then what we're going to do is update the display. The reason we update is so that every single frame we kind of clear the screen, right? And we don't have old drawings still on the screen. You'll see what I mean in a second, but this draw function is where we're going to do all of our drawing. For now, the only thing we need to draw is the background. Later, it will be the player, the blocks, the obstacles, etc. Okay, so now I'm going to go inside of my while loop, and I'm going to call this draw function that we just created. And I'm going to pass window, and then, of course, I'm going to pass my background and my BG image. Okay, now this reminds me that I no longer need this background color. We're not going to use that, so I can get rid of that there. Okay, so at this point, assuming I've loaded the image correctly, we're now going to see this tiling the entire screen. So let's save and run. And notice that we get it, right? It's tiling the entire screen, looks pretty good to me. And we can quite easily change this if we want by just going here and saying, okay, rather than blue, I want yellow. And then we say yellow, and now we get a yellow background. Great. So that's kind of the advantage of how I've done this here. You can change the background to any color you want. Well, given that it's in the background directory. Now that we have our background, what should we do next? Well, we probably want to put a player on the screen and start seeing some images for that player. Now, the player itself is the most complicated aspect of this program. There's a lot of movement going on with it. So we'll start by just creating like a block for our player, kind of move the block around, have it jumping around. Then once we do that, we'll do all of the sprites and animations just so that we can get some more progress before we dive into that, because it is a bit of work. Okay, so let's go here. And let's say class player. We're going to use a class for our player. It kind of makes sense here. And this class is going to inherit from pygame.sprite.sprite. Now, I don't typically use sprites when I'm working in Pygame, but I'm going to use them in this tutorial. And the reason for that is that it makes it very easy to do pixel perfect collision. When we have two sprite objects, which we're going to have because we're inheriting from the Pygame sprite class, we can use a method that tells us if these sprites are colliding with each other. So just understand that's why I'm doing this inheritance. You don't have to understand exactly what the sprite is, but it kind of denotes that we have some properties on our class, and then it allows these special Pygame methods to use those properties to handle the collision for us. So we don't have to write anything too complicated when it comes to the collision, although we still do need to handle it a bit. Okay, so what we're going to do here is define our initialization, and we're going to take in a self, an x, y, width, and height. Now, the width and height will really be determined by the image that we're using for our player, but for now, since we're going to have like a block for our player until we add that image, we're going to have a width and height. Now, that reminds me that I just need to set a color for my player, so I'm going to say color is 255, 0, 0. I'm making this a class variable just so it's the same for all of my players and I have access to it just right on the class. Okay, now what I'm going to do is say self.rect is equal to pygame.rect. I'm going to pass my x, y, width, and height. So rather than representing all of these values individually, we're just going to put them on the rectangle, and this is going to make it a little bit easier for us to kind of move the player around and do collision and all of that. So a rect really is just a tuple that's storing 4 individual values. When I make it pygame.rect, it means we can use it in some kind of special equations and whatnot. Okay, now for our player, we're going to have a few values. The first thing we're going to have, I'm getting a bit ahead of myself here, but is going to be the x velocity. And the next is going to be the y velocity. Now, the x and y velocity is going to denote, what do you call it here? How fast we are moving our player every single frame in both directions, right? So the way that we'll actually move our player is we'll just apply a velocity in a direction, and then it'll just keep moving in that direction until we remove that velocity. Now, this will be great, for example, for something like gravity or jumping, and you'll see what I mean in a minute. Okay, now that we have that, we need to add something known as a mask. For now, I'm going to say the mask is equal to none, and then I think that's all we need for right now. So now that we have that, let's add our first function here, which is going to be the move function. So move is going to take in a displacement in the x direction and a displacement in the y direction. And it's going to say the self.rect.x plus equals the direction x, or displacement x, sorry, and self.rect.y plus equals the displacement y. Now, if we want to move up or down or left or right, we just change the sign of this dx or dy, right? Okay. So now we have move. Next, what we want to do is create 2 functions, one for moving to the left, and this is going to take in the velocity we want to move in the left direction, and the next is going to be moving in the right direction. Again, this is going to take in self and vel. Now, to move left, what we're going to do is say our self.x velocity is equal to, and then this is going to be negative velocity, and then to move to the right, we're going to say self.x vel is equal to vel. Now, the reason we use negative velocity here is because if we want to go left, we have to subtract from our x position. In Pygame, remember, our coordinate system is that 0, 0 is the top left-hand corner of the screen. So if I want to move down, I add to my y coordinate. And if I want to move to the right, I add to my x coordinate. So if I want to go up, I subtract y. If I want to go left, I subtract x. So that's why I'm putting a negative vel here. I know it seems a bit weird how I've just done move, and now I'm saying move left, we're going to have negative. Don't worry, you'll see how this works in a second. Next, I'm going to say if self.direction does not equal left, then self.direction is equal to left, and I'm going to say self.animation count is equal to 0. Now, we're not going to use these right now, but I just want to add them in for now at least, and you'll see why in a second. Now, I'm also going to say up here self.direction is equal to left. And the reason I'm adding this direction is because I need to keep track of what direction my player is facing. So later, once I have my sprites, I know if I'm showing the animation to the left or I'm showing the animation to the right. Now, the animation count, we're resetting that when we change directions. And the reason we're doing that is so that the animation doesn't look all wonky when we go from going left to right. So we need to kind of reset the count that we're using to change the animation frames. Again, you're going to see that later as we go through the tutorial. Now I've just added up here self.animation count equals 0, just to make sure we don't get any weird errors later. So now I have my direction and my animation count. Perfect. Okay, now I'm going to copy this. I'm going to put the same thing in move right, and I'm going to change the direction here to say right, and then right. So now we know what direction we're facing at all points in time. Okay, perfect. Next, what we need to do is we need to have some kind of draw function, and we also need to have what I'm going to call the loop function. And in fact, let's do the loop function first. So I'm going to say define loop, and inside of here, I'm going to take in self and FPS. Now, what loop is going to do is be called once every frame. When I say frame, that's really one iteration of the while loop. And this is going to move our character in the correct direction and handle things like updating the animation and all of the stuff that we constantly need to do for our character. So for right now, I only care about moving in the X direction. We'll handle the jumping later. So what I'm going to do is just say self.move. And I'm going to say that we're going to move based on our X velocity and our Y velocity. Now notice we're updating our X velocity here when we move left or we move to the right. So now if we call loop and we have some velocity in the X direction, it's going to move our character to the left or to the right. Okay, again, all of this will start to make sense as we get through the tutorial. There is a lot of stuff I need to do kind of up front before I can just show you instantly. So hopefully you guys are following along, but I just want to note, we eventually, of course, will see how all of this works. I'll walk through the code, so no worries if it's a bit confusing right now. Now, what else do we need to do inside of loop? Well, we need to update something known as the mask, which I'm going to get to in a second. But before we can do that, we need to define what's known as our image. So I'm going to say define, and this is going to be draw. And this is going to be the function that handles drawing on the screen. And for draw, we are going to take in our window, which I'll just represent with win. Now, what we'll do for now is we'll just say pygame.draw.rectangle. We'll draw the rectangle on the window, which is the first argument here. It's where we're drawing it. The second argument is the color, which is going to be self.color. Then the last is the rectangle. So I'm going to say that is self.rect. Now notice the rect here, right, has our X, Y width height. And when we move, we're updating the X and Y of the rectangle, which will then change where we're drawing it, if I can find it here, on the screen. Okay, so that's what we need for drawing. Now, actually, for now, I think that's okay. We will add to this, obviously, in a second, but I think we can generate a player, draw the player, see it moving, and then go from there. So let's do that. So let's go to main here. I'm going to create a player. I'm going to say player is equal to player. I need to pass an X, a Y, and a width, and a height. So I'm going to pass, let's say 100, 100, and let's make him 50 by 50. And then what we can do now is pass our player to the draw function. We can then take player inside of here, and we can say player.draw, and we can pass the window. Okay, so I will move the player in 1 second, but for now, let's just see if this is working, if it's going to show up on the screen. So let's run the code. And notice that now we have a red rectangle in the top left-hand corner. Obviously, nothing's happening right now because we're not moving it around the screen, but you could see it's showing. So we have our player. We're drawing the player on the screen. Now we want to start using some of these methods, right? Moving left, moving right, etc. So I want to separate my movement into a function. So I'm going to say define handle move like this. And for this, right now, we'll just take in the player. Now, inside of handle move, what we're going to do is essentially check the keys that are being pressed on the keyboard. If you're pressing left or you're pressing right, then we'll move the character to the left or to the right. Eventually, we will check for collision, and we will do all of that. So I'm going to say key is equal to pygame.keys, actually not keys, .key.get underscore pressed. This tells you all of the keys on the keyboard that are currently being pressed. And I'm going to say if, and actually this is going to be key. Really, we should call this keys though, because this makes a bit more sense. So we're going to say if keys, and then this is pygame.k underscore left. This is the left arrow key. If you wanted to use the A key, then you would use A like that. Yeah, actually, I'll go with left arrow key because that's what I usually do, but you can use A or swap it however you want. And then I'm going to say, if this is the case, then player dot move underscore left. And how much do I want to move the player by? Because we have to pass the velocity. Well, this is going to be my player velocity, right? Okay, next I'm going to say if keys, and this is pygame.k underscore right. Then I'm going to say player dot move underscore right. Again, same thing. I'm going to move this by my player velocity. Now, it's important that before I do this, I set my player velocity to be 0. Now, the reason this is the case is because if I don't do this, what will happen is as soon as I move left, this is going to set my player velocity, right? Which you can see here, my X vel. It's going to set the X velocity. Now, once I set that, I'm going to continue moving in that direction until it gets set back to 0. So if you wanted to make it so when you press a key, you just continually move in that direction until you press a different key, then you could omit this. But in our case, we only want to move while you're holding down the key. So I'm going to say player.xvel equals 0. There's a lot of other ways to go about doing this, but I just wanted to stay consistent with our movement because of how we're going to do the gravity. So for now, just bear with me. We essentially set the velocity to 0. And then if we are moving left or right, so if we're pressing these keys, then we change the velocity to be, the negative player velocity or the positive player velocity based on the direction we're moving in. Okay, that's actually all we need for handling the movement. So let's put the handle movement function. Where are we going to put this? We're going to put this before we draw. So I'm going to say handle move. I'm going to pass my player. All right, now I need to make sure before I do this that I call my loop function, okay? And I pass my FPS. And the reason I need to call loop is because loop is what actually moves my player, right? If you look at loop, it's moving my player in the X velocity and Y velocity direction every single frame. So if I set the X velocity, well, then I continue moving. Again, if I set the Y velocity, I move in that direction, but that only works if we're continually calling this loop function. Okay, good. So we've made great progress so far. Let's see now if we can move our player or if I've made any mistakes, which are very likely. So let's run the code and let's see. Okay, so I'm going to hit my right arrow key. You can see I can move to the right and I can move to the left. Obviously, if I wanted to go up and down, I could implement that, but we want to have it jumping, which I will show you in a second, but we kind of need collision before we can do jumping. Very good. All is looking great so far. Now let's implement gravity. So we kind of fall down. Then we can do kind of the sprite sheets. Then we can do the collision because the collision makes more sense, I guess, once we have the sprite sheets done. So let's implement gravity. Now, gravity is a little bit complicated because we want to have like kind of a realistic gravity, right? That actually implements some basic physics. What I mean by that is rather than just having a constant velocity, we want to actually have an acceleration for our gravity. So as many of you know, if you're in physics, gravity, the acceleration is negative 9.8 meters per second squared. I believe that's what the acceleration is. Anyway, in our game, we want to emulate something similar to that, where it feels like the longer you're falling, the faster you fall. You're not falling at a constant speed. That makes the game just feel like really, really unrealistic. So the first thing we need to do is pick some value that we want our gravity to be. And this is the acceleration of gravity. So keep that in mind. So for this, I'm going to make a variable in my player class because this is the only place we need it right now. I'm going to say this is equal to 1. So gravity is equal to 1. If you want gravity to be faster, obviously you increment this value, right? Make it larger. Okay. Now, inside of loop, this is where we need to handle our gravity. So every single frame in our loop, we're going to increase the Y velocity by our gravity. However, how we know how much to increase the velocity by varies on how long we've been falling for. Again, I know this seems really weird, but we essentially need to keep track of how long we've been falling so that we know how quickly we should be increasing our velocity or how quick we should be accelerating downwards. So that means that I need to create a variable here called self.count. And given we should really call this something better, I'll call it fall count. And this will essentially tell us, okay, how long have we been in the air for? How long have we been falling? And we'll use this value to determine how much we increment our velocity by. So now I'm going to say my self.y underscore velocity. And I'm going to add to this the minimum of 1 or, and then I'm going to take my self.count, and this is my fall count, divided by the frames per second, multiplied by the self.gravity. Now, this isn't truly what the acceleration would be, but this will give us like a kind of somewhat realistic looking gravity in the game. So just bear with me here. So what we're doing, we're taking our fall count, we're dividing it by FPS. The point of this is that if I want this value to be in seconds, then I need to take whatever my count is, which I'm going to increment every single loop. In fact, we'll do this right now. Plus equals 1. And I divide it by FPS. So if my FPS is 60, as soon as this is 60, then I've been falling for 1 second. I take that amount of time, I multiply it by my gravity, and then that tells me how much I'm going to increment my Y velocity by. However, this is going to start out being really, really small, just like fractional decimal amounts. So just to make this a bit easier for us when we do our collision, I'm going to increment this by the minimum of 1 or this value. So every frame we're moving at least 1 pixel down, and it doesn't take us like a full second before we really start feeling any effect of gravity. Hopefully that makes a bit of sense. You guys are understanding me here, but just bear with me. I've experimented with these numbers quite a bit, so I think this should be fine. Okay, so now that we have this, what should happen when I just click run here is I should just start falling immediately on the screen. And obviously, until we have some platforms or collision, we can't really stop falling if we have gravity. But let's have a look and let's see how it works right now. Okay, so you can see that I fall, and notice, I'll do this again, that I start falling slowly and then it picks up the pace, right? So this is somewhat realistic to how gravity would actually work, and that's what I was trying to implement when I did this. Now that we have done that, it's time to move on and have some kind of sprites or images. I was going to do this later, but I realized that we can't really do the collision, which is going to be pixel perfect collision, until we have some kind of images. That's really what we need. We need our sprites. So what we need to do here first is examine what our sprites look like for our characters. Now remember, all these characters are pretty much the exact same. They just look different, but in terms of their movements, their animations, the number of images, they're identical. So whatever I show you for one of these is the same for all of them. Hence why we can just kind of swap them out. So when I go to mask dude here, let's zoom in. You can see that we have, for example, double jump, right? I just picked a random sprite sheet. Now this sheet has 6 different animations or 6 different frames, which represent what this guy's going to look like while he's kind of jumping or double jumping in the air. So what we need to do is we need to split this one image into the 6 individual images and then loop through those images at some frequency or some time so that we can show them on the screen and show an animation, right? We need to kind of manually do this. Now, some of these are single frames, like falling is just single frame. That's easy. Hit, okay? This is like, you know, the guy disappears for a second, kind of expands, goes back. You get the point. We want to loop through these animations. Idle, single frame. Actually, no, idle is not a single frame. It's a bunch of frames. This guy's arms are kind of wagging up and down. We have jump, a single frame, run, a bunch of frames, and then wall jump. Now, notice here with these images that they're in different directions, or let's say they're all kind of facing right. So another thing we're going to have to do is rotate this image to face left when our character is facing left. So that's another thing we have to handle, that not only do we just have to split these images up, we also have to get a rotated version of them so that we can show you moving in a different direction. Same with jumping, same with being idle, like whatever direction you're going, we need to show the image flipped in that direction. So not rotate, sorry, flip. That's what we're going to do. Okay, so let's do this. First thing I will do actually is I'll write the function that will flip our image. So I'm going to say flip sprites. This is going to take in a list of sprites. And I'm going to return pygame.transform.flip. And this is going to be sprite, true, false. Notice as it says here, this is indicating what directions you want to flip in. When I pass true, this means flip in the X direction. When I pass false, this means don't flip in the Y direction. If you wanted to flip both, you'd pass true twice, but we don't want to do that. So I have pygame.transform.flip sprite, and then this is going to be for sprite in sprites. Really, I could call this image, but you get the point. Okay, so we have flip. Now we're going to write a function, which is load sprite sheets. And should we call it sheet or sheets? I think sheets is fine. And what this is going to do is load all of the different sprite sheets for our character. So it's going to give us the sprite sheet for double jumping, for hitting, for falling. And then within our character, we can pick what sheet we want to be using and what animations we want to loop through. So I'm going to take in directory 1 and directory 2. And the reason I'm doing this is so that I can load other images that aren't just my characters, and this will be very dynamic. I also want to take in the desired width and height of my image. And if we need to load multiple directions. So I'm going to say direction equals false as a default parameter so that we only load like the left and the right side images, like we flip the images if you pass this equal to true. Okay, now the first thing we need to do is determine the path to the images we're going to be loading. So I'm going to say join assets dir1 dir2. Notice I can use join because I imported this from os.path, okay? Now I'm going to get all of the images in this directory. Now the way I do that is the following. I'm going to say images is equal to, and this is going to be f for f in list directory. Again, notice I can use that because I imported it here. We're going to list all of the things that are inside of this path directory. And then we're going to say if is file, and then this is going to be join path and f. So what this for loop is going to do here, this, I forget what you actually call this when you write a for loop in a list. Anyways, what this line is going to do here is load every single file, only file, that is inside of this directory. So again, we're just going to get every single one of these file names. And then once we have those file names, we can load that image and we can then split that image up into the individual images that we want. Okay, so we have images. Now I'm going to say all sprites is equal to a dictionary. And what I'm going to do with this dictionary is have key value pairs where the key is the, let's say, animation style, and the value is all of the images in that animation. Okay, so I have all sprites. Now I'm going to say for image in images. And I'm going to say that my sprite sheet, so the individual sprite sheet I want to load here, is going to be equal to pygame.image.load, and then this is going to be join path and image, and then .convert alpha, which is essentially going to allow me to load a transparent background image. Okay, so we are loading the image, which is just one of the files that we found, right, from this path, and we just need to append the path to it, right? So whatever the path to the directory is, plus the image name. Okay, we're going to load that in. We're going to get the transparent background. Now that we have this, we need to get all of the sprites in this image. So I'm going to say sprites is equal to, and now this is going to be a list. Okay, so again, the process is load all of the different files. Okay, we have all the files. These are sprite sheets. Now we need to get all the individual images from the sprite sheet and load those. Okay, so I'm going to say for I in range. And then this is going to be sprite sheet.get underscore width, integer divided by the width of the image that we're loading. Now, width is going to be the width of an individual image inside of our animation or inside of our sprite sheet. So if I know this is, say, 32 pixels, I pass 32, and then it gives me a bunch of images that are 32 pixels wide. That's how I'm doing the loading. So that's why I took width and height here. Okay, now that we have that, we're going to say surface is equal to pygame.surface, and then this is going to be width, height. We're going to pass pygame.src alpha, which allows us to load, again, transparent images. And then I'm going to pass 32 here, which is the depth. Don't worry about that, but it's just what we need to load these images. And now we need to create a rectangle, which is going to tell us where in this image, again, image being the sprite sheet, that we want to take an individual image from and blit it onto this surface. I know this seems really weird, but what we're doing is we're going to create a surface that's the size of our desired individual animation frame. We're then going to grab that animation frame from our main image. We're going to draw it onto the surface, and then we're going to kind of export that surface. That's the way that we have to do this. So I'm going to say rectangle is equal to pygame.rect. And for the rect, this is the location on our original image that we want to grab this new frame from. So I'm going to say this is I multiplied by my width, and then 0, and then the width and the height of my image. Okay, now that I have that, I'm going to say surface.blit. Blit really means draw. And I'm going to draw my sprite sheet, but I'm going to draw this at 0, 0, and I'm only going to draw the portion of it, which is my rectangle. So notice this is my source, this is the destination, and this is the area of my source that I'm drawing. So in position 0, 0, which is the top left-hand corner of my new surface, I am drawing my sprite sheet, but I'm only drawing the frame from my sprite sheet that I want. Okay, then I'm going to say sprites.append, and I'm going to append my surface, but I'm going to make my surface 2 times larger because that's what I want to do. I want this to be bigger than the default size. So I'm going to say pygame.transform.scale to x, and then I'm going to scale to x my surface. Okay. Again, I know this seems a bit complicated, but now we have essentially stripped out all of the individual frames. We've just scaled them up to be double their size. So if they're 32 by 32, we've made them 64 by 64. That's what scale to x does. And now we need to handle the directions. Okay, so now we need to say if direction, then all underscore sprites, and this is going to be image dot replace. It's going to be dot png. It's going to be an empty string plus underscore right is equal to our sprites. And then we're going to copy the same thing. Let's copy this and put it here. And now this is going to be underscore left is equal to, and this is going to be flip sprites. So what we're saying here is if you want a multi-directional animation, then we need to add 2 keys to our dictionary here for every single one of our animations. So for falling, for hit, for idle, we need a left and a right side. So the right side is the one that we already have. So we're going to say, okay, all sprites at, and then we're just going to strip off the .png from whatever the name of our base image was. So that's going to give us run, jump, idle, hit, whatever the name of our files. And then we're going to append underscore right or underscore left. Now for underscore right, that's our basic sprites. For underscore left, we need to flip all of those sprites, and we already wrote the function that did that. Now otherwise, then what we'll do is say all underscore sprites at image.replace.png with an empty string. This just removes the .png, and then it's going to be equal to sprites. Okay, then we can return all of our sprites. All right, probably one of the most complicated aspects of the code that we need to write. So don't worry, we are done now with loading images. At least, well, we'll have to load our block, but that's going to be a lot easier than loading our sprite sheets. So this now will load a sprite sheet for us. Now that we've loaded our sprite sheet, we actually want to start using this. So inside of player, we are going to grab our images. So I'm going to say my sprites is equal to, and this is going to be load sprite sheets. And now I need to pass what I want to load. So now I need to pass the main character directory. And actually this is main characters. Okay, so have a look here. So inside of assets, right? Yes, so we're joining assets with dir1 and dir2. So the first directory I pass is main characters. And then I pass the second directory, which is the name of the character I want to load. So mask dude, ninja frog, pinkman, or virtual guy. You can pick whatever one you want. I'm going to go with mask dude for now. Now for width and height, the width and the height of this is going to be 32. So make sure you do this 32, 32. And then you pass true because we want a multi-directional sprite. So both left and right side animations. That's what we want. Okay. Now that we have that, we are going to change our draw here so that we're drawing our sprite. Now for now, we're just going to draw like one simple sprite just so you see how it looks on the screen. Then I'll go through animating the sprite and showing you how that works. Okay, so rather than pygame.draw.rect, I'm going to say self.sprite is equal to, and then this is going to be self.sprites at idle. Now, idle is one of the name of our animations, right? So if we go here, you can see we have idle, jump, etc. So I'm accessing the key from my dictionary, and then I'm going to access the first frame of this key, which is 0, because every single key is a whole like sprite sheet, right? So now that I have my sprite, I'm going to say win.blit, and then this is going to be self.sprite, and I'm going to blit this at self.rect.x and self.rect.y, which is the position on the screen. And then if we want, we can just turn off the gravity for right now so that we can kind of see it on the screen and it doesn't just disappear. Okay, let's try this out. Let's just make sure it actually loaded correctly. So let me run this, and we got an error. Okay, so let me see what error we got here. Run this again. It said key error idle. Okay, so the issue here is that since we load a directional sprite, we need to reference either idle right or idle left. So we can actually do this by saying idle underscore plus self.direction. And then so long as we set the direction, which we did here, to left, this should work. So now it'll change based on if we're going left or right. So actually you'll see that it should swap as we change directions. Okay, let's try this now. All right, so now we have this guy facing left. If I go right, he turns right, left, right. Perfect. Now we want to see him animated. So as I was saying, let's get into the animation. Now, this is actually going to be pretty easy because we've already loaded in all of the frames that we need. So I know that we don't have a ton to show right now, but a lot of the hard stuff is done for this video. So just making you aware that all this time has not gone to waste. What we need to do is we need to come up with something that has a way to kind of update our sprite or update what we're showing on the screen. So I'm going to write a function here called update sprite. And I'm going to take in self, and I'm going to say sprite sheet is equal to idle. Now, this is the default sprite sheet. If we're not moving, if we're not jumping, if we're not falling, if we're not being attacked, we use idle. However, if we are running or we're doing something else, then we use the other sprite sheet. So now I'm going to say if my self.x velocity does not equal 0, then my sprite sheet is going to be equal to run. So if I have some velocity in the X direction, then I'm running, right? So then I want to change this to the run sprite sheet. So now I'm going to say my sprite sheet name is equal to, and this is going to be my sprite sheet plus, and then underscore, and then plus the self dot direction. Perfect. So now we just change the main sprite sheet name. So idle, run, jump, whatever. We add the direction to it, and this tells us, what exact sprite sheet we want. Okay, now that we have that, what we're going to do is say the sprites that we could be using for this animation is equal to self.sprites, and this is in all capitals, at the sprite sheet name. All right, now that we've done that, we need to essentially iterate through these sprites and every few seconds change the sprite that we're showing so that it looks like we're animating. So we need to add a variable here that is going to account for the amount of delay between changing sprites. So I'm going to call this the animation delay. I'm going to make this equal to 5. Okay, now I'm going to come here and I'm going to say that my sprite index, which is essentially the sprite that I want to be using here, is equal to my self.animation_count, which we're going to increment in a second, integer divided by my self.animation_delay, modulus by the length of the sprites that I'm using. Now let's just put some parentheses here for order of operations, and let me explain what we're doing. So we have an animation delay. That's every 5 frames. So every 5 frames, we want to show a different sprite in whatever animation we're using. So if we're running left, if we're idle, whatever, it doesn't matter. We want to show a different one. So we take the animation count, we divide it by 5, and then we mod whatever the length of our sprites is. So if we have 5 sprites, then when we're on, say, animation count 10, we're showing the second sprite, right? You get the idea. So this is dynamic. This will now work for any single sprite. So hopefully you guys understand how this animation count is kind of working, but we're just trying to pick a new index every animation frames from our sprites, but we want this to be dynamic, so we're using the length of the sprites, and again, it's dynamic. It will work for any single sprite sheet we have. Now we need to select our sprites. We say self.sprite is equal to the sprites that we have access to at the sprite index. Then we update our animation count by 1. Now what we can do is remove this here from draw, and we just need to now call the self.update sprite from our loop. Okay, so now that we've done that, we'll call this, we'll update our sprite every single frame, and then we'll draw that updated sprite on the screen. Okay, let's run it and let's see what we get. Notice we have idle. Notice I can run to the right and I can run to the left. Now, if you think this is too slow, and some of you may argue that it is, then you just make this number smaller. So make this 3. Okay, and now it looks like we're running a little bit faster. So it's completely up to you how you want to animate this. I'll do 2 for now, and let's see if this looks better. So actually, I think 3 was a pretty kind of happy medium here, so let's go back to 3. Again, you guys can change this. It's up to you how you want it to look. Okay, now that we have that, we're almost ready to start doing collision. However, we need to introduce something known as a mask. So I'm going to make another method here. I'm going to say define update. Now, what we need to do here is essentially update the rectangle that bounds our character based on the sprite that we're showing. So there's different like kind of sizes to the sprites, right? Some are a little bit taller, some are a little pushed to the left or pushed to the right. And the rectangle that we have, we want to be essentially the same as the sprite that we have. Again, I know this seems a bit weird, but we're going to do this. We're going to say self.rect is equal to self dot, and then this is going to be sprite.get_rect. And we're going to say that the top left of this rectangle is equal to the self.rect.x and the self.rect.y. Now, pretty much what's going to happen here is depending on what sprite image we have, if it's slightly smaller, slightly bigger, whatever, we're going to constantly adjust the rectangle. Specifically, we're going to adjust the width and the height of it, but we're going to use the same X and Y position that we've had for this rectangle. If you don't understand that, that's fine. It's not a massive deal. This line is not crazy important, but it's just trying to make sure that the rectangle we're using to kind of bound our character is constantly adjusted based on the sprite that we're using. Now, what's more important is this line, which is updating the mask. We're going to say self.mask is equal to pygame.mask.fromSurface, and this is going to be self.sprite. Now, let me quickly explain this. A mask is essentially a mapping of all of the pixels that exist in the sprite. So whenever we draw something on the screen, we're really drawing a rectangle, right? But the rectangle may not have non-transparent pixels, right? So only part of the rectangle is actually filled in, hence why we get kind of a circular image, a dynamic image, whatever. So what this mask tells us is where there's actually images, or where there's actually pixels, sorry. And this mask allows us to perform pixel perfect collision because we can overlap it with another mask and make sure that we only say two objects collide if pixels are colliding, not if the rectangular box is colliding. If we did rectangular collision, then it constantly looks like we're hitting something even when we're not, because the rectangle for our character is larger than where all of the pixels for our character are. You've probably seen this in a lot of games before, but what the mask does is solve that problem for us and allow us to do this kind of pixel perfect collision. It's very important, though, that you call this mask. If you don't do that, this collision is not going to work properly. It needs to be mask because the sprite that we inherited from here uses this rectangle and uses this mask property when it does the collision. All right, so now that we've done this, I just need to call this function. So I'm going to go here and say self.update. And now we're done with most of what we need for the player. So what we want to do now is we want to start adding blocks onto the screen and then letting a player fall, collide with those blocks, and then be able to jump. Because obviously we can't really jump until we have something to jump off of. Otherwise, jumping in thin air doesn't make a ton of sense. All right, so let's create another class here. And this class I'm going to call object. And this will be a base class that we use for essentially all of our objects, just so that the collision will be uniform across all of them. So again, we're going to inherit from the sprite class from Pygame, and we're going to define our initialization. So define init, we're going to take in self, x, y, width, and height, and name, which for now is going to be equal to none, but could be equal to something. We're then going to say super dot __ init, which will initialize the superclass, which is this one right here. Now that reminds me, we need this as well in our constructor for player. So let's put that in player. Okay. Now we need to define our rectangle. So we're going to say self.rectangle is equal to pygame.rect. And then this is going to be x, y, width, and height. We're going to say self.image is equal to pygame.surface, and then this is going to be width, height, and then we're going to say pygame.source alpha like that. If we spell Pygame correctly, again, this just supports transparent images for us. My apologies. And then we're going to say self.width equals width. Self.height is equal to height, and self.name is equal to name. We're then going to say define draw. I'm going to say self and window like this. And then we're going to say win.blit. And this is going to be self.image. And then we're going to blit this at the self.rect.x and the self.rect.y. Okay, I know I went fast. Essentially, this is just a base class. We're not actually going to instantiate this, but this just defines all of the properties that we need for a valid sprite. So we have our rectangle, we have our image, we are drawing the image, and then in a class that we're about to use, we're going to inherit from this, and it will just save us from rewriting a bunch of functionality that we don't need. So the idea here is that all we do is modify this image. When we change the image, now the draw function will automatically draw it accurately on the screen for us. And all these other properties we're just saving in case we need them from our child class. So I'm going to make a class now called block. This is going to inherit from object. Now we're going to say define init. We're going to take in self, x, y, and the size of our block. Now, since the block is a square, we just need one dimension, not two, right? Okay, we're going to say super dot __ init. And we're going to pass x, y, size. So notice this constructor requires 4 arguments, so we have to pass 4 here. We just duplicate size because it's the same for the width and the height. Then we're going to say block is equal to load block, which is going to be a function that we write in a second that will take a size. we're then going to say self.image.blit. Imagine that this is going to give us an image, okay, which it will in a second when we write it. We're going to blit the block at position 0, 0. And then we're going to say the self.mask is equal to pygame.mask.fromSurface. We're going to take our self.image, and there you go. We have our mask, which we need for collision. Okay. Again, I know this is a little confusing. It'll make more sense in a second, but we're using this object, which now has this draw function built in for us. It also defines the rect, it defines the width and the height and all of that stuff. Here, what we do is we get the image that we need, which we're going to write this in 1 second. Then we blit this image to our image, which is a Pygame surface. And then we say self.mask is equal to pygame.mask.fromSurface self.image. We also could just say self.image is equal to the block, but let's do it this way for now. Okay, so let's now write our getBlock function, which I'm going to do beneath our getSpritesheet or load sprite sheet. So I'm going to say getBlock, and I'm going to take in a size. Now, what I need to do here is essentially find the block that I want in my train folder. So I'm going to say path is equal to join assets, and then this is going to be terrain like so, and then we're going to use the terrain.png file. So if I go here, you could see that we have terrain, and then what we want to do is load this block, which I'll be showing you how to load in 1 second. Okay, now that we have done that, now that we have our path, we're going to say the image is equal to pygame.image.load, and we're going to say path, again, .convert alpha so that we get a transparent background. We don't really need it for this one, but just in case later we load something that does have transparency, we will. And then we're going to say surface is equal to pygame.surface. And for the surface, we're going to pass size, which is the width and the height of our surface. We're going to pass pygame.sourceAlpha with a depth, of 32. We're going to say rectangle is equal to pygame.rect. And then this is going to be 96, 0, size. Now, let me slow down for 1 second. If we go to terrain, we can see that we want to load this guy right here. Now, I've already done the math. This image starts 96 pixels from the top of the screen. So that's the reason I'm putting 96 there, because I want to start at 96. So 96, 0 is my position. And then I want to load the size of this, which I think is going to be either 96 or 64 or something along those lines. Anyways, if I wanted to load, say, this terrain image, then I would still have 96, but my Y position would be different. In fact, the Y position would probably be a little bit less than 96. It might be 80. It might be 85. I'd have to experiment with it to see exactly where this image starts. But I just want you to understand that what I'm passing here when I say something like 96, 0, I'm passing the position that I want to load the image from the image, right? So I'm picking out a part of this image, and this is 96, 0. That's why I'm picking it right here. Hopefully, you guys understand that, but if you want to load a different terrain image, then you have to adjust these to be the starting position, the top left-hand corner of whatever image it is you want to load here. And I was going to say we could load a different one, but I don't want to waste time guessing which one it is, so you guys can mess with that if you want, but let's just load this top one, which I already know works. Okay, now that we have that, we're going to say surface.blit, and we're going to blit the image. And again, we're going to blit it at 0, 0, but we're only going to blit the area of it, which is represented by the rectangle. Then we're going to return pygame.transform.scale to x surface. Okay, so we've passed what size we want our block to be. Then we create an image that is of that size. Okay, we then say rectangle is equal to 96, 0, size, right? And then we blit this image onto our surface, which will be the image that we return. And we return this scaled up by 2 times. So it just doubles the size that we pass here. You don't have to scale it if you don't want, but I want it to be larger, so I am scaling it. Now, I understand, again, it's a bit confusing. This size is going to be the dimension of this block. So you want to pass whatever the size from this sprite sheet is that you want to get. In our case, I think it's going to be 64 or something along those lines. So that's what size will be. You guys can mess around with this, but really what you're going to be changing is these 2 values and the size. That's what you're going to change when you want to load a different image for your block. Okay, so now for block, we have getBlock or loadBlock. Did I call it loadBlock or getBlock? I called it get block. Okay, so let's change this to be get block. All right, so we now have our block. Let's create a block. Let's draw a block on the screen, and let's do some collision with our blocks. Okay, so let's go here to main, and let's say blocks is equal to, and let's just start by creating a single block. So for our block, let's just put it kind of randomly on the screen for now. Where do I want to put this? Let's go with something like, actually, I'm going to create a variable first. I'm going to say block size. Let's put this at 0, height minus the block underscore size. Block size is going to be equal to 96, okay? And then for the size, we're going to pass block size. Okay. So the size of our block is actually 96. I lied. It is not 64. It's going to be 96. So we're going to create a block. It's going to be positioned at 0, height minus block size, which is going to put it at the bottom of the screen. And then the size is this. Now we need to draw our blocks. So I'm going to pass blocks to my draw function. Okay. And I'm going to go here. And actually, let's call this objects. And we're going to say for object or for obj in objects, if we could type this correctly, obj.draw. I'm struggling here with the typing, and we will draw this on the window. Okay, so we have our block now. Let's quickly look at this again, right? We load our image. Okay, we get our block. We have our size. Now we create the block down here, and then we put it on the screen. Let's run it, and let's see if we get a block. And of course, we got an error. What does it say here? I need to run this again. Take 0 positional arguments, but 1 was given. Okay, so let's go to our player class here. And we can see update. I forgot to add the self parameter. So let's add that in, and that should fix it. Okay, so now you can see that we have a block. So now what we can do is create a whole floor of blocks if we want to do that. And then we'll implement gravity and then collision with the block so that you can see that you can land on the block and we can jump off of the block. All right, so let's make a whole floor. So to make a floor, we can do this. We're going to say floor is equal to, we're going to say block. It's going to be I times block size. It's going to be height minus block size, block size. For I in range. And then I'm going to say negative width times 2. And we're going to divide this by the block size and by the block size. Okay, then for my blocks, let's actually just replace this, and instead we'll just pass floor. Okay, what I've done here with this for loop is I've said I want to create blocks that go kind of to the left and to the right of the screen. So I don't want to just fill the current screen because we're going to have a scrolling background in a second, which we'll implement in a minute. Anyways, I want to have some kind of going to the left and some going to the right. So I'm taking my negative width over the block size, which is how many blocks I want to the left side of the screen. And then I'm taking my width times 2, and I'm integer dividing that by the block size again. That's how many blocks I want to the right of the screen. Then I'm taking I'm multiplying it by my block size, which is telling me the X coordinate position that I want my block to be at. And then this is always going to be the same because I want it to be at kind of the bottom of the screen. And then for my block size, well, I want that to always be the same. Okay, so let's run this now and see what we get. And now we get a bunch of blocks. So now that we have these blocks, let's make it so we can collide with the blocks. And so we have gravity and we actually fall onto those blocks. So the collision. All right, collision is a little complicated, but let's write it and let's see how we can get it going here. So inside of handle move is where we're going to handle our collision, which means we need to have a list of objects that we can potentially be colliding with. Now we are going to write a function here called handle vertical collision because we need to handle the vertical and horizontal collision differently. For now, we'll just start with vertical. Now we're going to take in player, objects, and the displacement in Y that we just moved. Now we're going to have collided underscore objects is equal to a list. And we're going to say for object in objects. These are all the objects we could be colliding with. And we're going to say if Pygame dot sprite dot collide mask, and then we're going to pass our player and our object. Now, remember I told you collision was going to be simple? Well, there you go. This is all you need to do to determine if two objects are colliding. The reason we can do this is because our objects we've inherited from the sprite class, and on them we have a mask. So we're going to use this mask property as well as the rectangle property when we collide with the mask. So I pass my player, I pass my object, and this will tell me if I am colliding with my object. Perfect. Now, if I am, I'm going to do some stuff differently depending on what direction I'm colliding in. So if I'm hitting the top of the object, it's going to be different than if I'm hitting the bottom. So we need to handle that here. So I'm going to say if my displacement y is greater than 0, really this should be velocity, but that's fine. Then what I'm going to do is place my character on top of the object it collided with, so I'm no longer colliding with it. Now, what this is saying is if I'm moving down on the screen. So if I'm moving down, then that would mean I was colliding with the top of this object. So if I am, I'm going to take the bottom of my player rectangle, which is my player's feet, essentially, and I'm going to make it equal to the top of the object I'm colliding with. This is another advantage of using rectangles. You can use this kind of bottom and top property and avoid having to do, add the height and all that kind of stuff. So that's what I'm going to do. Now, otherwise, I'm going to say if my displacement y is less than 0, and I suppose this can be an elif, then what I will do is say my player.rect.top is equal to the obj.rect.bottom, because if I'm moving up, which means I have a negative velocity, then I am hitting the bottom of an object, so I need to make my top be equal to the bottom. Okay, this just makes it so you don't stay inside of the object, you go outside of it, and it looks like you collided, but you didn't go through the object. Now, one thing we also need to do here is we need to call the method player.landed and player.hitHead, which I've not yet created. And we're going to write these to handle what happens when we land on a block and when we hit our head on a block. Okay, then we're going to say collided objects dot append, and we're going to append our object, and we're going to return our collided objects, just so that we know what objects we collided with, so that we can check if we collided with like fire or a certain special object or something like that. Okay, so that's handle vertical collision. Now we need to write the landed and hit head method. So let's go to player and let's do this. So I'm going to say, let's do it here. Landed self. Now, what do we do if we landed? Well, if we just landed, then we need to reset our gravity or our fall counter. So we're going to say self.fall count is equal to 0. So that way we stop adding gravity, right? Okay, what else do we need to do if we landed? We need to say that our y velocity is equal to 0. If we landed on a block, stop moving us down. And I'll add this in now. We're going to say our self.jump count is equal to 0. We're going to do something with jumping that involves double jumping, so we'll have a jump counter. I'll just put this here now, and then we'll use it later. Okay, so that's if we landed. Otherwise, I'm going to say define hit head. For self, I'm going to say self.count equals 0, but if we hit our head, I want to reverse our velocity so that now we move down because we're moving up, right? So I'm going to multiply my velocity by -1 so that when I hit my head, I kind of bounce off the block and go downwards. That's what's going to look most natural. Okay, so that's all we need for right now for hitting the head. Now we can add our gravity back. And when we add our gravity back, what's going to happen is we'll fall, we'll hit the block, it'll move us to the top of the block, and then we should just be able to move on top of the block. Let's see if that's going to work, though. Although, it's not going to work if we don't add the function call. So let's add the function call here. In handle move, we're going to say handle vertical collision. We'll pass the player, the objects, and the player.y velocity. And the y velocity is essentially how much we just moved, right? Okay, very good. Now let's make sure handle move, we need to pass our floor. So let's do that. All right, let's run the code. Let's see what we get. And boom, look, we land on a block and we can now run on top of the block. And everything is looking very good to me. Okay, so that's pretty good. Now that we're on top of a block, we can jump, and then we can deal with hitting blocks, horizontally, right? So that we can't run into a block. And we'll also make the background scroll and then we'll be pretty good. We'll have a lot of this tutorial finished. I wanted to make us jump. Yes, let's make it jump. Okay, so let's go to our player, and let's create a variable here, self.jump underscore count is equal to 0. Now, based on the way we've coded this, jumping is actually quite easy. I can say define jump self, and when we jump, all we're going to do is say self.y underscore velocity is equal to the negative of self.gravity multiplied by whatever factor you want in terms of the speed of your jump. So I'm going to multiply gravity by 8. The reason I'm doing this negative is so that I jump up in the air, right? So now that I've done this, what will happen is as soon as I hit the jump key, I'll jump up into the air. It's pretty straightforward. And the reason that's going to happen is because my y velocity will change. And what will bring me down is the fact that inside of my loop, if I go to where loop is, I'm constantly applying downward gravity. So what I'm doing is changing my velocity to go upwards, and then I'm letting gravity take me down. So that's kind of the benefit of how we've coded this. Jumping is very easy. Now I'm also going to reset my animation count to 0. I'm going to say my jump count plus equals 1. I'm going to say if the self.jump underscore count is equal to 1, this means that I'm double jumping. So if the jump count's equal to 1, when I hit jump, that means it's just going to be equal to 2 now. Actually, let me take this, sorry, and put this down here. Then I will say self.count is equal to 0. Yeah, I think, does that make sense? No, I want to do it this way, sorry. Okay, so what I'm trying to do here is make it so that as soon as I jump, I essentially get rid of any gravity I've already obtained. So let's say I was like falling and then I landed and then I jumped. There would be some gravity on me keeping me on the ground. So I want to remove that gravity so that when I jump up, it's not in the factor, like it's not taken into account. And then I'll start applying the gravity after I've jumped. Hopefully that makes a bit of sense, but this should say fall count. So as soon as I jump, I'm resetting the fall count to be equal to 0 so that any gravity I've accumulated, I'm removing. But I'm only doing that if this is the first jump I'm making, because for the second jump, I want you to have to time it based on like when you're jumping, right? So if you jump a second time, close to when you jumped the first time, you will jump higher than if you jumped at like the peak of your jump when your gravity would be the highest. Okay, I don't know if that makes sense, but just follow along here. I messed with this before. This works, trust me. All right, so we have jumping now. I think that's all we really need for jumping. Yeah, that seems good to me. So now if we want to jump, let's make it so when we hit space, we jump. So we can do that inside of handle move. Actually, I'm not going to do it in handle move. I'm going to do it here in the event loop. And the reason for this is that if I do it in handle move, what's going to happen is if I press the jump key and I hold the jump key down, I'm going to keep jumping a bunch of times. I don't want to do that. I just want to jump once when I hit the key, and then I have to release the key and press it again to jump. This tells me if I'm holding down the key. What I'm going to do in here tells me if I released the key. Yeah, you'll see. But yeah, this is how I do it. So I'm going to say if event.type is equal to pygame.key down. Then I'm going to say if event.key is equal to pygame.k underscore space, and my player.jump count is less than 2, because I'm going to allow double jumping, right? So I'll have 2 jumps. Then I'm going to say player.jump. Okay. That should be all we need for jumping. So let's try it out, and let's see if this works. And I can jump. And notice I can kind of run and jump at the same time. Now, what I'll do now is add like falling and jumping animations, because obviously it looks kind of weird right now when I'm jumping. But there you go. We can jump. Nice. Okay, so let's add the animations now. So if we go to update sprite, all we need to do here is we need to say if self dot, and actually I need to refer to my cheat sheet here because this is a bit more complicated than I thought. Okay, I'm going to say if self.y underscore velocity does not equal 0. Then what I will do is say if self.jump count equals 1, then I'm going to say my sprite sheet is equal to jump. I'm going to say elif self.jump count equals 2, then my sprite sheet is equal to double jump. Now, this is actually going to be if my velocity is less than 0, which means I'm moving up. Now, the next one that I want to add is I want to say if, and actually these are all going to be elifs. Well, not that one, but this one. I'm going to say elif my self.y underscore vel is greater than 0. This means I'm moving down. Then my sprite sheet should be equal to fall. Okay. So this is handling regular jump and double jump. And this is telling me if I am falling. Let's try it now. And let's see what happens when I jump. Okay. So it's kind of glitching a little bit. The reason this is happening, I believe, is because we are applying gravity even while we're on the ground. So my y velocity is always greater than 0, and then stops being greater than 0. Then it's greater than 0 again. So I will show you how to fix this. All right. So actually, the way that I'm going to fix this is a bit of a hack, but it's going to be good. It'll work here. So I'm actually going to say if my self.y velocity is greater than self.gravity times 2. Now, the reason I'm going to do this for fall is so that I don't immediately start glitching into this fall state when I have a really low amount of gravity being applied to me when I've gone off the block and then I've fallen down to the block. So let me show you what I mean by just kind of running the code here. So you can see that what happens is when I hit the block, when I collide with it, it's going to reset my gravity count, and then I'm going to kind of spawn to the top of the block. So when I'm on the top of the block, I'm going to be slowly falling down to the block. Then I'm going to hit the block. When I hit the block, it's going to do the same thing. It's going to bring me to the top, reset my gravity count. So what was happening before is that we would go to the top of the block, and then our gravity would increase a tiny bit, right? It would increase to be 1 pixel per second or something along those lines, which would mean we were falling. So then we were falling, we hit the block, and then it reset it. So it kept glitching between the two states. So what I've done is just made it so we have to have a significant amount of gravity before it starts showing that fall state. So now it doesn't look glitchy on the screen as I'm jumping around. And you can see that what actually happens is when I jump and I get to the peak of my jump, you can see that it starts the falling state because now my velocity has changed directions, right? Now I'm going down. Okay, so now we have jumping. Now we have running around and colliding with blocks. Done quite a bit, actually. The next thing I want to do is make it so that objects move on the screen. Then we will do our horizontal collision, and then we will pretty much be done after I add kind of that like fire state, right? Or that, let's call it a trap. Something like that. Okay, so we want to do scrolling background. Scrolling background is actually fairly easy. The way that we do a scrolling background is we simply offset every single thing that we're drawing on the screen by a certain amount. So any object that we have, we don't change its position at all. We just change how we're drawing it on the screen. So it doesn't affect any of our collision. All it affects is what's seen, right? So what's happening in the background is we may be colliding at a really far position to the right, but we're showing the position currently on the screen. You see what I mean? But what this involves is having some offset x, which I'm going to say is equal to 0. Now, the way that I want to have it, and I'll just illustrate here, is that when I'm on the screen, I only start scrolling the background when I get close to the edge. So like here, right, it would start scrolling. Whereas if I'm in the middle and I'm kind of moving like this, I don't want it to scroll the background until I get to the edge. Oh, also notice you can double jump here. I kind of forgot to mention that part. So I'm going to implement that where essentially once we reach a certain boundary, then the screen will start scrolling. All right, so how do we do this? Well, we can do it just directly inside of our loop here. And we're going to do it here. We're going to say if the player dot rect dot x minus the offset x plus the player dot rect dot width. And actually, now that I think of this, we're just going to do this. We're going to say if the player.rect.right, which will account for the width, minus the offset x is greater than or equal to the width minus a variable that I'm going to write in a second, which is scroll area width, and the player.x underscore velocity is greater than 0, then we're going to say offset underscore x, and this is going to be plus equals the player.x velocity. All right, let me just write this variable, then I'll explain how this works because we also have to do the other side. So I'm going to say scroll area width is equal to 200. What that means is that when I get to 200 pixels on the left or 200 pixels on the right of the screen, I start scrolling. Okay. So here what I'm doing is I'm checking if I am moving to the right. That's what this checks. If my X velocity is greater than 0, that means I'm moving to the right. And this is checking if my character is right on the screen, like if it's crossed a specific boundary. So I take whatever the right position of my player is, which could be very far off the screen. I subtract whatever offset we currently have. So if we're offsetting everything by 100 pixels, for example, I subtract that. So I know where I'm actually showing the character on the screen. And I say if that's greater than the width minus the scroll area width, which means I'm at, say, 700 pixels, something like that on the right side of the screen, then I'm going to offset the screen by whatever the velocity was that my player just moved to the right. So that will make it look like I'm scrolling. Now we can say or and do the exact same thing for the left side. So I'm going to say if player.rect.left, and this is actually going to be, is it going to be plus the offset? I got to check if it's plus or if it's minus. No, it's going to be minus again. Minus the offset x is less than or equal to the scroll area width. And my player dot x underscore vel is less than 0, then I want to do this. Now let's move this down on the screen a bit. And I'm just going to add some parentheses so that my condition is correct here. Okay, so I think that should be good. Again, I'm checking to the left and to the right side. If I'm moving to the left, I want to check if I'm at that boundary. If I'm checking to the right, or if I'm moving to the right, sorry, I want to check if I'm at that boundary. And then I increment my offset x. Now, all I have to do to account for this is add an offset x to my draw function and draw every single object offset by this x. So I'm going to go here and say offset underscore x. And now, just to all of my draw functions, I'm going to pass offset x, offset underscore x. And I'm going to go to all my draw functions, and I'm going to add this. Offset x, and what I'm going to do is just subtract the offset x from the x position I'm drawing everything at. So I'm going to say minus offset x, and we'll take in the offset underscore x. Okay, now the reason this works, if I move to the left, my offset x is going to be negative, which means everything is going to push to the right side because we're adding to the position for it. If I move to the left side, or sorry, if I move to the right side, the offset x is going to be positive, which means everything is going to move to the left, so it has a scrolling background effect. Let's just run it though and see if it works, then I can fix it if it doesn't. Okay, so as I start running here, you can see that now the floor is going to start going with me once I reach this boundary. However, on this side, right, like kind of when I'm in the middle, it's not doing anything. I have to get to a certain boundary, which is kind of invisible on the screen, and then it starts scrolling with me, which is what I wanted to do. And then notice if I jump here, boom, I fall off the platform. Let's do collision with blocks in the horizontal direction. So to do that, I'm just going to add a block here. So I'm actually going to make a list. I'm going to say objects is equal to asterisk floor. Now, if you've ever seen like kind of ... in JavaScript, that's what this does in Python. It just essentially breaks this floor into all its individual elements and passes them inside of this list. So imagine it, if me just writing this here, that's what it's doing. And then I'm going to pass another block. And for this block, I'm going to place this at, let's do 0. And then for the y, this is going to be the height of the screen minus the block size times 2. Now, the reason I'm multiplying this by 2 is so that I get it a bit higher on the screen so that we can kind of run into it horizontally. And then I'm going to pass my block size. So I'll just see now, I want to go and rather than drawing my floor, I want to pass objects. And same here with handle move, I want to pass objects. So let me run this. So now you can see that I have that block there, right? Now, notice that when I hit the block, I kind of go to the top of it. And the reason I go to the top of the block is because right now I'm only handling my vertical collision. So when I hit the block, I have a little bit of gravity because remember, there's always some gravity on me when I'm on the floor. And so it thinks that I've hit the top of the block, so it spawns me on the top of the block. So we need to make it now so that when you hit the block in the horizontal direction, it kind of pops you off of it so that it doesn't think you're hitting the top of the block or the bottom of the block alternatively, which you'll see in a second. And in fact, let me add one more block to show you hitting our head on the block. So let's add another block. Let's make this at, say, block size multiplied by 3. And then for the height, let's do times 4. Okay, now we have another block. Let's see where this guy is. Now I can show you that I can hit my head on the block, right? And I can't kind of go above it. Okay, anyways, we have that. Let's do our horizontal collision. So the horizontal collision is a bit weird to implement. The idea behind this is that since we're using our sprite collide mask, we want to make sure that if we collide with a block horizontally, we move ourselves off of that block so that it doesn't think that we're colliding with it in the vertical direction. Now, you just saw that happen. We hit the block. It thought that we were hitting it like the top of the block, so it put us on the top of the block because that's what this line does right here. So in our horizontal collision, we essentially need to check, okay, by moving in this direction, are you going to hit the block? If you are going to hit the block, we want to prevent you from moving in that direction so that you don't hit it, collide with it, and then we like spawn to the top of it. So let me write it, and I'll explain to you how it works, but it's just very important that we check the horizontal collision first. Then, once we check that, we check the vertical collision, because we only want to check vertical collision if we are not colliding with a block horizontally, or if we haven't already handled, or if we have already handled the horizontal collision. Again, the idea is we don't want to be thinking that we're hitting the block on the top when really we hit it on the left or the right side. So we got to check that first. So I'm going to make a function. I'm going to say define collide. I'm going to take player, objects, a displacement x, like that. Now I'm going to say player.move, and I'm going to move my player in the displacement x direction and 0 in the y direction. The reason I'm doing this is I want to check if with the current velocity that my player has, now the reason I'm doing this is I want to check if my player were to move to the right, or if they were to move to the left, would they hit a block? That's what I'm checking essentially by moving the player preemptively. So now what I need to do is say player.update. Now the reason I need to call .update, and let's go here to .update, is because I need to update the rectangle in the mask before I check for collision. So again, what I'm doing is I'm preemptively moving my player to where they would be moving if they were going left or right. I'm updating their mask and their rectangle. And then I'm going to say for object in objects if pygame.sprite.collide mask, and then I'm passing my player and my object. So this is why I needed to update my mask and my rectangle. So I move my player, I update it, and then using that updated mask, I check would I be colliding with an object. Now I'm going to say collided object is equal to none. I've got to spell collided correctly. If I am, then I'm going to say collided, and this is just going to be object, is equal to obj. Then I'm going to break. Okay. Then I'm going to say player.move, and I'm going to move them back. And then I'm going to say player.update. Okay. And then I'm going to return the collided object. Okay. So what I'm doing, right? I'm moving my player. I'm updating the mask. I'm checking if they would collide with something if they were to move in that direction. Then if they did, okay, I get that collide object. It doesn't matter if they do or they don't. After I check this collision, I have to move them back to where they originally were. So I have to reverse the movement and then update the mask again. Then I return collided object. Okay. Again, moving, checking if we hit anything. Either way, moving back to where we were before. This is preemptively checking before we allow them to move into a block. All right, now what we need to do is use this function to allow us to move left or right, or to disallow us from moving left or right. So I'm going to say collide underscore left is equal to collide player objects, and then negative player vel. Then I'm going to say collide underscore right is equal to collide player objects, and then player vel. And then I'm going to say and not collide left and not collide right. Again, what we're doing here is we're checking if we should be able to move left or if we should be able to move right based on our current position. That's why I make that preemptive movement. And then here, I only let you make the movement if that movement does not cause you moving into a block or colliding with one. Now that we have that, that should actually handle our horizontal collision. That's actually all we need. All right, so let me run this code and let's see. So I'm here. Okay, obviously that's still working. And you can see that I can't go through the block. Now let's go here. And actually, I'm getting a bit of a bug on the right side. Okay, so that time it worked, but it's a little bit glitchy. And I have a feeling it has to do with the animation count of me running, because it's only sometimes when I'm running and I hit the block that it spawns me up here. So I'm just going to do another little hack here. And I'm just going to multiply this by 2, both of them here. The reason for this being that I'll just make it so there's a little bit of space between the block. And that way, me changing the sprite isn't going to affect if I collide with the object or not. Because remember, the sprites kind of shift to the left or to the right a little bit. So just by adding this multiplied by 2, it should make it so that I'm never going to be colliding left or right. It will make it so there's a bit of space. See how there's a bit of space between the block now? But that's okay, because now I'm never going to have that collision bug where it's going to spawn me to the top. And really, you could probably just add 1 or 2 pixels, but you can see that that kind of fixed it right there. Okay, so now we have collision with blocks. We have a scrolling background. We have double jumping. I think that the last thing that we need to add here is the fire thing, right? Kind of that trap where you hit it and you kind of flash. And then once we've done that, we'll pretty much be done the tutorial. All right, so let's write our class for representing our fire. So I'm going to say class fire. This is going to inherit from object as well. And this is going to be animated, right? We're going to have animated fire. So this will take a bit more work, but I think it'll be worth it. It looks pretty cool on the screen. So I'm going to take X, Y, width, and height. And then I'm going to call my super initializer. So super dot underscore underscore init self X, Y, width, and height. Okay, and then for the name of this, I'm actually going to call it fire. Remember that we can pass a name. The reason I'm adding a name to the object is so that I can determine when I collide with the object if it's fire, and if it's fire, then I want to do something, right? Okay, so for self.fire, I'm going to use our load sprite sheets function. For directory 1, this is going to be traps, and for directory 2, this is going to be fire. Now, if we go here to traps, you can see that fire is one of our traps. So we have hit, off, on, okay? Now, there's also a bunch of other traps, right? So you can pick a different trap if you want. Like you could pass this blink one or whatever. The thing with these ones is that they have some more animations, so there's a bit more logic you need to handle for them. So that's why I'm going with fire, because it's a pretty simple one to do. Now, up here for fire, I'm again going to have my animation delay. So let's just make that equal to 3. And now let's specify our image. So let's say our self.image is going to be self.fire off. We're going to start with it off and then 0. Okay, then I'm going to say self.mask is equal to pygame.mask.fromSurface self.image like that. Okay, then I need to set an animation count. So I'm going to say my animation underscore count is equal to 0, just like we did for our player. And I need to set my self.animation underscore name, which for now is going to be equal to off. Okay, now I'm going to make a few functions. My first function is going to be on, or my first method. And I'm going to say self.animation name is equal to on. If we look at fire, we see we have hit, off, on. We're not going to use hit. We're just going to use off and on. Okay, now we're going to have off, self.animation name is equal to off. Okay, and then we'll have our loop. We'll say define loop, self, and inside of our loop, we're going to do a very similar thing to what we did inside of our player loop. In fact, so similar that I can copy pretty much all of this right here. So let's copy all that, and let's paste that here. Now, for update, rather than actually just calling an update method, we'll just copy the stuff from the update method here and just paste it down here. Okay, and rather than self.sprite, we're going to change this to image. And I actually think that once we remove the direction here, this is all that we need for our All right, so now we just need to make a few changes. We're going to get rid of this sprite sheet name. And rather than sprite sheet name, we're going to say self.animation name. And now we should actually be good to just use this. So let me space this out a bit. We get our sprites, okay? Is it going to be self.sprites? No, it's not going to be self.sprites. It's going to be self.fire, which is this, okay? Really, I probably should have called this something else, but fire is going to represent all of our fire images, okay? So I'm using this to get my different animations. I'm getting the animation name that I'm currently playing, so either on or off. And then I'm saying my sprite index is equal to self.animation count divided by the self.animation delay mod the length of sprites, same as what we had before. My image is equal to sprites at sprite index, and then I increment the animation count, update my rectangle, and update my mask, which is important for the collision, and I'm good. Now, last thing I want to do here is I want to just check if my self.animation count is greater than, actually, if this divided by my self.animation delay is greater than the length of sprites. Now, the reason I want to do this is so that my animation count doesn't get too large. Now, you'll notice in my player class, I actually didn't do this. Now, that was intentional because if you do this, then it kind of messes up how the double jump works. You can do it if you want, but you'll see that it kind of messes with things. And with our player, we're constantly resetting the animation count when we jump or when we go left or when we go right, so that value doesn't really get too large. But here for our fire, since it's just static, like it's just sitting forever, what will happen is the animation count, if we never change it back to 0, will get to an extremely large number, which can kind of lag our program. So what I want to do is just make it smaller, right? So if it goes beyond what the actual animation, what do you call this is, the length of the sprites are, then I want to set this to 0. It's important I divide it by the animation delay, though, because if I'm dividing it here, I need to divide it here before I set it back to 0. Okay, so now we have fire. I think that's actually all we need for fire. So now we just need to add it to our objects. So let's create it. Let's say fire is equal to fire. And what do we need to pass for fire? We need an X, Y, width, and height. So we can pick where we want to put this. Where do I want to put my X and Y? Okay, for now, let's go 100. And let's go height minus the block size. And then I don't know how tall my fire is going to be. I've got to see how big I want to make this. Let's make it, say, 64. And then we'll go 32, 64 here. Okay, so if we look at fire, let's quickly have a look here, and go to off, for example, or on. The size of this is 32 by 64. Okay, that's what the size is, and you need to pass that correctly to the fire class. Otherwise, it won't load the image properly. So we take our height minus our block size minus 64, which will put us on top of a block. Now, I will put this at, 100 is fine for now for the X. And 32 width, 64 height. There we go. We have our fire. Now I'm just going to say fire.on. I'm just going to turn it on. We'll just leave it on forever. You can turn it off programmatically if you want. And then inside of objects, I'll just place my fire. Now that I've done that, it should just show up on the screen when I run my code. So I got an issue. Let's see what the bug is here. Of course, the output is not showing up correctly. It says init takes from 5 to 6 positional arguments, which 7 were given. Okay. I see the issue here. Let's go back to our fire, and we don't want to pass self. Let's remove self. Okay, let's run this. List index out of range, self.fire off 0. Okay, I'm wondering why that's giving us an issue. We have off here, so that should have been okay. So let's go here, and let's print self.fire. And let's see why it's giving us this, this bug here. All right, so I've determined the issue, and the issue is that I passed the incorrect size here. It's actually 16 by 32. So I was passing too large of a size, and that's why it wasn't giving us the correct number of images. So let's change this now and run, and now we should be okay. And there we go. Now we have fire, but however, it is off. Now, the reason it's off is because we didn't call the loop method on fire. So let's fix that. I can also get rid of the print statement that I put here that I don't need anymore. Okay, so let's go down to main, and where we have player.loop, let's call fire.loop. And is it asking for the FPS? I don't know if I took that in my loop here. No, I don't need the FPS for that, so let's get rid of that. Okay, now let's call it, and it should start being on. Fire object has no attribute sprite. Okay, let's go fix that error. My apologies. Fire, we have sprite somewhere here that we don't want. Self.sprite. This is going to be self.image and self.image. All right, sorry about that. Let's run it now. And there we go. We now have a moving fire. And notice that I can kind of be on top of the fire, right? So I can collide with it, and it's like pixel perfect collision pretty much when I'm hitting it. So now the last thing we need is to just make it so we go into that kind of hit state when we do hit the fire. That's actually pretty easy to do. We just need to add a kind of state to our player to know if we're hit or not. So we're going to say self.hit is equal to false. We also want a hit count because we're going to only be flashing for a certain amount of time. Then we're going to have a method here, define hit self. Self.hit equals true. And self.hit count is equal to 0. Then we're going to go in loop. And before our update sprite, we're going to say if self.hit, then self.hit count plus equals 1. And then we're going to say if self.hit count is greater than, and we can just pick some value, but let's say FPS multiplied by 2, which is going to be 2 seconds. Then the self.hit is equal to false. Then we go here into our update sprite, and we say, actually at the top here, if self.hit, it's important you put this at the top, by the way, so make sure you put it here. Then we are going to say the sprite sheet is equal to hit. Great. Then we want to now determine if we actually got hit. So we do that from our collision functions, which are going to be here. All right. So we have collide left, we have collide right, and we're going to have vertical collide. Now what we're going to do is we're essentially going to loop through all of these objects, and we're going to see if we hit fire. Now, the way we'll know if we hit fire is by looking at all the objects that were returned here, and it will tell us, well, if we hit fire or not, right? It's because we can look at the name of the object, and if the name of the object is fire, then we know we hit fire. So I'm going to say toCheck is equal to collide left, collide right, and asterisk vertical collide. Now, I realized that inside of here, I only returned one object, whereas inside of here, I returned all the objects I was colliding with vertically. Really, we should probably be returning all of them from here as well, but I think this is still going to work, so we'll just leave it how it is for right now. So I'm going to say for obj into underscore check. These are all the objects we collided with, remember? I'm going to say if to underscore check and to underscore check dot name is equal to fire, then player.hit is equal to true. Okay. That is all we need. And actually, I'm going to say player.hit. I want to call the method. I don't want to set it equal to true. So what we're doing here is looking through all the objects we collided with. If any of them are fire, then we will put hit on the player. The reason I'm doing this first, if toCheck, is because these could be none, right? We could have no objects we collided with. So I need to make sure I handle that case before I try to access name on an object that isn't defined. All right, let's run the code and let's see. And player has no attribute hit count. Okay, so let's go to player and let's go to hit count and let's make that equal to 0. I guess I forgot to assign that. All right, let's try this now. List object has no attribute name. Okay, interesting. Let's see here. Okay. All right. So I'm using toCheck when I need to be checking obj. So let's fix that and run the code. Bool object is not callable. Okay. Player.hit. Aha. So let's call this make hit. It's because I have an attribute with the same name as my method. So it's accessing the attribute when it should be accessing the method. So I'm just going to say make underscore hit. And now that should fix the problem for us. Run the code. And there we go. Now, it looks like I'm always being hit right now. That, of course, is a bug. So hit is equal to false. Let's check our hit count. It's because if self.hit count plus equals 1, if self.hit count is greater than self.hit equals false, maybe we need to reset our hit count as well. Okay. And there's probably a bug here. Let's scroll down. Keep scrolling with our fire. So we have toCheck if obj and obj.name equals fire player.makeHit. Okay. I'm not sure what the bug is. Let me run this again. And yeah, it seems like we start out in the hit state. So maybe it's an issue in here. Let's have a look here. If self.hit, sprite sheet equals hit, but are we hit right away? For some reason, it's making us hit immediately. Okay, let me have a look here, guys, and I'll be right back. All right, so I've realized I made a silly mistake here. I accidentally had this collided objects append outside of this if statement, and that was causing all kinds of bugs and issues for me. I think I was doing some print debugging, so let me get rid of that here. Anyways, I just moved it back now so that it's in the correct location. So now if I rerun this, now we should see that when I hit the fire, it puts me into kind of this hit state, lasts 2 seconds, and then it ends. All right, so with that said, guys, I think that's pretty much going to wrap up this video. This showed you how to create a platformer, how to do animations, how to do sprites, how to do a scrolling background. Obviously, there is a ton of stuff that could be added to this game, but I really want to leave that to you. Obviously, I could spend hours, days, months working on a game like this, but I think this is a solid enough base to really give you guys a good foundation to go out there and create something pretty cool. Obviously, there's all kinds of assets that I will leave in the GitHub that you can use. I have all kinds of other Pygame tutorials that you may want to reference if you want to learn about menus, sound effects, points, scoring, all of that kind of stuff. You guys just go on my channel, search Pygame tutorial. You will see a bunch of them. Those will show you how to do a ton of other things that you may want to add to this game. So I hope you guys enjoyed this. This was a ton of work. As always, the code will be in the description. If you did enjoy, make sure you leave a like. Subscribe to the channel, consider supporting me by purchasing something like Programming Expert, and I hope to see you in another YouTube video.